The subsolar point, as it passes over the equator, has the greatest rate of change by latitude as it's passing over the equator. And it lingers at a particular latitude at any time that it is not crossing the equator. Did you happen to catch that, Kosho?
Yeah, I got you.
Makes sense to me,
Basically,
anyway.
it's moving. It's moving the fastest. It's going to lag the most at the tropics because it's turning around. It's going to be passing over the equator the fastest.
These guys, you guys are funny, bro. You just want to hand wave reality and logic, bro. Come on, man. Come on, dude. Really? Really?
We
Dude.
typically, if we're going to talk about the globe model, we'll use the globe model when we're in our discussions. We do that.
Yeah, let's talk about that globe model. The globe model has recorded temperatures of the land of which is being affected by the sun in your world that's 93 million miles away, and for some reason that heat is then somehow hotter at a northern and southern position from the equator that should be getting the hottest direct heat from it. I don't know why you guys continue to spread lies and falsehoods. I don't get it.
As I just mentioned, the rate of change of latitude of the subsolar point is at its fastest when the sun is near the equator, and it is at its slowest when the subsolar point is nowhere near the equator. I just finished mentioning that, Apocryphon.
So you're saying that 6 months later, when it's supposed to be colder at one position as opposed to the other, you're saying that there's a like a phenomenon going on to where all of a sudden it's hotter? How does that make sense in your mind?
I never said any words that were anything like what you just said.
Well, I'm adding it to your logic because it does make sense. Do you understand that?
Right, the thing that you said didn't make sense. I'm glad I didn't say it.
Okay, so when it's winter time, is it hotter in certain areas as opposed to the others? Yes or no?
In some places, it is hotter than in other places at all points of the year.
Okay, so Death Valley. Obviously, this is the point I'm talking about that's being contended, right? Is the contentious of it all. I'm saying if you have a heat that should be hitting the earth directly, because I remember a long time ago, maybe like 2 weeks ago, for a long time ago, somebody was telling me that if I stood close to a bonfire but angled my body, my face wouldn't feel the heat as it is to my legs because I'm angled away from it. But
I believe
my
what I told you. You talk so slow, man. I believe what I told you was
I'm
that if you
drunk, bro.
move
Shut
three
up.
percent, yeah, I know you are. If you move 3% distance from the bonfire or whatever, you see 3% difference. Let's pretend it's a radiant heat, but we'll just say bonfire. And you do that as opposed to turning, perpendicular, so turning 90 degrees away from it, right? And you measure the temperature that your nose is getting, the tip of your nose, you're going to obviously get a much bigger difference by turning 90 degrees. So when you face it towards it, you're facing away from it, you're going to get a bigger difference than when you move 3% closer.
Oh my god, bro. Like everything you said right now, bro, it doesn't make sense because there's places in fucking America that the heat is way beyond what it should be in your paradigm. And I would argue that there's also places in Africa that also are way hotter in your paradigm. But for some reason, you guys want to stick to that. I'm gonna mute myself. You don't get it. You all don't get. You're blind, but you're blind. But you say you see, so you will stay blind. You understand that? I'm gonna mute myself.
It's interesting to me because they want us to prove something they can't prove, yet our model, we can go out there and prove like dozens and dozens and dozens of observations. But yet they're like, we're the fools because we can't prove that their model isn't correct. They can't even prove anything about it other than math.
Right. Well, the discussion we were just having was
Everything
about the sun and the.
ball is related to math.
Thanks, dude.
It has nothing to do with observations.
Thanks.
You're welcome.
The discussion we were just having was about energy distribution over the surface of the Earth. We could definitely go out and demonstrate in reality that if you change the angle at which light arrives at a surface, the energy distribution decreases rapidly. That's something we can definitely go out and demonstrate here in reality.
That's it.
You're going to tell me, though, that we can't demonstrate that stuff.
Wait, no, I'm agreeing.
Just going to lie to my face.
No, I'm agreeing with you. I'm just saying that doesn't mean the surface is a ball. And in fact, you're using angles which are straight lines.
Straight lines existing do not define a shape necessarily existing either.
You're right. It has nothing to do with shape.
Why bring up the words straight lines?
Yeah.
Because that's what angles are.
I got a fun fact. It's not really
straight lines are angles. Oh my god.
Yeah, I know. It's a mind blower for the ballers. I mean, it's hard. It's really tough.
What degree of an angle is a straight line?
And then they go into degrees. But still, if you bust out a protractor, you'll see, guess what? Straight lines.
No,
yeah, angles are not straight lines.
What angle is a straight line?
All of them.
Oh, just one, for example.
Okay. Just so we can. I looked up the a city on the equator in Uganda, and that was funny what he said though. But and I just
What's so alert? You can't prove to me that angles are bent.
Is it like a 360 degree
that's kind of
straight
the
line
definition
angle?
Of what angle is, man.
That's not an angle. A 360 degree line. That first of all, it's not a line, and it's not based on an angle. It's based on your personal observational point of perspective in your 360 degree, your ability to turn around.
No, 360
and look.
degree is an angle.
Yeah, that was really funny though. No. That was a good one.
360 degrees is your ability to turn around in your position to measure the light angles that are coming in straight.
So
I can save you
is
now,
359
my friend.
also an angle?
But the guy who was talking, so go ahead. I'm gonna talk over you a little bit.
It's French.
Yeah.
Repeat what you said.
Yeah. So is, for example, 351 degrees also not an angle? If 360.
You're really quiet now.
No, you guys are. This is what they do. Is they try to mix two things together.
No, so
and then they argue.
What an angle is. If you don't think that
an angle is a straight line metric. It's a It's based on geometry. It's based on distance, and it's based on the quickest path between two positions.
One
in a straight line. That's what angles are. They're all straight lines.
So when you have, for example, 90 degrees, what is it? An angle?
90 degrees is your position measuring the angular light, which is all in straight lines coming into your position. You can turn in a 360 degree circle to measure the angles, but that doesn't mean that the light is bent. It doesn't mean you're standing on a ball.
Angles, light, or whatever. What are we?
It's really simple, guys. You just can't handle it.
No, because we've been talking about angles,
regardless of that,
lines, and you suddenly brought up light.
Because it's ridiculous. You're trying to integrate angles into a spinning ball model. You're trying to say that you measured a ball with straight lines. You can't do that.
Exactly.
It's not even possible.
Exactly.
Okay, well, I have some news. That might be a little bit more rewarding than that. But I was looking at last year. I looked for a city on the equator, so I found one in Uganda. Well, I wasn't sure that was on the equator or not, but regardless, I looked at the 4 dates, being January 3rd and July 3rd and both April 3rd and October 3rd, right? Being the closest days, the closest days, and then I kind of did the 3 months later than that date. It's not exactly the equinox, basically, 3 months later. Anyways, it turns out that January 3rd. So what's it called? So January, March. Right. So I wrote them down, just making sure I wrote them correctly. So if you look at the date, basically the point is in July, even though the equator is going to be experiencing the equinox, it should be about the same temperature in both cases, and it should be about the colder when we're further, right, in July. And it turns out it's 2 degrees colder in July than it is in January, right? So on the equator, when it should be, it doesn't have the same bias from the tilt as the other, the northern summer, the southern summer, winter. You can find locations on the equator where, due to the fact that we're closer in January, the temperatures are actually warmer for them on the equator. So
Welcome to not a 25,000 circumference ball spinning through an infinite vacuum, Kosho. It's not a ball. What you just said explains exactly why we don't believe it's a ball.
because it's warmer on the equator in January than July.
Not only that, it's not I guess, should I say mathematically? No, recorded. It's not recorded that this particular temperature you're talking about, if it's now hotter north or south of that position, then it's not a ball. It can't be a ball. Do you understand what I'm saying right
It's
now?
a tilted ball. It's a tilted spinning ball. A ball that's spinning and that's being
It has
tilted.
to be.
Yeah, that's right. It has to be because of the measurements we get. The measurements we get
But no,
based on
correspond
math.
to a
no,
spinning
but
tilted ball.
no, Coach, your measurements would be off though, because the fact that you have a recorded temperature at the equator, yet you have something different north and south of it, then that doesn't make sense. Even in your own paradigm, bro, it doesn't make sense.
Okay, Pocketphone. The tilt and the distance both would result in a difference in temperature. So those would vary the temperature. That's true. On the equator, though, they have both the solstices are going to be equidistant from them in both cases, and the equinox will be right along the equator. So although everywhere else the tilt and the distance will correspond to different in temperature, out of those two, the only difference that they'd experience would be due to the distance, right? Because tilt is not going to affect them the same way because it's equal on both sides from their perspective. There's other factors that will give you differences in temperature, but out of those two things, the equator is only going to respond to the difference in distance. And it turns out that by looking at a city and looking at those dates, they actually are warmer when it's closer. So
No, come on, Coach. Like, are you being serious right now? Like, come on, bro. Like, you know that the equator is never hotter than the south and the north of it. How do you even, in your paradigm, how do you even explain that?
What's that? Yeah, sure.
Hello, Kojo? Can you hear me? Are we here? Are we live?
I don't understand what your point has to do with anything.
No. What do you mean you don't understand what my point has to do with anything? I'm saying
It's
if
super busy. I'm gonna take over, but it's probably not because I can do, I can multi. Not that not saying you can't, but
Right. Okay, look, if the equator in your world should be technically the hottest point
are we pretty
of
good
the
on
earth.
phones?
Go ahead. You're really loud, but go ahead. Jump in. Go ahead. You're really loud, but go ahead.
Is any hot micing?
Yeah, I think he went to the hot
Maybe,
microphone.
maybe I don't know, but Kosho, if in your paradigm the equator should technically every 3 months it should be the hottest point because it's getting the direct
No.
light from your sun. Oh, it's not? Okay, so
Yeah,
please.
the answer to your question is no. I think Doofus had already explained to you how the sun is moving the quickest. So as it changes latitude the quickest as it crosses the equator, which means it spends the least amount of time there. Spends the most amount of time when it's near the tropics.
Okay. So it because it's going quicker along the equator, you're saying that it's less.
That's exactly what I said, but I said it a lot faster.
Okay. So then you're saying that it's possible for the south and the north parts of the world to be hotter, yet it's still fucking traveling fast. Kosho, you're so full of shit, bro. Because if it's traveling fast along the equator, then it's traveling fast along the entire fucking world here. So,
let me just give you some heads up. Let me give you a heads up because I looked at this before. I looked at this before.
Oh my
During
God,
the equinox,
bro.
it changes each day by about 0.4 of latitude. So every day it's 0.4 of latitude north or south of where it was. That's fine.
Drive me crazy, bro.
On the solstice is by about 0.1 latitudes. So that means that any day during the month, before or after the solstice, it's only changing by about a tenth of a degree.
Why do y'all do this?
0.4 of a degree.
He keeps reverting back to the ball math with latitude and all these connections. It's
exactly.
like, dude, if you're willing to look at something that can do the same thing in a different shape, what's the problem? Why is it such a problem with these guys?
The problem is that you guys.
I need to mention real quick that if you're going to talk about what the globe model says should happen,
that's what you guys
the
are
discussion is going to be, dude. If we're going to talk about what the globe model is supposed to be doing, and the people that are involved in the discussion are going to talk about what the globe model says. Don't be surprised that in the discussion on what the globe model says, the globe model is what gets used.
Is that Matthew? Is that Matthew speaking?
No, it's not Matthew speaking.
Oh, it's Doofus? Is it Doofus?
Yes.
Oh, hey,
Jesus
fucking
Christ.
Doofus.
Keep guessing.
Yeah, I guess.
But I was telling you guys the same exact thing. I was telling you guys the same exact thing earlier. If you're gonna use the globe model, you got to actually use the globe model and what the globe model says.
So their globe model says that the Earth is spinning at a 23.4 degree angle. So then the sun would technically,
in reference to the
right. But it should heat up a certain point of the Earth always, because
apart from
at that. Go ahead.
While you were off getting a beer, I just explained to you that during the solstice, the January and July, or June and December, whichever, but the aphelion and perihelion, during those times, the sun changes latitude by about 0.4 of a degree each day. Okay, so that's pretty fast compared to the other months, or the opposite of what I just said. So I think I just gave you the
you had it backwards there, Kosho.
Yeah, I had it backwards. But regardless, But the other part of the year.
So what about March and August?
March and August? What the hell does that have to do with anything, man?
March and September.
March and August?
That's the divide of that 6 month period. So every 3 months, this is what I'm saying, Kosho. Every 3 months.
I meant to say was March. I meant to say March and September. In March and September, it moves. It changes by 0.4 degrees. So 0.4 degrees it changes each day, whereas during the solstices it changes by 1/10 of a degree.
Okay.
So it's spending it's lingering. Yeah, it's lingering more at each during the solstices, and it's traveling through the latitudes faster during the equinox, which means that they're gonna retain and get more energy. During those times of the year.
Okay, so somehow, some way, does it slow down in December? And
I just told you that.
What you did?
Yes, I just gave you that how much it slows down. I told you the whole thing.
So it slows down.
I told you how fast it moves.
So okay. So in your world, things are slowing down. Okay, now let's go back to the
That's
law.
slower.
Hold on.
in his paradigm.
Wait,
That's
hold on.
thing.
Let's go back to the laws of momentum. If it slows down, then what picks it back up in speed? In your fucking paradigm, what energy is
I gotta go.
allowing these? Go ahead. Go ahead.
I gotta go Apocryphon, but if in your free time, get a pendulum and swing it back and forth, and determine whether it's
That
moving
has
fastest
nothing.
on the
That has
edges.
no.
Determine if whether
No.
it's moving fastest on the edges or when
No.
it's at the bottom.
Has
No,
nothing.
hold on, that is relevant actually, because apart from
no,
where does it
it's
get the extra energy? Where does the pendulum get the extra energy?
No.
No, where does it get the extra energy? Where does it get it?
First of all, Arma. First of all, a pendulum
Wastable.
only starts with a human pushing it or
Talking about
making
while it's
it start to
swinging.
work. But I'm not talking about while it's swinging. I'm talking about if you want to say that the sun and the position of it to the earth somehow slows down and speeds up. I'm asking you, in the laws of momentum, what is slowing it down, and then what gives it the energy to speed up? Go ahead.
Apocryphon, very
gravity.
very
It's
quickly.
gravity. Yeah, obviously.
And nothing to do with gravity. Very quickly, the subsolar point is what Kosha was referring to, having a different rate of change of latitude over those periods of days. That difference in rate of change is not to do with momentum. It's where the subsolar point is located. The subsolar point is not an object that needs to accelerate or decelerate.
Okay, no, but you're talking about a point on the Earth to where you can have a recorded temperature. And once you have a recorded temperature that is now greater than what it should be, somehow you guys just want to turn a blind eye to that because
You're on repeat.
technically it shouldn't be that. Technically, it shouldn't be that. Technically, you shouldn't have this.
If it's warmer.
Exactly. You shouldn't have Death Valley be warmer than the equator. Yes or no? Yes or no? Answer that fucking shit.
I mentioned a long time ago, I guess it was an hour ago, that ecology has more variables than just where the sun is located.
Variables. Here we go with the bullshit math. You know what you remind me of?
Apocryphon.
Go ahead.
Have you Googled why Death Valley is hotter than the equator?
Oh, because Google will have all the answers because Google's almighty. That's what it is.
It'll have more than the zero that you have right now.
Oh my god, bro!
If you would take 2 seconds to Google why Death Valley is hotter than the equator, you would come to the answer of which you seek.
If I wanted to literally look into bullshit, I would just watch a fucking bull take a shit.
That's cool. Can we do without the melodrama if we were going to continue with this overly?
Sure. Here's the reality. Here's the reality. You have a planet in your paradigm.
I want to hear a little bit more about this bull taking the shit. Can we hear about that?
Yeah.
Oh, come on, man. You do not want to hear that.
You have a paradigm that has a ball spinning at a particular angle, at a tilt, and then for some reason, along its direct heat from the sun, it is not as hot as the north and the south of that position. Now, in my brain, I'm saying you're fucking full of shit, all of y'all. You don't fucking get it. But you want to continue to believe that falsehood. That's fair. That's fine. Fucking go ahead and put your teeth on a pillow and get fucking $2 from the Tooth Fairy. That's fair. But what I'm saying is that you guys continue to defend and try to justify these nonsensical claims that aren't even fucking logical. I'll shut up.
Okay.
Is this a bar jail?
Hey, he shut up, y'all.
No,
wanna talk?
APOC, don't stop. You're letting them off easy, APOC.
Oh, come on, Snacks.
They're denying your truth.
No.
Fuck, come on. No, fuck no. Sorry. Anyway, yeah, other things? Did anybody do other things today or have any other side topics related to this?
Nah, they wrong. At the end of the day, they're wrong, bro. I'll come back. They wrong. They're wrong because they want to try to manipulate the minds that have broken free, and they broke the chains of the indoctrination of which we all believe. By the way, ballers in this room right now, we were all fucking ballers at one point. We all believed.
Yeah, we heard the story like a bajillion times.
I have a question.
We get it. Every flat earther, it has like a like a what is it, like a villain backstory, whatever it's called. Like we get it, all right. Like the whole.
I have a question for the Globers.
We just started trusting our own senses.
Right.
We started going out there and comparing what we're told with what we can observe in firsthand witness account, and then we realized, wait a second.
Shit doesn't add fucking up. Exactly.
What you got, Godric?
Yeah.
Glober guys. Okay, so the Earth is spinning, and there's water on top of that, and then there's air on top of that. So how does the water tug the air on top of that along with the spin? How does that work?
Well, what?
Are you asking why is the
because if you take a basketball and put it in a tub and spin it, that water will lag. It will technically it'll lag behind the spins. How does that work on the Earth?
How fast will you spin it?
It doesn't matter how fast you spin it; it'll lag behind the spin.
Yeah, but I mean,
my point.
Earth spins.
So why doesn't the air lag behind the spin of the Earth?
Do you realize how slow Earth is rotating?
I think you claim 1,000, so you can just put a number there.
No, 1 rotation per 24 hours.
Right, you say that to try to push away the fact that it's 1,000 miles an hour.
Every 24 hours. We don't use linear speed to measure rotation.
The difference between the Earth and the area above the Earth is 1,000 miles an hour. You can say percentage, you can say 1 day. It's pretty damn fast.
Godric, in your example, the basketball in the bathtub, you said the water doesn't.
The water will lag behind the spin.
Is there any? I would say maybe the water surrounding it, right, is causing it to lag, right?
Yes.
Whereas that's not the case with the Earth. There's not a or a friction causing medium.
That's your whole answer?
Also, there is a guy who recorded Earth spinning in the speed that the Earth is actually spinning. I can bring this video up for you if you want to. But it isn't very fast.
Yeah, I'm like really fucked up, and I'm gonna go to Jam Pandas.
Hey, let me just clarify, because it's a big. The globe is big. It doesn't mean it's not going 1,000 miles an hour. It's still the same speed. You get that, right?
Like we don't measure linear speed. Like you use RPM or just say in how long is it rotating cloud. 1,000 miles an hour is only.
I'm trying to figure why the air doesn't lag, and you haven't really said it. You guys are like, because
Yeah, well, actually, yeah, the whole air thing though, because I've been thinking about that recently. Like, I guess, yeah, does it lag or does it not lag? On the, on the Earth.
The whole claim from the beginning is that it's lockstep. Is it not lockstep? Because if it was lagging, we could shoot a bullet up, and then it would, in California, it would fall into the ocean by the time it hit the ground. No.
Well, okay, I get that, because like I understand, like, because there are arguments, and I get this argument that the air is there's like friction and whatnot. The air is like colliding with like the ground and whatnot, and so naturally it's going to carry some of that momentum or whatever, right? So I get that part, but I do think it's a little tricky though once you start going higher and higher up, because at that point, yeah, there was the whole argument that was brought up, like, oh, if the air is going to be following the spin of the Earth, the higher you go up, it would have to technically move faster because it's a larger circle. I actually ran some of those numbers. I think if you're 20 miles up, I think it has to move 5 miles an hour faster, I think. Which isn't crazy. But yeah. And I think if you go up to like 70 miles, then it's like 18 miles. It has to move 18 miles an hour faster. But yeah, I don't know unfortunately I can't touch this because I don't really know the science behind that though. But that is interesting though.
You just said you did the math. You can't just put that in text for us?
Well, no, I'm saying in terms. Yeah, I'm saying the air would have to move like 5 times faster. Or not 5 times. It would have to move 5 miles an hour faster if you're 20 miles up for it to be moving. With the spin of the Earth, basically, right? If it doesn't move 5 miles an hour faster, then it'll lag obviously 5 miles an hour in the other direction. What I'm saying though is I don't know how that works, like if it does keep up or not, so that's the only math I can do is if we assume, then it would have to.
This is supposed to be science, so it should all be figured out. You shouldn't have
Well,
to.
you can frequently see clouds hanging out overhead that don't appear to be moving very much. So,
how high are the clouds? Are usually like what? Like
well, your
how high?
stratus clouds are way up there. Like 10,000 feet.
10,000 feet.
The cloud's not moving.
And that's
it's
like
in lockstep. It doesn't
that's
prove it's lagging. I'm trying to ask why is it not lagging?
so that's okay. So that's like around 2 miles, not 2 miles up, right? So that would be around
5 kilometers.
like 0.5 miles an hour.
Yeah, it's not much. It's really minute.
Yeah, because from my understanding, it's pretty. Yeah, so like if you're 20 miles up, it's 5 miles an hour faster. So half of that, which it does check out, half of that would be 10 miles up, which would be then 2.5 miles an hour, and then half of that is 5 miles up, and that's 1.25, and then half of that is 2.5 miles up, which is the half of that, which is like 0.7ish. No, 0.6 or something like that. Yeah, so it's probably like if I had to guess, it's like like half. It would be lagging behind, assuming it's lagging. It would be lagging behind like 0.5 miles an hour, which is really slow. Let me actually see how fast that is in feet. Miles to feet.
What's the subject matter?
0.5. So it's 2,640 feet an hour. Hold on. Divide that by, it's a minute. So be traveling. Huh, okay. It's like 0.73 feet a second. Yeah, that's pretty slow.
Yeah, that's slow.
Especially for a giant cloud like that, you're not gonna. At that point the cloud would be moving because of its whatever it's called like the wind or whatever it'd be drifting like clouds normally drift.
I count 1,000 miles an hour, so I don't know how you get 5 miles. That doesn't make any sense.
Wait, no, I'm saying, okay, so we have, okay, so 24,901 miles, divide that by 24. Obviously, you get 1,037 miles, right, at the surface. But if you increase the Earth's circumference, right, if you go up like 20 miles, right, then basically you're taking 39. It's like 63, right? 3963, because that's how you get the 24,901. If you take 3963 and plus 20 to it, right, then you get the new radius. Then you times that by 2.
You haven't explained how the surface tugs along the air. You haven't explained that part. Have you?
The what?
You haven't explained how the surface of the spinning Earth tugs along the air with it.
Well, I mean, from what I've heard, I don't know how, because I don't really do the, I don't do this science. I'm like literally like a casual, dude, whatever, right? So from what I've heard, it's, I imagine, the air like, hits against the surface, whatever. There's like friction basically, and so when it hits against the surface or whatever, it's gonna carry some of that momentum. Like that's just kind of how that works, Like when I hit into a stationary wall, right? I also want to be stationary, right? So when I hit it, I go, and I stop. Right. And vice versa. If I'm still and someone hits into me, then I'm gonna take their momentum, whatever. I'm gonna fly forward, like, oh shit, So same thing. The air, I guess, hits the surface of the Earth, right? And that surface of the Earth is moving, obviously. So bam, it's gonna move as well. It's gonna carry some of that. So that seems pretty logical. That seems pretty, like there's no stretch in that. I think there might be maybe a little bit of a stretch to say that the higher you go up, the air does speed up. But that's just for me though, because I don't know enough science to say whether or not the air should speed up as you go higher. But Yeah, I think you could agree, Godric, though, that the air hitting into the surface, the air would carry that momentum, of the Earth, right? That's pretty fair. Godric, hello.
Yeah, I would guess you don't know then.
No, well, I just said. Well, I mean, I do kind of know. I mean, I just told you, like, it's pretty logical to assume, right, that if you hit into something, right, with a different speed, you usually end up carrying some of that speed, right? You end up carrying that, momentum or whatever, right? That makes sense, right? Like if a train passes by and I go to touch it, right? Assuming whatever, it's gonna throw my arm back, right? Like that's how things work. You touch something that has like momentum, whatever, you're gonna sort of absorb that momentum, and it's gonna be so the air would do the same thing with the Earth's surface. Like it would touch the Earth's surface and be like, oh shit, okay, I'm gonna.
In your basketball analogy in the bathtub, the only reason the water moves with the basketball is because the imperfections on the basketball's surface. It's dragging the water with it.
Ooh.
Yeah. It's friction at the Earth's surface, no friction at the top. It's going to end up rotating with the Earth.
Yeah.
Well, it's just a lack of imagination.
Do you have an equation for that, or do you have any kind of proof that happens?
No,
But
it's just
equation
a basic.
Prove it.
It's just a basic statement, a basic concept.
Well, thank you, but it doesn't answer my question. I'm asking. It would lag. Where's the lag?
Once again, when you say lag, are we talking? Because I was on a whole point earlier about going higher up, like whether that keeps up or not. Are you just saying it would lag?
If you want to say it lags 5 miles an hour, then you need to put that in math or some kind of equation, and so that way we can test it. Because it is science, right?
I'm a little lost now at this point.
Yeah, I mean, you already did the math.
It's moving the goalpost.
Yeah, all I could say is, assuming because once again I don't know too much on this, but assuming just like the friction and all that, and then I could see that at ground level the air it's perfect. It's perfectly fine to assume that the air is going to be more or less moving with the surface of the Earth. Then once again doing the math though, because I don't know how this would work otherwise, because I mean I'm not really knowledgeable on this. If you were to go up 20 miles, right, the air would have to travel 5 miles an hour faster up there. That's what I was saying, pretty much. I don't really know how that works, though. So that would be some kind of lag, maybe, Godric. That's why I'm like confused on what you're talking about.
At the airport you have those walkways that make walk faster. It's like a walkway and like a little tram. You step on it, and it makes you go faster down the aisle to the airplane. Yeah. So if you blew smoke over that moving track, would that smoke stick to the track and move as fast as the track, or would it lag behind?
I mean, I imagine the stuff closest to at the very least, once again, because this is all I know, that the stuff like closest to the the surface of that track obviously would be moving, the fastest, or the most similar with the the track speed, and obviously the higher you go up, maybe that would start to lag. Yeah, sure, yeah. But I don't know how it works on the ball on the Earth. I'm not going to claim I know, but
I don't think anybody knows exactly how it works. But if it did happen, it should be real. They would know exactly how it works. So that's my point. They don't know how it works because it doesn't.
I mean, have you looked into this though? Maybe it is explained.
I'm looking into it now, and nobody in this room knows.
Subject to friction, the lower portion of the atmosphere is going to be inclined with the air below it, and so on and so over time, the whole system will get very close. Okay. See, yeah, because I mean that's tricky though, because like it makes sense in terms of like I know if you have like a solid thing, right? Like if you have like a wheel or something, right? If you spin that wheel, obviously you could make the argument that the outer part of the wheel is spinning faster or moving faster than the inner part of the wheel, right? And then, obviously nothing's being broken there. Like there's no, like, oh, there's more energy or some shit. Or I mean, maybe there is, I don't know, but like I feel like with the air though, obviously there is the friction thing.
Do you
Like I heard,
realize that's not an argument when you have a diameter and a spinning distance, that the center, as you move out, you will observe a faster rate of speed? Do you not realize that that's not an argument?
wait, you talking to me?
Yeah, I mean, you're like, well, you could argue that if you have a solid wheel and it's spinning, and when you move out to the perimeter versus the center, that you could be going faster. And I'm like, do you not realize that's not an argument? That's a proven observation you can experience yourself. So it's not an argument.
No, there was context to that. I was saying you could use you could use that argument with the atmosphere or something like that. Like maybe the atmosphere is doing like a similar thing to the wheel where you could almost treat it as like solid or something. That was sort of the argument that I was making like that. There was context to
No,
that.
you can't treat the atmosphere as a solid object.
Well, no, I know. I was
That's
just
the whole point of it being defined as an atmosphere, gas, and
I know.
molecule and density. And
I know.
what
I'm
are
wording.
you doing, dude?
I'm wording
You're
things
just
weird.
trying
All
to
right.
argue.
What? No, I'm wording things
Yeah,
weird.
you
All right.
just like to argue, dude.
No, okay. I mean, I do like to argue, but I'm not just saying bullshit. All right, hear me out. All right, what I was saying was, all right, once again, I'm not the best at explaining shit. I was just saying, you can make the argument, yeah, with the solid thing, it does that. I don't know if that can apply to like gases as well, where because like with the friction and whatnot, maybe you can, because there's so much interactions going on, maybe there is some math that that I don't know about that, at that point it's almost as if the thing was like a rigid, thing or whatever, I don't know. I mean,
do you
that's
guys know
if you don't know, just shut
how much
up.
you're talking about?
who the
Just
fuck
shut
said
up,
that?
man.
Who the fuck said
If you
that?
don't know, just
Who
shut
said
up.
that?
Sick
Who's
of
saying that
hearing
right
it.
now? Who the fuck are you?
Shut up, man. Just shut the fuck up.
I'm gonna drop
If you don't
kick
know,
you. Where are you?
if you don't know, keep quiet.
I'm gonna drop kick you. You shut up.
So, do you guys know the number of how much speed difference we're talking about? Like at the equator, the surface of the Earth spins at 1,040 miles per hour. But if you go all the way up to 36,000 feet, as high as planes fly, it's 1,042. So it's a difference of 2 miles an hour.
Matthew, do you know how wind is created?
Yes.
Oh.
Yeah, on the seventh day, God created wind.
I thought he passed wind.
The Pepto-Bismol wind.
There it was.
It's just high pressure and low pressure. That's
Right.
it. That's what creates wind.
Like a
It's the
downward
difference.
bias.
It's the difference between the two.
A
Thing to do
downward.
with spin. The Earth doesn't spin.
The Earth.
Wait, what does spinning have to do with pressure?
That's why these guys are saying, the spin of the Earth causes wind.
What? Who said that?
Well, that's the Coriolis, isn't it? Isn't that the Coriolis? Come on, guys, help us out. That's what the sticky air and all that. That's how that all works, right?
I'm just trying to figure out who said that, like right now, though. Who said that the spin did that? Because no one from the conversation I was having, no one said that.
You guys say that all the time.
But I mean, like right now, though. I
In
mean,
different ways. You're really clever about how you guys represent the same stuff.
I mean, like right now, though. I didn't hear anything about that right now until he brought it up. In which case, it means he brought it up, and he was the one that which is weird.
You didn't know how it was created.
I think when we don't know why something happens, we say it's because of God.
He was assuming earlier that's what the globe is, full of assumptions, ASS, assumptions.
Yeah, through that. So really, in that same analogy, the globe the glow ball would be more of a religion than going out there and seeing for yourself and feeling that you're not moving and seeing that massive, huge bodies of water maintain a flat, level surface at rest. And there's all kinds of things you can go out there to experience with that. But the spinning ball, I mean, the only way I've never experienced it, but the only way to actually like go along with it is a religious belief based
Would
on
you
some
call
expensive math and gadgets that are held by really high priests.
Expensive math.
Wait, would you call belief that Wi-Fi exists a religion also? Because we can't see it, taste it, or touch it. We have to use machines to kind of.
That's ridiculous because we can use analog meters and we can use frequency meters and ways to. That is an actual physical frequency. Just because
Exactly,
you can't
but
see
you
with
have to
your
use.
eyes
You have to
doesn't
believe
mean
in
it's a
these
religion.
machines. You can't sense it yourself. You have to believe that those machines are.
No, I can. So what I do is, and actually, I run an EMF survey business.
But you've never seen EMF yourself.
No, but what I did is because I was skeptical at first when I first got into it. I was very skeptical. I invested in a lot of meters. I had a lot of people saying, "Oh man, I can do this and that and this and that. I think it's demons. I think it's this. I think it's EMFs." Right? There's all kinds of opinions. But after I invested all these meters in analog, not digital, then I started experiencing the same things that people had been telling me about for years as I moved around the country. Sometimes I lived under very intense power lines. Sometimes I was near a smart meter that created a field that bled into my apartment, right? And then I had issues with sleeping and things, but it took a long time for me to realize that even though I can't see it, it's there. And when I first got into it, I was like, whatever, But, and I do agree with you, meters are great, but that's not a religion. What you're trying to tell me is that the meters that you use prove that you have you have things that we can't experience. So, when it comes to frequencies and EMF in the business I run, I did experience issues when I lived in low radiation field areas and high radiation field areas. I live on a ranch out on a farm now, where I'm completely away from all the radiation that I measured before when I lived in cities, and I do sleep better. Now, whether or not that's religion, I leave that up to other people to make their own decisions. But the fact of the matter is a frequency like microwave energy and radiation that we can't necessarily see with our own eyes. You can't see heat, but you can experience
I wouldn't call
it,
that
right?
religion. I just call
you
that
can experience it. You can hold your hand near a fire. You can experience the relationship and the intensity of the heat based on your distance to the fire. You can experience that sensation, but you can't necessarily see the heat waves, right? And you can sometimes, depending on the density and the medium that you're in. So really, that doesn't even apply. Nice try.
Yeah, so I wouldn't call that a religion because I would say it's just using evidence to say, hey, there's EMF radio waves here.
Right.
So just
exactly.
like that's not a religion, then
but that's
what
not
you're
the same
saying.
for a spinning ball. Nobody has any evidence for that.
Nobody has any evidence that convinces
been
you.
able to. Well, here, if it was true, like a merry-go-round, you could just simply jump up and down and feel the shift. You could feel the variance, even if we have sticky air and Coriolis that somehow holds me in place as I jump in the air while this ball is moving 1,000 miles an hour below my feet. Somehow the air is sticking to me, the gravity's holding me in that. It's just nonsense that you can't.
How is that
once per day.
If there was
one rotation per day.
Well, hold on. Well, here's the argument though, right? So obviously, the faster merry-go-round, you'll feel it more, and a slower one, you feel it less, right? So I guess the argument should be how much we should feel, all right? Because
right, but we don't feel any.
Okay,
and
but
that
here's
was
the thing.
totally experience. They proved it a long time ago, and you guys are still going on about it.
Okay, but hold on. I could feel, obviously, 5 pounds. I could feel 1 pound, but I can't feel 0.00001. You know what I'm saying? So it really
you might not be able to, but I bet other people
No.
might not be sensitive.
But here's the thing:
that's
you say we're
something you
still
can
going on
experience.
about it.
You're trying to break it down into an argument. You guys do this all the time. You try to shoot this math in. You try to break it into another argument.
Try to shoot this truth in.
You can't prove yourselves.
But
try to have logical, reasonable.
Hold on, I have a question. You said it wouldn't feel this way. You can't feel it when you jump up and down, so therefore it's not there. Like, how would you know how it would feel in
How
order to
would
say?
you? You guys are trying to tell us that you know when you can't even show it.
No, I'm asking
That's
you.
what's ridiculous.
I'm asking you what you said specifically. You
I'm
said
just
it
saying
wouldn't
I've
feel
never
like
felt
this.
the motion, and you guys are trying to tell me I shouldn't feel it based on your math, which is
Yeah,
counterintuitive.
yeah, but your
That's
argument
counterintuitive.
was I don't feel it, therefore it's not there. So
That
I'm
was
just
not
asking
what
you-
I said. See, you guys do this. You flip it around, and then you act like I have to prove to you your own model.
Oh, well, you're saying you
And
don't
it's
feel it,
ridiculous because
therefore
you
it must
can't
be
even prove your own.
stationary. But you're saying you don't feel it, therefore it's stationary. That's what you're saying.
I'm saying that you cannot measure the spinning ball in any
But
way,
we
shape,
can.
or form.
Yes, we
Other
can.
than
We
math.
can measure. We can
Math.
measure. Now we can
Math.
measure different weights at different latitudes.
Oh my lord.
There's several things we can do.
Oh lord. It's like
What's wrong with
saying
that?
the billiard balls are round, so that means the table's round. That's what you guys are doing.
Not at
It's
all.
so
Not at all.
absurd.
We can use the Foucault pendulum to detect rotation.
Again,
and it
here we go.
comports with every
This is
aspect of a
dumb.
rotating body that you can think of. Now, you can deny it all you want, but it can be done, and it does mean the Earth is rotating. Now, I'm open to any kind of
That's
objection
another
you may
argument,
have.
man.
No, you're gonna
Everybody
be-
is. This
Hey,
is
I'm
what
still
you guys
talking.
do.
I'm
The
still
full
talking.
cult
I'm still
pendulum has to
talking.
be
I'm
started.
still talking. Can you hear me talking?
Sure.
So let me finish my sentence, and you can
It's
make
beautiful.
a comeback. In fact, you know what? I think you have enough. Why don't you make your comeback now, and we'll discuss it. Go ahead. Why do you
The
think a
full
Foucault
cult
pendulum
pendulum is
doesn't just?
super easy, dude, because it requires a start, and then its whole rotation is based on the construction, the ring loop, the resistance of the weight, and all that stuff. It has
No, it
nothing
doesn't.
to do with the table being a ball.
It does actually, because what you just said is a
In your
bunch of
brain,
nonsense. All you need to do, you don't have to keep
you
it
can't
moving.
experience it. This is
Can
all
I,
in your
can I,
head.
can I go after you or no? You can
said you were
experience.
done,
You can.
and you said you were going to let me come back, so I was.
You
and now
did, and you stopped,
okay,
and I
so
started
enjoy.
talking. You said no, then you started contradicting what I
Go
just
ahead and
started to
spew your
respond with.
full cult stuff.
Okay, look, so we have the Foucault. We don't have to keep it moving. We just established that fixed plane in space. That is a swinging back and forth. It doesn't have to be continually pushed and continue to go back and forth. It can just actually start and let it ring out. And that ringing out might take 20, 30 minutes, depending how large of a focal pendulum you actually have. And you can, if you want to try to impart some type of fake rotation and see if it corrects itself, you can do that too. But you will find, though, no matter how you measure it, this swinging back and forth plane will show a precession of the ground underneath it rotating. So it doesn't have to do with what it starts with or the mechanism or rings or whatever you mentioned. That's all nonsense.
It's amazing magic trick because it relies on the patience of people sitting there and waiting it to come back to rest. Because you won't. Are you going to admit that it requires a start? You have to push it to start it. And nobody has the patience to sit there for 6 months for that thing to actually come back to a stationary point of rest, which they all do.
No,
they all
it's
do.
not true at all. No,
Yes,
it takes 20 minutes, and it will move the specified amount of precession that it would comport with the latitude that you're on. So wherever the latitude, so it's funny, all these starting and stopping mechanisms that you think you're catching me with, no matter how you do it, somehow the latitude of a sphere comports with the rotational rate of that precession.
It's a great magic trick, but I see through that shit so easy. That's why magicians don't like me.
You said it's a great magic trick. You don't know how it worked, but it's a great and you can debunk it so easy.
Oh, I explained how it worked. You just
you didn't explain how it worked.
You guys all deny
you don't have any clue how it works.
That's what you do. I told you how.
You explained how you have
zero clue. Do you want me to tell you again?
Yeah.
Here, okay. So a Foucault pendulum is based on the mass, the distance of the length of the string or the wire, whatever, and it's also based on the ring and that the attachment and the resistance and whatever fine metals. I mean, they've refined them really well. Let me finish, right? But when they get this construction done, somebody has to push it to get it started, right? And nobody, see, the really clever ones, the really good magic tricks are the ones that'll keep swinging for years. And nobody has the patience to sit around and watch these. But nowadays, we have the time very much because you can just put a freaking webcam on the shit for 6 years and watch it slowly come to rest again. But they don't like that information.
Every aviator that flies in modern aviation these days on airlines will understand how that works. And they have to sit there on the runway for about 6 minutes to make sure that the precession is going 15 degrees per hour. They make sure, because if it isn't, something's wrong with the system. Just sitting on the runway, no matter what direction they're pointed, they must see a 15-degree-per-hour rotation of the Earth. Yeah, I didn't think you had to come back to that one.
My Bluetooth. So, I'm done. I already explained it.
You are done. You're done because you don't know what you're talking about.
You
It's
said
apparent to everyone, but you, I think.
that's fine. You need to feel like I don't know what I'm talking about.
I don't need to feel
fine if
anything.
you feel that way. I'm
Math is
fine
not
if you
about
feel that way.
feelings.
That's the difference between us. Is if you feel like you need to feel like I don't know what I'm talking about, that's great. Cool. I don't feel that way for you. I'm interested in any of you guys presenting anything that I can go out and verify.
Verify
I'm totally
it.
interested
Swing it
in that.
any
But
way you want.
all you guys do is come up with some math or some kind of device or something that I don't have. You got to have millions of dollars to access. You got to be part of the club. And then I still can't actually experience it. I'm just regurgitating the math that the club gives me money to regurgitate. I still can't go out and actually see it and experience it or replicate it in any way, shape, or form. And when I do, it's not the way you say, especially when it comes to folk. Pendulums are the ridiculous. That's such a weak argument, guys.
Why do all
the ballers, you guys got to get away from the Foucault pendulum. That's just
why
dumb.
do all the Foucault pendulums act the same if it's like weird table design and lubrication errors? Why do they all act the same?
They don't. That's a generalization that is way off.
They just build these things that don't act.
So what
in
you're
a
trying to tell
replicatable
me is
manner
every single
for no
pendulum
reason.
built on Earth has all been built uniformly with the exact same, everything totally perfectly uniformly, right? No variances ever, right? That's what you just said with that generalized statement. It's ridiculous.
Xanax, do all the Foucault pendulums act the same?
Yes. They absolutely
Well,
do.
there you go. Xanax says so you know it's true.
Of course they aren't the same. As long as they're constructed and have accuracy, swinging back and
Well,
forth in a
see,
fixed
now,
plane.
did you see what he just said? He corrected himself. As long as the accuracy in the construction is consistent, which is what I claimed is impossible, because when's the last time anybody made more than one thing that's exactly the same?
For example, let me clarify before you start fucking straw manning me.
You guys
Stop laughing. Let me respond back. Don't be rude. If you used a string and held it nailed to the ceiling, that would not allow the precession, because you start implying a force on that plane, because the string would start twisting. But if you could have a relatively
but that's
free,
still a pendulum.
Can you stop it? If you could have a relatively free gimbal, which disassociates itself for a reasonable amount of force to the rotating Earth, then it will all act. They will all act the same. It all depends on how little friction. The only variable there would be the friction and any kind of wind or air currents that are in the room. That can actually impart some errors. There's little things that you can control, and they will obviously cause a deviation or not a deviation. But they'll be the wind, the gimbal, those kind of things. Not even how it's really released is the big deal. It can make a elliptical type of orbit or swing, but that still would show the precession as well. You could still get the same numbers and results by having it being released slightly imperfectly. But the main thing is the gimbal. So you started laughing and checking like you got me. No, you don't. If you swing something back and forth and establish it's a plane, I'm almost done. If you swing something in a plane, if you can get it as close to a plane as possible, it will precess according to your latitude, and that is very indicative of this rotating ball we live on. Because if it didn't, you wouldn't have this latitudinal relationship between the precession rates.
Well, I'm not laughing at anybody thinking I got you. Well, when I laugh, it's because what's being presented is humorous. It's comical. It has nothing to do with this power thing of like, I got you.
You did.
I'm
you
totally
did.
open.
You started laughing and said, "Oh, I got you." It depends on the accuracy. You said that. And talk over me. Go ahead, some more. Go ahead.
Well, I never said I got you. I don't do that. In fact, I would like you to get me. I would love for you guys to present something to me where I'm like, wow,
Foucault pendulum, a relatively free gimbal, 3-ring laser gyros, Yokos effect showing the heavier or lighter of an object, weight of an object, traveling east or west at the equator or anywhere else on the Earth, comporting with the spinning size of the Earth. So the list goes on and on and on. You're going to keep saying, nah, but that's not very, it's kind of incredulous, don't you think?
Yeah, it is.
I mean, if these pendulums like were so shitty, right? Like, why have they continued to build them all over the globe?
Because I mean, why does NASA get $63 million a day to show a CGI?
I mean, if like
Because,
these things
man,
don't work,
they really got this. They really got to make this work. They're willing to spend a lot, and they don't even work for the money. They just print it out. They just hit the button.
so like a $20 an hour museum worker that like operates the pendulum is in on the deep dark secrets of the
Not at
NASA
all.
conspiracy?
Not at all. That's your silliness. That's you guys' silliness. You always try to do that.
So like, why are all these pendulums like kind of acting
Because
in the same
people
manner?
get paid a lot of money to say so.
To say so? I thought we had cameras that could witness what they're doing.
Yeah, that too. But you still have to have the money to build them. And then you have to have the access by the club. And, when they find out that you're proving they're full of crap, they're not going to let you videotape their pendulum for like 90, maybe 90 days or maybe 6 months or even a couple of years. Some of them, these guys are really good. Some, they can get them to keep going for years. But
I mean, aren't they like
set up a camera in there to record for 5 years straight, there's going to be some glitches because somebody's got to go in there and keep it going. They all know.
Is there public
You
access
just
to
never
these?
witnessed it.
Is there public access to these pendulums?
For 6 years straight without interruption? No.
What's 6 years straight without interruption? What is that?
Yeah, they've gotten very good with the construction of these things. It's a great magic trick.
No, but
It's
what
all
is
magic
what does
trick.
6 years
The
straight
whole
have
thing
to
is a
do?
magic trick.
Yeah, that's great. But what does 6 years straight have to do with it?
Well, because then you could prove that it actually comes back to rest.
Well, when you say rest, you mean it just no longer like goes around in a circle?
It goes back to where it was when they finished the construction before somebody pushed it to start it.
No, but wait, what?
What, did you not realize that all pendulums are started after the construction?
No, I
is
get
done?
that.
Somebody has,
They don't take 6
so
years.
what I'm saying, you
Yeah.
asked me what rest means, so that is where it goes back to where it was after the construction before somebody pushed it to start it.
So you mean it just is still,
They don't
then,
push it
right?
to start it. They pull it to start
There
it.
you go. Yeah, there
so
you
how's
go.
that-
As in
how's that an
attached to a
argument, though?
stationary freaking plane.
How is that an argument, though? like,
What
okay.
takes 6 years? What takes
It's
6
a great
years?
magic trick. It's one of their best.
But how is that an argument? Though? I'm confused. So okay, it goes back to rest. Okay, how does that debunk whatever Foucault's pendulum? Like, how does that?
Because they're saying the spinning of the ball makes it continually move.
No one says that. We're saying the
No.
spinning of the ball.
Oh, you're saying the spinning of the ball causes it to change its little degrees
Yeah,
from
there
its
you go.
point of reference.
Yeah, there you go.
Oh, right. So where did the point of reference, was the point of reference moving to begin with when they were done with the construction?
Sure, I guess. I mean, the Earth is always spinning, obviously.
Yes, it's moving.
Oh, but it's weird because if that's true, then how come they can't measure the same thing right then?
Because he needs something that has to be relative to something. Something swinging in the swing.
The Earth, it's relative to the spinning.
No, it's relative to the inertial frame.
The inertial
frame. The inertial frame is where something will be if it's swinging back and forth. That'll be the inertial frame. It'll be swinging back and forth. And it has to go back and forth. It can't make. Hold on. It can't make a precession because there's no forces acting on it. It just everything, every object in motion will stay in motion until acted upon by their force. And the only force we have is down. So it's going back and forth in a plane. That plane, with respect to the ground is rotating. That's why I call it precession and not rotation. It's precession. It looks like it's rotating, but it's not. It's actually a precession. The pendulum goes back and forth in a plane, and the ring will look like that rotates around the pendulum. Oh, excuse me. The pendulum will look like it'll rotate around the ring, but in actuality, the ring is actually rotating around the pendulum. I mean, you know how this works. You're trolling or you're really confused. I can't figure out which one.
Well, I'm confused because like there was a meme posted. I guess it's a meme. I don't know. It's just really a picture of a guy holding a thing up. But the picture it says it won't move unless I touch it. So I don't know if that's like you know, if that's supposed to be like a you know, the flat earthers saying like, oh, you know, there's human error because, you know, if a person's, you know, starting the pendulum, of course it's going to drift or whatever. So I don't know if it's that, or if they're thinking that, yeah, the earth causes the pendulum to swing back and forth. You know what I'm saying? Like I feel like some flat earthers are thinking that, which is a little weird.
Well,
Yeah,
no,
he said
but the
that. He
reason
said
why
that.
is because that was the initial, and that was the whole point of them inventing the pendulum, and then it was debunked so quickly because of the resistance and the way they're constructed and how they have to start it. Then they
No.
reverted and they moved the goalposts like they always do, and they're like, "Oh no, it's not it's not the swinging, it's the degrees."
Wait,
Yeah,
when was it ever the swinging?
No one ever said the thing it continues to swing because the earth is spinning.
that's how it
ludicrous.
started, dude.
No,
That's
I
it
how
think
never
you're moving the
started like
goalpost,
that.
man.
They
Ever.
were trying to prove the spinning ball. They've been
No, I
coming up
think
with
they
these
never
things for about
let's see.
500 years.
Hold on, you're moving
No,
your
man.
argument. I think, man. I think you're moving your argument
Yeah,
because
he also doesn't understand what the pendulum's doing.
yeah, because I
Sure.
mean that's not
If
how
that
that
makes you feel
works.
better, that's great.
Well,
If
hold on. I'm not.
that makes you guys feel better, cool.
Well, hold on. Well, I'm not trying to. I'm not being rude or anything. But I mean, because I don't. If that's the case, then fine. You know you misunderstood it though. But where did you see this stuff? Because I mean, like, are you making this up or like what? Like when was that ever? Like, oh yeah, it's the Earth
Dude,
that's
it's
causing it.
your shit. See, this is what they do again. They revert it around, then they want you to prove their. Like, you guys are the ones that brought up the pendulum.
Yeah, but the
Now you want me to prove it.
No, we're not.
And
No,
all I said is my personal observations are total bunk. The research I've done, everything shows all of them. None of them will let you watch them for more than a certain amount of time. They're all protected. They're very expensive. And it doesn't prove anything. That's what's so ridiculous about it. Plus the floor is flat. The cable is flat. The only thing that the ball is the pendulum, and it's not even spinning.
Wait, the cable's flat. Maybe you're right.
Straight.
I haven't actually.
Right. This is what they do. They'll argue about it. Well, is straight flat?
I mean, is it? I mean, I don't know if
if it's that. Well,
I mean, technically speaking, I mean, when I think of flat, I think of like, you know, like it has like it's almost 2-dimensional. It's not obviously because you know, a paper's flat, but that's not like, you know, that's not 2-dimensional. It's 3-dimensional, obviously, because we're in a 3D world, and also it has thickness to it too. But I don't know. I don't think that's not really flat. I don't know. I don't know if I call it.
Yeah, I
flat.
totally get it, man. I
Weird.
totally get that because I'm very specific in my thoughts too. So I totally understand it, and I get what you're saying. That's why I think we should just start calling it level. Because flat is just another premise for another argument. Instead of just going out there and looking at the ocean when you're on the beach and realizing there's no curve, and the definition of something that is not curved is level. You start talking about straight or flat, then everybody just wants to argue about, well, how are you looking at it? Well, is it through this? Is it gravity? Is it density? Is it spinning? When you can just go out there and look and be like, no, there's no curve.
Oh, okay. In any case, I just wanted to bring that up though, because, and once again, I'm not trying to be mean or anything. I'm just saying because I noticed that was posted in this chat, or whatever. So I feel like that, because I hear this all the time. I feel like some flat earthers are still thinking the one thing where it's, you know, yeah, like the Earth does not cause it to swing back and forth.
Globe's already debunked.
Your mic's debunked, man.
So how long does it take to observe a so-called pendulum performing its
Depends
magic?
on the design, man. They've got some that will keep going for like 5 or 6 years.
Yeah, no, but how long does it take to observe it acting in the manner that they say it will act?
Like 20 minutes.
Yeah, that's a great point. They can never actually. Sorry, I didn't mean to interrupt you, but that's a great point because the so-called degrees of their little measurement of whatever, it doesn't match up with the seasons, the years, or anything else. But yet it's supposed to prove everything.
It doesn't have anything to do with seasons.
The ball does. Right?
What does
but the rotation doesn't.
Right. And isn't that based on the pendulum?
No,
Isn't the pendulum there to
just the
prove all that's
rotation.
working and happening? So how come
Just
there
the
isn't a
rotation.
relationship between the pendulum and the seasons? That's a great
Just the
point, Tara.
just has to do with the rotation. It has nothing to do with seasons and its location on
Yes,
the
but the
Earth.
seasons on the ball do have something to do with the rotation of it, right? Hello,
No,
McFly.
no.
Wait, the
McFly.
seasons to do with the rotation. Has to do with the seasons. Have to do with the tilt. That's not rotation.
Okay, okay.
I mean-
Here, let me make it simpler. The 24-hour days, the calendar. How about that? We'll
24
throw
Yeah,
the
only
seasons
thing,
out, but the calendar doesn't match up either.
Well, hold on.
The only thing that changes the precession of the Foucault pendulum is its latitude. It doesn't precess on the equator, and as you move closer to the North Pole, it has an increasing precession.
Well, I would say that would make sense because it's actually it's magnetic, and we live in an electromagnetic dielectric plate system. And when you're closer to the source of the magnetic field, which would be the sun, that's the most intense source of magnetism that we have available. Then yes, of course, it would swing in that manner during certain periods. Of
Yeah, left lane. That was a claim you can't back
precession,
up
as
about
you
you.
say.
My bad.
I know it.
You know
Well,
you
I mean
can't back
that's the story of it. I mean it doesn't depend on seasons or anything like that. It just depends on the rate of rotation and its latitude that it's sitting at.
But that would have to correlate with the seasons on the ball
No,
model.
no, it wouldn't have anything to do with the seasons.
Okay.
It doesn't. It rotates at 15 degrees per hour all year long.
Yeah.
So if I have a belief and I don't know if it's true or not, how would I go determining if it's true? Do I try and like falsify my belief?
Hold
Well,
on,
the
the
sun
15
actually
degrees an hour. Hold on, real quick. The 15 degree an hour all year long thing is also not true, even in your own model.
Is it not?
True. But what I thought was interesting about that is because
Oh.
that's how they measure the ball
Wait.
or the time clock. The sun supposedly moves 15 degrees
Wait.
right, every hour.
Wait. What was
That's
Jeremy
where
talking
all
about?
the latitude, the lines of latitude, and all that stuff comes from. But it
Okay.
doesn't match up when you apply it to the pendulum math.
Hold on. What was that thing that Jeremy said? Hold on. So you said that's not the case? Like, I mean, I never heard of that. Like, what are you talking about?
Yeah, it's an average ARMA, just like everything
In the
else.
globe
It's
model.
calculated average.
In the globe model, depending on where we are in the orbit, I believe.
Right. And if you looked at the
Hold on. So where we are in the orbit?
go for it.
I think it's where we are in the orbit. It gets slightly slower and slightly faster throughout the course of the year.
Well, hold on. I mean, the spin.
Right,
Wait,
but
hold on.
That would make the same sense with the tetherball analogy that I was making. So it would move slightly at a different rate if it's closer to the magnetic source that it's really being attracted to. And it has nothing to do with the spinning.
I'm pretty sure the technical name for this is called the equation of time.
Wait, you're talking about the actual spin, or like just like the
That's
sun
what
in the
you were
sky or some
talking
shit?
about. We're saying that it's actually something else.
No, but I'm trying to
in
figure
their
out.
model. I'm talking about in their model. Even in their model, they have this slowing down, speeding up of the
spin.
That's ridiculous. That couldn't even work
Oh,
in
the
their
sun?
own model. That's absolutely ridiculous. I can't even believe they use the
Hold
pendulum.
on.
It's not 15 degrees an hour all year. That's not a thing. Even in your model, that's not a thing.
Okay, so I imagine it's like it's still close to 15 though, right? But like, okay, but that's not okay. But I'm talking about like this. Okay, but
Speeds up and slows down.
Okay, but the spin itself though, that wouldn't be speeding up and slowing down, right? Because that would
The angular motion of the sun throughout the
Okay.
course of the year speeds up and slows down.
All right, that's fair enough.
Sometimes
seems...
it's 14.9 something. Other times it's 15 point something. Like it's not just 15 all year.
All right, that's fine. I can kind of see
Oh,
how
that's
that could
fine.
work.
Okay.
Well, because I can kind of see how that could work. I can kind of picture that. I mean, you are dealing with, the Earth is also moving around the sun, so you can kind of fudge that. Depends on how much it is though. Like if it's like a full like 16 or 17 degrees, then that's like, oh no, the Earth that wouldn't even. I don't even know how that would work. But if it's like 14.9, some shit like that, then I can kind of see that. That's not too worrying. But the spin would be different though. If you're saying the actual spin is changing, that would be, I don't even know how that would work, because that would actually be that would be weird. That wouldn't make any sense. But all right.
I was just correcting left lane. It's off. Everything he says he gets wrong. Sorry for the
Right.
interruption.
All right. Well, yeah. So if that is the case, then that wouldn't affect the pendulum by any means at all. But
Yeah, I'm checking it out. I mean, would it be fair to say that it's averages 15 degrees all year long?
It may. I'm not even sure if that's what the actual average is.
Well, and it would change based on your location, even by your own standards. So by
if we had
claiming that there's some kind of metric that is the cure-all, proven whatever, when you almost in the same sentence, you'll say, well, it depends on where you're at, the materials you use, and yada yada. Well, it's counterintuitive.
Why we're even pretending that this pendulum thing is a real thing. It's not like it's an experiment that's repeatable by anyone.
Exactly. Unless you have a bunch of money and a PhD and a good
what if you had the Foucault sitting at a particular museum in operation year round? Then we should see a difference in its precession depending on seasons, right?
Until you come up with the proof that this stuff is actually real, don't be a point in discussing it. It's like pop science. It's fake.
Yeah, that'd be nice.
I don't know. Do you measure deviations in the pendulum throughout the course of the year? I don't know, because you guys claim to measure it in the sun. So I don't know. I don't think it's related. I don't think it's related to the same thing though. With the sun, it's an orbit thing. With the changing of the 15 degrees an hour, that's an orbital thing.
Yeah, well,
pendulum is just a rotational thing.
Well, that's kind of interesting, because I mean, it makes you wonder then, right? Like if we notice, right, that the drift, the pendulum is the same, right, but the sun is, hanging up there longer, or whatever, right? That could like maybe tear apart the argument that the sky is what's causing the pendulum to move, like at least in terms of the flat Earth, right? Because if you guys are making that claim and we find out that no, the pendulum is doing the exact same thing, but the sky is sort of like slower, at least in terms of the sun, then that would be. Well, I guess that would be for the sun, though. I don't know about the other stuff, though.
The sun
never mind. Other stuff would have it. Yeah.
The sun and the pendulum are both magnetic, right? They both have magnetic properties, and the circuit of the sun could definitely affect the swinging of the other magnetic material, which would be the pendulum, right? Doesn't mean you're on a ball.
Your depends on things. Well, that's another point, is even if it did do what they're saying that it does, there's nothing to prove that it means what they're saying it proves. We have no other. Like, come on.
Let me see. Get that board. All right. Yeah, I just realized it would just only be the sun, because if it can't be like the stars as well, because I think the whole point is that like the parallax or something of like the sun, because it's more, like local compared to the stars, that we could see like, the sun not moving at exactly 15 degrees, but those stars are effectively infinitely far away. So there would be no way that our orbit could, make those stars last, be slower than 15 degrees. Those should be more or less, like exactly 15 degrees. So yeah, okay.
Yeah, but you throw in things like infinitely far away when at the same time the same people that present the ball model claim that they know how far they are. There's the nearest star is 4.3 trillion light year, whatever, right? They're claiming that they already know. So then when you plug in the math that they claim that they know, and there's no parallax, that's when it kind of falls apart, my friend.
Really? You sure about that?
All over the place. Look at. Have you ever heard of astrology?
Yeah.
Yeah, it's based on a 26,000 year clock precession, right?
Okay, but let's go back to the thing you just said. That you just
said
it doesn't.
Hold on.
You just made a fucking claim about it not working or whatever.
No, that's exactly the point. There's no parallax when you're dealing with these. You guys
effectively
can tell us,
no parallax. Effectively no parallax.
What you mean by effectively is that there's nothing you could observe, but you trust that it's there based on your math. What we're saying, what we like to see, is things that we can actually observe, and that's the whole definition of parallax.
Yeah, but you just made
You're
it
trying
seem
to tell
like
me that it's there, I just can't measure it.
okay, but you just made it seem like punching the numbers would give you like something totally different, or
Those
it
are
doesn't
your
line
numbers. I was punching in not yours, but the people that claim that we're in this ever-expanding universe, the sun and the solar system, the galaxy are moving in these directions, and yada yada yada.
Okay.
Even over 100-year lifespan, you would see parallax in simple constellations like the Big Dipper or all these other astrological signs that people and cultures have been using for not only 26,000 years, but several 100,000 years.
Well, one, I mean, I don't doubt it, but one,
the stars are still there.
Well,
They haven't spread apart. There's no parallax.
Hold on. Well, first off, I don't doubt that, but one, all right, have you actually ran the numbers, or are you just kind of guessing? And by the way, I mean, it's fine if you're guessing, because I mean, I also fine, you know, like that's reasonable. But two, besides the fact, you know, whether you actually ran the numbers or not, you know, at least the ball model claims that, you know, we got the Milky Way, or, you know, the galaxy, whatever, right? That's going around, you know, in a circle, like, right? And it's not just the solar system, it's everything in the Milky Way that's going around in circles, right? So we would expect to see the exact same stars, since it's all going around in a circle, all right? The only argument you could make is that, no, you couldn't make that either. Yeah, I guess no.
Yeah, you couldn't have a Big Bang ever-expanding universe if all the stars are going around in a consistent circle.
Okay,
and
hold on.
Spread apart.
No, it's
they
all
don't spread apart, and that would be your parallax. But you don't. It's never been documented.
Wait, why would it spread apart?
We have landmarks on the ground that have been documented to be in the same place above certain celestial bodies for over 5,000 years.
Yeah, and that's
for
fine.
5,000 years, they still line up perfectly.
Well,
and then
okay.
when you plug in the math and do the math as you asked, you plug in the math about, they're saying these stars are 4.3 trillion light years away, and that math only came into existence in the last 200 years or so, and this testimony of these landmarks lining up with these celestial bodies for 5,000 years go back to Sumerian tablets, and they're still evident. You can still prove it today. But somebody came up with some math about 200 years ago telling me that I'm in this ever-expanding universe when the nearest dot in the sky is actually 4.0 trillion light years away. Okay, cool. Well, over even my short time on Earth, I hope to live a lot longer, but even in the 50 years I've been here, the Big Dipper should be a little bit bigger. They should be out of position. Every single constellation should be slightly out of position and expanded based on that presentation, yet they're not.
Okay, hold on. You just said 4.3 trillion light years.
Whatever, dude.
What was that for? What was that for? What was that?
It's supposed to be the nearest star to us. It's like something like 4.3 trillion light years away.
What the hell? No.
Whatever. You guys move the goalposts.
Well, it's not even close.
You know how large
that is?
We can't.
Hold on.
That's a fact. First, you guys said the sun was 9 million miles away. Then it was 19. Then it was 26. Then it was 36. That's what you guys do. You just keep. But
hold on.
The funny thing is there's no parallax. So if everything keeps getting further and further and further and further away, how come the celestial bodies still line up in the same places as they have 5,000 years ago?
Okay, let's first fix what you said.
You guys cannot answer that.
Okay, you need to hold on. I'll get to that. Okay, but first, I think you mean just miles. You're saying light years, whatever. It's not 43 trillion light years, right? I think that might be like.
I said 4.3.
4.3. That's still too much. 4.3 trillion.
If I can find it on Google, you'll trust it. All right.
No, that's still bigger than that. I think that's bigger than the universe. Isn't the universe like 93 trillion billion light years across? I think it's billion. I could be wrong. I'm pretty sure it's billion.
No. The sun is 93 million miles away, is what you're thinking of.
Yeah, So I think what Flack's thinking of is that he's thinking of it in miles. He's using light years, but he's saying light years, but I think he means miles though, because like that would be too big. That'd be bigger than the universe. That's ridiculous.
I meant light years. That's how ridiculous your model is.
No, it is. The
nearest
pull up
star
right
to
now.
the Earth is 4.37 light years away. Sorry.
Yeah, you said trillion. You're off by trillion.
But that's how ridiculous it is, because if you factor in light years and you measure in the miles to that, you're talking about way more than trillions and trillions and trillions and trillions.
of miles, maybe, but not light
Yes.
years. Though you said light.
Well,
I'm just trying to correct you because that
it's
was
the same thing,
huge.
dude. Whatever. You love to
It's
pick
not.
apart shit, but the facts that I produced are still valid because
What facts?
4.37 light years equals like a few 100,000 trillion miles.
Wait a minute.
And over
What
50
facts?
years, I should look up and see the celestial bodies spreading apart. I should be able to measure even a couple of millimeters with these super high, awesome optics that you guys use.
I thought that
It's
was
not
actually.
there.
I'm pretty sure people
And
have actually noticed
here's
there's a
another
difference.
antidote. Sorry, I'll shut up after this. Here's another antidote.
Okay, man.
Every single so-called space picture, every photo from space, no stars. Every photo from the moon, no stars. Why? Because they can't fake it.
Okay, hold on. So real fast, let me just say this real fast. Okay, so one, unfortunately, I'm a little busy doing stuff, so this will just have to be a discussion rather than a debate itself, right? So, but I believe I have seen stuff where they said, oh yeah, the stars have changed, actually, not like a whole lot, but they have changed ever so slightly, like maybe like fractions of a degree, perhaps, and I mean fractions. But I've seen stuff where they say they have changed. But two, you're not accounting for the fact that once again, everything in the Milky Way, right, is going around in a circle. It's not just the solar system. If it was the solar system going around in the Milky Way, then yeah, we would expect to see different stars all the time. But it is everything, all right? Everything is traveling as almost as if it was like one solid thing, almost. All right. I mean, obviously, it's there's a bit of like imagine like lag on the outside or some shit, whatnot. But point is, it's all traveling around in a circle, right? It's not just the solar system. And now that I think about it, I'm pretty sure there is, a bit of lag actually, but that lag is after it does like one full revolution, I think. So, which hasn't happened in our lifetime, obviously, because that's a long ass fucking time.
I want to mention something, Jeremy. I'm looking for this variation in rate of rotation, and all I can find is something about 2.3 milliseconds per day over a period of many years, but I can't find where our Earth's rotation changes through the year. I can't find anything on that.
Basically, it's not provable, and because it's impossible. They just say that it's the most minute amount that you could never calculate it, and you could have never observed anyone's lifetime of what they claim. They say, there's a little lag after a whole revolution. How do they know? They're just making it up.
No, 2.3 milliseconds. That's something that we wouldn't be able to measure with our eyes and basic instruments, though, right? So if we, go back to the Foucault pendulum for just a moment, if that Foucault pendulum was located at a certain observatory or museum, and it operated through the year, if it was anything to do with seasons or magnetic field or any of that stuff, you would think that it would get a different reading in the wintertime than it does the summertime. Is that what you would think?
You
on
would
the
have
flat
to.
Earth, maybe. No, on the flat Earth, maybe that might be the case, but not on the globe Earth, though. Because once again, I think what Left Lane brought up was once again, I don't think that relates to the actual rotation of the Earth. That relates to like the sun, whatever in the sky. But how much was it again, though? Left Lane, you said how much was it?
It's 15 degrees, bro. It's like 2.3 milliseconds over a bunch of years. It's like something that we can't detect.
Oh yeah, milliseconds. That would be. Hold on. So milliseconds. So 2.3 milliseconds longer in the sky for the sun. Is that what it is? Because if that's the case, then let me see. All we have to do is take the day.
Hold on, Bart. Jesus Christ.
What? What I do?
This is a yearly. I don't know. You're spazzing out. This is a yearly. This is a yearly thing. It happens every year. It slows down and speeds up. I'm pretty sure it's called the equation of time.
Okay, so 2.3 milliseconds.
The 3 days where the sun doesn't change degrees in the sky after the winter solstice.
2.3 milliseconds. That's 10. 2.3 milliseconds.
Is that what you're talking about?
10th 100. 2.3 milliseconds. 2. I'm sorry. I'm talking to somebody. I'm sorry. I'm just. Go on.
I was just clarifying about when you said that it happens every year, sun slows down. There's 3 days after the winter solstice that the sun doesn't change in degrees.
Yeah, it's a pause. Yeah. Doesn't change in elevation and decrease in elevation. Yes. but the rate of rotation stays the same.
Yeah, it's like the whole Jesus.
The sun? Are you talking about the sun?
Yeah, because it's like the whole Christmas thing, the sun, it dies for 3 days, blah, blah, blah.
Yeah, that's what Jeremy was, or that's what Kosho was talking about earlier. That the sun will pause on the
solstices or the equinoxes.
On the solstices.
Yeah.
But it moved at a constant rate over the equinox.
So that's why the equinox
is
is called.
the thing I'm talking about. So maybe check with him or
if it's only if it's only 2.3 milliseconds, that's even if I go with an extra second, right? And let's just say, for example, right?
That's per century too.
Oh,
that's per century.
Yeah, so that's not the thing. That number you got is not the thing I'm talking about. That's not the thing. The thing I'm talking about, it changes throughout the year. Every year.
Well, you need to look that up then, Jeremy, because we have no idea what you're talking about.
This ain't it. This is how your model works, bro. I didn't make this shit up.
Yeah, but you got to help us out here. We don't know what you're talking about.
See, this is what they do. Now
I know your model better than you. We know
their model.
God, Christ.
Flack.
I know, it's crazy, dude.
Flack, don't even talk, man. You said 43 trillion light years, man. Get the heck out of here.
Hey, I admitted I made an error and I posted the actual facts.
Fair enough.
4.7, 4.3 light years is like trillions and trillions and trillions of
Fair
miles,
enough.
and you should see the parallax in the Big Dipper or Orion's Belt or Sagittarius or Leo or any of these signs. You should see that in just 30 years. But just a 30-year lifespan, you could look up and see, oh, wow, it's way over there now.
But you wouldn't, though, because all the stars of the Milky Way are traveling around the Milky Way. And here's the thing, right?
So they're not expanding in the Milky Way. They're stuck. Oh, I get it. So it's like the Coriolis and the sticky air effect, only in space.
Well, I mean, I don't know.
Oh, okay. Now I see how you guys are looking at this shit.
Well, I think there's a limit to how much it would expand, right? Like, obviously, because
that's why they need gravity. I see. No, this is making sense. Thank you.
Actually, I don't even know if it would expand. Actually, because I mean, isn't it? Aren't they?
You would have to.
Well, no, but they're in orbit, dude. No, but they're in orbit. No, hold on. The Big Bang. With the Big Bang, that's like the galaxies kind of spreading out from each other.
Yeah, exactly. It's got to expand.
But I guess everything else is also expanding too. But hold on. But that's the thing.
Exactly.
But what I heard though, the idea is that gravity and a lot of the other forces are, once again, I don't know how legit this is, but they're saying a lot of the other forces, including gravity, are sort of counteracting this sort of expansion or whatever, right?
Right.
So
gravity is the excuse for you to not see what you should see if your math or the spinning ball math worked. If it was real, gravity explains why you don't see that parallax. See, that people came up with this. I mean, people have been going along with the astrological clock for tens of thousands and thousands and thousands of years, before 500 years ago, when people came up with the spinning ball math.
But hold on, but this isn't an argument, though.
They've been questioning this for 500 years. Before that, it was just a known fact.
Yeah, but hold on, how is this an argument, though? Right? So our whatever you want to call it, our belief, if you want to call it that, right, has a story, right? And that story says this is how it works, right? All you're doing is at best like saying like, oh, this is ridiculous. You're not actually pointing out any holes. You're just saying, wow, this is a weird story.
No, stories that say how things work are religion.
Okay, but that's not an argument, though.
But hold on, but science is based on you going out and experiencing the realm as it is.
Okay, but this argument was supposed to be whether.
Difference.
Okay, but your whole argument. Okay, but you had an argument saying like, oh, we should see different stars, but then I gave you an explanation for why we don't, because the stars are all moving with us.
That was a question, but then your explanation was just based in math, and at the same time, I still can't compare your math to the.
Isn't yours based on math too?
No,
you're also you're also saying.
Look at it.
No, hold on. You're saying that we should see the stars move because of parallax, right? So yours is also based on math too. I mean, obviously.
But that's based on your math.
Okay, but math.
I'm not inventing my own math to try to prove yours wrong.
Okay.
I'm using what you have presented, the ballers and whatever, and then I'm going out and I'm comparing it with what I see, and it doesn't add up.
Okay, but we also say though, that the stars are moving.
I'm not inventing anything new.
But the stars are also moving along with us for the most part. All right, so
that's based on your math. That's you guys' model. You guys are the ones saying.
So then you don't have an argument. Then if you're using my math or the globe math, whatever.
I said there's no argument. You can go out there and look, and you can verify with, in my research, I verified with like 12 different cultures all around the world, whether it's Mayan, Incan, Zoroastrian, Buddhist,
the Zoras,
Christian, it doesn't matter. Nordic, Otan, they all the pagans, all of them go off of this same clock.
Hyruleans.
Whatever that you can, I don't know what that is, but I'm just going off of what I've researched, and they've all used the same metrics until
Incas?
500 years ago when some guys said, "Oh wait, you're all idiots."
What are they called?
I mean, you got Stonehenge, you got the Georgia Guidestones, you got all these proofs,
the fairy people,
that the spinning ball doesn't work with the math that you've presented, and that only came up in the last 500 years.
I think you're bullshitting me, man.
Hey, you can think whatever you want, but you have to go out and do your own due diligence. You have to look into Buddhism. You got to look into Zoroastrian. You got to look into Christianity. Look into freaking.
I actually took
the Nordic tribes of Odin and the Mayans and the Incans, and it's interesting because they all go along with the same metrics that were all thrown in the garbage 500 years ago. And to this day, people are saying that all those people are idiots, and you got to believe something that you can't actually verify to be part of the modern cool guys.
Yeah, well, you're not a cool guy.
Yeah, I know. Tell me about it.
Okay. Anyway, any topic that anyone want to talk about? Because this isn't going anywhere. Anyone have anything?
I always like to talk about missing angular height.
I see. Well, real fast, Jesse, I wanted to talk to you about that, the whole ship thing, and because I was thinking about that, and technically speaking, when you're looking left to right, technically, the distance of that ship is obviously increasing, right? Because there's
totally.
So I'm just trying to figure out, like, do you have by any chance like the predicted value for like a flat surface by any chance? Because
it should be flatline.
Flatline.
Because I did the math. I used the arctan. I put for the tan of the angle times the distance gives delta height.
Yeah, man. When you do the right math, your religion is valid.
I was using flat Earth math.
There's no such thing as flat Earth math, dude.
I know, you are correct.
No such thing.
Hey, Michael, you have a lot of experience with these things, don't
math
you?
is math. Yeah, I'm not going to play part of your conversation, though.
Oh, that's funny. I heard you talking. My apologies, sir.
Well, you did hear me talking because there's no such thing. There's planar geometry, but flat Earth math. No, that's just being ridiculous.
Thank you.
So, Arma, anyway, if you think about it, let's say you have a delta height of 100 feet, whatever, and it's at a certain distance, and that creates an angular height of 1 degree, right? If you double the distance, you basically cut your angular height, your angular delta in half, right? Double the distance, half the angle, right?
Pretty much, yeah.
Pretty much. Not exactly, but pretty much. We're using the small angle approximation here. So by multiplying the tangent of the angle times the distance, I've compensated for that because, sure, if it's twice as far, it'll have half the angle, but I'm multiplying it times the distance, so the distance is twice as far, so the result would be the same. So if the ship was moving anywhere on a plane, as long as I take the angle to the top, feed that into tangent, and multiply that times the distance, it will be giving me the actual the vertical axis delta height between me and the top of the ship anywhere, with no regard to distance.
So you made an observation of a ship weighed out at the horizon and used pure geometry. No, the light's not bending at all?
It was only a few miles out, like 7 miles out, I think.
Okay, so the light's not bending at all.
I make no such claim.
Okay, cool. So you make no such claim. Awesome. There's this thing called the black swan. It's an observation of an oil rig where we're just going to use geometry, and it's clearly going to debunk the hell out of the radius value of your globe. We all set? Or are you going to now make a refraction
Yeah, let's
claim
go.
now?
Let's
Yeah,
You want to
let's go.
switch it up and make a reflect?
You can guarantee that.
Reflection.
Well, you can guarantee they'll bring that in there.
Yeah, there's no dispute that when you shoot your line of sight close to the water, depending on the conditions, you can get, you know, the horizon below eye level, lots of obstruction. You can get the horizon at eye level. You can even get the horizon above eye level. I've filmed it all. I've got, you know, just ask. I got it on video and pictures. But I wasn't shooting near the surface of the water. The observer was 58 feet above the water. The top of the ship was 100 feet above the water. And what's more, I did this all in the same day, over a couple hours period or whatever. However long it took the ship to go across in front of me, probably an hour or something. So
got it. So you made a long range observation, went purely off geometry, lights not bending. I'm going to do the same thing. Can I do the same thing?
Well, it's only
I know.
It's only legitimate to, I was going to say, it's only honest to do that when you're doing it in a way that doesn't yield erratic results, right? I can go down and shoot 1 foot above the water like the Black Swan did, and I can get all kinds of crazy things. I can cherry pick to support the globe. I can cherry pick to support the flat Earth. I can even cherry pick to support a really tiny concave Earth. Okay. When you get up,
okay, so when it's
higher
high
above
up,
the
we're not
water,
going to use. Oh, my bad. I thought you were done.
almost done. When you get high up above the water, you lose that ability to cherry pick because the variation drops way down.
Yep, got it. Cool. So we're going to get way high above the water, use strictly geometry. That's what you did, right?
That's exactly what I did.
And you think this is going to work out good for you? Because I'm about to debunk the radius. Are you ready?
Absolutely.
We're just going to use geometry. Right? That's what we're doing? We're just using geometry, right?
Okay.
Okay, do you know what Canigou is?
Uh-huh. It's some mountain range in another country that I've never been to.
Yeah, it's the world record. It's the world record long distance observation. You can go crunch the numbers in and see if you can make that work without refraction.
No, it just barely works with refraction. It's a little bit dipped down without refraction. But refraction is a fact.
No, we're not using. I thought you just said we weren't using refraction. Why are you trying to use refraction now?
I didn't make any
I
compensation
know we're
for.
not using refraction. Remember, we're not using refraction now. I have a now. I have. You said we had to get way high up. I got some shit that's stupid high up.
Okay.
I didn't account. You asked about my observation. I didn't make any corrections or account for a refraction. Okay, that doesn't mean that there are situations where you don't need to, but I didn't in this situation, and I didn't make any such refractions. And I think my evidence still stands on its own, even without correction for refraction. But if you would like to apply correction for refraction, then let's talk about that.
No, I'm cool with not using refraction. We're up way high, no refraction. Good, let's go. I'm ready to go with this no refraction thing. Let's fucking go, bro.
So
you ready to do this?
Let me ask you this.
No, there ain't no asking me nothing. No.
Yeah, just let's go. Let's go.
Are you ready to do this without refraction?
Well, hold on. Can we just seriously let?
No holding on. Let him answer the freaking. Is he ready to go or not? If you want to change the subject, cool. But don't try to sidestep it.
I'm trying to do this real fast.
You ready to do this without refraction, Jesse?
I want to see this.
I'm just going to listen. If I'm going to be taking flack from 3 people at once, I'm just going to listen. You guys can do it however you want.
It's just one
when
guy.
someone wants to have an honest conversation, I'll have an honest conversation.
I'm trying to have an honest conversation. Are you ready to do this without refraction?
Sure. Do what with refraction?
Okay, cool. This observation that's way high up. You said we had to get way high up, then we don't have to do refraction. That's what I'm doing. That's what I did.
No,
and now
I
you're
did not say that. I said when you get way high up, the variation goes away. Because see, remember I said if you're down right by the water, you're going to get wild variation. You could have lots of hidden off the bottom. You could have a flat Earth height horizon. You could have a concave, you could have a horizon above eye level. I said when you get high above the water, the variation goes away.
Okay,
the horizon no longer goes above eye level.
Okay, so you are claiming that in your observation there is refraction.
I claimed neither way. I did not claim that there was, and I did not claim that there wasn't. I just measured angles and plotted it out.
So you have no idea which way the light's bending you have no idea about your variable, which way the light's bending? Real science guy?
I actually have done a bunch of...
What a fucking dishonest conversation. Go ahead, Jesse, my bad.
I have actually done a bunch of experiments, and I think I've got a pretty good idea how light bends, but that's not part of my ship tracking project. This was just a simple exercise to measure the angular height of the ship as it sailed by.
No refraction. Cool. So we're doing measurements and not using refraction. That's scientific to you? Not worrying about the variable, science guy? Fuck out of here. This is the most dishonest, disingenuous, bad faith conversations I've ever heard happen in my life.
Well, if you want to make an argument for how I should have accounted for refraction in my measurement, I'm glad to have that discussion.
We're not making arguments. We're just stating things, and we're saying, okay, here's a challenge. Just like Jeremy said, here's a challenge. Let's talk about this without you bringing up refraction. And you couldn't do it. You couldn't do it. We're not.
What's your point, though?
It's not. We're not arguing. We're just presenting observations and material that you guys refuse to focus on, and you keep redirecting and moving the goalposts and going back into an argument, and then you act like we're the ones arguing. It's just weird.
Are you making the point that the argument that because some things that we do see on Earth would require refraction if the Earth is a globe, therefore there's something wrong with my measurement of the height of the ship as it sails by?
Well, you always use that big, huge if the Earth is a globe. You guys always, everything you present starts with an if, and then it's followed up with assumptions based on things that nobody's observed, which is usually something like math, refraction, or extremely expensive apparatus that nobody has the ability to verify, other than the special club, the PhDs and the people that are making $63 million a day, to tell us that we're idiots.
And then instead of an observation in science, they start with an assumption, always. And it's always a bad assumption.
I know, it's so obvious.
So, Pumpkin, what's my bad assumption here when I measured the height of the ship as it sailed by? I made no assumptions for refraction. I simply took standard trigonometry, which we all know and love, and I used surveying equipment to measure the height of that ship as it sailed across in front of me, and it plotted a curve, even though the ship was going in a straight line. What was the false assumption in that exercise?
That it plotted a curve.
Craig.
And it didn't just fade out of your perspective view. That's your
It's
false assumption.
empirical measurement. Empirical measurement is assumption.
Oh,
wait,
so
hold on. How are you going to say that plotting a curve is an assumption or whatever? He literally got that
because
data.
it's never been verified.
But
and
that's
then
what
whenever they did a Bedford Levels experiment back in the 1800s to blow this argument away, and you guys are still pushing it in 2023. It's crazy.
You've got to wait on Rumpus's results to come in.
You're just saying
they even used Galileo's telescope to disprove it.
Flack, you're saying some weird stuff, man. All right, you're not making really coherent arguments.
Jesse, why are you using standard trig? Why are you doing that?
Well, that's the best I knew how to do. Do you know what I should have used differently? I can try something else.
Well, based on all of your observations that you have made, does everything follow just with standard trig and what you observe in distances, meaning that you can always just apply standard trigonometry and that's going to give you some sort of baseline?
So what are you...
Yeah, exactly. Standard trigonometry cannot be applied to long distance observations.
Of course it can.
Because
It tells you exactly.
you don't see in standard trig.
Oh, you don't? What are you
Well,
seeing?
yeah. You don't see
Yeah.
straight lines as straight, do you?
You've
So,
been
so if
listening.
we see in standard trig left lane, in reality, do railroad tracks meet?
Yes.
That's Trig. Trig predicts that. Trig predicts
That's
that.
right. Trig shows that perfectly well. It's rise over run inverse tangent, whether it be laterally or vertically. It always works. You're just
always
confused.
works. So you're
It
telling me
always works.
So what you're telling me is that the horizon where the railroad tracks meet is always going to be the exact same distance?
It never gets to that distance, does it? Never gets to the
No,
center.
it doesn't. Right. So we can't apply standard trig. Thanks
no,
for
you
proving my
can't. You
fucking
can
point.
because
Why
however
are you
close it
talking
does.
over me,
Okay,
Danik, when
you're
I
talking over
say
me
thanks
because you
for
asked
proving
me.
my point?
I'm trying to give the answer. If it never gets to the center of field of view, it gets close, and the closer it gets, the more acute that angle becomes, and you can now predict where it is in a distance from you very accurately. Accuracy limited to that angle measurement, but it never will get to the center, whether it comes in from the sides, from the bottom, or the top. But trigonometry always works, and this whole
No, it
Witsit
doesn't.
show, yes, it
does
does.
not.
Show me when it doesn't work. Go ahead. Show me an
Bullshit.
example where it doesn't work.
I can give you two different images from
Show
different
me one.
days of the exact same scenario. And if you could just apply standard trig to every single observation over distance and give me the exact location of where everything is going to be, then we wouldn't ever be in this conversation.
We would because you don't understand what trig means or what the trigonometry functions are. So show me this picture.
Let's
run the numbers. Let's run the numbers. Come on, let's do this.
Let's take, for example, the black swan. When you have the bottom of the oil rigs covered, and then when you have the horizon being beyond the oil rigs, can you apply standard trigonometry to both of those images?
There's always going to be an error. Yeah, that's an error factor. You got refraction.
So you can't just apply standard trigonometry. Thank you for
You
proving
can.
my point.
No, you can. Then you apply standard trigonometry that also related. Hold on. And you also hold on. Then you also invoke refraction, and you can actually measure that using standard. Would you stop talking over me? I can't even get a sentence out.
Well, you're trying to move the goalpost.
No, I'm not moving any goalposts. The question is, does refraction bend light? Answer is yes.
That was
some
not
observation.
the question.
Hold
That
on.
was not the question.
Let me finish one sentence.
We got it.
Please.
Yeah, come on, guys.
I am begging of you to just shut up. Let me finish the sentence, and you can talk. So what you can do, if you have
I'm
a
not
black,
gonna let you finish
God
it.
damn it, let me finish the sentence. If I'm talking about the black swan, or you're talking about the black swan, and we want measurements, and it's above eye level, that can't happen trigonometrically. We know that.
It wasn't above eye level.
Well, let me goddamn finish the sentence. What is wrong with you, Napalm? Are you retarded?
Oh, so now you're going to name call me because you're trying
Because
to.
you're acting like you're
shifting the
retarded.
goalpost.
I can't
You're
finish a
shifting-
sentence.
You're shifting
Let
the
me
goalpost.
finish the sentence. I'm
Can
not
we-
moving
guys,
the goalpost.
please.
So
It sounds
you
like
got this
Sanix interrupting a little bit.
No, I'm not. I'm really trying to get one
I
sentence
mean,
out.
it just
And
sounds
it's-
like that.
I know it does, but because
every time
Napalm is grandstanding. Let me just finish my sentence, and I will be quiet. I promise.
He's grandstanding?
So if you have something that is out in the distance and it is above eye level, you can measure it with a theodolite or any kind of measuring equipment. And then you say that's not possible because we're using trigonometry, but this doesn't really explain why that thing should be there. What you can do is raise your position of observation and
Red
measure
herring.
again and continue. It's not a red herring. It's
we didn't
exactly
hear
how
you
you do
the
this.
first time.
It's exact. Let me finish. If you raise your observation
out,
point
man.
if you raise your observation point over and over again, you will plot out a curve where this object should be trigonometrically, and you'll find out what that error is, and you'll be able to determine what that error is at any measuring height. That's how calculus works, and that's how refraction works. Okay, now you can talk. God, you're a loser.
Okay, perfect. So do
You're
you
gonna
have
have a stroke one day, bro.
Yeah, he is. Well, the cocaine doesn't help. So is there any
As a crackhead.
any empirical evidence that within the black swan image that horizon was above a horizontal line, meaning it was above eye level? Do you have any evidence for that claim? Crickets.
Okay,
Yeah.
so what he's saying, wait,
Yes, I
what
do.
he's saying is you can't
You don't,
apply
because you're just trying to
basic.
fucking red
I do.
herring.
I
away
have evidence for that. You want to see
You
it?
cannot apply basic trigonometry
Of course you can. Here we
beyond
go.
your
Here's your
ability
evidence.
to measure it and
So
witness it. That's the whole point of it.
if you're
There's
gonna
your evidence.
provide an image of a surfer involved in that equation at all whatsoever,
Well,
you're taking
for
a
those of us,
completely different video because you're dishonest. I already went through this with you like months
Really?
and months and months ago.
What is the argument? I want to hear this.
So if you have a guy
Your evidence have
in
a
your field
surfer
of
in it?
view, can I finish? If you have a guy,
Are
if
you
you have a
serious?
guy
You
that
said you were finished like 90 seconds ago. Now you got to go
know
off.
how
no,
much,
now he's a new answer. I said one word this time before he said.
New question.
We went over this a while
Like
ago, and he didn't get it then, and he's not getting it now. So we have an object, observation, 1
Jeff
foot
said
off
you're
the
not gonna finish
one.
this time.
Shut up.
Are you
1
alright?
foot
You
off
need
the
help?
ground. As soon as I talk, someone's got to talk over me.
Do you need help?
1 foot.
Okay.
Guys,
1
come on,
foot
for
off.
real. Let's let him talk. Let him talk for real, guys.
Are you out of gas or something?
1
Not
foot
two
off the
foot,
ground.
just one.
1
Okay.
foot off the ground. 1 foot off the ground. We have the observer. We have a surfer, which we know his head and his torso is a little greater than 1 foot. And then we also have oil rigs in the distance. If those oil rigs are above the surfer's head and you are looking at this from 1 foot, that means that the objects in the distance are above eye level. There's no two ways about that.
So you don't have actually any empirical evidence. You're just claiming that if this image is being provided to us, that it has to be in order to fulfill your ideas and your assumptions of what we should be seeing based on observations over long distances. So do you have any actual empirical evidence, meaning anything that involves like a theodolite or the establishment of a horizontal based on lasers or theodolites or any type of survey stuff that says that what we're seeing within the black swan is actually a horizon that is above eye level?
I just posted one for you.
Oh, hold on. Can I also add to that too?
Jesse, you posting something that isn't relevant to what we're talking about doesn't mean that. What I'm saying is opportunities like that can take place. We can see things above eye level. Do you have any evidence that the black swan image is above eye level?
I have my
just
own
gave
black
it to
swan
you.
image.
Well, hold on.
No, Jesse. So you're saying you were in California and you were viewing those oil rigs, and the horizon was beyond those specific oil rigs, and it was above eye level?
I got my own ship in Washington State, and it was.
Oh yeah, so it's not relevant to what the fuck we're talking about. Thank you.
I could still see it from way too far.
Oh,
So
cool.
it's the same thing.
That's not relevant to the image that we're speaking of, right? I never said that things could not go above eye level due to atmospheric conditions. I was asking Zanuck if he has empirical evidence that the black swan image that we all know exactly what I'm talking about when I say the black swan is an image where the horizon is above eye level. He doesn't have that evidence, nor do you. Just because you can provide evidence.
Yes, I do. I provided it to you. That is how theodolites work. You establish a line or a relative line with points based on height. If we know the observer is 1 foot, would you agree that everything that's 1 foot high off the surface, if the surface is flat, would be at that same level? The answer is yes. That means
nope, I'm not going down
everything.
That road because you are
you're just going to obfuscate and dance around the problem and talk over me.
I'm not
You're
dancing
an idiot.
around the
You're an idiot.
problem.
You really
are not providing any evidence. You're just claiming because you can get an image where something is above eye level. You're trying to equate
How
that.
do you get that image, Napalm? It doesn't just magically happen. It's actually how you measure things. Things zooming in or zooming out doesn't change.
Hold on.
No, you hold on.
Okay.
Field of
So just because I can get an image where the horizon is above
Wait, why did you mute him for?
the horizontal eye level, I didn't mute anybody. So just because you can get an image where something is above the horizontal eye level, like the horizon is presented above that, doesn't mean that you can take something else and assume that because the image is above eye level, or because the horizon is at a further distance than normal, that it is above eye level. You have no actual empirical evidence that that is what is taking place.
Well, these photos that he's showing with the airlines, or these HUD views, heads-up display views, what he's
is that what he provided? He provided HUD pictures?
These
We're
are,
talking about
but
the
what?
black swan, and he's fucking
I
providing.
know, but wait. So
Jesus.
if because I've been in these types of planes, and the only time you see that now, if he leaned his helmet over and looked outside of the HUD view, you would see the horizon at eye level. The reason why the HUD
No,
view
you
is showing
don't.
the horizon
You're making a
low
false
is
assessment.
because
Wait, guys,
this
hold on.
aircraft
We're getting off
is
track. We're getting
actually
off track.
heading down.
Yeah,
This
don't even
aircraft
let
is
him go
going
to
in
the
a
fucking
downward
HUD.
trajectory.
Hold up, guys.
That's
We're getting off
by the
track.
green light.
Don't even let him go to the HUD.
Armada,
I
shut
know.
up.
I'm just entertaining
Sorry.
it. I'm just
Because
entertaining it. It's ridiculous because
But
this
isn't
aircraft
he?
is
the
definitely
HUD
going
is
downwards.
completely irrelevant to what Xanix's claim was, that the black swan image, which we all know what that image is, it's the oil rigs off the coast of California. It's a very specific image that has been talked about for years. Xanix's claim is that within that image, the horizon is above a horizontal eye level. And he said he had empirical evidence that that was the case. So
I just showed it to you.
So why would you provide images from a HUD from an
Right.
airplane?
He's bringing something in the past. He's also confused. He thinks HUDs change as you move around. They don't either.
We're
You
not
see what's
talking
accurate,
about HUD.
or you don't see it. Now, going back to the evidence. Listen, I didn't.
Oh Christ!
I know, right?
Can I just bring up a point real fast? First off, I don't even think he brought it up. I think it was
I
Gleam.
would like all of you to consider one thing: you're not going to reach each other, but you need to reach your audience. And you're not doing that when it's just so hard to palate.
Right, but real fast.
I enjoy the conversation, but you're all pissing all over each other.
Yeah.
Cheers.
But real fast. So real fast. Zanuck didn't actually bring up the HUD. All right, that was Gleam. All right, the HUD was from another argument, a long time ago. All right, but he never brought that up. First off. Second off. All right, I just want to real fast, play devil's advocate on my own side. Right, for Zanuck, do we know for sure the camera's height? Right, because obviously knowing the camera's height is important. Right, like because if the camera is 1 foot off the ground, and yeah, the guy that we see, in that picture, if he, then yeah, what you say works, right? But if the camera is, let's say, not the height that it's claimed to be, then obviously that goes out the window. So do we know for sure the camera is like a foot off the ground or whatever? And can Zanuck respond? Is that allowed?
I'm not going to.
No.
Okay, but
obviously somebody muted him. He hasn't talked for 45 seconds, bro.
Yeah, but-
He's muted. Just leave him there.
Yeah, but hold up, he was muted though because people are bringing up the HUD shit and whatnot. Like he didn't even bring that up. Like people are like putting shit in his mouth, whatever. Like he never brought up the HUD thing.
Posted an image of the HUD.
No, today, right
That
now.
was Gleam. Gleam posted the HUD.
Yeah, I'm looking at it right now.
Yeah, look at the chat. It was never fucking Zanuck. So you guys are like giving him another argument to argue about.
Trying
It's like,
to keep up, Princess.
Bro, if we're going to use straight trig on things in the distance, Canagoo debunks you, Black Swan debunks you, a million other things debunk you guys.
Exactly.
Anytime you have the horizon over horizontal, debunks you guys if we're using straight trig on observations. You're not using straight trig. You can't use straight trig. Shit's moving from day to day. How do you use straight trig on that? What, two static positions are moving from day to day?
You're okay in the sense that just using trig. Obviously, you need to make corrections for refraction and whatnot. So I guess in that case, you wouldn't be using straight trig. But I think what they were saying is if you make if you correct for those things, then you could use straight trig afterwards, which doesn't really make sense. I guess
That's not what they were saying. They were saying use straight trig. It's fine. That's what Jesse did. It's fine to use straight trig, right?
Would you like me to apply standard atmospheric refraction?
We're going to have a whole nother argument then. We're going to have a whole nother argument after that. But if that's what you're going to do, obviously straight trig doesn't work for you, right?
Well, what would you like me to apply?
I don't know. If we're using straight trig, I debunked your radius value. Easy, 7 ways from Sunday, all day, 365.
Yep. How did you even establish what a standard would be?
I just looked it up. It was published. I just used the publish when I use it, but I didn't use it when I measured my ship movement there. But besides, how does the lack of applying for refraction invalidate my measurements of the ship height? So maybe maybe it appears a little higher or a little lower due to refraction, but that doesn't account for how it looks curved, does it?
I'm fine with using straight trig. You ready to go down that road?
Well,
where's the crickets on board?
I mean, basically, you're going to say that because there's some things on Earth that we couldn't see without refraction if the Earth is a globe, then therefore my measurement is invalid. But that doesn't follow.
I'm fine with using straight trig. Is that what you want to do from here on out? Because I have a bunch of stuff that's going to debunk your radius.
As long as you're honest about it and you strictly use straight trig for everything we look at.
Fine. That's fine. Yeah. Let's go. Straight trig all day, baby. You ready to do this?
Straight trig, right? Just straight trig. No application of anything else.
Okay,
that's it.
Let's go. You present one evidence, and I'll present one evidence, and we'll see which one comes closer to reality. How's that?
Is there a problem with?
What do you mean closer to reality? Hold on.
Hold on. This image, man, of the ship above the horizon, the horizontal. There you go.
Well, why wouldn't you want to have different? Jesse can back me up on this as well. All you have to do is take multiple measurements at different heights and see if that corroborates for a known distance away from you. If you know the distance to it, you have your answer right there. Every time you raise your observation point, you'll get an angle to it, and that angle will have different values because if there's refraction, it'll give you different angles. But the curve it plots will tell you what that error is. I don't think you guys are fully grasping the message I'm giving you.
So straight trig it is then, Jesse?
Go for it, Jeremy.
Okay, cool. I'd like to use your observation of the horizon above horizontal. Straight trig on that. Do it up. What kind of radius do you come out with?
Which one are you talking about?
Whatever picture you took. Didn't you take a measurement and you got the horizon above horizontal? That one.
Not when I tracked my ship, but I presented one evidence. You present one evidence, and then I'll present an evidence. How's that sound?
Sure, I'd like to present the image you took through your theodolite or auto level or whatever you had when you had the horizon above horizontal.
Okay, let me get you a picture of that.
I don't need a picture. It's fine. Just let me know what radius. We can do straight trig on it. Let me know what the radius value you get.
Dude, I'm glad I looked at the text chat because Zanuck did post a picture of the surfer. Of course she did. It's phenomenal.
Just do straight trig on the measurement you made.
Produce a picture of the surfer, not the HUD. That was way earlier.
Total bullshit, by the way.
You guys are
Total
ridiculous.
bullshit.
Yeah, but I was driving and I called you out and I said, don't use an image of a surfer because that's not from the same video.
It's from one of the videos that shows the exact same effect.
No.
The horizon is above. You said you want to see something of the horizon above eye level. And we see that above eye level based on relative positions of objects we know the size of.
What is the radius of the Earth based on standard trigonometry and that picture then?
It wouldn't have a radius.
It'd be concave.
Concave.
I thought we were just dealing straight trig, boys. Why does your straight trig fall apart?
Okay, I've put an image in the chat.
You are incorrigible.
It shows 2 different days, a couple days apart, where I measured the angle to the horizon, actually to the ship's waterline, but it's pretty close to the horizon. On one of them, it was 2 minutes and 36 arc seconds above eye level, and on the other day, it was 1 minute and 51 arc seconds below eye level. Which one would you like to use?
Whatever time you measure the horizon above horizontal, do some straight trig on that, and let's see what we come up with.
Okay, I can tell you right off the bat that it's highly concave. Do you want an actual number for the radius? It'll take me a minute.
Concave. Wow.
I mean that doesn't fit with a globe. I guess what do we do? Earth's concave.
Right?
Well, you cherry picked.
What the fuck?
Let's go concave.
Wow.
Yeah, you cherry picked that one because I gave you 2 options.
You asked me.
Measurements.
You asked me for one.
Yeah, so
I used your measurement. I used your measurement.
Jesse, the problem here is you said concave, and he assumes that you mean flat, but concave earthers believe the Earth is a sphere.
Right.
Anyways, so
in the opposite direction.
It's still a sphere.
how
Whether
is the
we're on the
baseline?
inside or outside of the sphere, it's still a sphere.
How is your baseline established, Jesse, to just say we can use standard trig, and then when there's a deviation from that, either being convex or concave observations and or flat, what is the baseline?
Do you want us to go higher up? We can get you one higher up, Jesse. Do you want to do a higher up one?
I'll present a higher up one when it's my turn to present evidence, and we can use straight trig, standard trig.
I mean, if you think I cherry pick that one, is it because it's too low? Like, where do you want to go from here? Because I have one that's up super high, where we could use straight trig and it's not going to match.
Yeah, even ones where it's like, oh, this is the curvature of the Earth because we see this horizon. That changes on a daily basis, and we can't apply standard trig to any of those images because it's constantly changing. So which one is the case? Where do we make our baseline, and who has established this scientifically? Do you have any peer-reviewed papers that has established how we visually see the world? Can you provide those in the text chat where this baseline was established?
This is the process of peer review. You guys are reviewing my stuff. You're the only guys that trust yourself. Why would I get it peer reviewed by anybody else?
So is your answer you don't have any peer-reviewed evidence or any scientific evidence where how we visually see the world has been plotted out and we have a baseline that we can apply to images?
All my YouTube videos are peer reviewed, except the ones that don't have comments turned on. But most of them allow comments. So
the answer is no. The scientific community has no peer-reviewed papers and evidence for how we visually see the world. Who's plotted it out to where we can have a baseline that we established?
Anyway, Jeremy, go ahead, Jeremy. Present your evidence that's up high, and then we'll use standard trig on it.
Yeah, you want to avoid the question because you know you don't have any actual peer-reviewed scientific evidence for how we visually see the world. And that destroys your claims that you can just provide images as evidence for curvature when we don't have an established baseline scientifically that would say, oh, maybe that's just how we visually see the world, right?
In other words, you're saying maybe even though it's flat, it just happens to look like a ball?
No, even though it's flat, the way that your field of view presents itself, meaning that if you're a 6-foot observer and you're looking out over the distance, like even over water, the bottom field of view, almost 50% of your bottom field of view is taken up by the ground, which is only 6 feet from your horizontal to your feet that is filling 50% of your field of view, almost 50% of your field of view. So then you have objects that are much higher than that limitation that is taking up the upper portion of your field of view. So you have what is established as a horizon, which is an apparent location, which is only a visual effect due to how our vision presents the world to us. And then you're claiming that this visual effect, which we know can be an optical illusion because things in the distance, the clouds don't actually meet the water in the distance, they just appear to. So you claim that that optical illusion and what's taking place is somehow the geometric leading edge of a physical ball. Yeah, because I have something to say.
Well, so do I. So in that case, seriously though, I mean, I'd be glad to discuss it with you, but you always just flit off like a flea in the night when we actually try to talk about real evidence. So why are you just going on and on about stuff you don't actually have any evidence for? Jeremy was trying to.
You're trying to you're trying to apply some sort of standard, quote unquote, refraction, and I'm asking, where has this been established? Who has done the rigorous scientific work to figure out how the world is presented to us visually through optics so that we can then establish a baseline to say one way or the other whether it's curved, it's flat, or it's convex?
When did I say anything about standard refraction? Where am I using standard refraction here? In my ship tracking project?
Even if you want to remove standard refraction, where does the world present itself to you? How do you visually see the world if there was no refraction involved?
Wait a second. I just asked you a simple question. Where am I using standard refraction? You just said I was using a presumed standard refraction. And I asked, where am I using it?
even if you remove standard refraction,
That's not
we say,
answering where did I use it. You just
said it
said I was
previously,
using it.
and then we said
I'm
we can
asking you,
remove it.
where am I using it?
Jesse, listen, even with it removed, where was the baseline established as to how the world presents itself to us at distances?
Is that
Without
your way of
refraction?
admitting that I wasn't using it?
You were, and you were not.
Okay,
And then
when were I?
when we used your own evidence against you, you say it's cherry picking.
You were and
right?
we're not. Okay.
When were I? All your
Napalm,
were
just
belong
stop it.
to us. Well, okay. So are you done? Are you done, Napalm? Because Jeremy's going to present his evidence, where he's going to present a high observation point, and we're going to use straight trigonometry with no refraction. Okay.
Dude, you're full of it, Jesse. You're full of it.
Thank you kindly. At least it's not nougatous.
So you don't actually have any type of baseline that was established, right, on how we view the world?
You answer my question, and I'll answer yours. Where was I using standard refraction? You said I was. I'm asking, where was I?
I said, without standard refraction, do you have a baseline as to how the world should visually be presented to us?
You'll never have that. You'll never have that. Never.
Yeah. Are you there, Jeremy?
Case in point. Case in point. He'll never have it.
So you're not going to answer. You're just going to ask for Jeremy.
I asked you a question first, Napalm, and you're refusing to answer. Why should I answer yours?
You're trying to divert away from my questioning. That's the point, Jesse. We all understand, and it's getting pretty old, because the whole entire server is starting to realize just how you operate.
Disingenuous he is. Yeah.
Hey, that's not nice.
Yeah, well,
you don't answer honestly, bro.
At least 3 people have brought this up to you over the past week. So
it's just the style that people talk in sometimes. Maybe it's some kind of illness people have gotten used to here, but just this clock sucking tactic, it's terrible. It's like people have lives. No, you do too, Jesse. There's no reason for you to bat this shit around like this. Come on.
What am I doing?
Well, if you really honestly wanted to figure out the truth, wouldn't you be curious as to whether or not there has been some scientific study into how we visually see the world? When you're trying to use visual observations to prove some sort of point, wouldn't you want to have a baseline for that?
Well, until Jeremy gets back, why don't you make your best case, Napalm? You got any evidence?
Why are you now asking
valid,
me a question after I just said that to you?
Do you have any evidence that straight trig is not a valid way to measure the height of something in the distance?
You were like the worst to deal with.
Because I
It's
asked
like,
for evidence. Yeah, I know.
If you can just qualify that you should be able to keep asking the question over and over.
You know why I'm not going to answer that question?
I thought I was the worst to deal with.
Well, you are. So do you know why I'm not going to answer that question, Jesse? Because
Jeremy's tied up.
I personally have not been satisfied in anybody providing to me exactly how the world presents itself to us visually in some sort of fail-safe, this is the silver bullet way to figure out how we visually see the world. I have not been satisfied in that, right? So this is why I don't use observations as evidence, because I have not personally been satisfied by anything scientifically that provides us definitive evidence on how the world is visually being presented to us, because it doesn't seem to follow standard trig. And there's been many things that have been brought to your attention that you guys tend to avoid, that now when they're starting to build in algorithms for AIs and robotics and things like that, in order for it to be definitively accurate, you can't just follow standard trig. There isn't just a silver bullet explanation to how the world is presented to us.
And I say something.
He's following the Witsit playbook to the T here, and it's just kind of comical. We do
What do you
see
mean a
things that
playbook?
follow
That's
trig.
being honest, Sanic.
No,
Do
we
you,
don't.
do you have
The reason we use those types of adjustments in robotics is for different reasons than you're stating here. We do see things as trig lays them out to be
Hey,
seen.
Napalm, I
For
tagged you with the
example,
video.
for example, mountains that are much higher, twice as high, the ones that are twice as close are not in line with each other. That's an indication that we do see things correctly and that the surface beneath us is curved, because that wouldn't happen any other way. And by the way, if there was refraction, it'd make your worse. But you can't accept that, Napalm, and it's very puzzling why you can't.
So do you have any scientific peer-reviewed evidence as to how the world gets visually presented to us, Zanuck?
I've got some evidence that you can review as a peer, Napalm. I just tagged you in the chat at 18 past. I took some theodolites and I measured the angular size of an 8-foot target at 100 meters, 300 meters, and then the spacing between two stoplights at 1,000 meters. And it gives every indication that trig works great at those distances. So unless you can present some evidence that it doesn't work at different distances, then what have you got to go on?
And we fly at 10,000 feet and see mountains that are 50, 60 miles away that are not in a position they would be in if the Earth was flat, because it looks like they're in line. And they are in line. But then as you fly toward them, one's a lot bigger than the one that was blocking it earlier.
We can think of them at the same
curve.
height, because they're effectively the same height.
Yeah, so these are based on your assumptions, right? So you
No,
do you
not
have
based
a
on- based on
baseline as
trigonometry.
to how you have a baseline that has established how the world is going to be visually presented to you?
Like, what do you mean, Napalm? Like, specifically, what do you mean?
Like in all the
Yeah,
surveying
so when I
manuals?
go out to the beach or when I make any observations over distance, right, things can vary and things can appear to be almost as if like they're optical illusions, right? I can see stretching of things. I can see many different things based on observations.
Yeah, don't
right?
conflate miraging with this topic.
When people try to make claims as to, okay, if the Earth was flat, I would expect this mountain to be here. When they say they have that expectation, I want to know where that expectation has been set. What is the standard? Meaning, who has
opposite.
actually done the scientific evidence? Who has
It's not
actually done the
expectation.
scientific work to prove that this is the way the world is presented to us visually over distances? No, trigonometry falls apart.
No, it
And
doesn't. When you're
so-
taking a picture of two mountains and you measure it, you then say the only way that mountain that is twice as high, which is twice as far away, can be well below angularly. Let me finish. The foreground mountain is because the Earth is curved. That's not saying the Earth is curved. This is what we think we should see. We're measuring it and then determining that the Earth is curved. You got it backward, Napalm. You have
things get shorter with distance. So if I'm on a known flat surface and I see streetlights appear to drop down as they go off in the distance, does that mean that those streetlights are actually getting smaller? Or is it just visually presenting itself as though they are going downwards and getting smaller? So when you say the only way that an object that's taller is going to be below something in the foreground is if it's curved. Bullshit. I can occlude a whole entire mountain with my fucking thumb. Does that mean that there's curvature because my thumb can occlude a whole entire mountain?
So the problem with that argument is that if your thumb is above eye level, then yeah, you can obscure the entire mountain. But
Yeah.
if your thumb is below eye level, at or below, then you won't obscure the whole mountain. The problem is, in reality, you can't obscure.
When you guys provide the images, like Zanuck wants to show of these mountains, you have no idea where eye level is in those images because you can't just draw straight
We
across
don't need
the photograph.
to.
What do you mean you don't need to? That's
Because we know the
legitimately
altitude.
your argument.
Okay.
So if your argument is
no.
that
Let me just finish. Let me just say something.
Object in the foreground, you say that the
I'll
mountain
let
in
you
the
finish. Go ahead.
foreground is above or below your eye level, and you have no actual documentation of it.
We have the
your
documentation.
whole entire argument falls apart.
Well, no, nothing falls apart. So there's two ways you can do this. We can have three known elevations, three objects, like the observer, and two objects.
You have none of this evidence.
Can I just finish this?
Yeah, you have no evidence.
Or you can have.
You have none of this evidence.
Can I just finish?
Provide
I know it's two part.
This
Let me
mountain
finish.
in the
It was just, you know, it's two part. You said all your things, and Jesse jumped in and said what I want to tell you. You get it wrong every time.
You could finish
I
line.
don't get it
Just
wrong.
let me finish.
You have
Let me
no
finish.
fucking evidence. Don't try to teach me as if I'm just getting it wrong and I don't understand. You provide an image that is cherry picked that has no indication as to where the horizontal is, where the eye level is, what the observer height is, and you just see a mountain that we know is taller appear smaller than a mountain that is in the foreground, and you say, this is completely impossible if the earth was flat. And you have no actual empirical evidence of what's taking place in that image at all whatsoever. It's the literal definition of cherry picking. You guys are fucking disingenuous.
But
You won't even let me. You won't even let me finish. Let me just say the evidence, okay? Because we have the evidence. The observer's 1,000 feet. The 50-mile peak is 6,400 feet, and the furthest peak in the background is 14,000 feet. There's the evidence. Now that's simple trig. You don't accept it. I get it. You do not accept trigonometry. What's the same
height?
thing. Hold on. Let me finish. Fuck. Let me just, dude. You talk forever, monologuing. You
observer
cannot
height?
let me finish a sentence. What is wrong with you, Napalm?
I think you've had a lot of time to.
No,
say
no.
it.
If you add up his time, I guarantee it's 4x mine. Just let me just finish the sentence. I'm not asking for paragraphs, just a sentence. Now, if you it's the same information, same evidence as if you had a theodolite and were able to line up mountains in the distance. So we're
That's
not
a
talking about
sentence.
doing that. Okay, forget it. I don't know why I even try with you guys.
But that's a sentence, right? Like you realize there's a period at a certain point, right?
Yeah, so what you're saying is the image that you're providing, there is no actual known observer height, no known horizontal that's been established to say whether something is or is not above the eye height of the observer. You just have an image where a mountain in the distance that is bigger appears lower than a smaller mountain in the foreground. Guess what? Shit shrinks over distance. You have nothing.
So, what if I were to set up a water tube level to establish a horizontal eye level plane?
Like I said before, Jesse, where has been your established scientific evidence that what you visually see and how it's going to present itself to you? Do you have any peer-reviewed evidence on how we optically see the world and how that is going to present itself to us?
Well, you mean like all the surveying manuals?
Do you have something that you can provide?
Sure. Let me go find some surveying manuals.
So are surveying manuals considered scientific proof? Has this been scientifically fleshed out, or are you just referring to don't use a geodetic surveying?
No survey manual is going to confirm curvature.
No, but they tell us how perspective works and they tell us how angles work and all that, right?
How did they establish that?
No, I don't think they do, Jesse.
They don't, but how would, in theory, they establish that information? So if I wrote a book, how would I establish that baseline for me to make a claim about how things present themselves in the distance?
I mean, do you really want me to go find something peer reviewed? You're just gonna discard it because it's from the mainstream, right? It's got to be peer
Did I
reviewed by
say
flat
that?
earthers, right?
No, I'm asking for who has done the science. Like I said, my only goal is to figure out the truth of the matter. And for me, like I said previously, I have not been satisfied with anything that has been presented because there's so many different ideas from experts in the field as to how the world gets presented to us visually. So you want to breeze over that and just go on with assumption, that's fine, but that's not acceptable for me personally. But if you want to just go based off of assumption and what feeds your agenda and your side of the argument, cool story.
So you're saying that you don't think I'm right, but that you also can't prove that you're not wrong?
Did
You
I
don't know
say
that
that
I'm
I
wrong,
don't
right?
think you're right and that I can't prove that I'm wrong? Why don't you actually just address what's said? I'm
Do you
sorry.
know that I'm wrong?
I'm disengaging with all of you guys. I'm done. You guys are so disingenuous. You literally don't answer questions and you can't stay on topic and you shift the goalpost constantly.
It just seems like
But
for a
what if
guy
I
that
shifted the goalpost over here
Are you a science denier, Jesse?
I don't even know what that means. But
do you deny science?
It just seems like the guy that on your
That's a
side that's taking
question.
up
It's not what it
90%
seems.
of the
Do you
floor.
deny science?
I should be kind of confident that he's right, and you're just basically saying that you haven't seen consistency in how you see how the world's presented, and so you don't know what it is. So you don't really have an argument one way or the other.
Who
You
has?
just
Who has
secretly know
established
it's a flat Earth.
I'm asking for who has it. Did I say that? Did I?
Yes, you did say that.
Is my claim that any observation is proof of the Earth being flat?
Right. You have no claims one way or the other. You have no evidence one way or the other. As far as you're concerned, you just can't tell by looking because you don't know how reality presents itself.
So then
right?
your previous statement is completely false and incorrect and is painting an inaccurate picture of me because I have not made the claim of any observation specifically pointing
Well, I gave you an
to
observation.
and
Why don't you
proving
respond
the
to it?
Earth being flat. Have I? No, I'm asking for the scientific evidence for the baseline of how the world presents itself to us
I just
visually.
presented
Why
something. Can
wouldn't,
you?
if you guys are scientifically minded, why would you not want to start there? That's the
I just presented
foundation.
it. Can you review it for me? Can you peer review my example? What does that
No,
mean to
I'm
you?
asking for peer-reviewed scientific
This is
evidence.
peer reviewed. Jesse, will you peer review that? You're my peer.
Looks good to me.
I got a
Oh,
picture. I got a
so-
picture of a 1,000-foot observer. I got a 6,500 foot peak in front of me, which we know is 6,500 feet, and then we have a 14,000 foot peak behind it. They're 50 miles apart. Everything's 50 miles apart. How do you have this observation? And scientifically speaking, how do you
What's
not
the
have this
observer height?
observation representing a surface which has a curved shape?
What's the observer height?
1,000 feet.
Did you provide this evidence? Is it a picture?
Yes,
Just
the evidence is. I provide all the evidence you want.
I told you that we're not just presenting images and then making claims.
No,
So
it's,
what
I
you
have
guys are
evidence. I have
saying-
I had the
Hold on.
data there.
You're
1,000-foot
saying
observer on the chart. It's at a park. That park is
your
outside of
idea
Portland,
of peer
just
review-
south of Portland, and it is a park you can go to, and it's 1,000 feet.
So what you're saying is your idea of peer review is you can just present an image and we can all talk about it, and that's the peer review process.
No, peer review is
do you
me
not
explaining
believe
it
in
to
the
you,
scientific
and then
peer
you peer review it by saying, okay, Zanuck said the observer's 1,000 feet. He drew a diagram representing 1,000 feet, shows a mountain that everyone knows about, Mount St. Helens, 6,400 feet, marked on it as such, and then another mountain 50 miles further away, which is Mount Rainier, which is 14,500 feet, which everyone knows is 14,500 feet. And then draws a triangle to represent those three data points. Now, it doesn't take a genius to figure out what the shape of the Earth would have to be for this observation to be true. But you fight it tooth and nail because you think we don't see things as we see things because you've been listening to the Witsit show.
I haven't been listening to the Witsit show. First of all, I've been involved in this well before Witsit was, right? Either way, what I'm saying is I'm asking for the establishment of how we visually see the world scientifically, meaning it's been fleshed out. There is no question about it. So when Jesse has an image where a ship is above, a ship and the horizon are above his horizontal eye line, is that refraction that's taking place? Is the Earth concave? What is actually taking place? Because where is our baseline to measure against? You say it's just regular standard trigonometry, but then when you go actually look at what the experts are talking about, there is no definitive idea as
No,
to
that's not what the
how we
experts are
can
talking about.
specifically apply mathematics to what we see visually. And if you guys don't want to actually have a scientific establishment of that baseline, you just want to utilize images to feed what you already think is the case, you guys aren't actually being truthful in trying to figure out the world around you. Sorry, you're not.
I'll be back later, but all these ballers are just like blowing smoke up your ass with their falsehoods and their claims.
That's not what that means.
I'll be back later though.
I just find it funny that when you ask the
Really, Zach?
ballers about the science, they want to just be like, we'll just peer review it right here and blah, 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 as if like they don't, for many other arguments.
You went, I keep on getting
about where's the science?
We're
Where's this been done experimentally? Where's the peer reviewed evidence? But then when it comes down to something like this, you just want to brush it away.
Yeah,
Because
tag you
the
with some
only
at
thing you
32
guys
after.
have for the globe is misconceptions of observations and how we visually see the world. That's it.
Right,
That's
right.
all you guys have.
Exactly. Zadok and Jesse alike, they're going to try to mathematically tell you the way things we should see them.
I would love to
But
get a sentence out without having to be muted or something. I'm trying to be
I would
mindful of
love to.
your space there, Napalm, but
I would love to get a sense out without you interrupting. By
you're
the way,
drunk.
shut up. You interrupted me, bro. Shut up. So these guys, Zadok and Jesse and alike, they want to throw in this falsehood that they themselves can't even calculate. By the way, Zadok, please calculate it. Go ahead. I'll shut up.
Thank you. I can calculate it. The thing that I wanted to tell you, Napalm, clearly, is that we can take these measurements, even the ones where we have a convex appearance of the Earth, we start using calculus. And calculus is the ability to actually start making changes with your
Calculate
observation point above the surface and see what happens to the representation of the angle for that observation. And then what
Calculate
you
it.
find, Napalm, and I hope you're listening. If you start raising up your observation point, you'll find that error will get smaller and smaller and smaller until it gets to be a
Calculate it.
consistent change of angle, which represents the change in height directly, without any kind of error. And then you can go back and plot what that
So
curve looks like and see where the error is, and actually how much the error is, and determine what the error would be at any measuring point by that information.
Calculate it.
You're not
Zadok,
listening. I know you haven't listened because you got. I know
Hold on.
you Apoco, you're talking over me. Napalm, you're just already have your response already in your mind already, so you're not listening either. But this is how science works. You have the information of measurements, change the variable, an independent variable, which would be height, and see how it reflects this angle. And you'll see the angle will change to be more true to the distance to the object as you go higher, which means there is an surface, which we all say there is, called refraction. Thank you.
Zadok, you said you're going to calculate it. Now fucking calculate it. Go ahead. Put the fucking formula in the chat. Go ahead. We'll wait. We'll wait. Go ahead.
Here's the thing. When you said error, Zanuck, what is the error based on?
He's muted.
It's based on where the object should be, where it is, based on the observer's height.
So
Zanuck.
hold on. Stop right there.
Go ahead.
So when you say where the object should be based on observer height, the should is established by what?
the surface being flat, based on triangles, trigonometry, as we have started this conversation out with.
Wow.
So when
if you have a triangle,
the surface being flat has established the baseline, do you have any evidence for me as to where people have done scientific experiments to prove how a flat surface would present itself to us over long distance visually through optics?
Optics or eyeballs,
I can
or
tell
anything
you one thing.
you can measure
on a
these
flat
positions
plane,
with a camera, with your eyes, with theodolites, with every kind of tool you want to use.
So is
to
the
have
answer no to my question? So I asked you a question. Do you have where somebody has established scientifically how something would present itself to you optically at distance?
I've already told you about this.
he just indicated he does not know. He just indicated that.
So can you provide me with that information?
Napalm. We told him. I told him post this mathematical equation, and he never did it. He will never do it.
Yeah, no, I don't even care about an equation because I want to see how the equation was derived and what
derived from
somebody
trigonometry.
what somebody did scientifically to prove that, okay, when we're talking about visual space, we would have to experiment with visual space, meaning, okay, we have a controlled environment. Now we're doing things optically, moving things in a distance, continuing to maintain an actual horizontal level surface, and then getting some sort of baseline as to what we visually see.
Yeah, and Zanuck could not post that when we asked him for it. He couldn't post it because he's just spouting off from the side of his neck lies. He's telling you one thing, but he can't back it up with evidence to
Yes,
prove
I've given
what
you
he's
the
saying.
equations and I've done the math for you. You just can't remember because you're drunk.
Post it. Go ahead, post it. Post it.
One of them is
So
in
if
the chat right
everything,
now. The other one was aviation, where we flew over at 35,000 feet and had
I'm
an
waiting.
airport with a green and white flashing light 200 miles away that should have been 1.5 degrees below level, yet it was
That's not
3 degrees
equivalent.
below level. So there is
That's not
evidence.
that's not equivalent. That's not
That
equivalent,
is
Zach.
but
No, it's
it
not.
is. That's exactly what we're talking about. All
No, it's
these things
not.
we're seeing, and we can actually have a descent rate to go to that point in our field of view that
If
comports with what we're seeing. There's no optical distortion. There's no
if
azimuthal grid of vision that's any different than in trigonometry. Or those positions of these objects in your field of view would actually dictate. You're just
if
making shit up because someone
so
said, "Oh,
you
we
have
use
proof
now
of
this
scientific
azimuthal
reason.
field of grid and curved vision in a robotics now," which is
Zadok,
true. They're being much
Are
more
you just
accurate
going
in
to
positioning of
continue to
these things.
talk around it so that you can avoid actually presenting
exactly.
scientific evidence?
Zadok, if you think that's
Yeah.
equivalent, then you misunderstood the question. If
Yeah.
you, Zadok, think that's fucking equivalent, then you misunderstood the fucking question at hand. Because I'm drunk as fuck, Zadok, and I still understood what Napalm was asking you. And for some reason, you fucking can't, bro. Come on, bro. How does that, what does that mean to you when
I
I'm
understand that
out
he's
of my
just not
mind?
honest,
Yeah,
Apocryphon, and
exactly.
he came in to save Jesse because Jesse was against the ropes. Hey,
Right. That's
Yeah.
facts right there. That's facts.
You guys just drowning in bullshit. Zan's trying to throw my life preserver.
Yeah. Okay.
so do you have scientific evidence of any of this, Zanuck, or are we just going to talk about how it is the case? Because I could just talk about how visually, if there's anything that comes above my horizon or dips below my horizon over distance, I can say that's just how the world works and the earth is flat because we know it's flat. And I can just say that and establish that, but I don't do that, right?
Wow. Crazy.
Yeah. Speaking of which, does your trigonometry tell you that objects will disappear from the bottom up on a flat plane? Does your trigonometry tell you that? Distant mountains will vanish from the bottom up. Do they say that? Where's the trig on that?
Right. Does your trigonometry tell you what happens to something that is over the visual horizon and how that's going to present itself to you? Because we know that just under 50% of your field of view is going to be filled up with the ground. As you look off into the distance, almost 50% of your field of view standing on the surface of the earth is being filled up by the ground. So you have from your feet to your eyeballs, and just under 50% of that visual field of space is filled up with ground objects. And then we have
And the sky comes down, right?
very large gap between our eyes and things that we see really high up in the sky. And when those things get further away from us, how are they going to interact with this horizon that is being falsely set as an optical effect in the distance? Do you know how that all works? Is it just basic trigonometry? Because based on basic trigonometry, where is that horizon going to be set? And how are things going to visually appear that are higher than those things in the distance? That's the big question.
Exactly. That's exactly right. Crickets. Crickets, by the way. Crickets. They can't answer that.
Well, they just have rhetoric. That's my problem with it. Is it's just fucking words. It's just rhetoric. There is no actual scientific. You guys, all you globers want to boast about science, this fucking peer review. We know because X, Y, and Z. Here's our experiments. Where are your experiments about the visual space that we have, how the world presents itself to us? You don't have any. You just have baseless claims, meaning there is no basis to these measurements that you're taking, the claims that you're making on how the world's going to be presented to us at distance.
So here's the problem, though. We can do measurements, and I've done a bunch, and trigonometry does seem to work. So unless you have some evidence that counters that, I don't see why you need to assert that it doesn't work. You don't know that you don't.
So when you measured or you made an observation where a boat appeared above a sign that you know that sign is above sea level, but you had a horizon and a boat that appeared above that sign, can you give me the mathematics and the trigonometry for that image?
Well, no, because I went back the next day and the horizon and the boat was all back down below the sign. So what we can take from that is that, and this is important, you should pay attention to this. Any measurement method which yields wildly varying results is not consistent and it's not reliable, okay? You got to pick some method that's at least consistent, right?
So if we consistently have atmospheric conditions that give us an artificial or an optical horizon under normal everyday conditions, we're seeing something that isn't actually how the world is being presented to us. Does that mean that since we see that more often, so let's say if you went out to the water and on a consistent basis, the atmospheric conditions gave you that ship and that horizon above what you know is actually higher than it, does that mean that we can establish our baseline as being a concave Earth?
Well, no, all your measurements have to be consistent.
Right. So if we have atmospheric conditions that show us the opposite of that, that we live on a convex Earth, can we say definitively that even though these are what we normally see, is our normal atmospheric conditions actually what is taking place? Or is our normal atmospheric conditions giving us the illusion of a horizon at a specified distance that appears as though we live on a convex Earth? We wouldn't want to establish our baseline off of either of these observations, regardless of what we normally see. We would want to do scientific investigation to remove as many variables as possible to really see ultimately how that the world presents itself to us.
So then I guess it would make sense if near water measurements provide uselessly wildly varying results, it would make sense to go higher and higher and higher and see if we got consistent results somewhere else, right?
Why does that make sense?
Well, because any measurement that varies wildly from day to day is not dependable, right?
So like I said before, even if you were getting the exact same image on every single day, how do you definitively know that what you are observing, even though it's consistent, is related to what you're claiming based on an assumption?
Because then I try it also at 100 feet and 1,000 feet and 10,000 feet, and I see if they all give the same results. If one of them gives different results than the others, then something's obviously wrong. Right?
Like I said before, you have to establish a baseline. What is your baseline? To where you say, like Zanuck was saying earlier, there's an error. Okay. Error based on what? All of our assumptions of how things are taking place. I don't care about the assumptions and the assumption that if we get higher, somehow the observations that we see are more consistent. But if they're more consistently showing us something that is a like a bending up or down either way, just because it's more consistent doesn't mean that it's accurate to make an assumption off of that consistency.
It's not what I said. I said you take observations, you deviations, where an object should be and where it is, and
Should
that
be
rate of
based
change,
on what?
whether it be flat or curved, starts to stabilize at heights that you can then assume very easily that what you're measuring at the higher heights is more accurate in the lower heights. And then you can actually decide what the error is, but the deviation as a deviation from the mean. The R-square value of that curve will be better at the higher elevation than at the lower elevations. That means how well that data that you've achieved, you've acquired, represents the actual data set.
So
How
like
well
I
the
said
curve
before, you
represents the
have
data
to
set. Sorry.
establish a baseline for that data set for you to be able to say,
you create
okay,
the data
we
set.
go up to 10,000 feet and we view something 100 miles away.
Perfect.
Right. If we go up 10,000 feet and we view something 100 miles away, and it always consistently seems to be within some sort of error bar, right?
No error bar.
We see a consistent observation at this distance. How are you making the definitive claim that what you're observing is giving you a consistent curve or a consistent deviation from flat? How are you eliminating whether or not it is a deviation from what's taking place or it is a what is always
well one of the major most important is angle of refraction. And if you're changing the angle of incident by going higher and it's not affecting this particular result, then you can then be rest assured that it's not refraction anymore. There's not refraction anymore because it would be changing it precipitously. If you raised your position, you change the angle and you saw a deviation. So you're not seeing that deviation anymore.
Cool. So that's a cool claim. Do you know
Not
anybody?
a cool claim. It's true. If you believe the refraction is real, that's how it's established.
Interrupt. Who established this scientifically?
Snell did.
No, Snell's. Dude, don't even bring Snell into it. If you wanted to actually maybe come close, you could bring in Fermat. But Snell deals
Snell's
with
law.
Snell's law deals with light's deviation from normal when it's interacting with two different mediums, right? So
that's exactly what we're doing. The differential medium is what we're talking about. The differential form of Snell's law is what we're establishing here.
Hold on, I'm not going to let you try to slip in differential for different. I said two different.
That's what it means.
No.
So it means change.
Within the atmospheric. So when you're making this observation at 10,000 feet over 100 miles, what is the second medium that the light is interacting with in that observation?
Depends on the rate of change of the angle.
What is the second medium that light is interacting with?
The gradient in the atmosphere.
The gradient is not what Snell deals with.
The differential form of Snell's law is the gradient. Oh my God!
You're fucking lying.
No, I'm not lying. You are so ignorant of these concepts. Unbelievable.
Because you don't fucking comprehend it and you're disingenuous does not mean that I'm.
You have two mediums. You have a dense medium and a not. You have a dense medium and a not so dense medium.
Where
that happens along. So you don't think the differential form of Snell's law exists?
Give me a citation.
I asked the question. Can you answer me? I'm not going to do anything for you until you answer the question. Do you not think that the differential form of Snell's law exists?
It's called Fermat's principle. I told you.
No, I asked you about the differential form of Snell's law.
I told you.
Yes or no?
Going to have to deal with
I'm not going to respond to you
because you don't even know what the fuck you're talking about. You're trying to apply Snell's law to a gradient. Can you give me a citation where Snell specifically applied his principle to a gradient?
He already knows if you try to apply Snell's law, you're going to be way off. Ruhif admits it. They all know it. They know you can't use Snell's law. I don't know why you even said that, Zanuck.
It's so disingenuous. And they come back day after day continuing to spout this crap, dude. You would think that if they were operating under good faith, I've been around for a very long time, right? I've been in the server for a decent amount of time. Has anybody here ever had me present some sort of observation as evidence for anything?
No, you just waste time. You have no evidence.
The reason I don't provide an observation as evidence for anything, because I have not been personally satisfied that what we are seeing optically has been established to have a baseline scientifically. So I don't feel comfortable just being like, here's an image, this proves something.
I just posted the differential form of Snell's law, so there it is in the chat. You think you know things you don't, Napalm, and it's just really, it devalues your intelligence, just so you know.
Here it is again with the
You just said we were going to use Snell's law. You know you can't do that.
That has no application to Snell's law, what you posted.
Why would you say that? Do you even know what it is?
Nope. I haven't even looked at. I haven't even looked.
Well, because you don't know what the differential version of anything means. What does that mean?
Can you walk me?
I can tell you what it means.
Yes, I can walk you through it if you'd like.
I can tell you what it means.
Go ahead,
Hold on, let me answer this question. I can tell you what the differential means. It means it's different, not the same. So not Snell's law.
Doesn't mean different. Well, it kind of does, but it means a change. A change.
Differential
Differential is a
Snell's
change.
law. It means not
A
Snell's
differential.
law.
So when we have Snell's law, basic Snell's law, we have a medium and an angle of incidence. The differential version would be a constantly changing one of the other, either the constant changing density or the constantly changing angle. Both could be a differential version of Snell's law. That is something known. It's in physics. I just wrote down the equation, and it means, well, we can say, let's suppose, here's, in fact, I'll just post this right here.
Did you write down Snell's law? Because that's what we were talking about. You said you use Snell's law.
It's a differential version of Snell's law.
Okay, so you're not Snell's law. Definitely not going to use Snell's law.
Differential. Dude, think about it for a second.
Come on,
I'm giving you Snell's law, and I'm saying there's a differential version, which means along its path, constantly changing the angle.
Which means different.
And we're
not Snell's law, something different.
Exactly.
No, it is Snell. Hello, differential
Just say it's
version
Fermat's
of Snell's
principle.
law.
You can fucking
It's
move
not
on.
Fermat's principle. Why do you keep on saying Fermat's principle?
Because that deals with gradients, does it not?
We're not dealing with the radius. We're dealing with a constant change. It can be due to all sorts of things. The change in medium, it could be a change of the refractive index, it could be a change of the angle of incidence, and it could be a change of the gradient.
Stanek, why do you believe these lies, bro?
So here's me read it to you. The Snell's law in the form of n sine theta. Okay, that constant is useful in calculating how a ray lies bent and traveling from one medium to another where there is a discrete change of the refractive index. If there's a medium in which the refractive index is constantly changing, a differential form of Snell's law may be useful. This is obtained by simply the differentiation of n sine theta equals a constant. To obtain the differential form of Snell's law, I wrote it down in the chat. And now we can we can plug in those variables to do calculus to figure out what the refractive index, how it would change, and what the effect on the light bending would be as far as angle.
Solely based on an observation, what are you plugging into that equation? Solely based on like going up to a mountain, snapping a picture. What data are you plugging into that equation?
We're gonna so as I mentioned earlier, we're gonna back into it. So we don't want to assume the sphere, right? So what we do is then we start raising our observation point and start seeing the deviation from where this object should be based on flat or curve. Use both. We do them simultaneously. Part of the mathematics. And at the end of the day, we figure as we go higher and higher, make small changes in incremental changes of elevation or observation elevation. And at the end, we find out which one better matches the data that we're getting based on the known distance to the objects and the known angles to them.
Zanuck, you're just saying stuff. Hang on. Zanuck, you're just saying stuff. We're telling you, you wouldn't know what a flat
It's
looks
called
like.
math. It's called things that you have no clue about.
What data are you plugging in for your differential within Snell's law? So Snell's law would deal with two different mediums and two different refractive indexes.
Not just
so
two different
when you yes, it does, Zanuck. So within your differential equation that you apply to your observation based on Snell's law, how are you gathering the data to put into your differential equation based on the atmospheric conditions?
Crickets.
It's like you're not even listening.
That's a great distraction away from what I just said because you have no answer.
I'm telling you how this works. I'm telling you how you do this. You
Then
change, you back,
then
you
And
don't
I'm asking you,
we don't
and
know.
I'm
We don't
asking
know.
you,
We don't
within
know.
your observation, if we're taking a differential of Snell's law, which deals with mediums, different mediums, right, which have different refractive indexes, how are you establishing what different refractive indexes within the medium in your visual space need to be applied to your differential equation? How are
It's,
you getting that data?
it's like you're not listening. I already explained it to you. We're not using the data. We're not gathering any
why
data. We're not even
not?
putting
Why not?
So
because
you're not using that
we don't
equation.
know it. We don't want to assume anything. So what we do is we back into that differential.
Wow.
We go back. We back into the differential form of Snell's law from the reverse direction. We start measuring the data, and then we figure out what those angles
How
and what the
convenient.
Hold on.
differential reading
You're
will be.
measuring the data. What data are you measuring?
The angles that we measure to an object that is a known distance away.
Okay, so you've got an angle. So now we know the angle. So how are we going to know what the normal would be?
We take another measurement slightly higher up.
Whoa. Hold on.
It's called
So
different. It's called
our
calculus.
measurements are
You don't
only
know how
going to
calculus
be
works, obviously.
so our measurements are only going to be angles. So within Snell's law,
yeah,
or any differential of it, with I guess whatever you posted, I'm not even looking.
Of course, you're not looking.
What portion of that equation is the angle?
It's the answer. It's the answer is the angle.
So the answer is the angle. Okay.
Correct.
So now we know that the answer is the angle. So we're making an observation and we're getting an answer.
Right. We're getting the answer, and we're getting the answer for every one of these tests. So the reason we use calculus is because we take multiple measurements. I've said this 100 times. Assume flat or round. Do it for both scenarios, and see which one fits. Which one fits? Which you're not listening. Which one fits that distance, known distance, to the object by raising the observation point. Now, as this change stops, hold on. Both will have, as we go higher, we will find that both will stop changing, and then we'll figure out which one is actually more valid: the curved assumption or the straight assumption, based on the change and based on the lack of change as you go higher. That will back into Snell's differential version of Snell's law. You're not getting this. I get it. You just want to talk to me.
Here's the thing. You've said all we've measured so far is angles, which is our answers within your equation, right? So I'm trying to figure out your differential equation. So we have the answer portion of it, which is the angles. And now you just said a whole bunch of words, but you never actually determined any other data input into that equation.
Exactly.
So the other portions of that equation, where are you obtaining those values? And can you tell me within that equation which each value applies to in reality?
Thank you. It shuts him fucking completely up.
No, you can't just keep on muting me every time you don't like what I say.
I'm not muting you.
You get the answer at any one of those values. You'll get the answer that's for Snell's law and the differential of it, because you've got the answer. It's kind of like having an answer in algebra and having variables stacked up, and then you fill in the blanks to equal that answer. So now we can figure out and have a mix. We might not know exactly the proportions, but we will know which one is correct and true based on
first observation.
how far. Okay, I'm not gonna deal with this.
We'll take our first observation because you're avoiding it completely. We'll take our first observation. So we have our angle, which is our answer. So within just one observation, how are we building in the other data solely based on our answer of the angle?
You can't. You got to take more. That's the whole idea about calculus.
Okay, cool.
You're not understanding differential equations, integrals, or something that are foreign to you. I get it. You've never worked in calculus.
That's not what I'm saying.
But you can't get an answer for the.
Zadig, just listen to him, Zadig.
So cool. So we've got our angle from observation 1. That's it. We have no other data points to derive any type of equation. So now we take observation number 2, we get an angle. So between those two things, we have 2 observations. Can you tell me where we're gathering the data to fill in the other aspects of the equation, which deal with refractive index of mediums, and or if we're doing your differential and you say that it claims to take into account a gradient, how are we measuring that gradient and the different refractive indexes within our observation?
why are you assuming there's different refractive indexes? Give the air 1.004 or something. That'll be the or 1.004, whatever that number is. We'll keep
I'm
it constant.
glad you said that.
So we'll say that that's the refractive index of air,
no
which everyone
difference,
agrees. Which
you
everyone
asked me a
agrees.
question, I'm going to
Hold
answer.
on. Which
You
everyone
asked me a
agrees.
question.
And so then now we're going to say the rest of those variables will account for either angle, and we're
Bro, you
changing it.
asked me a question.
Hold on. Let me finish.
You
We're
didn't answer
changing
my
the
question,
Okay, so
and
you're
you
not going to let me
answered
answer.
my question with a question, dude. You can't do that. But I'll answer your question, even though you answered my question with a question because you have no actual data input. And you said, oh, well, why are we assuming those different refractive indexes? We're dealing with the atmosphere. Then why are we using an equation like Snell's law or a differential of Snell's law with deal with different refractive indexes of different mediums and or a gradient if you say that we have no difference in refractive index?
Exactly.
Yo, this is the thing Zanuck does right here, where he goes, measures an angle to an apparent position, has no baseline. Then he moves, measures another angle to an apparent position, still no baseline, and just keeps doing this and doing this with no baseline ever, and then thinks he knows where the stuff is without making any presuppositions about the shape of Earth or anything.
Because when you start making those changes in altitude, you stop seeing changes in where the object should or should be. That
You say
determines
should based on what?
either flat or round. I'm giving you everything you need. You're just not.
We'll have to
I'm
deal
giving
with
you.
the
I'm
opposite,
leading you
brother.
to the water. You're just not drinking. It's okay.
You have no baseline. That's
Just
the
stop with
point.
your baseline. You're starting to bore. So it's okay.
Yeah, Zanuck, you fucking you're not at least addressing his like evidence. Why you do that, bro? At least address the evidence. Why you be so dishonest? It's almost like you just had to take a pause to for whatever reasons. Dude, come on, bro. Like at least address his evidence, bro. For reals. Can you or no? Is that a yes or a no? What's going on?
I see drunk people.
Yeah. Zanuck, Z, whatever the fuck you want to be called. Address what he fucking claimed to you, bro. Like, be honest with yourself. Fuck the community. Be honest with your fucking self, bro, because he made a lot of sense. Would you agree to that? Yes or no?
No, he made very little sense.
Wow. Why does everybody around you get it, but you don't?
Find someone who's not a flat earther that gets there. He said.
Okay, that's fair.
Can you provide me a non-flat earther that has done the scientific work to prove how visual space is presented to us optically? Or do you just want to make assumptions about it?
Provided you scientific evidence. We have the Black Swan. We have the pictures of the mountain. We have HUD's display of at 40,000
So who
feet.
are
Between those four random observations, I can give you a very, very gross version of the differential form of Snell's law.
I don't care about your uneducated
those are actually
opinion.
more accurate and at higher altitudes, and they're less accurate at the low altitudes. Meaning we have refraction that happens at the low altitudes, very close to the water, and the temperature inversion is a real thing. They've measured those things near the water. That particular day, we have the day, we have the water temperature, we have the air temperature, and we know what the temperature is near the surface. And then we can easily extrapolate through differential calculus or even just by simple measurements where would be the most accurate measurements of where these objects should or shouldn't be.
Yeah, I don't
and you
care
can do
about
that by measuring, and you do this by just raising your observation point and see when there's less change from where they should be and where they are based on the angle. And that gives you all the answers you want. Now you're not listening because you're already establishing your next response to try to shoot me down. But if you thought about it for a second and realize that that's how calculus works, and that's why they do it, you might get it and might realize that we do live on a sphere and that those measurements near the surface are inaccurate because of refraction.
Did that make you feel better about yourself to say all that?
I don't need to feel better. I already feel really good about myself. So don't worry about that.
Yeah, I know you
But
do.
thank you for caring.
I feel like Zanuck loves Zanuck
Because
a
sharing
lot.
is sharing.
I feel like Zanuck
Absolutely.
loves Zanuck a lot. So I don't really care about your uneducated opinion about this stuff. Do you have any scientific evidence that you could post that backs up your claim?
I already posted it.
No, you didn't. You posted a differential equation, and you couldn't even answer how we would input data into that
I did. We
differential
back into
equation.
it.
No, you didn't. You're a joke.
That's not
You think the world's flat, and I'm a joke. Okay.
Hey, Zanuck, you don't get it, bro. You fucking honestly don't get it, dude. Everything that's pointed out against you, you want to hand wave and try to you belittle, you mock. But when real evidence, like what he just provided you, real evidence get provided to you, and you just want to fucking you laugh at it, bro. Like, come
Where's
on,
the
dude.
science, bro? We're just asking for the science of the establishment of your
Exactly.
claims. So are
I'm
you
out
the
of here.
science? Are you the citation, Zanuck?
He is a
In this case,
citation.
I'm the citation.
God damn. I'm
Yeah,
I'm
exactly.
gonna jump pandas. I can't stand Zanuck. Goodbye.
Well, Jesse said he was doing it scientific earlier, but he wasn't worried about that variable.
How are you guys doing tonight?
We're great. How are you doing?
Why is Zanuck rattled? What are you guys doing?
So Charlie, I have a question for you. Do you think that the best way to go about making a educated assumption or establishing some sort of factual information would be to use some form of science?
Sure.
Yeah. So let me ask you a question, like just straight up honest question.
Mhm.
Have you ever seen anybody prove out scientifically through experimentation and documentation how the world visually is presented to us?
I don't know what you mean by that question. What do you mean? First of all, what do you mean by have I seen it happen? Do I need to be present there when they perform an experiment, or can I just see the resulting documentation?
The resulting documentation.
Okay,
Have you
so
seen any evidence?
Well, what do you mean by how the world presents itself to us? Can you be more explicit about what you mean by that? Because that's very vague.
Sure. Yeah, visually, because it's an interesting conversation, right? So when you delve into people's thoughts and ideas as to how we perceive the world and how perspective and the world gets visually presented to us, you get a lot of differing information. And I was just wondering,
What do you mean by how the world gets visually presented to us? Like, what is the world, and what do you mean by visually?
the world. Do you understand what reality is and like what you see visually?
So hold on.
Are
Some
those
people
interesting concepts to you?
Let me give an
Of course, they're
example. Look,
interesting questions.
how
But
how
some
would
people
this look?
some people refer to the world to mean like Earth, or like what some other people would colloquially refer to as the universe, or reality, right? So
All of the above,
again,
yeah. Yeah.
okay. So when you say
How
the world,
that
you
is
mean
presented to
everything.
you visually.
Have
Okay,
a mountain.
so you're talking about like the experience of consciousness, really, not
No,
just
no,
like,
no, 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 no. Just observationally, the visual representation, right? So we know we can use things other than our eyes to get a
Mhm.
visual representation of the world. We can use a camera and we can produce an image.
Okay,
And
so
we can
you're
look at that image, and that image looks very close to reality, but not exactly perfect to reality in the way that we perceive it visually, right? Slightly off, not
Right.
by much, but that's what I'm talking about.
I see.
How the
Okay.
world is presented to us visually, optically.
Yeah. So the best thing that we could do, right, is build models which account for as many physical effects as we can perceive and know about, and see if those produce the same things that we actually perceive, right?
I
So
agree. Do you know anybody that's actually gone through the motions or the process of trying to prove this out scientifically?
yeah, of course. I mean, I've seen it with, for example, the physical descriptions of models of cameras, right? So when we're talking about like what projections are, right, which is really what we observe, right? A 3D projection into a 2D plane, which we call an image that's on our retina wall, right?
Right.
We have we could talk about the equivalent of like a camera, right? And there are different models of different cameras, lensless pinhole cameras, and also
Yep.
cameras with lenses, right? And
Yep.
then we observe what the mathematics, excuse me, we predict what the mathematics tells us that we should observe, right? And every once in a while, we'll see, well, there's really what we call chromatic aberration in reality, and the model doesn't capture it, right? Or there's really
Right.
radial distortion in reality, and the model doesn't capture it, right?
Well, hold on. We don't actually see chromatic aberration in reality. We see that through the images, right? So chromatic aberration would be on the edges of the image, typically based on lens quality. You would get chromatic aberration. But when we're talking about like refraction through the atmosphere, we don't actually see a chromatic aberration on something that we see in the distance or something on the peripheral of our vision ourselves. It's only through cameras and optics that we get that chromatic aberration.
So my understanding is that the human eye does have has a lens, which means that it technically does it can have the effect of chromatic aberration, like that can be observed. I can't think of something off the top of my head, but surely we can look one
Right.
up.
But
Maybe
the
hell,
paradox of like the observing chromatic aberration, which tends to happen on the peripheral, is kind of like a paradox of you can't visually go move your eyes to the periphery of your vision to actually focus in on what may be chromatic aberration, right?
I don't understand what point you're trying to make by that. Are
Like
you
if we
trying to
take
say
an
are you
image,
trying to say that because we can't focus on it, that therefore
well,
we
if we
can't
take an
observe it?
image with a camera, right, and we can look at that 2D representation on the paper, and we can see where chromatic aberration is taking place, typically on the outer edges of the lens, depending on lens quality, right? So if we say that that same effect is taking place within our eyes, do you have a good way of you personally seeing chromatic aberration?
I can't think of one off the top of my head, but as I said, I'm sure there's probably something that we can Google that we can probably do right now, right?
'Cause
There's
I
there's
feel
there's a ton of like fun at home experiments that you can do
Sure.
to demonstrate all sorts of funky effects that the eyes can have. Like I know of
Like
one
the
where you can
blind
actually
spot,
see,
right?
yeah,
The
yeah,
blind
exactly.
spot,
And I
stuff
know
like
there's
that,
one where you
right?
can actually see like the veins in your eyes, right? If you poke a hole in like a white piece of paper, put it against a screen, and then you move it in circles. It would not surprise me if there's something like that for chromatic aberration that we could just see.
Gotcha. For me, like I don't know of anything that would show us chromatic aberration, and I know that if I move my eyes to try to go to the periphery of my vision, it's my focus is just completely shifting. The middle of my image is shifting, so the chromatic aberration is moving. It's nothing that I can actually like focus in on to differentiate whether or not it's chromatic aberration or not. Does that make sense?
Yes and no. I get your point that it's difficult to observe things that are in our periphery, right? By definition.
Mhm.
But that doesn't mean that they're not real effects and that we can't observe them through our own eyes.
Sure. I'm sure there's tests that could be done or something like that that may give us some sort of idea as to the extent of chromatic aberration that may be taking place on the periphery of our vision.
And attention in your vision is more. It's not like you can only see one point in the middle of your visual field, right? It's more like an area that
It's pretty
where
small, honestly, for
I
humans, but
agree that
yeah.
it's small, but it's not a point, right? It falls
Right.
off as you get further from the center, right? But
Correct.
it's not like a hard drop.
Correct.
But anyway, why do you ask the question though? Like,
Right, because when we're talking about making an observation, right? If I'm making an observation of the world around me, and I know that, in theory, railroad tracks don't actually physically meet, but they appear to meet to me visually, right? But I know if I'm using other senses like sense of touch, I can touch all the way down those railroad tracks for the whole length of them, and they're always going to be the same distance apart. But I know that visually they can appear to come together. But I know in reality they don't actually meet, right? So we have these things that take place optically that are presenting the world to us in a way that is familiar to us, right? Because we've always had this perspective of the world. So it's familiar to us, but isn't an actual direct representation of reality, because we know in reality railroad tracks don't actually physically meet. So the appearance of them meeting
is what I would consider like an optical illusion, right?
Okay.
So how that presentation comes to us and how we visually see the world, has there been scientific experiments and definitive things that have been done to fully flesh out exactly how we see the world? Do you think it's as simple as we can just apply straightforward trigonometry and that is always going to give us an answer to what we are seeing in the world?
Yes-ish. I think the vast majority of the effects that we see can purely be answered by just basic optics, which is just geometry and trigonometry, right? I think there are always going to be effects which
I would
are
agree.
not.
Most of it.
Yeah, I think there's always going to be effects that are not explainable by just that.
Right.
And at
And
that
those
point,
effects tend to happen towards like the center point of your vision or the horizon line, where we see things that, you know, even I would like to think that even every glober would say that the horizon is an apparent location,
well,
meaning it's an appearance of the sky or things in the sky appearing to meet the ground when we know that they don't actually physically meet, similar to the railroad tracks, right?
I don't understand your point. But
So
it doesn't
that
have to
point
mean
of
peripheral.
convergence is where we see, the closer you get to that point of convergence is where we're going to have deviations from.
What do you mean by the closer you get?
The closer you see things to that horizon point.
The closer you see things to the I don't know what it means.
So if I'm
closer,
standing in between railroad tracks,
Uh-huh.
I know that if I look down, visually I can see that those railroad tracks are separate. And the closer that as I raise my head and I look further off in the horizon, the closer that those railroad tracks are to the horizon, the more they appear to not be separate.
Okay, so the closer they are in the image to the horizon, right? Because they're not
the image that
physically
is being presented to you. We're talking just strictly about human eyes right now.
Correct.
Right?
Yeah.
So
Okay.
would you say that the closer the railroad tracks get to the horizon line optically for you in your field of view, the more likely they are going to appear to be something other than what they actually are in reality?
I don't know what that means, right? So
the railroad tracks actually do merge.
So the railroad tracks actually touch
Optically.
each other.
Optically, yes.
Right,
So-
which is not actually taking place. It's only optically
Correct.
taking place.
So
So it's appearing to meet. It's apparent.
I mean, to me, I don't even think about it in those terms, right? To me, I think about it in terms of, can you give me a model which is consistent with reality that can reproduce what you see? Right. It's as simple as that.
Yeah. Can we do that?
Yeah, of course we can. If we're talking specifically about the railroad tracks having perspective, yeah, all you need. Okay, so we do it all the time with 3D graphics, right? It's called perspective projection. You take the position of the camera, you model your railroad tracks in the real world, right? You orient your camera in the way that you want. You perform a projection based on whatever parameters of the camera you want, like field of view in the X and Y direction, right? Then you perform what's called a perspective divide, which sort of, after everything's sort of projected into a single plane, which is called the image plane, it sort of shrinks all the points that were originally further away to be smaller and smaller, right? I mean, this is done. This is how it's done in 3D games, right? In 3D games, you are in a 3D world, and you can put down railroad tracks in the 3D game. In the 3D game, if you look up, you will see the railroad tracks sort of meeting together in the image, right? So I don't know if you would call that an experiment, but at the very least, they can.
So when you talk about
what
these,
you observe.
Yeah. So when you talk about these 3D games, are you saying that when you're playing a 3D game, it appears the same as reality? So like if you walked outside, the appearance of the game and how it's presenting, how it's being presented to you is the same as you see visually in the world, or very close.
As it pertains to perspective projection of railroad tracks, absolutely, yeah.
right? It's very close.
Yep.
So within the gaming industry and within games, can you provide me with any specific games that model into how they perceive the world through perspective, that they model in a specified curvature to the ground level in which they are building this 3D world?
A curvature like a spherical planet?
Mhm.
No. I
Okay,
can't think
cool.
of a single one that I mean, I actually that's not true. I mean, I will say
For
the
the
vast
most part.
majority.
Mario
Majority.
3D did it, but it was weird looking.
I can think of
Back in the
Prey, like
day.
the original Prey had it. I think I mean, I don't know about like the new like space games like fucking Star Citizen, right? I think they might do it. Like they might actually have like a sphere in which
But
you're
when you
actually
get
part
like
of.
to the ground level, really, I mean, like Mario 3D was one that initially did it, right? Where they built the model of the environment based on a sphere, and it looks very weird. Like it's very obvious that you're on a sphere.
Yeah, because the
So
sphere is
these
very
other
small.
games, like with anything, you're going to take the easiest path to be able to produce the thing that's going to most closely relate to reality. So like in the gaming industry,
Correct.
if you're going to build an environment, the easiest thing to do is to treat it as flat.
Yeah, well,
And
it's not because it
use
most
perspective.
closely matches reality, but it's because it is easier to code to just assume everything is on a flat plane, right?
I agree.
Especially if your game doesn't care about planetary scales.
Sure. I agree. So when we're talking about these gaming environments and you're saying this is how we build out the perspective, we make no input or assumption of curvature strictly because it's easier. These games look pretty realistic,
Mhm.
very close to reality. Where would you say, aside from the gaming industry, right, which we've kind of just established doesn't build in any type of curvature to the ground surface in order to give us an image that matches reality pretty closely, where would you say anybody has actually physically mapped out, trying to control for as many variables as possible, how that perspective strictly applies to the human vision through scientific experimentation?
Well, I don't know about the human vision, right? But I do know about simulations, right? Which I mean, what they give you is the output of a camera, right? I've never seen it done through like a model of the human eye, although I'm sure that they might exist somewhere, but I haven't heard about them.
Okay, cool. At least you're honest about that. Like, so I don't know how late you came into the conversation, but I don't present, or I don't typically put forth observations as proof of anything. And the reason that I don't do that is because I have not personally been fulfilled in the explanation as to how the world gets visually presented to us and how we can use like a silver bullet claim as to what's taking place. So I don't make any assumptions and go out in the world and say, okay, I'm snapping this image, I'm visually seeing this, let me go ahead and use this as proof positive for X, Y, or Z, whether that be a concave Earth, a flat Earth, or a convex Earth. Because I haven't personally been satisfied with any scientific definitive evidence for a baseline in which I could then try to figure out a deviation from a baseline of perspective. Does that make sense?
Yep.
So that was our conversation previously, and there was other people that were claiming like, oh, we have this definitive blah blah blah, but there was no presentation of actual like scientific evidence to back that up. Like, hey, we've taken multiple people and we've given them objects and we say place them here or do this or do that, and
where do we expect certain things to be? And if things are here, how is that being presented to us? We have a known flat surface with a known lack of refractive index, or we have known refractive indices, and how those apply to us visually. There's just not enough information that has been done in that realm for me to make a definitive claim one way or the other solely based on optical either observations or measurements or anything like that. Because to me, in order to make a measurement, you have to have a baseline that you're measuring from to give a definitive claim as to. Does that make sense?
Yeah.
There's a lot of presentations of like, oh, this thing in the foreground, which is smaller than the thing in the background, presents itself as though it's larger than the thing in the background that we know is actually bigger. There's many things that can take place that can give us the optical illusion of something in the foreground that we know is smaller, appearing as though it's larger than something in the background that we know is larger.
Check. You know what this?
Yeah, sorry. I kind of took over the VC for the last hour.
No, that's fine. You're good. We all get our shot, bro. You had your shot.
Yeah.
Everyone gets their fair shot.
I listen a lot, and I get to a certain point where it's like I can no longer remain calm about the lack of actual empirical things to back up some of the claims, and it just gets frustrating.
Yeah.
I feel your pain, bro.
Hold on, just real quick though. I want to do it just a hard topic change, real, because I just thought of something. In the globe model, when the snipers take their shot, they're doing one of these 2 mile whatever joints, and they got to lead the target to adjust for Coriolis, right? Right, Charlie?
I'm
About
sorry,
that
what?
sniper shit.
What?
When a sniper shoot like a mile or 2 miles or whatever, they gotta lead the target to adjust for Coriolis, right?
Typically, yeah.
Yeah, that's when the bullet goes in a straight line and the Earth rotates. Basically, your target rotates into the bullet and you meet it, right?
I don't know if that's a fair description of it, but
How would you describe it?
I haven't reviewed Coriolis in the last couple of days in order to give you a
Then
fair
how do you know that wasn't a good description of it? What I just said.
I never said I know that it's not a good description of it. I said I don't know if it's a good description of it because I haven't reviewed it.
Oh, okay.
Jesus.
My bad. I thought you were trying to diss my shit. Like, I'm like, what the fuck?
No. The general point that they have to correct for the effect, though, is true. Depending on which direction they're shooting, right? The rotation of the Earth is what they.
Yeah, that means they fire the bullet straight where the object is going to be. They lead the target.
I
made a perfect
I
description.
don't know if that is a fair description.
That is a perfect description of what's going on. What do you think they do when they? Okay, what do you think happens when they have to adjust for Coriolis? How do you picture that happening in your mind?
I don't know. Jeremy, I just told you I don't know.
Well, I just gave you a perfect description of what's going on.
How would
They're
I know
leading the target.
How would I know that's a perfect description?
I don't know. I am
You
the
just trust me,
citation,
bro?
maybe. I mean, you could go look it up.
I could. You might be right? What I'm telling you is that I'm not familiar enough with the subject right now to confirm
Okay.
your description.
All right, fine. That's fine. Yeah, you don't know. It's fine. This is going to be the magic bullet. Like literally right here, this bullet thing. We got this, guys. We got this. Don't worry. You don't know if that's a fair description. What? I'll tell you right now, that's what's happening. When they have to adjust for Coriolis, they're leading the target. There's nothing else to do. I don't know what else adjusting for Coriolis would mean, but that's definitely what's going on. They're leading the target. Does anyone else have any other ideas on what might be happening when they adjust for Coriolis?
I thought Coriolis is going from like the one speed to like okay, so like obviously the equator, the Earth rotates or moves. The surface of it moves roughly like 1,000 miles an hour, right? And obviously at like the poles, it's 0 miles an hour, right? So I thought it was at least this is what I thought. Coriolis. Hold on, let me finish.
Bro.
Yeah, okay. So I thought it was going from like, for example, 1,000 miles an hour to like 0 or something like that, where obviously it's a difference in like speed.
Listening? Were you even listening to the conversation?
Are you listening to me right now? I'm telling you what I think Coriolis is.
No, but here's the question. The question is, what do you think a sniper does when they adjust for Coriolis effect? What do you think they're doing?
They're adjusting, but I don't think they're aiming where it's going to be, though. I don't think that's necessarily the case.
Okay, what do you think it means? What do you think it means?
I think the bullet is probably actually just. Yeah, I don't think it works like that. The bullet is doing a weird thing, though. I don't know.
Yeah, so like Jeremy, I'm not saying this is the way that it works, right? But I could, I thought it was a little bit more complicated than just they're shooting where the target's going to be, but also that there are forces or effects on the bullet itself. So it's not like they can just adjust the aim to where the target's going to be. It's more like they have to adjust their aim because their bullet's going to land somewhere else.
Yes, they have to adjust their aim. They can't shoot where the target is because it's not going to be there by the time the bullet gets there. They have to aim at where the target's going to be.
Can I maybe clarify? So what he's saying is, what would the process be? So like, if I know I'm shooting say 1,000 meters and I know that the wind's 3 meters per second, right? I can say, and it's going from left to right, whatever. Okay, I can then adjust where I'm shooting to the left slightly or to the right slightly to compensate for that. Cool. So that's the process for adjusting to the wind. What's the process for adjusting to Coriolis?
I don't know.
Because that's what he's asking.
It's literally the same thing you just said, only for Coriolis and the wind.
Okay, cool.
But then the question is like, do they do that?
No, I'm willing to say they do it. For my argument, I'm willing to say they absolutely do it. Let's go.
You said
this is the magic bullet for my other argument I've been on about for weeks now.
Yeah, I feel like you've been trying to get me to commit to a claim, but I just don't.
You don't know. I know. Yeah, you don't know. It's fine.
So think of it in terms of this, right? If you have a rifle scope, things that you want to take into account when you're making a shot over distance is you're going to want to factor in the distance, right? Drop over distance. So the further out you are, the more you want to aim above the target. Then there's something that you also call windage, which is an estimation of the wind in which direction it's coming in. And there's 2 different knobs on your scope that deal with both of these scenarios, right? The first one deals with your distance, right? So you make an estimation of that. You adjust that knob based on how far your target is so that your target comes to the middle of your reticle based on your adjustment, meaning I'm looking out at this object. I've got my crosshairs directly on the object I want to shoot. I know the distance. So then I click in the distance on my knob. And once I know the distance and I've clicked that into my knob, my reticle has changed. So now I need to readjust my reticle so that my target is directly in the middle of my reticle based on my distance. Cool. So now I've got that set. Then you have a second knob that is dealing with windage. You have 10 to 15 mile an hour winds coming from your left to right. You're going to click that into your windage thing, and it's going to now move your reticle into a direction that would counter that, so that when you're actually aiming at your target, your reticle is going to appear as though you're pointing directly at it. But you've made adjustments for drop over distance and windage. So if we're dealing with Coriolis, what kind of knob do you think there would be, and what adjustment needs to take place for this other thing that we would deal with?
Yeah, I mean,
is this like for the sake of? I mean, are we just
you know,
speculating here? Because I mean, anyone who doesn't know how Coriolis works or isn't like
you
like
don't know.
well,
You don't know. You don't know that they're leading their target.
okay, I'm just that's what I was asking though. Like, are we just speculating? Or are we like what's going
No,
on here?
I'm not speculating. I know exactly what this would look like. This Coriolis thing. I know exactly how they would adjust for it. They would shoot where the target's going to be. Obviously, duh. You have to, because there's not controlled flight. You have to shoot where the target's going to be.
So how do you know where that target's going to be? And if we wanted to put our reticle in that position, meaning the object that we're going to try to hit is going to be in the middle of our crosshairs, what adjustment are we going to make? And how do we come to that adjustment? What are we plugging in?
So my understanding is that you need to know the distance to the target, and you also need to know your direction to the target. My understanding is that the force, I think it's a fictitious force, right? That the bullet feels is dependent on the distance, and I think it might also have to do with the velocity of the bullet, and the direction.
So in your scenario, we have 3 different inputs. How does that apply to what we're visually seeing through our reticle, and what adjustment are we going to make? How are we going to make that adjustment?
I don't know anything about ballistics.
Yeah, obviously we're going to shoot. I'm telling you right now, the only way to do it, the adjustment for Coriolis is obviously not shooting where the target is. It's you have to shoot it where the target's going to be. Duh.
Well, Jeremy, you keep saying that, but
Let me know when these guys get up to speed.
Jeremy, let's say Coriolis wasn't the thing, all right? And we live in a flat Earth, and Coriolis is not a thing, yeah? If your target is like 2 miles away, would you aim at the target or aim at where the target's going to be? Or something else?
If my target, if there's nothing affecting it, I just shoot where the target's going to be. If something's affecting it, I shoot where the target is going to be.
Right, but you realize that
What I say the first time?
you realize that effects don't just apply to the target, but they also apply to your bullet, right? Like if you're firing a bullet, you have to aim
Yes.
above the target.
The Coriolis effect is there's no force going on or anything. All it is you need to shoot where the target's going to be.
Okay, but
that's
that's
the
like
Coriolis.
saying
That's
if I'm
how a
shooting an
sniper
arrow,
would adjust for the Coriolis effect.
that's like saying if I'm shooting an arrow to a target that's like really far away, I'm not shooting at the target, I'm shooting at where the target's going to be. I think everybody in the room would say, no, you're shooting above the target to compensate for the fall of the arrow. So I think it's a little weird to phrase it as I'm going to shoot where the target's going to be.
So we've taken care of the drop over distance and how the wind's going to affect the bullet with the 2 knobs on my scope. So how are we figuring out where we need to point our gun based on the Coriolis?
My understanding is that the Coriolis effect also has a component that also affects vertical drop. So it's not just drop because of distance; it's also drop because of distance with Coriolis.
You think it's drop? You think they're adjusting on a up and down for Coriolis?
My understanding is that there is a component that goes up and down. Yes.
Oh,
Most
man.
of it is side to side, but there is a component that goes up and down. Down, actually.
Oh, okay. There could be a Younghouse effect or something going on, sure, but it's mostly left to right. Yeah.
Right. What about
So
what I said
when
is compatible
a
with that?
sniper adjusts for this, when a sniper has to adjust for it, that means he He can't shoot where the target is. He has to shoot where it's going to be. That's his adjustment. He's shooting where the target is going to be due to the Coriolis effect.
If you say the same thing about shooting an arrow at a target that's 1,000 feet away, you're not shooting at the target. You're shooting at the target it's going to be. I would say that's a weird phrase. It's a weird way to phrase it. But if that's the way you want to use language, sure.
If something's moving in the distance and you're trying to shoot it, what are you going to do? You're going to shoot where it's going to be, not where it is.
No, your bullet also has effects on it, right? Your bullet isn't necessarily going to travel in a straight line.
Yeah, he knows. So okay. So let's just think about clay pigeon shooting. Have you guys ever gone clay pigeon shooting before?
Yes.
Right. You know that you have to shoot ahead of the pigeon, right? If you shoot at the pigeon, you miss it.
Yep, you got to lead the target.
So that's what we're saying.
Yeah, but I mean, I think the whole thing is that I don't even know if
Eventually some globers will come in that know how the Coriolis adjustment would work for a sniper, and we'll be able to carry this forward. But this is the magic bullet for this argument I've been on for about a week now.
Do any of the globers in the conversation actually have guns?
Yeah, I do.
I don't. But
You do, Charlie?
You sound like you got a Nerf gun, Armbar.
What are you trying to shoehorn the globers into being liberals? Because I'm not.
No, I'm just asking if so it's probably, but it is a legitimate question, right? Because if we're talking about shooting a rifle, if somebody has done it many times and owns and possesses firearms and has to make adjustments to their scope based on certain things that are taking place, right? Known elements that are taking place, the windage and the distance. If we're adjusting for these things and we understand how this works, and then we have a question about Coriolis, the reason I asked if anybody has owned guns is because you would, unless you just own a handgun and only shot handguns, you've probably dealt with the factors that you need to take into account to accurately shoot a gun over distance, right?
I have never shot a gun that would at a distance that would require for me to take into account Coriolis.
Have you shot a gun at a distance that would make you take into account the distance that you're shooting?
Of course.
Okay. And you make an adjustment on your scope for that, right?
Yeah.
Yeah. So you're taking into account drop over distance because that's a known thing that's going to take place. Then you have windage, and you also have, you're typically going to sight in your gun, right? You're going to make a ton of adjustments to get kind of a baseline, typically on a day that has no wind.
Sure.
So you can figure out the rifling of your barrel, which is going to give you a deviation no matter what, right?
To be correct, I've never done it, but sure.
Yeah, because the rifling is you're going to get spin drift based on the rifling of the barrel and the spin of the bullet. So you're going to always have a slight deviation based on that, which is going to be pronounced more over distance.
Yeah, I think that's called the Magnus effect, isn't it? It's
yeah,
the
where
same
it creates the differential in pressure, so the bullet or the object deviates towards that differential. Yeah.
While it's specifically while it's spinning, though, it's the same thing that when like footballers kick a football with curl, quote unquote, it's the same thing's happening.
Yeah.
Oh, there's
Lights on a golf ball,
there's
bending
a
a football.
there's
Yeah.
there's an app where you can calculate like what you have to adjust your aim for, given distance to target and direction.
Right, based on rifling.
Yeah, so okay, hold on. So now we know that we're not shooting at the target, we're shooting where it's going to be, right? They're showing you the math for how to do it.
I mean, again, you're never just shooting at the
This is
target, right?
daunting,
Your
Tab.
bullet also has effects going on it. The way that you're using language right now implies that the bullet that you're firing always travels in a straight line.
But
and that therefore all you have to do to shoot the target is lead it.
Right, Charlie, but what
it's a
we're
little bit
saying
more
is
nuanced than that.
we're making adjustment for the known things, right? The things that we know, the things that the average person is going to use when they're trying to make shots is going to be these known things that we can measure: drop over distance, wind, spin drift, right? Where I think what Jeremy is trying to ask is, once we take all those into account, right? Typically, if we're doing that over distance, what we're aiming at is
in the center of our reticle because we've made the adjustments to our scope, which puts our scope where it needs to be, even though that scope is going to have a deviation. That scope makes the deviation, which puts your barrel in the direction that is going to lead the spindrift. It's going to be above the target so that you can take into account the drop over distance, and it's going to be adjusted for the wind.
Okay, so would you call that aiming at the target? I would call that aiming at the target because the center of my reticle is aiming at the target.
Sure, let's use that as our baseline.
Sure.
So we have a zero wind day. We don't really have to take into account windage. We have drop over distance. We have a spin drift. We perfectly get our scope sighted in. Now let's make a really long shot, right? So now the spin drift is going to come into play a little bit more. So we're going to have to make an adjustment for that. A little bit more distance. So we're going to have to make that adjustment as well with our scope. Now we figure out we're facing either north or south. How are we now going to figure out where our gun needs to be placed, where our rifle needs to be angled to take into account for Coriolis? How does that look to the shooter?
Sure. So I have never done it before, but if I had to do it, I would probably download this app that takes in my position on the earth, the direction to my target, the distance to my target, and all these other parameters that probably don't matter for Coriolis, but like air pressure, humidity, et cetera, et cetera. But if I want to be more and more accurate, I press OK, and it'll give me how much I have to adjust my scope for, and then I would just aim dead center to the target on my scope.
So in theory, would you say that the adjustment for the Coriolis effect would be effectively leading the target?
Again, I don't know. No, I don't know if that's. It could very well be that's a fair characterization of it. I don't know if that's the case. I could see how that is accurate. It could be accurate, and I could see how a description which doesn't characterize that way would also be accurate because it's just different reference frames.
Okay. So I would describe my adjustment for windage as an adjustment for leading the target. Meaning I'm going to have to aim where I think that bullet is going to end up based on how much the wind is going to blow it in a specific direction.
Correct. That's fine. Right. But that's not what Jeremy's saying. Jeremy's saying the target is moving, which is why I say that the characterization isn't fair, because I could see how Coriolis is an effect that happens on the bullet. Right. Does my objection make sense?
Yeah, I think Charlie, I think what you're saying with regards to Jeremy's language is actually fair. I would agree with that, because you've got there's kind of two stages of adjustment, isn't there? There's the stage of adjustment for a still target. You would still need to adjust for things like winds, things like spin drift and all this kind of stuff, even for still target. And then there's like a second layer of leading it because it's moving. And these are separate, and I don't think Jeremy meant to conflate them, but it might have sounded like he was. So I understand what you're saying.
Well, yeah, and he's saying that Coriolis is merely an effect of the target moving, and I don't know. It could be correct. I don't know if it is.
Yeah, when you're on a drone, when you're on a merry-go-round, and you're going to throw a ball at someone, and you're rotating, you can't throw it. You can't throw the ball where the person is. You're not going to hit them. If you adjust for Coriolis, guess what you got to do? You got to lead your target and throw it where the guy's gonna be to hit him. This is like basic shit, man.
Yeah, but the thing is, I don't. I think the way you're describing is like, oh, Coriolis is like the Earth, like moving under the like object or whatever. But that's not necessarily like the case. Like,
dude, yeah, it is, man. What do you think's going on?
There's an added complication that it's not just you throwing a ball over the merry-go-round, right? But you're standing on the Earth, right? Like the Earth is imparting momentum and angular momentum to you as the bullet's leaving your rifle, right? And that, I would think, has additional effects. Maybe I should just shut the fuck up and reread my notes on Coriolis and and then actually start.
Dude, you're on a merry-go-round. You're on a merry-go-round. Two people.
Jeremy, we've done this before.
You got
I
a
don't want to do
ball.
this again.
You got a ball. Two dudes on a merry-go-round. All right.
Sounds
You're
gay.
spinning. You're spinning. It's two dudes. All right. We got Alice and Bob are on a merry-go-round. Okay. Alice throws the ball to Bob. They're rotating. She can't throw it where Bob is, or he'll never get the ball.
Mm-hmm.
You know what? She has to lead him and throw it where he's gonna be, or otherwise he'll never catch the ball. You'll never hit your target.
No. So if they're both on the
What do you
merry-go-round,
mean no?
if they're both on the merry-go-round, okay. If you say okay, if by throwing it at where he's going to be, you mean she needs to look at where Bob is going to be, and then throw her arm in the direction where he's going to be and then let it go, you're incorrect, because that's not what Coriolis does. What Coriolis will do is that it will seem like the ball is experiencing a force, which will make it deviate from a straight line path, which means wherever she's aiming at is not where the ball is going to end up. So if that's what you mean
Which
by
means she can't throw it where Bob's gonna be. She has to lead him. Exactly.
no,
Oh
that's
my
not what you
goodness,
said. You
man.
said she can't throw it where Bob is. She has to throw it where Bob's going to be, and that's wrong, right?
If she throw it where Bob is, and in the moment, she'll miss him.
Do you agree that from her point of view, the ball's not going to travel in a straight line, whichever way she throws it?
Do you understand? If she throws the ball at Bob, the
Can you answer
ball's
my
not going to
question?
get there.
Can you answer my question?
What's your question?
Do you understand that wherever, forget about Bob existing, right? If she throws a ball forward, the ball is going to move in a weird direction. It's not going to move forward.
No, if she throws it in a straight line, it's going to go in a straight line. It's just going to appear to deviate because she's rotating underneath it.
From her point of view, it doesn't go in a straight line.
I know, but it actually does, though.
Well,
it only appears the curve because she's rotating under it.
Okay, to me that means the ball isn't going where she's throwing it, right?
I know.
So if from her
That's why
point
she
of
has
view,
to lead the target.
Listen, if from her point of view, if from her point of view, Bob is going to be 10 meters to the left in 1 second, and it takes 1 second for the ball to get to Bob, right? She's not just going to throw the ball 10 meters to the left of Bob, because that's not where the ball's going to go. It's
Dude,
not
what
just
the
leading the
hell are
target.
you saying? If she throws the ball at
Listen.
Bob, dude, no, you listen. If she throws the ball at Bob, she's not going to hit Bob. Do you understand that?
Yes.
Okay.
Someone,
So in other words, she has to throw it where Bob's going to be so she can hit Bob.
No. You're wrong. If she throws it where Bob is going to be, okay. Let's set up two targets, okay? One where Bob is, and another target where Bob is going to be. Yeah?
But we don't do that. We always throw to Bob because he's always stationary.
Jesus Christ.
I'm going to hang out with my wife, man. This is beyond stupid.
Of course,
huge waste of time.
Jeremy. Jeremy, he's trying to say that you move with the spinning earth, so you have the the guy is spinning.
I mean, we could maybe we should do like a little like a little drawing or something, like just to kind of get this more fleshed out, because sometimes it's a bit hard to picture it, in your head.
I mean, it's super easy, right? He's conflating leading the target with accounting for forces on the ball. Those are two different effects which he thinks are the same thing, which they're not.
Yeah.
But if
in the
but
Coriolis,
exactly.
in the Coriolis thing, there's.
But I'm saying just maybe we should just do a graphic just so we're all on the same page, because I feel like some of us are like picturing something else or something,
There's a difference between leading a target because your target's moving and accounting for a force that your projectile is experiencing.
And the Coriolis effect is you are leading the target because the target's moving. Demonstrated with Bob and Alice on the merry-go-round.
Not from the reference frame that Alice is on.
It's demonstrable.
From Alice's point of view, there is a force being acted on the projectile. You're right that from a different reference frame, it's just a difference in path, right?
A sniper shooting.
The thing I'm saying. Hold on, Apoc. The
Right,
thing
but
I'm
I
saying
mean,
is the
but
monster.
but
Well,
I
and it's
understand how
hold
you
on,
can't
man.
see this point of view if you don't accept relativity, because that's a central tenet for the relativity. Right? Different reference frames can have different experiences.
Yeah, we know there's no force there, and it's only a pseudo force. You know why it's called a pseudo force? Because it's not a real force. They had to make the force up for what their force would be if there was an actual force there. But there is no actual force
Sure.
there. The
Sure,
Coriolis
makes sense.
effect, as demonstrated, just stop, man. 30 seconds, bro. The Coriolis, as demonstrated on the merry-go-round, Alice has to throw the ball where Bob's going to be, or she's not going to hit him. If she throws the ball where Bob is, she won't hit him. We know this.
Okay.
She needs to throw the ball where Bob's going to be, so she can hit him.
Okay, sure, but that's not what you said earlier. You said that she needs to aim where he's going to be.
Yeah, she needs to throw it where he's going to
That's not
be.
the same thing.
Okay, if she throws it where he's going to be, or she aims it where he's going to be, what's the difference?
Because where she aims isn't the same thing as where the ball's gonna go. Do you understand?
Oh my God. Okay,
sniper-
dude. You understand that she needs to lead the target, or she's not going to hit him?
Do you understand that she needs to account for the ball not going where she's going to aim?
Yes, because he's moving. It's demonstrable, dude.
Right.
It's
I
literally
don't deny
demonstrable.
that. I don't deny that. I don't know why you keep saying that I'm denying this, right?
A sniper shooting north to south does not have to account for the curvature or the rotation of the Earth. They don't have to do that. All they have to account for is the wind and the angle of how they're shooting somebody. Never will they ever account for a spinning rotation ball, bro.
How's that
They
relevant?
never do that.
How's that relevant?
It's relevant because you're trying to say that they have to account for that in their relative frame. Come on, bro. Like, be real with yourself.
Well, that was what I was going to kind
No,
of.
that's what Jeremy's saying. Jeremy's saying that in a merry-go-round, Alice has to account for it. So, pay attention.
Yeah, that's what I was going to kind of get onto, because you said that a Coriolis would be factored into drop calculations, right? But of course, like this, it seems to me like you're kind of trying to throw the baby in with the bathwater, in the sense that, yeah, I know, I just made it up, but in the sense that you've got
Well, that was
two
real
of-
too.
The fuck does that mean?
Well, I'm
Throw
trying to
the baby
explain.
in with the bathwater.
We know what the expression "throw the baby out with the bathwater" means, right?
Oh, okay. I see. All right. That's why I felt familiar. Okay, go on.
Right. Okay. So what I'm trying to say is that it seems to me like you're trying to sneak Coriolis in, which you don't actually know is happening, into the bullet drop calculation, which we know is happening. And then just saying, well, we know they're both happening because the Earth's a ball, right?
No. I'm not making a claim for Coriolis right now. I'm just responding to Jeremy's. Excuse me. I'm just responding to Jeremy's claim that, we're not even talking about Coriolis on the planet anymore. We're talking about Coriolis on like a merry-go-round, which we can all agree happens, right?
I mean, sure, but the discussion is whether there's Earth-based Coriolis, right? That's the question here. And if it can be demonstrated with sniper rifles.
I mean, is it, Jeremy? Jeremy's the one who brought it up.
Well, I would imagine that is the question, because otherwise this is a pointless conversation.
I mean, I do know that there are videos on, like, plenty of videos on YouTube of like, random gun people, gun channels where they do this. They set up two targets at 90-degree angles from each other, and they show that there is a drift in like, I don't remember in which direction, but it is also like a down direction component that they have to account for.
Yeah, I mean,
that has nothing to do with the curvature of the Earth or a spinning ball, bro. Everything that they fucking try to calculate when they're sniping a target has only to do with the wind and the distance and the angle that they're shooting it.
Well, hold on, real fast,
Right.
real fast. Hold on.
No, hold on, man. Hold on, because I gotta go. No, hold on, real fast, because I gotta go. I'm willing to give them that this sniper Coriolis thing is actually happening, but we just can't agree on whether. I don't know. They don't understand how Coriolis works. Maybe we got to get some other Globers in here. I don't know.
I'm curious though. Do you have an explanation for it, Jeremy? I'm not saying that it's bad if you don't. I'm just wondering if you do. Like on a flat Earth, why
Bro,
that
don't.
the bullet
Heat the
drop
drift or
happens?
something. If I
Dude,
had
I'm
to,
not even worried about. I'm not even worried about all that. We can't get through this scenario
That's fine.
because you guys don't understand how it works.
Okay.
Exactly.
Which is fine. I'm not mad if you don't know about it. It's fine. But I mean, I don't know why we're even still talking about it because you don't know. I mean, you understand that Alice can't throw the ball where Bob is. She needs to throw it somewhere else. Where do you think she's going to throw it? Where
Jeremy,
he's going to be. Obviously, she has to lead the target.
if I'm shooting a bow and arrow, and the target's 1,000 feet away from me, I have to aim above it, right? Would you say that's me leading the target?
If you have to shoot above it to count, no, you're going to have to. If it's running to the right, you're going to need to be farther to the right.
Listen. I'm on a flat Earth.
What are you talking about drop for, dude?
I'm on a flat Earth. I'm shooting a bow and arrow. There's gravity or whatever drop effect you want to whatever name you want to give the effect of stuff falling down, right? I want to shoot the arrow at the target. If I aim directly at the target, I'm not going to hit the target, right?
Yeah.
Would you then say it's fair that I have to lead the target?
So there's a deer just standing still, and you need to account for the drop.
Yeah.
Of the arrow. No, that's not leading the target.
Excellent. Great. So
Target's not moving.
Excellent. Okay. I mean, if the target was moving, right? Then I do agree with you.
But it's not. But it's not. It's staying still.
I know. But Apocryphon, this is called a hypothetical. Okay, try to pay attention. But if the target was moving, okay, if the target was moving, I agree with you. You have to lead it, right? Because by the time the arrow gets there, the target will have moved by a certain amount, right?
That's what That's what a sniper's doing when he adjusts for the Coriolis effect.
Okay, hold on. Excellent.
What do you mean? What?
Excellent. But in my example, right, of like me shooting an arrow, am I aiming where the target's going to be?
If you want to hit it, if the target's moving, if the target's moving from the left to the right, and you want to hit the target, you're not going to shoot where the target is because it's moving, and by the time your arrow gets there, it won't be there anymore. So you need to shoot where it's going to be.
Right. I'm not asking about where I'm going to shoot. I'm asking where I'm going to aim.
You're going to aim where you're shooting. What do you mean? What kind of weird semantic bullshit, fucking weirdo, pedantic, fucking
listen.
nonsense game are you playing with me?
Listen. If I look at my target, right, and then
nah,
I say,
dude, I gotta go, man. I gotta go.
Run away. Go ahead.
You're doing. I know. Yes, I'm so scared.
Run away.
Hey, Charlie. I'll take over if you want. Listen, if you
Oh.
have a target, if you have a target, really? Okay. That you can say what you want to say.
Wait,
But if you have
did you say easy mode? Did you say easy mode? Is that what you said?
Yeah, it's easy mode. It's easy mode. So if you have a target, if you have a target in the distance that is literally just like grazing on grass or the field that is grazing, you don't have to account for the curvature of the earth or the rotation of it. All you do is look at the target through your scope and you pull the trigger and guess what? If you aim directly at it from a certain distance, it's not necessarily going to hit it at your scope. It might hit a little lower because the projectile that you shoot at this animal in the distance, it's gonna drop down naturally. That's a given. But if you're trying to say that you have a target spinning and moving with you, well then you're trying to say that you have to lead to the target. That's only if it's moving, bro. That's only if it's running away or running, in a direction to where now you're trying to lead because you know that when you pull the trigger, it's gonna run into your direct line of fire. Come on, dude. Why are you trying to go down this stupid ass path, bro? Really?
Okay, I think I'm starting to get Charlie's point now. I'm starting to get okay. So Alice would be aiming where Bob will be in the hold on in the frame in the reference. If I guess it's a reference frame or whatever. In the frame that's outside of the spinning one, right?
How does Alice aim in a reference frame that she's not in? She can only use her arm and her eyes to aim.
Well, yeah, I know.
Exactly. I think
I know.
even Gio understood my point in this whole thing, right? Like, there's a distinction between leading a target and correcting for effects that your projectile will have, right?
Okay. Well, okay. Maybe I should reword it then. So I guess what I'm trying to say is, if we put this into like a grid, right? Like we had an x and y coordinate, and we're only dealing with 2 dimensions, right? And I guess essentially we're looking at this from above, right? Where she's going to essentially, like, I guess if I had to plot the point where he's going to be, where Bob's going to be, right? And then she pretty much aims towards that direction. Maybe I should draw this out. Maybe I should.
Listen. Can I give you a description which I think is perfectly clear, which I think should clarify it? I have a crossbow. I have a scope on the crossbow. The scope is perfectly aligned along the rail of the crossbow.
right.
Okay.
All right.
My target is moving slowly to the right. Okay. The target's also far away. Okay. Obviously, if I aim directly at the target and I press the trigger, I'm going to miss the target because the target's moving, right?
Right.
Obviously, if I just lead the target, I'm going to miss because there's drop in the bolt, right?
Right.
I have to do both. I have to lead the
Right.
target and account for the drop.
Right.
Right?
Absolutely. Yeah. I
Excellent.
agree
Then
with
we're
you.
in agreement, right? Jeremy was just saying, oh, well, you just have to aim where the target's going to be, which is not
No,
true.
no.
Well, hold on. Can I maybe
you,
explain
but
my
you
position?
wait, hold on. But you then invoke that it's moving. So if your if your target was moving, of course you can try to calculate where you're going to shoot in a specific direction to meet that target moving. But that has nothing to do with the curvature or the rotation of the earth. What don't you understand about that?
I don't know why you keep bringing that up, right? We're not talking about that right now.
No, but we are though. You're saying that if the
Sure.
target's moving, then you're saying that it's because the earth is moving. No, the target is moving.
No, that's
bro,
not what I said.
the earth.
That's what Jeremy said, dude.
Okay. I apologize. Go ahead. I'm sorry. I misunderstood. My
No
bad.
worries.
Well, I'm about to draw my picture real fast because I feel like maybe I'm not just putting it into the right. I'm not using the right words. So I'm gonna real fast draw this just to show you what I meant to say.
Yeah, draw a deer and then draw a position where you're shooting it at. Now, we live in a stationary, non-moving, rotational plane. So when you shoot the deer in a distance, all you have to do is just shoot straight. Now go ahead.
What's a rotational plane?
It's called the Earth spinning ball on your in your paradigm, if you will.
Oh, I thought you said it was a rotational plane in reality.
No, that's not reality. The reality is it's all stationary. It's all fixed. It's all non-movable. So if you see a deer in the distance and you shoot the deer, you're not accounting for the spinning of the ball because the deer is in a position to where the only thing you have to account for is the distance from you to the deer. So you might have to angle your bow and arrow, whatever the fuck you're shooting it with, maybe a little up, only because we're accounting for distance. That's it. You're not accounting for a curvature or a rotating ball that you believe that we're having to account for. That's not reality, bro. The reality is you shoot a deer at your your fixed position, and that's it. And you will hit the deer. It's gonna die, and you're gonna have fucking deer meat for the night. That's it.
Cool.
It has nothing to do with the spinning ball, bro.
So that's gonna be roughly 3.
I know a couple dudes that they go bison hunting, okay, in Arkansas. And they never account for the rotation of the earth or the curvature of it. All they do is they fucking will shoot a fucking hog in a distance according to their position in a non-rotating stationary position, and they
Okay,
will hit it
hold
every
on.
time.
Can we talk
Go ahead.
about Armadur? Is that how I
Armadur,
pronounce
yeah.
it? Your diagram? Okay, so
Call him Arma.
Arma. So that's a merry-go-round, right?
I guess, yeah, sure.
And it's rotating along the center axis, right?
Yeah, and I guess
Okay.
and it's going, I guess, counterclockwise.
Yeah, okay, so I like your drawing of Bob, right? But then what does that arrow coming from Alice represent?
Yeah, I mean, so the arrow represents basically, I guess, the angle, I guess, in which he's going to aim, and yeah, I guess the angle, I guess. So I guess I don't really. I guess
Okay.
that's not exact.
If she can I ask you a question? If she let's say that arrow represents her arm or whatever in the direction in which she's going to try to throw a ball.
Mhm.
Can you draw for me the path in which, from her point of view, the ball will actually travel?
Yeah, so for him, I guess. So where? Let me see. So she would be real fast. Do a light version. So I mean, I guess from her, I would have to first maybe real fast move her position, and then I'll do that as well. Move her position. So so she'd probably be like around here or so.
Okay,
And
so the picture that we're looking at is, excuse me, the picture that we're looking at is fixed to the world, not to the merry-go-round.
And that's the problem, though. That's the problem. That is what we're discussing here. Because once you move it, once you move that position, then you're trying to evoke this spinning, moving target. But technically, it is where it is, bro. You don't have to account for that moving position.
Thank you for that fascinating comment. So the diagram which you've drawn is fixed to the world, right?
Yes.
So if it's fixed to the world, the path the ball is going to take is just a straight line.
Right. Yeah.
But if you fix it to the merry-go-round, it's actually going to look curved.
Yeah.
Okay, so from Alice's point of view, she just tried to throw a ball in a straight line, and the ball just fucking did something weird. It didn't travel in a straight line.
Right.
Right. That's that's the issue that I say, where she's aiming isn't where the ball is going to be. It's not only where Bob isn't going to be, it's not where the ball is going to be.
Right. Yeah. Yeah. I'm not disagreeing with that. I'm just saying, like, because I think at least forgot who it was. If I was wondering if that was what Jeremy was saying. I was just saying that I guess you could argue, like, if the way if you want to look at it, like, at least according to my diagram, if you want to look at it as, okay, yeah, from what we're seeing right now, that Alice is aiming towards that, where he's going to be, then you could look at it that way. I don't know how correct that is, but I think that's what maybe Jeremy was on about, though. Is this is essentially what
Nobody shoots that way, bro. Nobody shoots to project where they're gonna be on the spinning earth, bro. Everybody shoots directly to the target.
You're no pun intended, but you're jumping the gun right now. We're not talking about that right now. I was just talking about the merry-go-round example, but yeah. Anyway, yeah, nice picture that I did. I complimented myself. Anyway, let me just cut this off. I think you get the point. I wasn't really, disagreeing or, or agreeing. I was just, or I mean, I guess I was kind of agreeing, but I was just trying to, I was just trying to show this.
Yeah, you're pointing out that there has to be a movement of the target naturally by the rotation of the earth that you want to believe in. So you're trying to say that you're trying to say that if you shoot something that's moving, then you're gonna try to lead the target. Yes or no?
I mean, I don't really know how the Coriolis things work. I mean, in terms of like the merry-go-round, I guess you could look at it as leading, I guess. But in terms of Coriolis, I don't really know how that works exactly, so I'm not going to touch that.
Yeah, because it doesn't work that way. It doesn't work that way, Arma. Come on, bro. You're not trying to when you're a sniper shooting a target, you're not trying to account for Coriolis on a spinning ball. The Coriolis you're talking about is that the bullet, the projectile that you're shooting, is going to travel through a medium where there's wind that may be affecting your target.
All right, but I wasn't arguing that though. I was just trying to do a thingy though. I mean, that's fine. I don't really know enough on this topic to really argue it anyway. I was just trying to, almost be like devil's advocate in a way, but I don't know. I don't worry about it. I wasn't even trying to argue that.
No, you prove that it's a flat earth. Congratulations.
I don't know about that.
because you don't have to account for a curvature of the Earth or a rotation of the Earth. All you have to do is just shoot the target in front of you, and that's it.
Yeah, but I mean, isn't it like I'm pretty sure it's not just like, oh, it's a myth. I mean, there is people, or at least it has been documented that the shit, kind of drifts over a long distance, right?
No, of course. The snipers will tell you that they have to account for the wind, and that's it. It has nothing to do with the curvature or the rotation. It has to do with if you take like a flat and stationary plane and you shoot a bullet, then it's going to obviously travel a certain direction, and I mean, come on, bro. Have you ever played like Fortnite or
I
Call of
haven't.
Duty?
I haven't. I mean, and that's not me trying to be like, like, oh, I'm, whatever. Like, I'm not trying to have some kind of high ground. I just haven't though, personally though. But, no, I haven't.
If you ever, this is what's funny, bro, because video games are pretty accurate to this whole Coriolis fucking effect. So if you shoot somebody from a distance, you cannot aim directly to them. You have to aim to them like at a slanted view, if you will. Not
Really?
because the Earth is yes.
Talking
Now,
about all the games I've played, you just aim where you point and that's it.
no. If you want to, if you okay, let me
I
tell you this
played
right
I
now.
played I played some
Armor.
Black Ops in my day. All right, Black Ops,
Okay,
Black Ops
yeah.
2.
Well, that's one thing, but that what okay, Black Ops and Call of Duty,
Yeah, call it. Yeah.
they always like if you're a sniper, they always made it to where you can hit the target. You don't have to fucking account for fucking curvature and spit,
Well,
all
yeah,
that.
obviously, yeah, but
But on Fortnite, it's probably more accurate because if you see a target way in the distance, you have to first of all you have to angle your barrel a little bit up because it understands
Oh.
in the game itself. It knows that if you angle a little bit up above the target, the bullet is going to fly up and then come down and hit your
That's kinda cool.
target.
Pretty cool.
Yeah, but never does it have to be like I have to point left to hit right.
Well, yeah, no shit, because I mean they're not gonna freaking program that first off. I mean that's just ridiculous.
But that's reality though.
Yeah,
That's
but games
reality.
aren't reality though.
dude.
But Fortnite is actually kind of accounting reality,
Okay,
bro.
for a second I think I say Fortnite's reality.
I'm telling you, bro. The game itself, it has a very very well established principle to where if you're trying to snipe somebody from a distance, you don't have to aim left to hit it. You
I
have
mean,
to.
okay. I mean, but once again, though, I mean, just because they're fairly accurate doesn't mean it's fully accurate. Like it depends on how much they wanted to, how accurate they wanted to make it. They were like, okay, let's just make it where it drops, at a
No,
certain
bro,
distance. Whatever.
Fortnite is real life.
I really thought he was gonna say that. I got scared for a second.
Dude.
I was like,
I'm
don't
just
say
saying,
that.
bro. I'm just saying it's more realistic because something
Sure. I mean, yeah.
something in a distance, you're not worried about the left or right. You're worried about the angle of which you shoot your bullet to go up and come down. And if you were to aim directly to the target, you wouldn't hit that target because it knows that the projectile that you shoot is going to land at its feet. So you might have to aim a little bit higher to make it arc. And that's all I'm saying, bro. There is an arc in the distance. There is an arc.
That is pretty cool, though. I do think that's it's pretty neat. Pretty neat.
It's pretty accurate, by the way. And guess what? You're not having to count for a spitting ball, and that should be enough evidence in itself, bro.
I mean, just slightly off topic, but still on topic. freaking Fortnite, I saw that they added like they recently added like anime characters. Like a while back, they added like fucking Goku or some shit, right, from Dragon Ball Z.
Yeah.
That's pretty cool.
Yo, anime's degenerate, dude.
I
Well,
mean, yeah, but it's still pretty neat though. But
it's interesting that even a real life sniper never has to account for a spin or a movement laterally. They never had to do that. They never had to do that.
Dude, there's plenty of videos on YouTube of people who shoot guns having to account for this and demonstrating it.
It only has to do with the speed of the wind.
That's
so
not true.
yeah,
That's
no,
not
it
true.
is.
They
It
in
is.
the video say it doesn't, right? Like
No, it is true because if the wind is stronger,
I understand that, but I need you to acknowledge that that's not what the people who make these videos say.
Okay.
Right?
Okay.
Like you must either think that they're wrong or lying, but you
please
can't say that they don't say it.
Please post the video. I want to see
Sure,
that.
sure.
I want to see them talking about.
Hold on, I got 5 or 6 of them. Give me a minute.
Oh, nice.
Yeah. Post the video.
Let's say it is the wind, though. I mean, how consistent is the wind? Like I know, like sometimes the wind is
it's very consistent.
Okay. I mean, I don't really. You're probably right, honestly.
That is a huge problem for people trying to shoot a target from long distance. Is the wind, because once you pull the trigger, it's going to be adherent to the environment that you're shooting through.
I just sent you a video. Watch
All
it.
right.
Explain it to me.
All right.
Are you saying the guy's lying?
It's probably ether drift. That's what it is, right? Right. Apocryphone.
Wait. Who is that?
Is he an Electric Universe person?
I don't know.
Extremis, is that you, Extremis?
But I think that would be the
Well,
explanation.
Charlie posted. I guess he said I'm posting them in the main chat. I don't know where Charlie posted his.
Oh, I sent it to him directly. But
wait, is that Extremis? Extremis posted.
I posted 3 of them. I'm posting 2 or 3 more. So give me a minute.
Oh yeah, I mean you posted the one that I posted.
Wait, who's talking? I'm so lost. Who's talking?
The one by Gunworks. That's the one I posted.
Charlie. Charlie's the one that's talking.
All right, Charlie. What did you post, Charlie? I'm waiting for it.
I sent it to you directly. I also posted it in the general chat, and Extremis is also posted in the live stream text.
Directly? I have no message for you, bro.
What are you talking about? I'm
You sent
spamming
it.
you right now.
Okay.
ASDF.
Dude, I have nothing from you. I swear to God, I have
What are you
nothing.
talking about? Why are you gaslighting me right now? Holy
No,
shit.
I'm not. Dude, listen. I'm gonna screenshot my shit.
Are you on drugs?
No.
Yes, he is.
I have
Are you on
nothing from
alcohol?
you, bro. I have nothing from you, bro. Dude.
Alcohol is a
Have you been
drug.
drinking?
Hold up. Listen, I'm gonna screenshot. No,
What, have you been drinking? Because I've been drinking. In fact,
Yes,
I'm gonna go get some Tawny Port right now.
Look, okay, that's good. But look at but look.
I'm gonna get smoked now.
But look what I post right now.
Okay, I don't drink.
Tell me where you sent me a message.
Okay.
Look
Do you
at
see at the top left? Do you see at the top left where there's like a little speech bubble?
What?
So yeah,
Like a speech
I
text.
have nothing from you, bro. I have nothing from you.
Oh Jesus. Okay.
Look at the. I screenshot my shit. I screenshot my phone, bro. God damn. What more do you want from me?
Okay. Click on live stream 1 text.
Okay.
Yeah.
Live stream 1 text. Okay.
I posted a link to the video right there.
There you are, Charlie. Okay, now you did. Okay, now you did.
No, I did it last time too. You're just too drunk to realize how to.
You
direct messages.
No. You said you sent it to me directly.
I did.
I didn't get nothing from you.
Whatever. That's not important. Keep going.
I mean, okay.
It's there now. In the main
that's
chat.
all that matters. That's all that matters. So he's picking it.
No, this is too important to me. I'm gonna show a screenshot of me sending him the message and spamming him.
Yeah, and then Apocryphon, you have to send a screenshot too to prove that he hasn't sent it twice or spammed it.
Right. I'm still waiting for messages, by the way.
Or are you drunk?
Because go on. when you get messages directly to your DM, it shows somebody messaging you. Am I wrong now?
No, it could also go to message requests, right? You have to open those as well. Anyway, I
Okay.
posted a screenshot of me sending you the message, so it doesn't matter.
All right.
Anyway, what have you been drinking? Tell me.
Oh, here, message request. Here it is.
What?
Now I got it. Message request. I got it. That's what
Very
it is.
strong. That's all I know.
What?
That's what it is. You're right. You're right.
Meth? What?
Message
requests.
Mescaline.
Message request.
You've been doing mescaline.
Message request.
By the way, Charlie, if you haven't met Apocryphon, he's our official chat drunk.
I know that Gem Pandas has one as well. What's his name?
Johnny.
What?
Johnny.
Johnny,
Bernard.
yeah. Hey, how are you guys? How you doing?
That guy, I have to admit, he is worse than Apocryphon. Apocryphon is not quite that bad.
You're right.
But
anyway, hold
Well,
on.
thank you.
Don't
Thank
do
you,
anything fun without me.
question
I'm gonna go
mark.
get some. I'm gonna get some more Tony Port. I'll be right back. Hold on.
Thank you? Question mark. Okay, so I get what you're saying. I had to accept your request of sending me messages, so that's why I didn't see it. That's why I didn't see it. So, truth be told, he did send it, but
Yeah, so
I
both
had
sides were telling the truth, just that you just didn't realize that you didn't. Yeah, it's fair enough. Yeah.
Yeah. Well, let me take another drink.
Take a drink.
The number of notifications you have, Charlie, is giving me anxiety.
I want you guys to know that at 10 o'clock, it's 8:29 right now. At 10 o'clock, I would have been drinking for 24 hours, and I'm proud of that because that's a new
Wait,
record for me,
Wait,
bro.
you've been drinking for 24 hours, or you haven't drunk for 24 hours? Because both are
No.
concerning.
No. At 10 o'clock tonight, in an hour and a half, I have been drinking for 24 hours. In an hour and a half.
Oh my god, man! You got that's. I don't know how is that. Jeez.
All right, I'm back. Wait. Apocryphon, what
Eh.
did you think of the video?
I saw the video. I saw it.
You did?
And
I wasn't even gone for the length of the video.
I scrubbed through it. And please tell me how he was accounting for. Give me a timestamp. Give me a timestamp.
No, why don't you watch the video? It's only 3 minutes long, dude. Come on. Don't be ridiculous.
Dude.
You guys will give me like, oh, watch this 5-hour schizo documentary that some guy made.
Okay. That's fair. That's fair. Hold up. Let me mute this shit. Okay, give me a second. I'm gonna watch it. I'll be back.
Just go to bed.
Sure.
Apocryphon. Fuck, man.
What happened? Where'd everybody go?
Oh, he's gone. Apocryphon?
Dude.
No, he's back. I'm back.
What'd you think?
Dude, are you kidding me right now, bro? Are you kidding me?
Spare me the fake barrel clutching. What's wrong with the video now?
Okay, hold on. First of all, he's talking about shooting one target to the east.
Mhm.
Okay. And then he turns to the west and he shoots another target and he has a higher elevation to the right of that target. Now,
Clearly flat.
the funny part about this is this, bro. We do not know the elevation of the terrain of which the targets were at.
You don't. Why would you
So,
need? It's clearly flat, dude. You
well,
can see it's a flat desert and there's
dude,
no wind. You can very clearly see that.
no. You can't
Are
see
you
that.
serious right now?
That's the point. That's the point. Here's what I'm saying, bro.
Okay.
If you
Charlie,
shoot,
he's just drunk.
no.
All right, bro.
That has nothing to do with
Go ahead.
it, bro. If you have a target that is to the east and they're hitting lower from the bullseye, and then they switch to the west, and all of a sudden it's higher and to the right of the target. Please explain to me how that explains
All right,
a
bro.
baller.
All right, bro. Whatever you want.
All I'm saying is this, bro.
No, I think you already made up your mind, right? You're not open to scrutinizing other evidence, right? You've already made up your mind. It's
Well,
fairly simple.
well, it's obvious that their target east to west was clearly on a slope of one sort or another.
Really? It
Yeah,
seems pretty fucking flat to me. It's out in the middle of the desert.
I'll tell you why. Because if you took your gun and flipped it 180, and it's still at the same elevation, and then you had a target in the distance, and it was higher on one point than the other, clearly it's representing elevation to what you're shooting at.
What
Clearly,
makes you think it's higher at one point than the other?
because of the target. He shows you that the target was hit higher and to the right of the
You're begging the question. That's circular reasoning. Right?
You're begging the question.
You're using the fact that the clusters, the bullet clusters are at different elevations on the target from one side to the other as evidence for there
But
being
they
a
are,
different
though.
elevation.
But they are, though.
No,
They literally are.
right, but what is that contention is an effect
Okay,
which would
okay,
cause
okay.
that in the first place, right? How do you
Okay.
not see that this is circular reason? Why am I upset over a dumb drunk not understanding basic concepts? Holy
Wait,
shit.
hold on. If I put my gun to face in one direction and I hit it below the target, right? So I had a bullseye and I'm lower to the target. That just means that I didn't aim my gun at an angle to where it would hit the bullseye. That's fair. But we still hit this target, the outside of the target. Now I spin my gun 180 degree. All of a sudden, it's higher and to the right. He just spun it 180 degree, bro.
Okay,
That
you're
means
right,
that.
Professor Apocryphon. You're correct. You should go
That
into university and teach all of us.
Well, here we go. That means that the target that he was shooting at was literally topography was lower than what he shot at. And by the way, if you want to try to account for Coriolis to spin to the right as opposed to the left, well, that's obvious, bro. That's obvious because when you shoot a projectile through a gun that has a right spin, obviously over distance, it's going to travel to the right. What don't you guys get about that? Why do you guys like hand wave the fact that a projectile shot from a cannon or a gun, if you put a right spin to it, it's obviously going to travel. This is why snipers have to account for that. Snipers shooting through a fucking, if they're going to hit a target from a mile away.
All right, I can't. One of the reasons why I left Gym Pan is because I just spilled my wine.
Oh, dude, don't spill the fucking wine. What the fuck are you doing? I'm just kidding. Okay. Party foul, bro. Party foul. Stop spilling it, bro. I'm saying this, bro. Snipers, when they shoot something in a distance, they do have to account the fact that their bullet is going to spin and veer a little bit towards the right. So what do? They adjust that by going a little bit more left of the target. If it's going to be a problem. So it depends on the distance. Now, a sniper knows as well as a spotter. Have you ever, by the way, have you ever seen a spotter um um help a sniper? Yes or no? Hello? Mic check, mic check. Can you hear me?
Charlie left.
Can anybody hear me? Hello, check, check, check.
Charlie left. You're talking to yourself now.
Oh shit. Okay, yeah, he left. Okay. Well, a sniper will generally always um he will listen to a spotter. This is what I want to talk to these guys. Do they even understand how the spotter is the one that lets the sniper know where he has to be as far as clicks, as far as direction? But whatever, bro. Like these guys, bro. These guys are funny, bro. Crazy, bro. Crazy how these guys think, man. Crazy.
Mic check.
Oh shit! I'm still in a fucking call. I didn't even realize that.
Oh hey.
Yeah, I'm just like on YouTube and I hear mic check. I'm like, oh shit, who's that? I didn't even realize. Yeah, that's how
Well, if
quiet
you're
that is.
if you're not Mike, you don't have to worry about it, right?
That's true. Yep.
So did I answer your question earlier about the ship height tracking thing?
Oh, for the yeah, I think so. Yeah.
Okay, good. Hey, Essie. Hey, Roofy.
Hello. Perhaps.
I was just about to invite Essie to hop on VC and help me with my measurement. And you were a bonus.
What measurement are you doing, Jesse?
Ooh. Well, did you see my ship top measurement earlier?
Ship top measurement? Nope.
Oh, hold on.
I've seen this one. Oh, excuse me. Wow.
You'll never learn manners, huh? Will you?
No.
Always burping online.
Yep.
There, I tagged you, Montreal. It should show up about now. We're at 16 past the hour.
Oh, that's too many lines. Too late at night, Jesse.
Oh, okay. You want one with a single line?
Sorry, bro. We got extremists obsessed with Coriolis. Doesn't have the faintest clue anything about it. It's just amazing.
I think Extremistus is taking to the woodshed, SE. As QA would say.
There, I got a single liner for you there.
Extremists can't tie his shoelaces. You know that, bro. He's just follows around and makes insults.
All right, I'll let Jesse have this rather than hassle you about Coriolis.
No, I ain't talking about Coriolis this late, bro. I've been destroying you guys all day. So
yep.
I'm just relaxing now. You should have been around earlier. Oh God.
You ever have the feeling that your head is spinning?
No, sitting right now on my couch. I got my legs up. I just had a tea, feeling great. I'm not spinning. I ain't moving. I ain't traveling at 1.5 million miles an hour. That's all in your heads. All in your fantasy that you've been sold.
Splendid. Well, do you see the picture I posted for you at 17 after the hour?
Okay, what you got there?
I've got Mount Shasta, 14,179 feet tall. Oh, do you need this in metric?
No.
Okay.
We can handle feet.
Okay. 14,179 foot tall Mount Shasta is viewed from 105 miles away from 8,934 foot high Mount Scott. Isn't that quite a shot?
Wow. Did you do that?
Yes, sir.
So let's say it again. You're at 149. Say it again.
I'm at 8,934 foot elevation, and I'm shooting an angle to a mountain that's 105 miles away and 14,179 feet tall.
Okay.
Now, I should be looking up at the top of this mountain, right? I'm 9,000, it's 14,000. That's above me, right?
So you think, let me get this straight now. You think from 100 and how many feet away?
105 miles, but I could convert that to feet
You
for
think
you if
from
you want.
105 miles away that you should be looking up at that mountain?
He's asking you, SE. He's asking you.
Yeah, do you think I should? It's like 5,000 feet taller than me, right? It's almost a mile taller than me, right?
Can you answer straight questions, SE, or are we just going to do your bullshit again?
Who's talking to you? Are you a sidekick analyst?
Well, I'm just waiting for you to answer a question.
I don't care what you want. I'm talking with Jesse.
All right. Are you though? Don't seem to be talking much.
So what are you trying to say, Jesse? You're trying to say that the mountain should be higher? What, it should be equal? What's your point? What are you trying to
He's
say?
asking you, SE. He's asked you a question that you're avoiding.
Is he your lawyer? You have a lawyer tonight, Jesse?
Well, at least he's talking. But if you respond to me, he won't need to, right?
Correct.
What is your question,
My
Jesse?
question is, should I not be looking up slightly to a mountain that's a full mile taller than me, right?
At that distance, no, you shouldn't be looking up, I think.
Okay.
Just,
Oh.
I don't know what you've done here. I'm just responding like briefly to your question. No. Why should you be looking up? You're far away.
Well, it's taller than me. If you're standing 10 feet away from a 9-foot basketball player, you'd be looking up to him, right?
Are you standing 10 foot next to it?
No, you're 6 foot. He's 10 foot. He's 10 feet away, right? You're looking up to him, right?
No, but the mountain, is the mountain 10 feet away from you, or is it 105 miles away from you?
It's 105 miles away, but it's also a mile taller. So you're saying I should be looking down at something that's taller than me?
I'm not saying anything. It's just a picture. It means nothing. I mean,
Of course, you're not saying anything, SE. That's all you ever do.
What do you want? I mean,
I'm
you got a
asking you.
picture here. You got to cry. I mean, it's a joke, bro. What are you trying to prove? Make your statement. What's your statement?
Well, where do you think I should
You
be
asked me
looking?
a question, and I told you. Now,
Well,
what is your thing here? What's the purpose of this picture here?
Well, this purpose of the picture was to measure the angle to the top of the mountain, right? So do you think I should be looking downwards at the top
I don't
of the
care
mountain?
what is your claim? What
He's
you
asked a
posted
question,
a
SE,
picture?
that you refuse
What
to
is
answer.
your claim?
My claim is that the angle to the top of a mountain that was 105 miles away and 1 mile taller than me, the angle was about 1/10 of a degree below eye level. I was looking slightly down at it. How is
And let
that
me guess.
possible on a flat Earth?
And what's your claim? What is your claim? So you took a picture. You're this distance. You're 105 miles away. What is your claim for this picture?
Well, my claim is that there's like thousands of feet missing height.
Thousands
His
of feet
claim,
missing
hold
height?
on,
From what?
I'll sum it up. His claim is you cannot look down at something taller than you on a flat Earth.
Oh, you have another spokesman now? You have two spokespeople for you?
Like I said, SE, I'll shut up as soon as you start answering questions and stop avoiding questions.
Listen, I'm laughing
That's
at
all you
this.
do. You're just
What do you
fucking
think? You
incredulous.
think you can post a picture and like say something like what? I mean, okay. Kudos to you, Jesse. You took a picture. You think there's something missing. Okay, what do you want from me now?
Yeah,
Well, how do you explain this on a flat Earth?
I am explaining nothing. Why do you feel that I have to explain anything to you?
Oh, well, you don't have to. I thought maybe that you had expressed some indication that you believe that people who thought the Earth was a globe were not the nicest or best or smartest of people, and so I thought maybe you would help me understand how this apparent globe evidence was possible on whatever shape you think the Earth is. But maybe I was mistaken. Maybe you think globe Earthers are quite legitimate in their idea of what the Earth is.
No, you're totally mistaken in the whole picture and everything that you just said. To me, it's just a picture. That's it. And you have a claim that something's missing. Whoop-de-doo. Just another day.
So you don't see any problem with this being compatible with a flat Earth?
It's just a picture. That's all it is.
Yeah, yes, we know it's just a picture. But it's
But you want to
also,
make it more than just a picture.
well, but it's also a picture of a measurement. And it comes with a first-hand testimony of a measurement, right? I mean, let's say you were in court and someone brings up this picture and shows the guy in the very act of the crime, and the judge says, "Oh, that's just a picture." And the guy that
Okay.
brings the picture and says, "Yeah, but I was there, I saw it, I took the picture. I'm telling you, this is what happened." And the judge says, "Ah, it's just a picture." See how
Okay. And
silly
if
that
the
is?
judge would ask you, let me ask you, Jesse, how did you measure it? What
I
would you
used
say?
oh yeah, I used a theodolite. I lined up the crosshairs to the tippy top of Mount Shasta. I zeroed it in super careful. I recorded the numbers. And then with keeping with the tradition of operating a theodolite, I flipped it all the way around, turned the telescope over, and took a opposite face reading and recorded those numbers just like I was supposed to.
So you took a theodolite measurement from 105 miles, and you're going to present that in court. You're saying?
Oh yes, sir.
Okay.
What do you
Okay.
have some reason?
All
Why
right.
would you?
Literally all you have is denials
Bro,
of it.
good
It's
luck to
embarrassing.
you, bro. I
It's
mean,
so embarrassing.
I got
good
a
luck to
question.
you. Go
Got a
and
question for
do
SC.
it. I could care less about your picture, man. I mean, seriously.
So let's see.
If you feel that strong, take it to court and make a case.
Well,
Say, look, Your Honor, I have a picture. I measured it, 105 miles. Now this is proof of globe for me. What do you think, Your Honor? What do you think the judge would tell you?
Well, the judge would ask the opposite side to make their debunking of why, their response of why they think this wasn't evidence of globe curve. So that's you. What would you tell the judge? You'd say, Your Honor, this is not evidence of Earth curve because why would you give him?
I'd say, Your Honor, get the
just a
bailiff.
picture.
This man needs help. That's what I
It's
would
just
say.
a picture.
You probably would,
SC,
but
I don't understand why you're here, SCD. Absolutely nothing.
He needs big help because, Your Honor, he keeps telling me this picture proves the globe, and I keep telling him, Your Honor, you need help. I think you need help. I keep telling him, but he won't listen to me. He keeps telling me this picture is proof of globe. That's what I would tell him.
But what if he says to you, Mister, why looks like a good picture to me? Why do you think it's not evidence of a globe?
Because I would tell him, Your Honor, evidence means a concrete measurement, and these guys just snap the picture and think it's a measurement. I mean, Your Honor, you must admit it's ridiculous, Your Honor.
Jesse, I got a question.
Uh-huh.
So, SC, does this picture, I got kind of a two sort of sided part question. Would this picture look the same if the Earth was flat versus if the Earth was a sphere? And similarly, can you draw any conclusions of the shape of the Earth based on this picture?
Well, I think if it was more triangle shaped, I'd have a better shot at it. But seeing how it is now like that, to me, it's completely useless, Extremistes. It's just a picture.
So you're saying we cannot draw any conclusions of the shape of the Earth based on this picture?
I'm saying it's just a picture. You can draw any conclusions you like. To me, it's just a picture.
So instead of saying you cannot draw any conclusions, well, I guess you'd say that. You can draw any conclusion you want to based on this picture.
Yeah, I could say it's a pretty picture. Look at that. What nice picture. I could say that.
Okay. I mean, that answers the question.
Why do you bother, SE? Like, I don't understand.
What's that,
you literally have nothing. Why do you bother speaking at all? You literally have nothing.
Is that your opinion? Is that what you're saying right now? Good for you. And what do you have? What do you think you brought to this combo?
I have measurements similar to Jesse.
Simp for the other dude, like a lawyer on the side. What did you bring in? What have you said today? Hey, SC, you didn't say nothing. Hey, SC, you didn't answer a question. That's all you said all night.
Yeah, because that's you never answer questions. You're
like the peanut gallery
all
guy
the time. I don't understand why you ever bother speaking to anyone.
Look, dude, you don't have to speak to me. You can go away right now. We won't even miss you. We won't even notice you came and left, bro.
Same for you.
Well, you can't honestly expect someone to admit defeat, right? And be like, you guys are right?
Yeah, they're flat earthers, correct? Yeah.
Correct about what? You came in with a picture. I'm laughing at you guys, bro. Right now, I'm laughing at you.
Okay, so let's say you grumble to the judge that it's just a picture and not a measurement, and the judge turns to me and he says, Mr. Jesse, is this a measurement that someone could reproduce? And I'll say, oh, yes, Your Honor. The coordinates are in the picture. Everything's right there. It's a public park. Anybody can go right to those coordinates, top left corner of the picture, shoot right at that direction. They can see Mount Shasta. They can measure this exact same thing. So then the judge says, all right, call a local surveying team. We're going to send them up there. We'll bring them
Or
in
you
as an
think the judge
expert
is going to
witness.
do that? Is not going to ask you for the proof? Obviously, you have
Maybe he would
no
ask.
clue how courts work, right?
Maybe
You
he'd
think
ask
the
me
judge
to.
is going to
Yeah.
call somebody for you and have a
No, maybe
measurement taken?
he might ask
You
me.
are in fantasy land, my friend.
Okay, he might ask me to hire some surveyors to testify as
He's going to
expert.
ask you,
What?
let's see the evidence of which you speak. And if you don't have it on you and just have a picture, he's going to throw you out of court.
No, I don't think so.
Yeah, ask any lawyer. Yeah, ask any lawyer.
If I'm producing what appears to be valid evidence, a record of an actual measurement, and the other side thinks I faked it, but they have no evidence, the judge very well may allow an actual remeasurement to be taken. So let's just say, for the sake of
But you
discussion,
didn't take a measurement to begin with. You think you're a crafty salesman, bro. You came in with a picture. You have no measurements. You have nothing. Just a picture. Now, maybe the judge might grant you a later thing to do to take measurements, or maybe not. He might laugh at you and say, "Are you here with just a picture accusing this gentleman of something?" He might just throw you out of court right there.
I thought you were going to say I came in with a picture and that I was going to go out with a picture.
Maybe you'd be going out in the window or with a bailiff. I don't know. But you certainly ain't going to prove anything with a picture.
Well, let's
Guarantee you that. That the Earth is a globe with a picture, you'll be laughed out of court.
Let's say the judge does allow time for more measurements. He says, okay, we will reconvene in 48 hours and sets a new date for the continuation of the trial. They do that sometimes, like if something new comes up or whatever. And somebody hires a professional, uninterested, unrelated survey team. They go up to that mountain, they measure it, record everything, and then 2 days later, they come back to court and they testify. They say, Your Honor, we measured the angle to the top of that mountain from the plaintiff's position, and here are our measurements. We used all the proper methods and tools, and this is what we measured, and it matches mine.
So you realized your picture was a futile endeavor and it's a complete joke and a waste of time, right?
Oh, not at all. It has brought me much enjoyment.
Dude, you have nothing, man. Give it up, bro. You came here with a picture. You're going to leave empty-handed with a picture. That's all you have. You can dream about what the judge could have done or this and that, make stories. All you have is a picture. That's it.
I'm sorry, that's not the way it works in New Zealand courts. The judge doesn't get to decide if the judge doesn't have the knowledge of the subject. The judge will ask for expert witnesses from either side, and then they might ask for a couple of expert witnesses from either side, and those expert witnesses will have to please the court somehow, maybe a jury or maybe take some time off to, have a meeting and talk about it.
Right. So
okay.
let's say,
so they might. You mean they're gonna hire people to do measurements and stuff like that? Is that how it works?
Yeah, like you have two parties, and you have one with a photo. Two parties are going to the defendants and the what do you call it? The other team. They're going to have to come up with their own expert witnesses.
Right. So I would probably have to hire my expert witnesses, and USE would have to hire yourself a team of expert witness surveyors. All the surveyors would go up there, they'd measure the angle of that mountain, they'd get the same results I did, and then all the expert witnesses would come back. I would say, Your Honor, my expert witnesses have gone up, measured, and they measured the same number I did. And the judge would turn to your team and say, well, sir, what did your expert witnesses? And you'd have to tell him, well, sir, Your Honor, they went up and they measured the same thing his team did.
No, don't rush. No. I'm going to tell them my team, Your Honor, made a straight line segment and kept extending it, Your Honor. We went past 100 miles, Your Honor, and we still had a straight line segment, Your Honor. This guy has no clue of what he's talking about. That's what I would do. If I could hire my team, I would blow your team out of the water. You wouldn't stand a chance, bro.
Well, until I demonstrated to the court that your straight line segment actually was not straight because your plumbs were not all parallel.
Oh, yeah, good luck with that. I'll put my surveying team against yours anytime, Bubba. You will be ridiculed.
Yeah, because our expert witnesses will say they never account for Earth curve when they're doing surveying.
Well, in this
Yeah,
case,
and I'll show him as evidence a poll done by a surveying from the city of Montreal that I stopped one day, and I asked him, how long can we make a straight line segment? And he said yes. And I asked him, how long can we extend that straight line segment, sir? And he drew me a thing on a pole that extended straight out into space. Of course, he drew a sphere because, he's programmed, but indefinitely, he told me, Jesse, you would lose, bro. You'd be laughed out of court.
But see, here's what I'd say, Your Honor, his team did not go to measure the angle that I measured. The question here was whether I had accurately measured this angle. And he would either throw your team's testimony out of court or make them go measure again and actually measure the angle as I claimed I had. So what would you say to the court when your and my expert witness angles all measured the same?
The court would say, are those tools you're using fit for the purpose? And they're not.
Hey, Carlos.
That's right. Yeah. What tools are you using? He would tell you.
Hey, Carlos, are you up for some discussion? I don't think I've got to talk much with you. Montreal doesn't want to talk with me.
I'm only here for the
Montreal is
peanut.
laughing at you, bro. What are you talking
I'm only
about?
here for the peanut gallery because I'm driving.
Oh, okay.
What tools are up for the job? What tool would you use to measure angles over
flat earthers are tools. Sorry, I had to say it.
My tools are up for the job. The manuals put no limitations on the maximum distance, but the flat earthers just like to say that they can't be used very far because that's when Earth curve becomes undeniably obvious, and so they just nuh-uh them as a tool.
Once a surveyor comes in court and the judge and the jury starts asking him questions, they're gonna laugh the hell at you, bro. You're gonna look like the biggest fool that has ever entered a court when you start telling them these things. When the surveyors start explaining what a straight line segment is and how you can extend it, man, you're gonna look so bad. You're gonna wish you never went in that court.
Okay, we could daydream all day. Anyway, does anyone know how long? Does anyone know how long Xanax is gonna be? Having a warning tag because apparently he's got a warning tag, so he can't access this chat right now or something. Does anyone know? Hello?
No, I don't know.
Any mods?
I was busy doing a little plumbing in my bathroom when all that happened.
Let me see.
I just came back and the room was empty.
Any mods here? Let me see. I don't know if I see any mods here. Maybe I should just type this.
Geo's here.
Yeah. Well, I mean, I don't know if he's AFK, though. He might be AFK.
Right. I haven't heard anyone talking.
Why? What's going on? What do you guys want?
Well, because Xanax got like a warning tag or something. He's trying to figure out how long he has that for. So.
Oh, Montreal's a mod.
Oh, I don't know how long he has it for, and I really don't know how to check. So sorry, guys.
All right, I'll just ask in the chat then, in the text.
So Montreal. Oh, go ahead. Whoever said that.
Yeah, I was going to say, have you ever taken a different route for conversing with the flat earthers instead of debating the size or shape or dimensions of the Earth, like about their other beliefs that prevent them from accepting any of these observations?
Not really. I mean, yeah.
Why would map makers use a straight line scale to map the entire state of Oregon if it's curving?
Hi, Jerry. How are you doing?
What's going on?
Oh, not too much.
Look, you guys could believe in your sphere. No one's going to take it away from you. Just don't try to convince us of your silliness. That's all.
There's
If
nothing
you
wrong
want to
with the
live on
sphere.
a spinning ball surrounded by water in a vacuum, you can do so. But just don't think you're going to convince us of any of that nonsense. That's all.
Well, my goal isn't specifically to convince you. My goal is to find out if there's any possible flat Earth explanation for my real life observations. And I think basically you're saying no, there isn't. And I appreciate your honesty in that.
If the reality says
You
it's
think
measured with straight lines, then who cares what a flat earther's explanation could be? Right?
it could be flat, triangle, cube, earther. It doesn't matter. Reality is reality. You're not going to change a straight line. You're not going to change a straight line segment. You're not going to change surveying. You're not going to change how water flows. You're not going to change how gas flows. You're not going to change how rotation is. You're not going to change, how water, like, you're not going to change these things, bro. Fluid mechanics. You can say whatever you want. If you want to think you're traveling at millions of miles an hour, spinning in a vacuum, that's your prerogative. More power to you.
Yeah, I guess just to maybe, I don't know, continue some of this conversation or something similar to this conversation. Yeah, I really don't get this argument about like, like this whole, oh, what if our visual space is curved or something? Like, like is the end goal saying that, oh, we can't do like certain measurements because of that? Like it's pretty obvious that where we're pointed towards, right, or where we're facing towards is where the thing is going to be, right? Like there's no way in any world, except for maybe some bizarre world, but in any world though, where I have like a stick, a really, really long stick, all right, and there's an object in front of me, and when I go to turn towards the object with my stick's going to hit into the thing that's in front of me, right? So I expect things to visually be there as well, unless the light is bending, right? But the weird thing is though, the arguments that I've heard is that it has nothing to do with the light bending, it has to do with the eyes or the lens or whatever the hell it is, and somehow that could like misplace the object. Like it's just weird. Like okay, if the object is misplaced, right, where and then how much, by how much, right? Like by how much is the most important part, because if it's not enough to matter, then the whole argument is moot. It's moot. You know what I'm saying? Like let's say it's off by like 0.00001 degree, right? Then no one cares. The what is it? The measurements that we make for the, what is it called? The spherical triangles, whatever, right? Then at that point, that whole spherical vision thing doesn't even matter, But anyway, the main point I'm trying to get at is, I just think it's dumb. I don't see any evidence for it. Jesse's posting like that picture. I read up on that. Like the thing that I saw was like, it was about like, trying to guess like if the thing is pointed towards the ball or not. And I feel like you could replicate that in a 3D program and get very similar results, where it's just hard to guess. It's just hard to guess like where it's pointed exactly. But anyway, just to shut up now so I can give you guys
What
a
are
way
you
to.
talking about, Arma?
I'm just
I
ranting
I
right
didn't
now.
understand
I'm
anything you
mainly
said.
ranting. I'm mainly ranting right now. But to sum it up, though, I just don't get this argument about curved visual space from the flat earthers. I just don't get that.
Don't worry
The
about it.
curved visual space. Yeah.
I just
Just see
don't.
which way the
Did you
water
say?
flows.
Did you say spherical triangles?
Yeah, dude, we're not gonna fucking have this argument like, oh, you can't have a triangle. Yes, a spherical triangle. All right, what about it?
That's an oxymoron.
You're a fucking oxymoron. that was totally like, what was it? That was that was instinct. I didn't mean to say that.
Hey, Scrat, are you just trolling, or have you actually never heard the phrase spherical triangle before?
Actually, I've never heard that before because that doesn't make sense.
Oh, okay. Well, let me explain. We didn't come up with it. It's in geometry books. Basically, people realized that a sphere was a shape. Like, they made glass marbles and basketballs and stuff. So they're like, well, what if we make 3 straight lines, as straight as we can get them, on this sphere? So they're like, well, of course they curve in one dimension, but they're straight in the other dimension. So they called it a great circle. And then they're like, well, what if we take 3 great circle lines and connect them and make a triangle? What do we call it? And they says, well, let's call it a spherical triangle. Spheres do exist, and
Oh my god.
so they needed something to call that phenomena on a sphere, and that's what they called it, and that's all it is.
Yeah.
Do you say that they drew straight lines on a sphere?
As straight as they could get them, the shortest distance between 2 points on a sphere.
On the surface.
How do you draw a straight line on a sphere?
Okay,
That's-
look, the point is, if you just take a basketball or something and you write, you draw like a line on it, or even better, how about this? Okay, this can work, right? If you take a piece of paper, right, and you draw a straight line on it, right, and then you curve it around on itself, right, as to make a cylinder. All right, it was initially straight when you drew it on the paper. Obviously, now it's not though, because you're curving the paper.
That's not what you're saying, though.
No,
you're saying drawing a straight line on a sphere, which is impossible.
Okay, so similar to drawing a straight line on a piece of paper and then wrapping that paper around on itself, right, to make like a cylinder. All right, that's as straight as it's going to be on that cylinder, right? It was initially straight when I had it, as a piece of paper, but when I curved it on itself, obviously it's technically not straight anymore, right? So doing the same thing on a sphere, okay, the straightest you can get on that sphere's surface, right? Make a triangle on that. Yeah, I don't care about the.
Here's the thing. Well, here's the thing. You can't make it straight at all.
Okay,
because
whatever.
a sphere constantly curves.
Okay, it's not straight then. Whatever. We still make a shape, all right, and that shape is called a spherical triangle. Okay, it is so pointless to have a fucking semantical argument. Like it doesn't matter. All right, like there is a name. It has a name. All right, whether it's a triangle or not, it's still called a spherical triangle. All right, like you guys are acting like fucking like elementary school, schoolers, whatever. Like it's so dumb. It has a name. All right, like
Arma. I literally just came from Jen Panda's server right now, and there was a guy acting like a girl, and right now I'm hearing you almost equivalent to this dude
acting like a girl.
Yeah, he was like trying to be a female, but you can hear he's a guy. So
okay, and you're saying what are you trying to say here?
In other words, your falsehoods are very, very prevalent, just like that dude. Oh my god!
Where was I wrong? Where was I wrong?
Because everything you're explaining right now is based upon the model that you cannot let go of.
That's not. No, it isn't. Spherical. You can have spherical triangles without a globe Earth. You know that, right? It's called geometry.
No, you can't, because a triangle cannot fix on a globe.
No, hold on. You're mixing it all up. Okay, yes, sure. All right, we have the globe. All right, and we can make.
Arma,
dude, please have a no. Seriously, no joke. Grow. I'm not trying to be rude. I'm sorry if this is coming out, but seriously, like just grow a slightly larger brain, man. Because this is stupid. All right, this is geometry.
You're arguing with a drunk dude right now, bro.
Okay, yeah, I'm
drunk. I know. Maybe I need to grow a bigger brain.
Spherical triangle.
So Arma, listen to me, a drunk guy. A triangle, will never fixate on a sphere unless you curve and bend the lines that that if you want to, that's fair, that's fine. But once you bend the lines, it's no longer a triangle. Let's get that out the way.
Yeah,
I'm drunk, by the way, and I'm still telling you that, and I'm hiccuping because I've been drinking since yesterday. So listen, listen. A triangle is 3 straight lines. No matter how you want to fucking manipulate that.
Okay, so that's why we're calling it a spherical triangle, right? Just because it's called triangle doesn't mean it has to be, the exact. It's just a name, all right. So we're calling it spherical triangle, all right. We could
There's
even
no
call.
such thing.
Okay, fine. Okay, fine. Then let's. Okay, then we don't have to name it that. You understand it's a name, right? So we can literally call it. I don't know. I'm trying to think of a fucking random name. Blurpy fart. Okay, let's call it. I don't know. Blurp. Okay, let's call it blurp. Okay.
Mm-hmm.
Okay.
But it's still not a triangle.
I don't care if it's a triangle or not. Who cares if it's a triangle or not? You guys are. This is such a stupid point. No, it doesn't. It doesn't matter.
Yes, it does. Yes, it
No,
does. Because
tell me why it matters. Tell me why it matters.
Okay, because in math, a triangle has no curved edges. It's
called the blurb. Remember, we're calling it a blurb now, right? So why does it matter? Why are you trying to compare it to a triangle for?
Okay. So
it's called the blurb now. It's called the blurb.
You're only introducing this because it has to try to make sense in your paradigm.
It's called the blurb. It's called the blurb.
Okay. Well, you have a blurb. You have a blurb, but that is not reality because there's no blurb in reality. Get it straight.
But I just defined what a blurb. But we know what. Okay, hold on. Okay, if we define something, right? If this is how, if I have a certain set of rules for what what a blurb is, that's what a blurb is. I define that as a blurb, right? So when I have, when you have three angles that you're making on like a sphere or whatever, and you're making these curved lines, okay, on the sphere, all right, and you have three of them.
Nobody's
you have a blurb.
Curved lines on a sphere. Nobody's making curved lines on a sphere because it's not a sphere. That's your problem. You're interjecting a falsehood to make it a
okay,
curved
dude. Listen,
sphere.
I'm gonna listen for real. I mean, I know you're cool and all, dude, but I'm not gonna talk to you though if you're not gonna even like actually try to have a conversation with me. All right.
Well, here's the conversation.
No, we're not having a conversation. This is not a conversation. We're literally talking past each other, all right? If you want to,
that's fair.
Yeah,
that's fair. It's not a curved ball, bro. I'm trying to wake you up.
I'll respect that. We'll have to agree to disagree.
Okay, all right. I don't know why you want to hang on to the ball, but it's not a ball, bro.
Okay,
it's not a spin ball. Guess what? Earth is not a ball.
Okay,
that's it.
Hey, if triangle's gonna have curved sides, then what I posted at 47 past the hour, that's a triangle, right?
No, because a triangle, right, it's a two-dimensional, like shape, or whatever, right? And what you have there is technically, at best, you have. No, it's not, because you have the circle is two-dimensional, right? But the vertexes that you have, right, those are on the the outside of that circle, which would be technically like a one-dimensional shape, whatever. That's pretty much a curved line, whatever. So what you have there is not a triangle. For it to be a triangle, it needs to be, angles or lines on a surface. All right, if that's not a surface, you have whatever that is, like a line, an edge.
What's your definition of a triangle?
It's a pretty much a two-dimensional shape on like it is a specific two-dimensional shape on a surface, all right, which is two-dimensional, all right.
What is it?
It has three angles, three lines, on this surface.
Wow.
3 lines, right? That's what I have there.
But that's not on a surface though. That's literally on the edge of the circle, so that doesn't count as a triangle.
The angles have to add up to.
Oh my god!
They got to add up to 180.
Exactly. So once you bend one line, then it's no longer 180. Come on, guys, wake up.
Okay, if you want a traditional triangle, sure. But I mean, if you want to do like obviously
traditional triangle, really, Arma?
Can I just finish? Okay. But if you want to have like other triangles, like spherical triangles, or like a cylinder triangle, or whatever shaped triangle you want, whatever. Hear me out. If you want a triangle, if you want it to be considered a triangle, then you would need straight lines on that surface. From my understanding, I could be wrong about this, but from my understanding, you have to have straight lines on that surface, all right, and they have to have 3 angles and obviously the shape on that surface, all right. But
and that's
this here, no, but that's not what you have though, because technically those lines are curved. If we're assuming, right, what we have here is hold on. If we're assuming we have
curved.
Hold on, let me just fucking finish, all right? If we're looking at your image here, right, which is a square, right, and we're assuming that those 3 points, right, are the vertexes, right, and we're assuming those 3 lines, I guess, in between the red lines, right, that are curved. If we're assuming those are the lines, right, then that isn't a triangle because those are curved onto that surface, right? They're curved on that surface, all right? They're not straight on that surface.
Curved,
So
kind of like a sphere, right? So you can't have a
yeah,
triangle
I
on a
get
sphere.
that, but the surface of a sphere, though, all right? The surface of a sphere is definitionally two-dimensional.
Arma,
Bro, don't take it. Just take it. Look, if you're so confident, bring this to a fucking, I don't know, person who's into like, geometry or whatever the fuck. All right.
No,
Like,
everybody figured out what a triangle was 2,000 years ago. We don't go to that.
That would be me. So a triangle is a two-dimensional shape with three sides, three angles, three vertices, and they're always straight lines. There is also something called a spherical triangle, but it's not a triangle. It's a spherical triangle, and they're different shapes with different definitions.
Fair enough. Yeah. Fair enough.
Right. Arma.
But that's. But hold on. I want to just go back to Matthew though. So, but yeah, I mean, obviously, yeah, there's a definition for triangles, and obviously the definition for spherical triangles. I was just saying, from my understanding, if you want to like coin the term, like this is a a cylinder triangle or whatever shaped triangle, right? Like on a three-dimensional surface or three-dimensional object, on its surface, right? I imagine for it to be considered like a triangle on that surface, the lines would have to be straight, relative to that surface. Anyway, I mean, I don't know if that's the case. That just seems to be like the pattern that I kind of picked up, right? Like on a flat, plane, right? The triangle has straight lines relative to that plane, and then on a sphere, right? The lines are also straight relative to that surface. Once again, obviously it's a spherical triangle, but I imagine the rules apply to other three-dimensional objects as well. If with their surfaces and whatnot. I don't know if that's true, but that's
Arma. Have you ever built anything?
Yeah, there's been some stuff that I've kind of built, but I mean, they're not like built. Like I mean, it's like like I don't know, like really stupid shit or something. I don't know.
Do you know what the 3-4-5 method is?
Isn't that like a triangle thing?
Yeah. Do you know what it is?
I mean, kinda.
So if you could lay something out at a 3-4-5, that means that you're square level plumb. Do you understand that?
Okay.
So everything about that is flat and horizontal and vertical. Nowhere in that, understanding is anything bending or curving at any point. It's all straight and flat. And in the big and in the big world, when we're building big buildings, this particular 3-4-5 it holds prevalent because we understand that there is a straight line.
Okay.
There's 3 straight lines.
Okay, well, that's why I said earlier, I was naming the spherical triangle blurb because at the end of the day, it's just a name, all right? You're overcomplicating it by, saying, oh, the name, because the name is, like paradoxical, whatever, that, that can't even exist, whatever. Right? That's why I just said, just name it blurb, whatever, right? It's just a name, all right? There's still math you can do for this blurb or the spherical triangle, all right? So you saying, oh, it can't exist, that's just you saying, no, all right? There's literally shit on it, all right, man?
No. My point is, it doesn't exist.
It doesn't exist?
You are saying that there's a spherical triangle. You say that. No, I'm not saying that. You're saying that. And you are then invoking something that is not reality because nobody
Why isn't a spherical triangle a thing?
Because nobody builds anything to that spherical triangle. Nobody does that.
A spherical triangle is not a triangle, but a spherical triangle is a thing, and a triangle is a thing. They just don't overlap.
Exactly. It's something, but it's not a triangle, and that's my whole point.
No, you just said earlier. No, you're kind of moving the goalpost back and forth. Actually, not at this point. At this point, you're just making sure the fucking ball isn't. You know what I'm saying? It's just like because you at one point you were saying, okay, it's not a triangle, but then you're also saying, oh, well, it's not a thing in general. But now you're saying it is a thing. It's just not a triangle.
It's not a thing in construction, but there is a quote unquote spherical triangle, but it's never used in reality. So you can have a spherical triangle in theory, but technically it's never used as opposed to the way we build shit. So
Not never. It's just that most triangles are, most buildings are rectangular, not spherical, except for that new thing in Las Vegas.
Okay, I think I understand this here. So, what you're calling a spherical triangle is three lines drawn on a sphere that connect each other. You're calling that a spherical triangle.
Him and everybody else, right?
Okay, gotcha.
The
It's
coin was
not a triangle. It's not a sphere. It's a triangle-like shape drawn on the surface of a sphere.
Right, and it's not a triangle.
Gotcha.
It's a spherical triangle.
And you're just calling it that. Okay, gotcha.
Not him. Wolfram Alpha, mathematicians, geometry people, everybody.
and it's been called that for like thousands of years, I think.
Well, I didn't mean just you. I said
Yeah,
that's what you're calling the shape drawn on the surface of a sphere. It's called a spherical triangle. Gotcha.
Yeah, that just sure.
The first definition of a spherical triangle is contained in Book 1 of the Spherica, a 3-book treatise by Milanius Alexandria, circa 100 CE.
Were you there when he did that? Did you know personally he did that? Maybe he was lying.
Yeah, were you alive that many years ago? Like, did you watch
Do
him
you have
write it? No.
personal knowledge of this?
Well, I was just quoting Encyclopedia Britannica.
So no personal knowledge.
No.
It can be.
Did you watch him? Did you watch him become born? Like,
personal knowledge is not the criteria for truth. Wait, what? No, that's wrong. Just because you don't have personal knowledge of something does not mean that it's not true. I'm using flat Earth logic here, by the way. That's wrong.
Yeah, you had to clarify. Just
Yeah,
because
wanna
you were.
be
It was pretty
clear.
convincing. It was
That's flat Earth logic, not real person logic. Logic?
how did that become like spread in the flat Earth community? Like, the TEDx reasoning.
Is that what?
How did what
reasoning?
get spread?
Isn't that what it's called? The TEDx? I mean, I'm not pronouncing it right. The TEDx reasoning.
Is that what that's called?
There is something called that, but they don't actually do it. But they use the term and say they're doing it.
In any case, yes, yep. I'm just. That's pretty cool though, Matthew. That you're actually that's your thingy. The shapes and the maths and yeah. Because I mean, like I'm not like an expert on this, obviously, and I'm gonna pass the mic, if someone's knowledgeable on that. So, all right, I'm just talking right now. Anyway, yeah, that's pretty cool though. But yeah, spherical triangles. We'll call them blurps if you want. Apocryphone. I'll call them blurps if you want. Yeah.
You could just call them spherical triangles. That's what the rest of the world calls them.
That's true. That too. I could do that too. But I don't know. I think spherical triangles is like a trigger word for apocryphone. So maybe I can, I don't know.
It wouldn't matter if you had a totally different word. They'd bait you into saying, "Well, is it like a triangle? Is it on a sphere?" And then it'd be the same thing over.
Perhaps.
Can I build the porch with a spherical triangle?
If you got a spherical house.
See how silly you guys sound, man. See how silly you sound.
No, yeah, exactly. Hold on. Amar, whatever. Look at you are trying to invoke this stupid fucking like shape that nobody ever fucking accounts for in anything other than this ball fucking belief. So when we're building something, nobody fucking builds according to a spherical triangle. Nobody ever in my history, in my career, have we ever built something to a spherical triangle.
Right,
But
because
you,
your buildings are rectangular mostly.
right, because that's reality. Now,
Well,
once
not
you
all
fucking
buildings are
invoke,
rectangular.
oh my god. Regardless, okay. Actually, I'll give you something. I'll say a fun fact. The Disney Concert Hall over in the fucking Los Angeles County, there was no angles to the building, and it was a fuckery because as it was built, they were trying to figure out how you can build this building because the designer or the architect he made it to where there's no fucking angles. That's the Disney Concert Hall. Look it up, Google it. I don't give a fuck.
I've been there in person.
And
Also, see
it was
the one past the hour. There's another spherical building I showed.
Nice.
Okay, so this was the only building in all anywhere where there was no angles and there was no fucking 90-degree angles
Right.
to the entire building. Now, if you want to incorporate this fucking spherical fucking triangle bullshit, like that's total bullshit, bro. Like, wake the fuck up, dude. Nobody fucking builds according to that, bro.
Yeah, what are you talking about? You use a spherical triangle on spherical buildings. You use a regular triangle on rectangular buildings. It's really simple.
Apocryphon. Why is the
There's no spherical buildings, bro.
I
There's
posted
not
one at
fucking
one past
one
the hour.
building.
There is one building in Las Vegas. I've seen it.
What? Oh, really? And
Yeah.
and they use. Is that like the Disney Control?
It's like that.
It's apples to apples or orange to oranges,
Right.
or is it apples to oranges?
Spherical triangles you would use if you're building a spherical building. Regular triangles you'd use if you're building a rectangular building, which almost all buildings are rectangular. So regular ones.
Okay, so if you have a building that's being built accordingly, you're trying to say that they use spherical triangles? No, that's
Go look
false,
at the.
because even
Take a look at the chat before you start talking.
no, dude, I'll tell you right now, bro. Even the Disney Concert Hall, to where there's no angles, they never had to incorporate the spherical triangle. All they incorporated
Okay,
was
grab
the
another beer, then look at the picture at one past the hour and count how many triangles are in that building.
Dude, are you
Or
kidding right
don't,
now, bro?
One past the hour.
Okay.
Spherical building.
Okay, let me hear this out. So, what are you trying to equate a spherical triangle with what?
I don't know. We've just been talking about spherical triangles for an hour.
Yeah,
because it's Apocryphon's trigger
Ah.
word.
So
knows the answer
let me
to
hear
that
this. Let me hear.
Safety word. It's a safety word.
So okay, it's a spherical triangle is a construction method, right, for support and strength. It's a really nonsensical debate unless you're in architecture or construction or some type of government organization. You don't know what you're talking about. You're just making shit up to troll people, and it's ridiculous. Where's the mod? I'll get you guys kicked off. You're just full of shit. So
Wait, who? Which one? Which side? I'm really confused right now. What are you
I'm
talking
confused. Is he complaining
all of
about?
you.
All of us.
No, I'll get you all kicked off because it's bullshit. You just filling the airspace up with nonsensical rubbish.
Right, start a new
So
conversation.
what's the point?
Would you like to present us some stunning new flat Earth evidence, or some good old tried and true flat Earth evidence?
Yeah, let's hear this. You got anything?
Yeah, the Earth's not a ball. That's
Why would I talk to people who rant about things I don't understand?
Yeah,
I might as well talk to the grass. The grass will be more interesting.
That's a good point, but we do understand things. So
Actually, we should be touching grass actually, because. Or maybe I should be touching grass. I don't know about the rest of you guys. I need to touch
grounded. Because you get grounded. Yeah, for sure.
Well, you
get grounded, by the way.
you could bring us some good globe evidence then, Blatek.
Yeah, give us something. Give something to work with, you know?
I want to hear some globe evidence. Evidence based on what?
Observations.
Okay, look, let me tell you. You really want to know the truth?
We think
We're
we do,
inside a
go ahead.
computer game, right? We're inside a computer. It's not the Matrix.
I fucking
It's
knew
an
it.
operating system created by ancient people. Right?
Blatek, computers
the sun
are
the sun and
incapable
the
of
moon are
simulating
man-made.
consciousness. We know that
Why
we're
do you
not in a
think-
simulation because computers are incapable of simulating consciousness.
How do you know? How do you know they're not capable of running consciousness?
Because consciousness is based on an immaterial aspect. No physical thing can be conscious.
Well, I will say this. There is an argument to be made that, at least for me, because once again, this is what I kind of believe in. The whole the Descartes thing again, right? I don't really, you can't really know anything but your mind. For me personally, all right. I know other people have their own views, but for me, I don't know anything else but that I exist, right? Now it could be, right? Here's the thing: it could be that computers could simulate stuff, but I also can't. I can never really prove that either. All right, it could be that they don't. They really don't. And there's
it's not simulating. The computers run a reality because we know we're real. We know everything's real. We can touch it and feel it and create it. But everything around us is operating.
Yes, but computers are made of physical things, physical objects like silicon or whatever, and
But it's
nothing physical can create consciousness.
I do have a theory on that, or not a theory, whatever you want to call it. All right, there's a little me philosophizing. There you go. I have a little philosophy idea on that. I won't share it though because I want to maybe write about it in a book first and then have that No, but I mean it's interesting though because I do feel like
because it's flat. Like the Earth is flat, right? It's an operating system.
Okay, well, I think it's
that's when they drill in. When you drill in the soil in certain areas in the rock, you find oil. Now, why would you find oil? Tell me that.
What?
Because it's there. What are you talking about?
It's the
because it's been placed there. It's placed there as a cooling system, right? Computers get hot. Our computer's very hot. It burns the rocks, all the construction, right? That's why we have lava.
I wanted an actual philosophy. Here we are talking about some fucking Minecraft Matrix thing, or we're in a video game. Come on, man.
Okay, get out of the science fiction realm. You guys are stuck in this 1960s mentality.
No, you are.
Come on, I wanted a legit.
I'm not. This is true. Get up and have a look at the moon. The moon's man-made, and so is the sun. It's obvious.
The moon has been there as long as man has been around.
That's all. We don't know that for a fact.
No
I think man
person has
created-
ever not experienced the moon. What are you talking about?
How can you make that statement and be serious? How do you
What statement?
know that the moon has been around since man has been around? How do you know that?
Because no person has ever reported making the moon.
You know,
because all the knowledge was lost. All right, the ancients who created a lot of these objects.
Wait a minute. Hold on. Wait.
Okay, hold on for a second. I'm not saying that it's it wasn't always there, but you can't just say it's always been there as a statement of absolute fact.
It's always been there as a statement of absolute.
You actually can't make that.
Hold on. I want to turn this into an actual philosophy chat. All right. So, okay, aren't most of you flat earthers, not to be that guy, but aren't you most of you flat earthers like religious, whatever? So, like, you guys at least believe that it's always been there, right?
Yeah, they're right. There is a creator. Yes.
Okay.
But
So
a lot of the objects were created after the creation.
So hold on. So is the argument then that if you're not religious, then you don't know if the moon was man-made? Because that's an okay argument, I guess, because it's like,
Okay, now think about it. Okay, now listen about it. Why do you think all the globe earthers are atheists? Isn't that bizarre?
We're not.
You'll find
most
of the
globe
globe
earthers
earthers
are not
atheists and communists, right? They all fall in this same category.
Most globe earthers are not atheists.
Yeah,
and you'll find their big science fiction believers. It's a very common pattern.
Stop. You can't say that. You cannot say that because I've been a Christian all of my life, and then until just 6-7 years ago, I believed in the ball. Okay, the globe.
When you
So
stopped going to church?
You can't say that all believers are atheists or communists.
Take a poll. Take a poll. You'll find that majority of the ballers, most of the ballers are atheist, communist type.
I don't know about that.
That's not true.
That's not true.
100%.
I'm neither.
The vast majority of people believe in the ball. How can you say it's only? Well, do you realize that almost everybody believes in the ball, and there's a lot of Christians who
They don't believe it. They've been told it. There's a difference.
Yeah, so they believe it.
Is it really a belief or is it indoctrination?
What the?
Well,
I'm
it
not
is a
trolling.
belief. That's
If
my
you're
point.
indoctrinated,
It is a belief.
If you're
Because it's
indoctrinated,
not reality.
You still believe it.
Oh, my inside sources tell me that Blautek was just a troll trying to get a rise out of us.
I mean, yeah, that's
serious.
obviously what he's doing.
I am 100%. No, I'm 100% serious. Trolling is
fucking
talking
ass, you
about
are. Get-
spherical triangles for 3 hours.
Get
That's
the
trolling.
fuck out of here, man. You're trolling. Get the fuck out.
Okay, so Blautek,
What did I
about
troll?
7% of the world's population are atheists, and so
Right.
it cannot be true that most of the ballers are atheists because there's only 7% of the world.
You
The
and
simple
your numbers.
statistic. Oh, I'm sorry. You're right. I use numbers in a.
Well, hold on. No, because that would just mean that 93% are flat earthers.
Damn, there's a lot of flat earthers.
That's stupid.
47.5%.
Well, actually, okay, you've thrown a spanner in the works then, right? We can only deduce that people are now going their own ways, aren't they?
Or no, what the reason you say that like most of them are atheists is because the only ones who argue about it, who have to defend their religion, are the atheists.
That's not
they
true.
have to defend their ball. Yeah, for the most part.
I'm not
Because
an
a lot of
atheist.
Christians would. I didn't say all.
You kind of just did, though. I mean, at least you kind of, or at least it seemed that way. Maybe you just maybe you just got the wrong impression. Okay, go on.
I'm just saying most of the people who argue, who debate with flat earthers, most of them are atheists.
That
At
could
least
be true.
almost all that I've debated with, they're atheists, and that's because they really believe they have to believe in this because they can't believe in a God, or they don't want to believe in a God. So the ball has to be real. Now, when I do talk to Christians, I show them the logic of it's stupid to think that it's a ball. Then they start to think about it.
Okay,
Now,
hold on. I would actually kind of prefer if the Earth was flat, because then I would have certainty. Like, well, there you go. That you know what I'm saying? But I have personally seen no evidence for the flat Earth. That shit, I would prefer it to be flat, but it's not. From what I've seen.
I don't know how you can say.
So you're saying the Earth is not flat?
Yeah, I'm saying I would prefer it that way because that would be a clear sign. Like, oh shit, yeah, fucking this shit was created. Like it's you know what I'm saying? Like, I would be 100%. I fucking don't like. There's no way you could explain that naturally. That would just be the weirdest shit ever.
Okay. Do you have a vision problem or any eye problems, eye infections?
No, my eyes are actually. I actually have pretty good vision actually.
Okay, and you still believe in round Earth?
Yes, I believe. I still believe in it. Yes, man.
Go and climb a mountain, and go have a look.
What's that supposed to do?
What would I expect to see, Blautek, if I climbed to a mountain and handed me a look?
If you've got 20/20 vision, that means, and you've got long range viewing possibilities, you can see 200-300 miles. You just got to know what you're looking at. People have been trained not to use their eyes nor to use their perceptions. You've been trained to look at things close up your whole life. Computer screens, televisions, driving a car, only see 20 yards in front of you. You've been trained to be blind. You just don't realize it. Once you snap out of that matrix and start acting like a regular person, you can see things far away.
For example,
humans have really good vision.
I just tagged you, Blautek. I went up to this 8,934-foot mountain, and I could see a 179 foot tall mountain 105 miles away.
I know this. I've proven this. That's how I discovered flat Earth.
Okay, so how come this mountain that's 5,000, 6,000 feet below me or above me appear below me? I actually have to look down at something that's a mile higher than me.
Now,
How do you
you're
figure
going to
that?
have to. Okay, you're going to have to provide me a photograph, and actually, give me the location. I'm coming to America next year. I'll fly there myself. This exact location. Get a photograph, and I'll post it back to you to prove flat Earth. Because I'm an expert flat earther.
Hold on. Hello.
Right?
You
I do this all day, every day.
Do you know that things get smaller with distance?
Oh my god, we
That's
get
why
that.
it's not a
No, they don't.
No, we do get that. But
They don't get
here's the thing, though.
smaller.
No, hold on, we
all
get.
perspective.
Yeah, but there's a way perspective works, and that's not.
They don't get smaller. They're
what's
further
shown,
away from you.
Yeah, but the thing's okay. But here's the thing, though. What's shown in that
It's
that
still
picture,
the same size. Jesus Christ.
What's shown in that picture, though? Yeah, we know. Come on. What's shown in that picture, though, is not going according to how. It's not following perspective rules. Okay. Here. Let me give you this paradox real fast. All right. If I point, all right, my gun. All right. Okay. It's like horizontal or level, whatever. Right. The point is it's not like tilted at all. If I have my gun, right, and I aim it, all right, and straight ahead of me, all right, is that mountain, right? And let's say roughly the tip. Let's say the tip of that mountain, right, is where my crosshair pretty much lands on because whatever, right? If I shoot that gun, all right, will my bullet hit the top of that mountain, or is it?
I'm not even going to bother getting this debate because there's so many variables in firearms, and so much things could happen and go wrong.
Okay, so hypothetically, then. Okay, well, hypothetically, the bullet is like really, really fast and it never falls. It just keeps going on. Just keeps going. All right. I shoot my gun.
Can we talk about reality, please?
Okay, fine. I get a really long stick. All right. Imagine I constructed a stick. All right. I constructed a really long fucking stick. All right. I put like trillions of dollars. All right. I'm fucking, I don't know, whatever, the billionaire guys. All right. I made a really long fucking stick. All right. Because that you can imagine that in a world where I put like $1 billion into that. Right. That's possible. Okay. There you go. I get a really long fucking stick. All right. And when I go to poke the top of that mountain, all right, I touch it. Okay. Now, how does that happen? All right. With perspective. Okay. Because if I'm touching the top of that mountain where I see right in front of me, all right, and I don't have to, bring the stick up, that doesn't make any sense. All right. For the most part. I mean, you could argue.
Do you understand that perspective has to do with optics, not physicality?
I know, but if I have a really long stick and I point at that mountain, right? Is that stick going to like what? Is it gonna?
Is that optical or is that physical? You jackass.
Okay,
that's what I'm saying. It's a physical stick, so I take the stick and I point it.
Yes. If you're touching it, is it optical or is it physical?
It's physical, but I'm saying visually, what will I see? So visually,
things don't change.
So visually,
they just look further away.
So visually, what will I see though? Will I see the stick bend or something?
Forget your vision. Get a camera. A camera brings things back into close up.
Why are you guys?
Zoom,
why are you guys avoiding this? Huh? You guys scared?
Because the objects are the same size. They just further away from you.
Yeah. Okay.
That's it.
Once again, I get
Stop debating this. It's illogical.
No, the whole point of my little thought exercise, whatever, is that if I have a long stick, that's a physical thing. If I have a physical long stick, here, this is the best way to put it. And I place it down on the ground, right? And then as I take the stick, right, the other end of the stick, right, and I place it on the top of that mountain, right? How does that work? All right, that mountain's supposed to be higher. That mountain's supposed to be way higher than the mountain that I'm currently standing on. All right, or wherever I'm standing on. Right.
Obviously, if the mountain looks lower because of perspective, then the stick would look like it would appear to be dipping down too.
Okay. But
use your brain.
No, I get it. But here's the issue, though. Here's the issue with this, though. The stick now is level, though. The stick is level, but somehow, all right, the end of the stick is making it to the top of that mountain. All right.
What the hell are you talking? How is the stick level if it's touching the top of a mountain that's supposedly higher than you? How
that's
can it
the
be
point.
Level, jackass?
That's the point of Jesse's picture, right? He has the fucking camera or whatever, right? And he's saying, I'm at this height, and the mountain is at a certain height as well, and it's a certain distance away, right? If I have my camera set up a certain way, right, the mountain should be above my crosshair or whatever, but it's not. All right, it's a lot lower.
Why do you say that?
Blottek, the coordinates are in that picture, so just save that picture, and when you come to America, just go visit there. It's a public park. It's really nice.
Wait, real fast, Jesse, is that camera like leveled? I would have to assume it's leveled. Otherwise, what's the point of this?
No, it's pointed down 6 arc minutes and 30 arc seconds.
Okay, to touch the top of that mountain. So okay, I get it now. Okay, so that makes sense. All right, there you go. So who was I talking to? The guy that called me a jackass.
Scrat. Scrat is flat.
Okay, Scrat is flat, right? So you say so the fact that he's tilting down. Okay, the fact Scrat is flat, whatever. The fact that he's tilted down, all right, a little bit, like what is it? It says 0.106. All right. The fact that he's pointed down a little bit, all right.
Who are you trying to convince, bro?
Look, just hear me the fuck out, all right? So hear me out. He's tilted down a little bit, all right? If he was to actually lift it up, if he was to actually make that camera level or whatever the fuck he has here, if he was to make that leveled, that would actually be slightly above that mountain's peak, all right? The top of that mountain. The argument that I was making is that if you replace the camera now with the leveled stick, all right, we would see that stick touch the top of that mountain instead, all right? In fact, it actually wouldn't touch the top of the mountain. It'd actually be hovering a little bit. All right, which is fucking weird because that mountain is supposed to be taller than what we're than where Jesse is. All right, that's the issue. It's like trying to you get that?
No, but you're completely wrong because it's flat. The mountain hasn't changed. It's further away from you. Yeah. If you walked up to that mountain, it'd be the same size that it is.
Okay, I get that. I understand how perspective works. All right, what I'm trying to say though is that this isn't going. According to this isn't working with perspective, right? Yeah, maybe the shrinking part is, but it should be a lot higher than what we see in that picture. Because once again, let's use my stick example, right? Take the camera away.
Most of it's rubbish.
Yeah,
rubbish
okay.
argument.
So I got a question for that last comment. You said if you walk up to that mountain, it will be as big as it is. You mean as big as it was as it appeared to you when you were further away?
It's the same mountain. It hasn't changed. It's just further away from you.
Wait,
you
hold
zoom
on.
up on the camera, you'll see it's bigger than what you are. It doesn't curve away from you.
What did Scratch say?
There's nothing.
What did Scratch say?
Where does this crack piping, smoking lunatic stuff came from?
What I'm asking you is when you said if you walk to the mountain, it would be as big as it is.
As it is, yeah. It hasn't changed.
Oh, okay. Not as it appeared when you were further away, right?
It's the same mountain with the same height. You're just further away from it. What are you talking about? Where does this idea come from?
I feel like I'm...
No, what I'm saying here, when you're further away from it, it appears smaller.
It appears smaller, but it doesn't mean anything. It's still the same size.
What are you dreaming right now? Am I in the bizarre
I thought you were saying it would remain the same size in appearance. Never mind. Okay.
You guys are something else. Anyway, back to my fucking stick example. All right, let's go back to the stick. All right, this is very simple. All right, if you have two tables, all right, same height, and you put a long stick down on one table, and then one end of it, and then you put the other end on the other table, right? The stick is going to be fine. It's not going to roll off or anything. It's going to sit down real nice because it's like, oh, both sides are at the same height. So bam, it's a leveled stick pretty much, right? Now imagine doing it with mountains, right? The mountains would have to be the same height for me to put the stick down, all right, and then rest on those two mountains, right? But the thing is, though, if I was to do that with the picture that Jesse has here, right, that would be really weird, all right? If I was to replace the camera with the stick, okay, that stick, we would see the end of that stick, more or less hovering above that mountain, all right, while the stick is leveled, okay? The stick is leveled. And now the issue with that is if the stick is leveled, all right, and it's hovering above that mountain, and that mountain's supposed to be taller, or higher than where we are, where Jesse is, or where the first end of the stick is, then that doesn't make any sense. I mean, I probably don't.
Oh my gosh!
I probably didn't word that well.
Dealing with optics.
No,
I don't know why you're saying. Why would you say it would be level? Aren't you saying you put it on top of the other mountain?
Yeah, I'm saying what you do is you take a stick, a really long ass stick, and you make it level. When you make it level, you'll see that the end of that stick more or less touches the top of that mountain.
Again, you're dealing with optics, dude.
Okay, so what is your claim? Are you saying light is bending here? Because that can work. If you're saying light is bending, all right, then I'll at least grant you that. But you have to say light is bending. That's the only one.
Things get smaller with distance.
That's not
That's
enough.
how optics work.
That's not
I don't
enough.
care if you say it's not enough.
It's
That's reality, okay?
No, it's provably not
reality
enough.
is that as you get further away from something, it will get smaller. That
I
is
know.
reality.
I get that. I understand that. Yes, but there's also a method to.
I'm sorry. I need to rephrase that. It will appear to get smaller. It doesn't get smaller. It appears to get smaller.
I get you're not. I'm not trying to like parrot wits it, but you're not teaching him right now. I get that, man. All right. I'm just saying. Like there's a method to like it gets smaller, sure, but it also moves up or down. A certain amount. It's a predicted amount too. We know how much it should move visually up or down, okay? And it's not doing that here, all right? If we're assuming the surface is flat, all right? If you want to make the argument that light is bending, I will give you that. But that's the only way this can make sense. If light isn't bending, this physically cannot happen.
Okay, when I live in the Denver area, if I'm at the top of a building in the Denver area and I look to the mountains, some of them appear below my eyesight. They look because no, I'm sorry, not Denver, further away. But there are times where the mountains look lower than where I am. When they're
Do you make a
thousands of
measurement
feet
of this,
there.
or are you just eyeballing it? Measurement or eyeballing it? Are you making a measurement, or are you just saying, "Oh, it looks that
No,
way"?
I'm just looking. I'm saying it's optics.
Okay.
It appears to look that way.
Well,
You just need to accept that.
Well, hold on. There's two issues with that. One, yeah, is what Rufus said. You didn't make any actual measurements. You're just eyeballing it. But two, they would be lower because it's on a ball, right? If you did measure it, you'd probably find it is lower, and it's probably because it's on a ball. Once again, it's farther away. It's far away, and it's also
now you're just
dipping
assuming
down.
something.
No, but
you see what you're doing there?
It's not.
You're automatically assuming that the Earth is curving, so it would be lower.
Okay, there's also the
absolute nonsense.
Okay, there's also the possibility. Granted, I don't think refraction really works that way though. But there's also the possibility, or at least you could at least potentially explain this, or you would have to say that the light is bending for that to work, right? If the light is bending, then sure, you could have the object not where it's supposed to be, obviously, because the light is bending, obviously. But
wouldn't that be diffraction?
I don't know, but that's besides the point. Though all I'm saying is that they have to at least claim light bending for this to work. If the light isn't bending, then the whole they don't even have an argument. They literally have nothing to stand on. It is.
Wait a second. Wait, you're saying that things getting smaller with distance, it can only happen if the light bends?
No, I'm not saying that. I didn't say that.
Okay. That's what it sounded like you were saying. That's great.
So what I was saying
then I don't
is,
understand what you're saying.
So things getting smaller, that has nothing to do with light bending. That's literally just the angular size of the thing is decreasing because literally the angles you make to that thing get smaller with distance, obviously, right? What I was saying is it's elevation angle, if you want to call it that. Let's use that because I don't know if there's another word for it, but it's elevation angle, right? It being what is it? It being lower than where it should be. If we use trigonometry, that would have to be due to light bending. You would have to have the light bend in order for the thing to visually be lower than where it actually should be. Does that make sense? I'm not saying anything wrong, right?
I don't think he knows what the pitch. I don't even think he's seen the picture. So.
Oh. Anyway, look, Scrat, I'm not going to have this argument with you because and I'm not being mean or anything. I'm just saying I don't think we're on the same page, honestly. And once again, I'm not being mean. I think we're just talking past each other. So whatever, man.
Well, if you're talking about a picture, I'm driving a truck right now.
Yeah, don't worry
I'm not
about it.
looking at no picture.
It's fine. Yeah.
Well, can I ask you a question, Scrat?
Yeah, I don't care.
So let's say we did like Arma said, but let's say we stretched a string, a weightless, very strong string, super tight from the top of the mountain to the observer location. So at my end, it's 9,000 feet high. At the far end, it's 14,000 feet high. Okay, it's super tight and super strong and it's straight. It's a straight string.
Gotcha.
Would that string be sloping up towards the mountain, or would it be sloping down? If I were to take a carpenter's level and set it on that string, would it show that the string was sloping upwards towards the mountain or downwards towards the mountain?
No, are you talking about the mountain being far enough away where it's below, it appears to be below you? Is that
Same
what you're
mountain.
saying?
Yeah, same mountain. It appears 1/10 of a degree below eye level.
Then
But
obviously, if the mountain appears to be below you, then it's logical to me that the string would appear to be sloping down if it's connected to the mountain.
Well,
It would appear that way.
How do you reconcile that when, I mean, but if I took a carpenter's, do you know what a carpenter's level is?
Yeah.
A bullet level, a torpedo level?
Yes, I know what it is.
Okay, but if I took that and set that on the string, would that tell me the string was sloping up or sloping down?
Again, this is optics. It appears to be sloping down, but it's not. It's obviously going up because the mountain's higher, but
Well,
because of
I've got an
optics.
alternate explanation. Can I offer an alternate explanation of why it's below eye level?
Sure.
Hear So what is the alternate explanation? Let's hear this. Or you like something?
I'll get laughed out of the room if I give the alternate explanation.
Oh, what? Oh, okay.
Well, I'll ask him another question then.
Well, did you understand? Did I get my answer clear to you, or?
I think you're saying that the string would be sloping upward according to the carpenter's level, right?
Physically, yes, it would be angling upward because the mountain's higher than you, your elevation, right?
Correct. Like
Okay.
Almost, yeah.
Okay,
5,000 or
but
6,000
in
feet
reality, in reality, it is really sloping upward. But because of optics and the way things getting smaller with distance, it would, to me, I would assume it would appear to be sloping down since the mountain appears to be below you and not above you.
Hang on,
How is this not logical to you?
Is light not taking the same path as that string? Is light taking a different path?
Why would it take a different path?
Well, then the light's taking the same path as the string, then, right?
Isn't the light from the mountain coming straight at me?
Well, it's a question for you. Is it?
We think it basically is, but that's what we're asking.
I don't even know what light has to do with this.
But that was the whole point of Jesse's picture, is because he has a this little camera set up, and he has it set up in such a way that the mountain from afar is below, like level or whatever. So I don't know. We were trying to give you the whole string and stick argument just to sort of connect it all together, but I don't know.
Yeah, we're making headway, I think. So, Snow Scrat, would you agree that then if we took a perfect laser beam and shot it from the observer's end straight to the mountaintop or back, either way, that the laser beam would run right parallel to the string all the way?
If you were shooting it at the exact same spot as the string, yeah, of course.
Okay.
Why wouldn't it?
Well, here's the problem. Now, let's say we took a 100-foot long piece of water pipe, nice and straight, 1 inch in diameter, and we point that pipe around until finally we can see the top of the mountain and the laser through the pipe. Okay? We're sighting through this 100-foot long straight 1 inch diameter pipe, and we can see the top of the mountain and the guy on the top holding the laser shining it at us. Okay? Is this pipe going to be sloping up towards the top of the mountain or down towards the top of the mountain? If we take a carpenter's level and set it on this pipe, will it indicate that the pipe is sloping upward or sloping downward?
I don't even think it even needs to be sloping. You can probably see the top of the mountain with it completely level.
No, it's 100 feet long. You can't. You could.
Why?
Well, because the mountain is not going to be at eye level. Remember, we have to look.
Yeah,
Remember,
but
we have to look.
if it's so far away, it could appear to be at eye level.
It doesn't, though. It appears 1/10 of a degree below eye level. We have to point
Everything
the pipe.
comes to. Go ahead.
We have to point the pipe 1/10 of a degree downward slope to see the top of the mountain through the pipe.
Why?
That's what I'm asking you. It's reality. How does that work on a flat Earth? Go again, you cut out. Try again.
He might be in a bad spot.
I'm going to go on mute for a while. So, can you hear me?
Yeah, now we can.
Well, I'm in a canyon, so I'm going to go on mute for a little bit until I'm out of this canyon.
All right. Sounds good. Thank you.
Yeah.
I gotta say, how hard is it just to do simple fucking geometry?
Geometry. Yeah. I mean, I don't know. I mean, that's why I like to do like, visuals, because I'll be honest. Sometimes I just can't follow along either. So I'm just like, I think visuals is just, I don't know. It's easier to kind of work with because there's no misinterpretation really. Because like sometimes when you're like forming like this, the image in your head, you maybe you did it wrong, and then bam, the rest of it's wrong. So, I don't know.
Ruhif.
Yeah.
What are you doing for Saturday?
Hang on 1 second. I'm gonna turn the music down here. Fuck, how do I turn Steam music down? Exit. Back. Options. Music. There we go. Say again.
You're tomorrow, not yesterday to me, right?
Yeah,
so
I'm Sunday afternoon.
My Friday is your Saturday. What are you doing Saturday next week?
My Saturday or my Sunday?
Your Saturday.
My Saturday, I'll be taking my daughter to drama in the morning and picking her up at lunchtime. That's about it, hopefully.
We're trying to see if we can get Jesse, you, and I, and Plain Truth Travis in the same arena.
Sure.
And I think we might have promised to do it as an event at the Tartaria place.
Ooh.
So we'll try and corner Travis on that. It was Jesse's idea to get him.
We wanted someone who'd at least been out of their lazy chair.
Yeah.
Besides, he's got some amazing photos.
Will that give you time to get your math together for me?
Sure.
How we get these big 45-degree bends and all that?
What do you mean 45-degree bends?
Well, straight up in the air from that angle, it looks to be about 45 degrees over my head. You're insisting it's over my head. I'd just like you to map out what it would take for the environment to do that.
Sure.
Oh, jeez.
Since it doesn't do it all the time.
Fuck.
It's not a regular thing.
Hey, Dan, I tagged you with a link to a picture. It shows a 45-degree ladder.
Oh, wow.
I dare you. Hold a piece of square paper up to that on your screen.
What do you
You'll
mean?
see it really is 45.
Degree?
What?
What do you mean 45?
It's my crepuscular ladder.
Oh, okay.
If you hold a piece of square paper up, you'll see that the two sides are 45 degrees, or actually 90 degrees from each other. each 45 degrees from the viewer.
It's kind of a nice picture. Looks a lot like my railroad tracks.
Yeah.
Well, flat earthers have finally figured out crepuscular rays don't mean that it's pointed to the sun.
Excellent. How many years did that take?
4, I think.
Yeah.
Maybe 5.
Wait, what? Flat earthers did what? What the rays?
When flat earthers think that the crepuscular rays are a way to triangulate the sun, the sun's position.
Right. Okay.
And it appears it appears appropriate, but it only happens through clouds, so you're really only seeing it through a portion. The sun, you're only seeing a portion of the sun beaming through, so it's really attached to that opening. It's not attached to the sun.
And you'd have to get in a viewer position where the two rays were perpendicular to your line of sight to them, kind of, because if they're streaming towards you or away from you, then they're gonna either appear to fan out or converge. Either way.
The crazy thing about them, at the same time when we figured it out, is if we're still looking at this latter picture, or if we're looking at crepuscular rays as they're fanning out over our head, if we go behind us, they're probably going to reconverge again, like a diamond shape.
Or just like train tracks.
Can you guys hear me better now?
We hear you.
Am I breaking up at all, or am I coming up through good?
Crappy mic syndrome.
A little bit.
I'll wait until I'm further out then. You guys, I'm still breaking up because it says I have a full signal.
Oh, we heard you say that, but we didn't hear what you said before that, except to ask if we could hear you.
All right.
Yeah.
So I'm coming through a lot better now.
Yep. I think so.
Yep.
Okay. What was the question you had? Oh, you said if you use a 100-foot pipe, how do you know that you would have to angle it down? Have you done that?
I used a theodolite, which works exactly like that. And I've also used a water tube level as my horizontal reference, and the line of sight passes through the water tube level, which is below eye level.
Okay.
And actually, I actually have used a short aluminum tube too to do something similar to that.
Okay. Well, a short one. You said 100-foot one, but you're saying that a theodolite, it works as though it works in the same way as if you were looking through a 100-foot pipe, correct?
Yes.
Yeah, I did not know that. All right. And so, what was your question then?
Well, my question is, how does that work on a flat Earth? If the kite string to the top of the mountain is a slope upward to the top of the mountain, and a laser beam to the top of the mountain or from the top of the mountain is a slope upward to the top of the mountain, but I have to point the pipe downwards to see the mountain.
It's optical. I don't know. The only thing I know is optics. Things get smaller with distance.
Do you know the math to that? Do you know what the relationship is between height and distance and angle?
Not completely.
Well, it's supposed to be that the delta height, that means the difference in height, divided by the distance, fed into arctan, gives you the angle. So in other words, looking at it the other way, the angle...
Don't you also have to deal with the atmospheric distortion and everything? I mean, there are times where things you can't see them very well because you got thicker atmosphere, air and stuff. So that doesn't always work.
But the mountain still always, when you're at 8,000 feet or whatever, the Fire Mountain always looks lower than it should on a flat Earth.
Always looks lower than it should.
Yep.
What you say it should.
Well, it should not be below eye level for sure. Something that's 6,000 feet above you should not appear 1,000 feet below you, right?
It's not lower than you, right?
It doesn't appear to be 1,000 foot below you.
Well, but the angle that you have to aim the pipe at is aiming it below you. So this sets up a real conundrum for you, because you just admitted that the laser beam would be sloping up to the top of the mountain, or coming in from above you from the top of the mountain, but you've got to aim the pipe down below that to see that very laser on the top of the mountain. So now you've got this laser beam in two places simultaneously at two different angles, and it's self-contradictory. Does that make sense?
Kind of, sort of, yeah. Actually, yeah. I don't
Yeah,
know. I can't explain why it's like that.
Yeah, in order for you to see the laser through the pipe, the beam has to go inside the pipe, right?
Yeah.
Are you suggesting the mountain is shorter than it was measured to be, Jesse?
Yeah, that's why we're gonna put it on the sides of all the milk cartons, because maybe someone will know where the missing height got lost.
Yeah, I mean, if it's taller than you, then what's the problem? It's definitely not lower than you are, right?
Yeah, hey Scrat, I gotta get some food and stuff here, but let's talk more when you're in front of your computer, if you ever do that, and I can show you some diagrams, and at least you can understand the dilemma. You don't have to agree with me, but at least you'll understand the dilemma.
Well, I apologize. The only time I really get on this is when I'm driving, because it helps pass time. When I'm at home, I spend time with my family.
Oh, totally understandable, as you
Fair
should.
point. Yeah.
Was he flat smacked him like 24/7?
What's that?
What's that?
See, are you flat smacking your family like 24/7? Look at those pancakes! Damn it! They're flat.
He probably gets on here because his family doesn't want to hear about it.
I just teach my kids to use their critical thinking. Because this freaking school sure as hell hadn't.
Yeah, well, I've given you some new critical thinking things to go over, huh?
I don't know exactly what you're trying to suggest, though, because what is it that you're trying to suggest?
Well, I'm suggesting that real world observations, that is, observable reality, does not work with flat Earth.
Really? I find it just the complete opposite.
Yeah, that's the joy of it.
You named one thing that it's an area that I don't really know a whole lot about. Only one area so far that has to do with appearance. Now, because everything I observe, it makes me think of flat, not curved. I see nothing that makes me think that the ball would be curved. I mean, the Earth would be curved.
Right. Well,
I see nothing in that.
Right, and somebody who thinks it's flat, they're going to see everything as flat, and someone who thinks it's going to be curved is going to see everything as curved. But that's why I'm going to be on the subjective to actually measure.
That's not true, because I was a staunch ball believer for 43 years probably. And when I was so the Earth's flat, I told my brother he's a freaking retard. Like, oh, do boats fall off the edge of the Earth? I was the exact same thing. But when I actually started using my critical thinking thinking about what I actually observe, how the world appears to me, then, and along with a lot of things, then it just clicked. I mean, it's common sense.
See, I'm sort of the opposite. I mean, in terms of like the seeing the world, because it's round or whatever. Like when I'm on the bridge, you're just driving on the bridge, whatever. And I look out, like if you look out right to like the horizon, like it for me, I just like wow, that looks like that's just where it cuts off. Like it almost like it's almost like eerie because it almost like feels like I don't know if you've ever like what is it called? Like in a video game where you like sort of glitch out of bounds, whatever. But like it almost feels like that almost when I look out to the horizon. Like it's just like in a video game, if you just go out far enough, there's just like a weird like most games, there's like a wall of just like of like detail to make it like an illusion of like like there's like trees in the distance, whatever, right? And when I look out in the distance, it's like I almost like feel that, it's not that obviously. I'm just saying it just
Because you can't see very far.
No, okay. I mean, obviously, this got off like I'm on a tangent now. But the point I was just trying to get at is when I look out to the horizon, it just feels like it just cuts right off. Like in the distance, it just like cuts off, and it's like that's not what
Yes, because you can't see very far. Yeah, but here's the thing.
No, but it's a cut off though.
Get
It's
a
like
pair of binoculars. Get a pair of binoculars. Get a freaking telescope, and wow, it doesn't cut off. You can see a lot further. When if you were on a ball, you wouldn't be able to.
No, but I mean, it really feels like it cuts off. Like it just it just stops almost. Like I feel like if it was a flat Earth, it would just like, even though sure, things get smaller and smaller to the point where you can't see them. You would still like, it'd still be like some sort of hint of like, okay, you know what I'm saying? Like it just cuts off, and it's very like it's almost like an eerie like feel to it. Almost it's like wow, like, that's just where it ends.
I have a question for you, Scrat. If the Earth is flat, wouldn't you expect if you were like on the top of Mount Everest that the sun would never disappear?
No. Why would I expect that?
Well, I mean, if the Earth is flat, right, and level, and you're on the tallest point on the Earth, being Mount Everest, I would expect the sun would never disappear because it would never go out of my line of sight.
Right. There's nothing.
Why would you expect that? Why would you expect that?
Because there's nothing obstructing the sun from my vision.
There's not a whole bunch of air in between you and it, and it's not getting further and further away. And what's that law?
The inverse square law.
Yeah, inverse square law. Things get smaller and dimmer with distance. Why would you not assume that it would disappear?
I can appreciate that argument for sure. But when you measure the light on a light meter, like a par meter, for example, it'll say, almost at dusk, it'll say between 500 and 1,000 micromoles. So the inverse square law would say that, it should be getting a lot lower, a lot lower if it was to fully disappear, right? Like it would go to 250, then to 125, then to 65, then to 35, right? Or to 30, then to 15, then to 7.5, then to 3.75, right? That's inverse square law in action.
Okay.
You don't see that. It's a drop off from 500 to 1,000 when the sun sets.
You also have to understand that with more distance, you have a lot more air that you're looking through. The further it gets away, the more air is going to be placed between you, which distorts it and makes it. Why are you not taking this into consideration?
I am considering that, but what I'm saying is when you measure the strength of the sun's rays near sunset, right, it drops off considerably, or not as much as you would expect.
The strength of the sun's rays at sunset, is that constant? Because I would assume that the strength of the sun's rays on a very hazy day would not be as strong as on a very clear day.
Yeah, it'd be less strong on a hazy day. But
okay,
if you're on the top of Mount,
go ahead.
If you're on the top of Mount Everest, right? Why does the sun set why does it go down and out of sight? Wouldn't it just like fade off into the distance and you just slowly lose sight of it? It just become darker and darker and darker and darker gradually. Why does it go over an edge?
It doesn't go over an edge. It just okay. I don't know if you ever saw the video, but Rob Skiba actually made a video that demonstrated this very clearly because of the way the Atmo acts as a lens. He used a lens and everything, and he made this the sun, so it was on a stick, so it was the same height all the way across the table, and he moved the sun away from the lens, and it appeared to set just like the sun sets on, or a lot of times sets here on Earth. It was almost the exact same thing.
Hold on.
But the thing never got lower. It appeared to get lower and go over go over a horizon because of the lensing effect.
So hold on, though, real fast though. So you understand that that's a different argument than what you just said earlier, right? You said something about the light. Well, because weren't you earlier saying like, oh, the light, like just as it goes away, it just gets dimmer and dimmer. Now you're saying, well, this is the you said Rob Skiba, is that what you said? You're saying, oh, this is why the sun disappears or whatever. Like
no, that's not what I said. I didn't say this is why it disappears. I says when it looks like it's going over a horizon, this was a demonstration of how it could look that way based on the lensing effect of the Atmo. Okay, but
so
there are also hold on, let me finish. There are also times videos of people videoing the sun, and it just disappears. It doesn't go over the horizon. It just fades out. So, I'm just saying that with the Atmo acting like a lens, that's how you can get the appearance of the sun going over, down, below, under horizon. Does that make sense?
So basically, different days have different conditions, and some days it just does the lensing effect. Other days it'll do the disappearing thing.
Absolutely. Because nothing's the same in all the places all the times. There are times where hold on. There are times in this different areas like the desert. You can the sun will actually get smaller as it goes away. In other times where it doesn't get smaller. Most of the time it doesn't. But there are times where it's really dry area where the sun will appear to shrink.
Okay.
That sounds like a
no, it's a decent argument. In terms of it's a decent argument in terms of I can't really think of a way to like really refute that per se, because I mean I could say to you that the reason why it disappears is it has something to do with like like at least from what I've seen those are like weird. They're kind of like I want to say blurry, but I don't know, they're a little weird though. But with that being said, I mean I guess I can't really refute that. Me personally, in a genuine, in a really good way. So I guess me personally, I'll let it slide. Does anyone else want to maybe refute it?
What's the question?
Nobody can really say absolutely exactly why it disappears. You're going off of you're trying to use logic based off of what you do know, and you add things together and stuff. But here's the thing: we do know that we see way further than we should on if we were on a ball.
No. We see way further than we should if there was no atmosphere. Right?
The atmosphere allows you to
say that again.
We see way further than we should if there was no atmosphere.
There is an atmosphere, and we do see further.
No, the atmosphere allows us to see further.
Yeah.
Magic.
Not magic. Density gradient. Light bends through a density gradient.
All right.
All right. Yep.
Those are just words, man. Show me their numbers. I keep saying this.
Go on, Dan. Show you the numbers. I've shown you the graphs. They are the numbers.
Real life. Real life.
What do you mean real life? How are these not real life numbers?
Okay.
They're
Jesse
actual
can
measurements.
exaggerate the conditions, right? He can exaggerate, or is he impersonating, or is it real? Or is his exaggerated conditions over miles equal what we're seeing? I need you to show me something I can compare it to, so I can say, under these conditions, it would do this, and under these conditions, it would do that. I've been to the same spots when it was fucking cold, when it was fucking hot, when it was fucking cloudy, when it was fucking clear,
When it was
day
cold,
and
when it was
night.
hot.
Different distances. You got to
Cold.
understand, we can point the thing straight across the fucking lake. So just because you think the lake is curved is the only reason you're saying that my light is curved, because the conditions aren't there. We go deliberately waiting for the conditions to be clear. I mean, it's like we believe in minimum refraction, not standard refraction, and not whiteout conditions due to the weather. It's like, wow, it's clear. We should look now. How do we know that? Because we can obtain the distances. You think we're waiting for some sort of perfect conditions, and that doesn't coordinate with our vision of the shoreline left and right, coming around, wrapping around, not going through the same conditions. It doesn't match the expectation of water and its behavior, and it doesn't match the fact that we're making a straight line segment somewhere. We're capable of making a straight line. You're saying it's bending. You're going to have to tell me at what point my light becomes unreliable as a straight line, and why. Did you mute me?
No.
No, I went on mute. Yeah.
It's just that you make some serious claims, and I'm like, I've been out there. It doesn't do that. You saw it bounce off the water, and you're trying to tell me that's a mathematical equation due to the density of the air. Yet it's not doing it all the time. It just happened to do it for a minute. Then you take a still frame, which is totally cherry picking, and then I tried to show you other examples of it actually, of targeting and how this happens, because I've been out there. Fuck, Jerry. Fuck.
Fucking A.
The fucking nonsense here is like, sometimes I think you're the only guy that makes any sense. You know, you don't argue, you don't get angry, you come around, you're just waiting. It's like you just walk slow and keep looking back and saying, "Are you guys coming?" And that's like, "Yeah, I'll be there, Chair. I got to fight with these idiots first." I'm wrong. I should be following you in this more sane path, because you don't bicker, you don't get involved in the bickering, and you don't get involved in the emotion. And, you know, in some ways, you're so rock solid. It's so interesting.
Well, just stick with what you could prove. That's all. And find agreement.
So frustrating. It's like these basic properties. You know, I was listening to somebody talk, and I think it was Rakia, and he's just like, you know, okay, Globers, it's like, can you measure this curved water? And they'll talk about optics all day long. No measurements. Optics. And it's like, okay, well, so we're stuck in optics still. But so my question is, you know, was what he was saying is, you know, can it be measured? He feels he can make little lines. He calls segments, and whether we extend those or repeat those, at what point are they saying I'm failing? Is my yardstick no good? Is my 6 foot level worse than my 1 foot level?
What I want to know is if light can supposedly curve for tens of miles around a curve and look perfectly clear and have things appear where they're supposed to. How come the only time it does that is when it's supposed of Earth curve? Why isn't there an example of light curving around something other than when it's Earth curve? Supposed Earth curve. Why can I never see anything from the other side of a hill? A long hill. The only examples you guys have of light bending around a curve for miles and miles is when it's supposed Earth curve.
Well, because I mean, aren't the conditions different? You know, like with the mountain compared to, you know, for example, over the ocean. Like, I mean, I know there's at least over water. You know, there's usually that usual gradient that gives you.
There's always a gradient everywhere.
But I mean, like, but I mean, like, in terms of like, you know, like the black swan, for example. Like, I don't think you're going to get a similar situation, you know, like near a mountain to where, you know.
No, you got to be when you're away from the surface, the refraction's pretty stable. When you're close to the surface, it literally could be anything.
Well, you can't really claim that light curves around a curved Earth if you don't have any example of light curving around a thing for hundreds of miles and miles.
I've got
This is a deductive. Sorry, it's deductive. We have a density gradient. Light bends in a density gradient. The end.
I don't live in a deduction.
I think you live in a subduction zone.
That's interesting.
1, 2, 3.
But no, Scrat, actually, I filmed the water line on a ship that was a few miles out to sea. Well, not sea, but in the Straits of Juan de Fuca. And
Juan de Fuca?
Yeah. Oh,
I
no,
would.
the Straits.
Yeah, I do.
When I'm done.
I had the camera placed behind a sign, 300 feet behind a sign, which was physically higher than the camera a little bit, and I could actually see the water line on the ship over the top of the sign, even though it should have been physically obstructed. So the light was definitely curving over the top of that sign. Otherwise, I couldn't have seen the ship's water line.
Say that again.
Okay, so I had an obstruction, which was a county park boundary sign that was 300 feet in front of me, okay? And directly beyond that county park boundary sign, a little blue and white metal sign on a post, was a ship in the water, okay? Now I took my camera and I lowered it down a couple inches below the top of that sign, right? So the top of that sign was physically between me, my camera, and the water line on that ship. And yet I could still cleanly see the water line on the ship over the top of the sign.
Okay, so what's this prove?
This proves.
Hang on. It wasn't clearly below it. It was apparently below it. So you disregarded the refraction up to that point, and then you continued your concept further by doubling down. I'm really convinced of this. You know, you said you lowered it to below the level, but it was apparent. It was apparent. We can't just give you that.
Well, the angle to the sign was a positive slope from the camera up to the sign. So wrap it however you like. Light had to have been bending.
How do you know you're seeing a true image of the sign? You're not allowing me these kind of true images. As a matter of fact, I could quote you all, quote Ruhif all day long. There's always a gradient. Light always bends. There isn't a chance of me looking at anything straight on, particularly at that kind of distance. like the supposedly Rakia says about surveying. It just, after 200 feet it becomes problematic. Plus, I don't understand how you're ignoring it to that point, and you're convinced where you are with zero measurement.
And you said that the sign was like 300 feet away from you?
Yes.
So how the hell do you know that you are actually below that sign? Because that's just, I can't believe you actually use that as an example.
Well, I can't believe we can't catch you every time either, because you make sense when you speak earnestly, and it's like, fuck, we have different
I didn't
standards.
catch that. I didn't catch that the sign was 300 feet away.
Well,
was that you could not possibly tell unless you use some kind of measuring device that you put the camera below. Because if you did put it below it, it would be obstructing the freaking boat.
No, I used a surveyor's total station.
Still, it seems like a double standard. I feel that you should have to have already changed your math, accounted for stuff, in some way. And I'm just using logic. I don't know that that's true, but logically speaking, you said we brought it down below, and I was in the other room, and I'm thinking, no, it was apparently below. So we'd have to verify that in some way to continue the hypothesis forward, or the conclusion from the result forward.
Yeah, and I plan to do that just for you, Dan, because the sign's out in the water, so I'm waiting for this next summer to get hot again, so I can do it again, because it only does it when the air is hot and the water's cool. This ain't California I'm in here, and so yeah, I'm gonna try and do it again this summer, but go out when the tide's out and put inch marks down the signpost so that I can know the exact height of the sign above the water, and then
So you're saying,
use the
hold on
water
for a
as a
second.
reference. Go ahead.
So you're saying that you're waiting for the right conditions. Don't you understand that you're admitting that with the different conditions, you're going to get different results every time the conditions are different?
For
So how
line
can
of
you?
No, for line of sight near the water, you're 100% correct. I show everything. I show the concave Earth evidence, I show the flat Earth evidence, and I show the globe Earth evidence. Because if you go take pictures or make sightings with your line of sight close to the water surface, you can totally cherry pick evidence for flat Earth, evidence for concave Earth, evidence for globe Earth, whatever you want. Because it just varies wildly. You can cherry pick anything you want, and I show it all on my YouTube channel. The flat earthers love me, the globe earthers love me, and the concavers all love me because they can I show them how to cherry pick anything they want when they're doing line of sight near the water.
Hey, hold up.
Just found a fucking awesome game called Hex Cells. So good.
Can you hear me?
You're real faint, Murphy.
I think he said that this is a holdup.
Oh, Scrat's got the money, but he's driving, so you better go fast to catch him.
Hey, can you hear me now?
Oh fuck!
You hear me now, right?
You're really faint.
One, 2, 3, 4.
Hey, hello. Hey, can you hear me?
Yeah.
I had to switch to my microphone. Hey, I just set this. It's like 2 a.m. here, and I just switched this on in the background. But I just overheard. I think it's named Jesse Gordon. He just spoke for me, and I'd ask if he doesn't speak for me when he said all flat earthers love him. That I disagree. That's inaccurate and it's incorrect, and I'm upset about that.
What? You're not a flat
don't.
earther. You're a Smurf earther.
Who do you
I
think?
didn't say anything about the Smurf earthers.
Smurfville isn't wobbling around. It looks flat from here, and you don't speak for Smurfs either.
I didn't purport to. I listed globe earthers, flat earthers, and concave earthers. I said nothing of Smurf earthers. So you're safe.
Okay. Because, hey, I choose who I love, and I love the real flat earthers, like the real ones who are searching for the truth out there. Like, those are good people.
Oh, those were
But,
deep words from the Smurf.
yeah.
You get the definition of search.
What, now we have a surf earther?
1, 2, 3.
Aloha.
No, search.
Hey, I just
Can't
want
hardly
to
search when
clarify.
you live leave your house.
Just want
Are
to
you
clarify a few things. I'm not in the love triangle or anything.
are you hot miking, Court, or is you trying to come through and we're not hearing you?
2, 3. One remaining. Yeah, I'm trying to come through, but I've got very bad reception here, so I'll just say that.
Ouch.
I agree. Yeah,
Try
terrible.
again. We heard you say that and then nothing else.
He muted himself.
Oh, you're right. You did.
So I'd just like to say to Rufy and Jesse, I just want you to understand you have all of academia, all the time on your hands, all the tools, and all of the resources of all government efforts. I got Smurf. Maybe Jerry. My resources are pretty thin.
Got to make the best of what we all have, though, right?
So,
Absolutely.
so we have a thinner pool to work from.
Well, believe it or not, nobody funds my experiments either. So we're both in the same boat on that one.
Did you look up that link I've been dumping around to that wiki thing?
I don't know. What was it about?
It was a thing called WikiMill, and I typed in like 1958 space. I'll give you a link here, and I typed in like ether, like I figured it was something Witsit was talking about, and I just typed in like two of the random words. And the results are just brilliant. And I think the thing's designed for reading to you out loud. I'm not sure. But the results on this are fun, man. Just boom. Like do a date, do like it did 1958 space, and that's what impressed me. And then like type in magnification at sunset, I don't know. It's just anything. I guess long distance observation is what we could try. Something like that. But
wow.
It's really, the results were a lot of fun, and the way it formatted it and the way you could go forward with that. Let's see. Long distance observation. Yeah, so anyway, it seems like a really fun tool. And once you click in, it just keeps going deeper and deeper. So I typed in long distance observation, and I got long distance observations, of course, observation tower, observational astronomy, the Levenstein distance, a sniper, Cook's distance, observation car. I don't know what that is, but it's up by you. It says an observation car, Toronto, Vancouver, with the same dome observation. Lounge cars in use on the train since 1955. Something about Amtrak. Something Russian. So it's like, it's really, you click on any of these and then it just keeps going. Seems really healthy. Are you looking at it?
I took a peek. I think it was a reader of some sort. Is it an app or a website? I don't know.
It's whatever a reader is. What's a reader?
I think it's if it's a screen reader or if it's a publication reader, it's either something that allows you to see on your screen some publication, or it reads in English or whatever chosen language out loud. It reads to you.
I haven't clicked on anything beyond the search. You know, like I'll show you. Like, oh, I'm not sure if it'll give you this as a link. It seems like when I put this link in, it just comes up generic. Oh no, there you go. Click on that link, and you'll see how the results look. Gotta help. It's pretty bright.
Oh yeah, that's different. Okay.
Like, and I think this might read to you. Otherwise, it says it's a 15-minute read. So yeah, maybe. Oh yeah, top right button says listen. Actually, so I haven't tried that yet because I was just into the links and the summary on the right. So this is one of these agencies we don't hear about. The National Geospatial Intelligence Agency. This is they wrap it on a ball. This is we wrap it on a ball. Fuck you. That's what this is where it happens. This is your 15-minute delay or 10-minute delay. I think. Because realistically, there's a lot of intelligence going on. So they got to filter images, cut out what they want to cut out by coordinates, or, you know, just like they used to airbrush stuff out. And they would just supplement it back in. Once it's mapped properly, you just supplement back in something that isn't live. Patch it in, you know, with your standard look, whatever that is.
Five. Fuck, this is a good game. Called Hex Cells, people. Get it up here.
Hex cells, you mean as in straight segments that turn into a ball? That kind of hex? Like a hexagon? Kind of? Hex.
One. It's kind of like Minesweeper.
Didn't you say you were sending us pictures of your wife earlier?
Again?
Yeah.
Didn't you say something about you were going to send us pictures of your wife?
No, I said I would not send, and they were pictures of my wife's rack, which is the best rack that money can buy. Who is that?
Well, it sounds like water
Dan.
running, right?
Yes.
Dan the Bong Water Man.
Yeah.
You do know I do it in a lab coat, right?
Yep. Scientific.
When you say it's the best rack that money can buy, does that mean that you bought it for her or she's a whore?
Oh, I bought it for her.
Oh, okay.
What is it?
The best rack money can buy.
Like a coat rack or a...
No, Jesse.
Yeah, that's it.
Yeah, magnificent. 3, 1, 2, 3, 4. Oh, 1. 1, 1, 1, 1. Only 1 in there. that. Oh goddamn! I'm good at this. Oh, this is getting tricky now. 1, 2, 3. Of those.
Well, back when I was in.
Go ahead.
So when you start talking?
Go ahead.
Back when I was in the canyon and I went on mute, I heard you guys talking about corpuscular rays. What exact? You're saying that flat earthers now admit what?
That's not triangulating the sun. It's not a good example of triangulation.
Oh, okay. But it is a great example of the fact that sun rays do not come in parallel.
No, it's not. For fuck's sake! Oh,
It's not. Oh,
Jesus, Jesse, can you post the? Oh, Jesse's gone. Jesse's gone.
Said something
Wait
about
a minute.
food.
Parallel sun rays.
Hang on, here it is. All right, give me a sec.
What happens if
Yeah,
the
Jerry?
verticals are parallel? Wouldn't that make the sun flat? I mean, right?
There you go, Jerry.
Yeah, so
Is that the former?
Jerry, can you
Yes.
see the image that I've posted?
Yeah.
Right. Are the sides of that ladder parallel?
The sides of a ladder are parallel, yes.
Yes. Well done.
Okay,
You've just
now my
debunked
question.
corpuscular rays. Well done.
Yeah, so if the sun rays are parallel, wouldn't that make the sun flat?
Sorry,
Why?
what?
Yeah.
Twice. It bounced off of him twice. That's like getting hit nuts with the tennis ball, Rue.
Sorry, would that make the sun flat?
Yeah.
Why?
Because the rays are perpendicular to it, all to a straight line. So they're parallel.
I got no idea. No idea.
Come on, Rohit, it's basic geometry, right?
1, 2.
I mean, at some point,
3. 1, 2.
we got to look at the reflection off the moon to measure the sun. We don't really see a hot spot, so they're all coming off even off of that too, huh?
the reflection off the moon. The reflection of what off the moon?
Well, supposedly the sun.
Oh, okay. That's right.
Yeah.
But you never see a hot spot. You never see like the reflection of the sun on the rock. You don't see that. It's just evenly all lit up. Evenly.
Which is impossible on a sphere.
It really is. It's really a shitty kind of like, they need some explanations on that.
They just ignore it. They can't explain how you can have uniform lighting on a sphere with one light source, so they just ignore it.
I still can't figure out how there isn't a big dark rock in the sky just before and after a solar eclipse. You know, as it moves across the sky.
Come on, Dan. Do I have to pause my game to explain this?
Do you have to pay attention? No, because you're picking and choosing.
When I hear something,
no, because you're picking and choosing. When I had shit to say that was important, you didn't want to talk about it. You're busy playing games. So make up your mind. Are you playing with me?
Can you see the new moon? So regardless of an eclipse, regardless of the eclipse, can you see a new moon?
This is my whole beef. No.
No. Why not?
It's not I can see lit portions of the moon.
Right.
I want to know why I can't see dark portions of the moon.
During the day?
Yeah.
Yeah, because it gets scattered away. The blue light.
Bullshit.
It's not okay. All right. 1, 3.
I mean, there's no kind of filter I can fucking pick up either. Nothing.
You could try an infrared filter. That would be the best shot, I'd say, or radar. Like any longer wavelengths would be the best. Your best attempt.
Why don't we see those?
I don't know. Get a fucking radar gun. Shoot at the moon.
I thought you were going to explain why crepuscular rays are not a good example of why sun rays are not parallel.
Dig in.
Okay, at 31 minutes past Scrat, I posted an image to Jerry of a ladder. Can you see that image at 31 minutes past?
Okay, you're talking about. I'm assuming you're talking about what what happens when you're like looking at a train tracks going away from
Yes. Yes. Well done.
you. Okay. That
Are those train tracks parallel? Are those train tracks parallel?
I'm not talking about lights that are rays that are coming towards me from the sun. I'm talking about ones that when I'm looking at the sun shining through the clouds, rays are pointing way off to the. If I'm facing east, the rays are angling way off to the north, way off to the south, and all that. Not the ones coming towards me.
Right. So the railroad tracks, right, that go off to the left and go off to the right, that's exactly the same thing.
No, I'm talking about going down,
Yes, it is.
not towards me,
I
going
give up.
down,
I give up.
angling to the north.
Yeah, I give up.
What?
I give up.
Well, good, because you're not
It's
making
such-
what you're using is not even close to the same thing that I'm talking about.
It's such a simple thing. It's exactly they're exactly analogous. The railroad tracks and Jesse's ladder is exactly analogous to crepuscular rays. They are parallel.
Okay, so you're telling me that when I'm looking and I see sun rays that are angling way off to the north, and then I'm seeing rays that are angling way off to the south, those rays are parallel.
Yes.
Really?
Yes, it's called perspective, Scratch. It's called perspective. Holy fuck. Anyway,
Let him
I'm
say
going to get back
it.
to my game. I'm going to
He's
get back
saying
to my
that.
game.
He's saying that the sun is flat.
Hey, Scrat, close your eyes and think of railroad tracks. Think of what they look like going away as you would draw them if you were doing a drawing or something. They're not really changing, is what he's saying, is that it appears like a motherfucker, like they're disappearing together to the center, but they're not. Well, go run to the other side, think visually in your head, look backwards, and now they appear to be widening. So that's what he's saying, is like the train tracks aren't widening, and neither are the beams of light.
Correct.
Train tracks will never appear to be widening.
Yes, they are. What do you think you're seeing? Holy shit. When you look at railroad, you know the image I'm talking about. They appear to you to be going to the left and going to the right.
If I
But you know they're parallel.
if I turn around, they'll appear to be going together again. Are you guys on drugs?
That's called anti-crepuscular rays.
Railroad tracks will never appear to be going away from each other. They will always appear to be going towards each other.
No, anti-crepuscular rays meet at like a vanishing point on the far horizon. That's proof that the crepuscular rays are parallel as well.
No.
Okay,
Again,
I give up. We'll go back again.
You got the sun. You're looking straight east, and you have rays that are pointing directly north.
Dan's posting other railroad tracks. Can you not see the analogy?
Look to the right. No, because they're pointing in the opposite freaking direction. Those cannot in any way be parallel. They're pointing in the opposite directions. Coming from one source. How can you not
stuck.
see this?
Stuck. Yeah. Oh, I'm the king. I am the king. I am the king.
If you're talking about your game, can you go on mute? We don't want to hear about your game.
Yeah.
And if you say king, we're supposed to mention England and all the bullshit they're going through today.
Okay, other than the sun rays, can you give another example of things being parallel together, appearing to separate? Other than your so-called parallel sun rays, is there an example of anything, any example of parallel things appearing to separate and not come together?
It's basic perspective. You're just used to seeing it the other direction.
Basic perspective. Okay, show me an example of it. You say this is basic perspective. No, basic perspective is parallel things appearing to come together. Where do you ever see them go apart other than your so-called parallel sun rays? It's the exact same thing as light bending around a curve. The only examples you have of it is when it's so-called Earth curve. Why can't you guys ever give real examples of this happening somewhere other than your make-believe stuff?
Well, I'm a flat earther, and I'm arguing the point with you still.
I'm sorry, what?
I'm a flat earther, and I'm still arguing with you.
About what?
Well, that in the distance, things appear to narrow.
Yes, I agree.
Well, it's the exact opposite effect. The same effect coming at you is wider. Going away, narrow. Coming at you, wide. Crepuscular rays widen. Coming at you.
Yeah, I'm talking about seeing things go out.
Well, in this
Away
case,
from me.
it's because it comes from a single source. If you're looking at anything on the screen, you'll see what we're talking. What we're saying.
No, I know what you're talking about, but here's what you're not getting. I'm talking about the sun rays that are not coming at us. The ones that are going down, either towards the north or the south. They're not coming at us. They're going downward at an angle, at very great angles away from each other. Not coming at us. They're going in another direction.
Right, they're diverging from the source. You're just freaking out about it. You are.
No, and okay, and it appears to diverge and stuff like that when you're looking at them, looking at it. I'm not saying it right. If we're looking at sun rays that were coming directly at us, then yes, you would see them get wider as they're coming closer. Yes. But I'm not talking about those rays. I'm talking about the sun rays that are say I'm at a certain location. You see the sun rays pointing down, going down to a completely different location, way off to the east, in north, completely away from you. And then other rays angling down, way in another direction, touching the earth in a way off to the south. How can those rays? They're not coming at me. They're going in other directions. I just see them because of the break in the clouds and stuff, but they're not coming at me. Why would my perspective of what you're referring to apply there?
3, 4.
What?
It's just a matter of perspective. It's not as complicated as you're making it seem, because it's when they're coming at you, it's the perspective of convergence to the middle. When you're seeing it fan out, it's like anything else, like a sprinkler with water, when it fans out from a smaller source. And it's essentially fanning out as it busts through a small hole in a cloud.
No, that's if it was coming at you. That's how that perspective works. Okay? You can't add it when those light sources are aiming in a completely different direction than you. That type of perspective does not apply.
I don't want to argue with you. I don't know what it's called, but it's some kind of spread pattern that has a name. It's some sort of divergence. It's a normal thing for a flashlight or anything that you know of. It's a cone shape with a laser in the distance. There's a divergence.
So they're diverging, so they're not parallel. Are the actual light rays diverting from what you're talking about? Are they actually diverting?
Okay. No, we might be talking about two effects on your eyes. You might be right that they're not the same, but it doesn't triangulate the sun is the primary.
I never claimed that it was. What I was talking about.
Many flat earthers.
What I was talking about was that it's a proof that the light is not parallel as it comes in. That's all I'm saying.
No, it's not at all, because it's all a new batch of light from the source. And the source is now in the clouds. It's not open. It's just in the clouds. It's just where it broke through the clouds did it start to behave with the atmosphere again. And it's spread out like any lamp might.
Okay, well that's the thing. They claim that the light comes in parallel, and it doesn't. Very clearly, it doesn't.
But the portion that got through behaved in the way you're seeing, not the other portions. The portion that got through is what you're seeing. That's why it's lit up. It's a very small portion of light that got through and behaved the way you're seeing. It spread.
Yeah. So we see how the light behaves. It's not parallel.
It's
right?
different.
Do you agree with that?
It's different thing. We're arguing two different things. Yes, you're right.
Okay, are you saying that it comes to Earth parallel? And then when it hits...
No. It's just a different thing than perspective. It's a real thing you're seeing.
Yeah, so rays are not parallel.
You're just not seeing the sun rays in the case of crepuscular rays. That's why it doesn't triangulate the sun.
Crepuscular rays are very nearly parallel. It is a matter of perspective.
Well, I don't know about that. You can explain.
I'm not saying anything front to the sun. I'm not talking about that at all. I'm just talking because they claim that the sun rays come in parallel. That's it. It has nothing to do with triangulating the sun or whatever. It's just it's very clear that sun rays are not parallel. Nowhere do you see parallel sun rays. So why do they say they are?
Because for all intents and purposes, the sun rays that you see, crepuscular rays, are parallel.
So they're not parallel, but they are.
No,
they
they
appear
no.
not to
You're
be.
saying they aren't, but they actually are. Your perception is false. When
Okay,
you see a
well,
crepuscular ray,
you claim
when
they
with
are.
your
How
perception,
do you know this?
because there's pictures of crepuscular rays from overhead or far enough away that you can see them as parallel. But when you're looking at them from the ground, they're not going to look parallel. They're going to look like they diverge because of perspective.
Wait, you say you actually see lights that are parallel?
Yeah.
Okay, are they directly below the sun, or are they off to? Is the sun off to the side some way? Let me guess.
What do you mean by off to the side?
Every time you see so-called parallel sun rays, the sun is completely directly above, right?
No.
Okay. Well, if you can show me an example of parallel sun rays with the sun not directly above, then you'll have an argument. Until then, your argument is just garbage.
Well, it shows me that when we rely upon and what we think is happening, that we become limited. That's why magicians do so well, and that's why shitheads manipulating us do so well too.
Have you guys ever seen the Great Courses? Anything from the Great Courses or Wondrium? There's a course on there, or there's a section on there called Our Deceptive Mind. Definitely worth looking into. What you just said made me think of that.
Let me know if you got a link.
Yeah. Let's see here.
Otherwise, short attention span, blah, blah, blah.
Yeah. I'll get a link right now.
Like, I can barely say, what was that again? With the short attention span issue.
Okay, I'll put it in chat right now.
Sweet.
And it kind of goes over some of those phenomenons of what you just described for people are like magicians but it goes in depth into other things other phenomenon that are happening.
That's cool. It's exactly like some TV show, some European TV show that came to interview a bunch of flat earthers, and they contacted me, and they were doing something on good and evil, and the way that we were being persecuted and labeled as bad. And they had done stuff on like the mind. It was all about the mind. They had done everything from like, drugs to exercise to foods, and all of it about effect on the mind. And they were in like their season 3, so they got to like, it wasn't about flat earthers, but they realized that we were pushed away pretty easily, and that was like a societal effect, like the gut reaction people have.
Oh, okay, interesting.
Yeah. So, and when you look at their shows, it looks just like this, where each show had a theme in relation to how your brain reacted to daily life stuff, just like this. I can't remember the name, even though I should. I can't even remember the country they were from. Shit. It looked just like this. Their website looked just like this. It was like some European PBS kind of thing.
Like the BBC?
Yeah, and the host dude was known where he was from, because when we asked if we could like ask him questions and shit on camera, they were like, no, he's kind of worried about, him being the guy, like he wasn't candid with us. He showed up separate than the crew, like he was a star more.
Okay.
So he was like the host, like a hired gun host of it, pretty much. Which actually just invited bias. I remember he was like not into it. So how many people know what that pareidolia?
I don't think many people do.
It's so common though. It's retarded. It's part of our survival skills.
Yeah.
It's totally about our survival skills and being able to recognize friend or foe. And trying to find the face as quick as possible.
Yeah, pattern recognition, shortcut, reduced amount of calorie usage on the brain. Anything that could save calories. Actually, I don't know if that's actually part of pareidolia or not, but
that's what I was wondering. Me neither. But it is about facial recognition, right? Seeing faces and things.
Yeah, seeing things that aren't there, that look like they might be there.
It's not about faces, because we tend to see faces in things.
No, I mean, not to my knowledge. I know very little about pareidolia, so.
Oh, okay. Yeah, I always thought it was about seeing like faces and things, and like because, like I said, the friend or foe situation is complicated for us, and finding the face may, recognizing danger or not. Something's gritting its teeth, or smiling. So, where's Dora, or whatever that is? Find Waldo. Let's put it this way: I worked as a paparazzi, and we worked from cars here in Los Angeles, and this key to not being seen was to not move. So just if your car's just parked there, nobody notices you. It's only when you pull up and leave, so you just don't do that. You don't run off to lunch. You bring your lunch, because when there's no motion, there's nothing to recognize. It's really a trip. Like the first thing we spot first is motion, then recognition. Like mathematically, you know what I mean? To get your attention, got to have motion. Then you seek recognition. If they're not the same color skin, or that you might recognize it as danger because
one of those.
It's it's not like me. Once you have recognition, is it like me? Almost,
Yeah, I find that stuff pretty interesting. Have you ever looked into stuff where like you don't recognize the face, like the upside down faces?
Yeah, have you seen the sharks faces upside down? They're like these adorable smiley faces. It's really see if I can find one. I mean, it's really funny. It's just
There's other things where they show a bunch of people dancing and then after you watch them dance, they ask you how many bears replay it slowly. There's like 3 or 4 people dressed in bears that come in and are dancing with the people, but nobody noticed them until they asked how many bears, and then show it again going slow. It's just what you're focused on.
Hmm.
Okay, I got these shark faces coming. Because they're fucking hysterical.
Going on, Dan?
That sounded like Brian. Is that you, Brian?
It did sound like Brian.
Yeah, can y'all hear me?
That was good. We heard it like and we both recognized you in a second.
Did y'all see my my video that I just made a few days ago?
No, you'd have to link me.
It's about the prediction. Like I had a few people like asking about it, and I was like, no, you got to wait for the video. But I went into Google Maps, and I was looking at the roads, and I was, I've made a prediction about the boat races. How I bet, I predicted that the times would be significantly faster in the long distance races in the north and in the south, and sure enough, it was even probably more than I expected. And it's what would be expected if maps were maybe manipulated and the southern hemisphere was bigger. And so I got to thinking, I'm like, why didn't I think of this sooner, man? I need to just check the road. So I predicted here on on Earth Awakenings a few weeks ago, maybe, I don't know, a month ago or a few weeks ago. I was like, I bet you the freaking roads, because they would have to stretch the roads out. They'd be straighter in the south, and they'd have to make it seem bigger in the north. So I bet you all the roads are curvier, the interstates and shit. And so I checked it on Google Maps, and dude, it was fucking like crazy, dude. The further north I went, the windier the interstates get, with obviously some inconsistencies, but overall, like I-10 is the lowest interstate that goes clear across east to west. And then you go up to like 64, and then you go up even further, and you go up into Canada. And the further north the east to west go, the windier they are. And then so I went to the southern hemisphere, and you go down to like Argentina, South Africa, and whatnot, and there's just straight roads east to west, just straight, with a couple windy roads, but like the main roads that go across east to west are just straight as fucking could be. I couldn't fucking believe it, dude. Like I didn't even, it was just pick any highway that went east to west, and you could bet your ass that it was going to be almost straight, and even the bends were like instead of like long curves, they were like straight angles over, to wherever they needed to go, but just straight lines. And then so I went up to northern Africa, and sure enough, dude, it's just bendy. And then I did the same thing in South America. Went to North South America, and from east to west. So it's like to me I ain't looked much into the north south, but as far as the east west distances go, I think the maps are obviously manipulated, man. So where if you're checking your odometer, you're gonna get fairly accurate distances, but the roads are windy, man. You look at the freaking maps, and they're stretched. They're windier than they're even showing on Google Earth in reality. And I just seen Taboo Conspiracy come out with that dude Sergey, the guy who did the boat races and stuff, and he speaks Spanish, and they translated his video, and I was like, dude, this dude thinks just like I do, because he came out with a video saying the same shit, but he got out on the road. He literally went and filmed. I just went and did a mile, and I did it a couple times to see how much difference it would be by curving. I just went to a road with a couple service roads off to the side, and I just kind of angled across a couple times, and then I drove it straight, and it was off by like a couple tenths of a mile, or about 1.5 tenths of a mile, and whatever the fuck that is. But it was like just about 2 tenths of a mile when I angled across like 3 times in the mile, compared to the straight line mile. So it was pretty significant. It ain't like the difference between a flat Earth and a curved Earth, like up and down. I'm talking about side to side. And I was like, this dude thinks just like I did, but he got out there with a fucking tape, like one of them roller tapes where you roll them.
Yeah.
And then he recorded himself driving. I was like, this dude went the extra mile to prove it. I just went and filmed myself, and recorded doing the mile. And then I just went to Google Earth and just traced doing the highways. In the South, like I dude, at one point I only had to change my screen orientation one time to span the entire continent in South America until I got to the mountains. Like I just scroll, and it angled just a tiny bit, but I wouldn't even have to. It straightened back out, and I wouldn't even have to change my orientation. Where in the north, to trace them roads, bro, I'm having to turn my screen, like it was making me dizzy when I was editing this shit. But it's so consistent. Like, dude, it's to me, man. I hope this catches on. Like, I hope people watch his video that I think just came out today, and mine that come out. Who knows? It doesn't matter who's come out first. We're thinking alike, and just see our evidence, man. Or just go to Google Earth and check this stuff yourself, man. Um, I glanced over Australia. I need to really maybe check into that, but I went into depth in like Northern Europe. I did a bunch, and then like I said, in the Northern Africa compared to Southern Africa, Canada compared to the Southern United States, and just dude, the windier the roads get, it's like, and some of these areas are like, why? And especially in the like where it's just cornfields and shit. Like, why are they fucking winding these interstates? It's goddamn ridiculous, dude. I should have noticed this shit sooner, man. Like, it's just curved for nothing, dude. In a lot of these areas, it's ridiculous, dude. And it becomes obvious the more you look into it that bro, they have to do this to match their fucking worldview. The north to south distances are pretty close, but the east to west, man, they're stretched and compressed to match.
I never check out your channel. Is it this one 4 days ago? This video?
Yeah. Yeah. Cool. I went ahead and put it with other predictions. So if you want to jump straight to it, just go to like 6 minutes, and it's the new prediction. I had to throw in, the other predictions. So I just made a big. I should have just did my new prediction, but I couldn't help it. Like, I had to throw in all the predictions because it's like, what would we predict if the Earth is flat and the southern hemisphere is bigger? Then there's certain predictions to be made, and so I threw in 9 others to go with my new one, and kind of condense them. But my newest evidence is like at around 6 minutes, maybe 6.5 minutes.
Cool. I'll watch that.
In fact, I'll
Unless
post
you
it
want-
for anybody who wants to see it. I'll post it real quick.
Sure, we could play it. Nothing else is going on, I don't think.
All right, I've returned. So you can watch my glory.
Oh,
Don't you
thank
think
God.
don't you think that's a little fishy, Ruhif? That
What's so fishy?
like all the predictions, you know, if the Earth was flat, if the southern hemisphere was bigger than the northern hemisphere, like there'd be a lot of predictions, you know, that could be made, and what we would expect to see, you know, and all of them are pretty much what you find, you know, all the way from no undersea cables to the times in the boat races to the roads being straight in the south. The further south you
Yeah.
go, the straighter the roads are, and the further north you go, the windier they are for nothing. And in a lot of regions, just for no reason at all, they're just bending and winding. It's
Right.
there's several other predictions to be made. It's pretty fucking consistent, man. If you make these predictions and you look into it, man, there's arguments to be had for every one of them, man.
Is that like Minesweeper?
Yeah, it's awesome. It's called Hex Cells. Very cool.
What is the difference between the ones with the brackets and the ones without the brackets?
So the brackets are consecutive. So it has to be 4 consecutive around here.
There's a bracket 2 there, so I guess the one next to it is free, right?
Hang on. Where are you looking?
There's a 2 in brackets with 2 blue tiles next to it.
Oh yeah, so that
Okay.
one's nothing. Yep, very good. So which makes boom boom. One of those. 2.
There's a 1 there with 1 blue adjacent to it. To the right.
To the right.
No, up.
Up.
Yeah, that one.
Yes, that one has to be a bomb. Boom.
And the other one has all the surroundings free because the other way has a blue one. It's hard to explain where it is. Yeah, that one.
Yeah. Yep. Yeah.
Okay, guys, I'm running your game.
Yeah. Pretty cool game. I like it. 3 consecutive. 4, 3.
Is this a Discord game?
No, Steam.
Is it free?
It cost me $4.50 Aussie. So not very expensive.
So, are you going to respond to the question that was asked of you, Drew? Or you
Sorry, who
just
asked
want to
the question?
ignore it?
Sorry, me or someone else?
Yeah, Ruif.
Well,
He asked you,
What was the question?
what do you think of...
I was actually talking to you, Ruif. But go ahead, dude.
What
Sorry.
was the question?
Well, like I said, if the southern hemisphere is larger in reality, there'd be certain predictions to be made, and several actually. And when you look into each and every one of these individually, like for example, like no underground cables in between the continents in the south, and the boat
Yeah,
races.
let's talk
the
about one of
times would
those
be
at a time.
significantly different. But ain't it kind of funny? Like a hell of a coincidence that there are good arguments to be had for each one of these predictions.
Right. First of all, so undersea cables, right, were laid because of the internet, and most of the internet at the time was in America, right? So all the undersea cables go from somewhere to America. There's no point laying an undersea cable from Australia to South America.
Yeah, it's clearly not the major factor.
It's a
on
lot
the side where the
closer, bro.
fixed
So
cables.
you're telling me that it's better to waste money and link and lay new cables going up and around and use that much more cable than to directly connect the two? That's ridiculous, bro.
There's no possible economic benefit for laying a cable between Australia and South America.
Yeah, there is,
It
bro,
wouldn't-
because there
no,
are
it's not.
there are color coded, like they have the color coded which ones that like connect which, and there are the ones that are just connecting. They're the ones that branch, and they're the ones that are connecting. Like the yellow ones will connect like South America to Australia. The ones that are like rainbow colored, like branch off and shit. They have literal cables going twice as far, going up and around that
Right.
are linking fucking like South America to Australia. That's
Right.
goddamn ridiculous, bro. You can make
No,
an
it's not.
excuse with that.
That there's
But that wasn't my
no there's
point,
no
bro.
cost that there's no cost benefit analysis that would make sense to save what is it 100 milliseconds between Australia and South America. There's no economic reason to do it.
Wait,
So
Brew,
5,000 extra miles of cable ain't economic.
No, the
Brew,
bulk of the traffic goes to and from the United States. That's why the cable was laid.
Rue,
That
have
wasn't
they
even my main
had
point.
undersea cable for 100 years prior to that? And
For
all
100 years prior to the internet?
undersea cables are fucking old. Telegraph?
Really?
Yeah, really old. I'll find you an ancient map
Alright.
on it. Ancient map.
Optical
1800.
ones?
No, not optical. We're talking about routing. We're not talking about optics. Undersea cables are old, man.
Really?
Really old. Telegraph. Telegraph?
Undersea cables from like Australia to the US.
Continent to continent.
Okay,
Common.
yeah.
Yes. I'll get you the map and the age.
That'd be cool. Yeah.
Yeah, when you're designing a network, just the
How
distance
do you
isn't
think?
needed.
Sorry. How do you think the telegraph worked if they didn't do that? How would a
Over
telegraph
land?
work from the United States to England?
Transatlantic.
Telegraph? Yeah, I thought that was the whole Marconi issue, wasn't it?
What does transatlantic mean? 1858.
Wow, for undersea cables. Jesus.
Yeah. It's really old. That blew my mind.
Atlantic cables.
I don't think that's continent to continent yet, though. So I'm trying to find the map that I'm used to seeing.
Holy shit, the first transatlantic telegraph cable was like 1858.
Yeah, but I wasn't really meaning to. That was just an example, like one of the. My video. I got 10 of them.
Yeah,
and I got
and then the other
the 10th one is my newest one, the one that I made a prediction here on this channel, and then I looked into it, and sure enough, bro, it's exactly what I found with the straight roads in the south of South America, like the highways and the long stretch.
That's an atrocious
major
prediction, by the way.
the
I
long.
completely disagree with your prediction.
Well, look into it. I mean, I showed all the examples, like not every highway in South America or the south part of Africa, but just look at the east-west highways, bro. They're straight, and there's a couple exceptions, but there's no wind. It's the further north you go, bro, the windier it gets. There's no getting around it, bro. You can maybe I couldn't find any exceptions in general as far as the entire stretch of highway, but and then you go into North Africa, and it starts getting windy. Then you go into Europe, Finland, and all that, and it's just windy for nothing, dude. Same thing in America. As you get up into Canada, and the further south you go, the less windy the roads get. It's like a pattern, bro. You will recognize it. You can't not recognize it. So I traced out a bunch of them in my video. I showed, I zoomed in to the roads and just followed them. And when you get down to South America, like in Argentina and whatnot, like I said, I scrolled clear across the continent and only had to change my screen orientation one time and just scrolls. The same thing in the southern part of Africa. Like I only had to change my screen orientation once or twice, and I just scrolled clear across the fucking continent, bro. Where you get into North Africa, and it's dizzying, bro. You got to keep changing your screen orientation to follow the roads. It gets dizzying trying to follow. And the further north you get, the more you have to change your orientation to trace these roads. So I just did it in fast motion, so everybody could see all these main highways, and it's there's no exceptions, man. And everywhere I looked, there was no exception. It all stemmed from me trying to find some straight roads. When I drove down I-10 west, pretty much from where it starts here by the Atlantic Ocean, a few miles off, about probably 10 miles off, but where it starts. and there's no straight shots, bro. More than a few miles, bro. Like it just bent, and I was like, some of these places, it's like for nothing, dude. Like it's just winding and bending for fucking nothing, and then I got to thinking about it. I was like, man, I should have thought of this sooner. Like the further I went, the more aggravating it got. That there was just no straight stretches of road because I was trying to get up underneath a cloud. So I just wanted to find one good, 10-mile straight section of road so I can identify a cloud in the distance. And I literally drove for hours, I-10 West, and there was never a fucking section of road, even fucking 5 miles, to try and see how far it would take me to get up underneath these clouds. And then I put 2 and 2 together, a few months later, which was about a month ago. And then I looked into Google Earth, and that's when I came up with this. But bro, anybody, having said that, anybody who lives like in Argentina, that'd be the place to go to look for clouds, to see how far they are in the distance and how far it takes to get up under them, like ones that are maybe like 5 degrees above the horizon or 10 degrees or just barely above the horizon, like because all the roads are straight, all the highways going east and west, they're all fucking straight. Same thing in South Africa.
Have you
And then
noticed
you
how
said that
whenever
there was
you
no
give
cruise
evidence?
ships. Sorry.
No, go ahead. Go ahead.
Yeah, you said there was no cruise ships between Australia and South America. Correct. Who the fuck is going to cruise that way? Is that a luxury cruise? Like, is that an enjoyable trip? But there are cargo ships that go from Australia to South America.
Not very many.
I
Doesn't
can't
need
get on
many.
a cargo ship, Ruhev, can I?
More than are traveling.
Actually,
Like, I mean,
probably
I can show you like a tracker that shows very few numbers on it.
Yeah, if you look at the
There are
almanac,
some.
if you look at the Australian almanac, one of the old ones, it shows the distance that the route you're talking. It showed them way longer, man. Like
Way longer?
not like AE map longer, but longer than what's than would agree with Google Earth.
You saying the old books are more accurate than Google Earth?
I don't know. No, I'm just saying.
Well,
I'm just saying what they said, man. I'm not saying they're more accurate or not. I'm just telling you what we would expect if the Southern Hemisphere was bigger. It's just another thing we would expect. We would expect no cruise ships. They go between the continents up north. Why not in the south?
Would you
And the ones
expect
that
no
do jog
cargo
over, they
ships?
go way up north, and then they cut over. That's fucking crazy, dude.
They don't go way up north. Bloody hell.
Well, you also got to remember that the Earth is pear-shaped.
So, is there a curvy road conspiracy afoot?
Yes, there was. Not that one.
God, it took me that long to find that. I think this is the first.
That was another one of my predictions. the pear shape, like we would expect for people who did notice, that they would have to literally call the Earth pear shape if the people who did do measurements is like, wait a minute, we're getting bigger measurements down here, and to satisfy them, they call the Earth pear shaped, like the military, the Navy, the fucking NSGS, and then Neil deGrasse Tyson. Of course, I got that little compressed video where they're all saying the Earth's pear shaped. They even show an animation in the Navy of a literal pear shaped Earth. It's like an animation. It's fucking hilarious, dude. And then when we go to talk about it, the anti-planeters are going to say, well, yeah, it's just you can't see. It still looks like a perfect fucking sphere, rounder than a cue ball, but it's still pear shaped. Like, dude, which is it, motherfucker? But we would expect horse shit like that.
Well, they say it's pear-shaped, but yet they say their perfect navigation on the globe, what we were originally told it was, it still works even though the Earth is pear-shaped. Really?
Navigation's not affected by the geoid. By
Bro,
undulations in the geoid.
You look at the time zones too, man. Like we would predict that if it was bigger in the south, we would predict more time zones, and sure enough, there is. And then you start looking into time zones, and this is something that dude Sergey pointed out. There's in the fucking by the international date line, which is a perfect place to do it, there's like a big stretch where the continents spread out. Like there's 4 time zones right there, and on the edge of Alaska going to the Soviet Union. There's like a 50-mile stretch where windsurfers can literally go across from Alaska to like the Soviet Union part of it, and they got 4 time zones right there. It's like, bro, that's I mean, that's a targeted fucking. I don't know. To me, that the position where the date line is to confuse people, where they won't look into it. You know that don't work with flat earthers, but anybody else is going to see it, and the date's going to flip. They're just probably going to look past it. But four time zones in that little area, bro. That's the same area as the whole continental United States, bro. And you got that in that one little section. You got 4 time zones, bro. They have to get rid of area. So that what better place to do it than in between our fucking arch nemesis, the Soviet Union, dun, 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 and right there between Alaska and shit. That's why we bought that.
Can't
shit,
you
probably.
actually see it? Can't you see across the Bering Strait from Alaska to Russia?
Bro, I don't know. I've never seen it. I'm just going off what I heard.
Okay, maybe Google some photos of that. See what happens.
So isn't that funny that's called the Bering Strait when we have a common term that you should get your bearings straight?
Right. Oh, finally. Fuck. Finally. Not that one.
Do we laugh now or laugh later, Ruth?
Huh?
Do we laugh now or laugh later after that one?
Oh, that I finally got that one. That would just fucking stare him in the face. Yeah, that was pretty bad.
1800s on this fucking oversea cabling. That's amazing, isn't it?
Yeah.
I guess I'd have to say maybe the ocean isn't as big as we think. It just was slow and dangerous early on.
Oh, fuck me, I'm getting worse at this.
What on earth is that game called, Ruth?
X Cells. And it is a great game. Oh, Four.
Well, I hope you excel at it.
Yes.
Right. Say, man, y'all's model, bro, is it's getting called out like a motherfucker, dude. All the bullshit, man, getting pointed out. More and more people are looking into this shit, dude. It's like it's had its term, bro. It's served its course. It's an archaic model. It did what it could. Time to progress, man.
1, 2, 3, 4, 5. Boom, boom. 1, 2, 3, 4, 5. Yep. Boom.
Sure, it's a little complicated, man. It's going to take some machine heads, some definite mathematical geniuses to map it out, to figure out the every bit of it, but it's a celestial sphere. It's not an actual sphere. So there's going to be some new map, there's going to be a lot of new surveying needs to be done.
Yep.
Distances and all that.
Let us know when you got it sorted.
And so there's a lot, like I said, there's a lot to be done in the future, man, to get this model right, man.
But won't the powers that are suppressing the truth prevent the true surveying from happening?
Well, I think they've just depended on. I think that generation's almost dead, and there's probably a few left, like the anti-flat earthers, but like the guys, I picture them like the old English society, like the sun is 1 million miles away, and that's final. Like we know this, we got
no.
all that.
But what I'm saying is the people that are suppressing the truth, right? Like, don't you have to get past them? Like that's
I
hiding the
think
true
yeah,
nature
I
of the
think the
Earth.
majority of them are just brainwashed and thinking it's a globe. But once it's pointed out to them, then a lot of them in positions of not absolute power but partial power and knowledge can will see the truth and be like, damn, why didn't I notice that? You know, just like pilots or who are coming
Yeah, but
forth
there's
and
isn't there like people like actively lying about the shape of the Earth? Like, don't you have to get past them?
yeah, I used to think that it was more just people wrong. But after looking into the like after talking to Gio about it, and he made a couple good points, and then looking at these roads and shit, like that had to be done. There's no way that the roads get windier the further north you go without intention. You know what I'm saying? It's not a coincidence that when you get farther south, the roads straighten the fuck out. That had to be done intentionally and shit. And so yeah, I do think there are some manipulators in positions um, to back the model. That and that kind of makes me think everything different. I'd never really like to go about it looking at it like conspiratorial. I just always considered them to be fucking just wrong. And now
Well, I
when
mean,
you
they would have
you
to
know,
be like not telling the truth, right? If they're like saying we're going to space.
well that's a given. Like the astronauts and shit, they're full of shit. We pointed that out long ago. Like, but they're military, you know. They've all signed agreements and shit. You know, anybody with clearance that signs stuff like
Yeah, but
that's
like SpaceX, right? That's a private company.
no, it ain't.
SpaceX isn't a private.
No, it was until they sold out to NASA. Remember the NASA people came in and fucking took over pretty much like years and years ago. They tried to keep up the the camouflage of it being private, but no, it's not private.
Okay. So what about like
Why
private
why
satellite?
are you asking about that though? As far as the I mean, we called that out and pointed out that bullshit a long time ago. Like the astronauts and all that, you know, they have to be lying. And we've caught them in bold face fucking lies. Bold fucking face lies and pointed them out. And so I was way satisfied with that, but it's like the map makers and the road makers and shit like that, like the people directing making these roads and stuff. Like you're talking to areas of just cornfields and shit with a windy fucking interstate. Like what? Like
They're
dude, that's
working in concert to make it seem like it's longer than
yeah,
it
they got to
actually.
be. Yeah, that's not. It can't be a
Yeah.
coincidence for all the major highways east and west to follow this pattern. They got to be.
Hmm.
And so that kind of changed my thoughts. Like there has to be a people in positions doing this shit on purpose to make their model seem more feasible. Because just think about it. If you had roads here in America, highways with big long straight stretches like you do in the southern hemisphere, the further south you go, then we could check shit. There's nowhere to go to check anything, dude. Like I couldn't even fucking find a stretch of highway clear across fucking Florida and further to even get to see how far away the clouds were, just to see if the trigonometry matched. I couldn't even find a stretch of road 5 miles, much less 100 miles or 200 miles or 1,000 miles. So here in the northern hemisphere, it's like that everywhere, every fucking where. Not just most places, every fucking where. There's no straight stretches of interstate going east to west any fucking where in the northern hemisphere that I could find. And I searched for a few days. And I mean, granted, I never really searched like China and shit like that, but I searched all the free world basically. And yeah, that would have to
Brian,
be yeah.
sorry, I've been driving and listening to you. So it is your contention that SpaceX is in fact a part of NASA?
Yeah, they came and remember, you don't remember them talking about NASA coming in and taking over the controls, all that shit a long time ago when they basically merged or what do they call it?
Received
forgot
a
what they called it.
contract from NASA.
Yeah.
Yeah, and they had to run
Well,
everything through. They had to run all
and plus,
their big decisions have to go through the
yeah, because
hands of NASA.
they're getting millions and millions of dollars of
Oh,
taxpayer money.
yeah. I'm just
Space
saying that
Force.
they're not calling all their own shots. That's my point. That's all.
Yeah, I'm trying to back you up. When you get
Okay.
millions of dollars from the U.S. government, you do what the government tells you. They're not private; they're run by the government.
Actually, that's completely incorrect in that SpaceX is a private company and they are actually underregulated rather than overregulated. You can look at Starlink, for example, for this. Starlink is a major problem for ground-based astronomy. We're talking about billion-dollar installations that are funded in
Starlink
part
is shut down,
by
bro.
the U.S. that are funded in part by NASA or by the federal government.
Bro, they
And
shut that shit down, bro. What are you even talking about?
Starlink, they shut Starlink down.
Yes.
It's
Like
weird
it's
how
like
they're like
some like
actively
That's
deploying
fun.
new satellites as we speak.
no, the shit they have is
Yeah,
fucking like conglomerated and fucking and it is what it is. Like they're not what are you talking about? They're still launching shit. So show me one flying by my anywhere around me or anywhere anytime soon. Show me the last Starlink video.
I saw them. I actually have it on my Instagram. I can when I get later on, I'll DM it to you. I saw one go over my observatory. It was a pattern of 40 some odd lights in tight formation going over my observatory.
Okay, and I made a video on that, and they had a 700-mile stretch of these satellites going in a straight run. So I found the most orthogonal view I could find on the whole internet. Okay, and I showed it, and it's a dead straight fucking line, bro. Okay, now what we would expect if they're the height they say they are, is we would expect them to curve down. You know, they would be dropping in the distance, especially hundreds of miles like that. Like perspective would enhance the curvature, but yet we see a dead straight line of satellites, bro. That right there should tell you that that they're not orbiting in a fucking circle. They're following a dead straight line. You're talking about a 700-mile straight line of satellites, bro. That proves they're not fucking curving, dude. That proves they're not orbiting in a fucking curve.
I don't know how much a curvature you would expect with a 700-mile long line of satellites, but what I can tell you is that observations from large ground-based observatories are getting more and more polluted by satellite trails going across those images. We actually are now starting to do studies to figure out exactly how bad Starlink mega constellations are going to affect astronomy and how we're going to deal with it.
So how are they keeping
these
it away
aren't
from Florida? Just asking. How do they have this orbit like just dodging fucking the state of Florida?
I'm not entirely certain what their injection orbits are, but I can show you maps of where the satellites are being deployed.
So
Also,
so you can just show what they've told you, basically. So whatever they've told you and whatever you see, you know, you ignore the fact that it's a dead straight line of satellites, dead straight line, and not a curved fucking arc path, a dead straight line of satellites you could film yourself, and you ignore that part and just harp on the part that you can't really confirm any of this other shit. You really can't confirm it. You're just going off what they tell you. And you're saying that they're a private company, and they're not. They have to, everything they do, they have to run through the heads of NASA. They're basically the same shit, dude. I'm surprised you don't know this, dude. SpaceX is basically NASA 2.0.
They are not actually. SpaceX has their own space pad. They don't even launch through NASA. The Starlink satellites do not launch through NASA at all.
Where do they launch?
They launch at Texas, which is a nature preserve, to be quite frank, which is also another reason why I don't like SpaceX.
Right,
But
so why are they avoiding
in terms
Florida? I'm just wondering why are they fucking avoiding my state?
I don't know why they seem to be avoiding your state. I don't know whether or not they are in fact avoiding your state. Why
What
they didn't
good
build
is
in Florida?
Bro,
Why
you're
didn't
missing the
build in
point.
Florida?
If it's if it's internet service and they're circling the earth in 90 minutes, bro, that's worthless, dude. If you only got a 700-mile trail, then you've got internet for about fucking 20 minutes, dude, maybe 10 minutes. Bro,
Brian, I don't know what you're on about. I mean, dude, the Starlink system definitely works, man. It's a whole system. It's absolutely happening. So, whatever it is, I mean, I don't think you can evaluate the straightness of the lines enough to decipher whether they're circling around the North Pole or around a sphere either. So, I don't.
Okay.
Yeah.
All right. Well, they do.
Starlink is a very real thing that gives full service. So I don't know what you're
full service.
Asking
Okay, so
Ukrainians.
I'll give you that, Gio. But if you have a 700-mile strand of satellites, okay, 700 miles, okay, now they circle the Earth once every 90 minutes. What good's that going to do for internet? How can it be full service if it's only a 700-mile strand of satellites? And in other words, they're on the whole opposite side of the Earth. And it's only 700 miles, so you're talking.
Are you under the impression
That's
that there's
not
a
satellite.
singular 700-mile strand of satellites
To me, that could
Starlink?
work on a flat Earth. Is my point. That we could make that work on a flat Earth, full service. But if you have a 700-mile chain of satellites, it's like 736 miles. If it's on the opposite side of the globe, then it can't be full service.
I think you,
Brian, that is not Starlink.
Starlink.
Yeah, I don't know what you're on about, bro. That's what I was saying. I don't know where you're even getting that information. Are you talking about Starlink? Yeah.
Starlink is equal coverage around the Earth when it gets fully deployed.
Yeah, and I was going to read this too about I mean, technically, they do say SpaceX is a private company. That is true. It's not a government. In terms of the quote unquote paperwork, the public, as it were. However, they are deeply, deeply bound with NASA on multiple fronts. And yeah, Elon Musk years ago, the thing that Brian's referring to, Elon Musk was in an interview saying that he just gave all their mission control over to NASA, and all these government officials came in and literally took their entire mission control, systems and stuff. So there are many deep intertwinements and all the finances as well. And I was just going to read this real quick. This is from the Wikipedia page for SpaceX. It says NASA awarded the first commercial resupply services (CRS) contract, awarding $1.6 billion to SpaceX in December, thus financially saving the company. So, I mean, to say that they're not NASA literally gave them $1.6 billion to save the whole company. They're not very private.
Well, do you guys
They are still private, and also, if you look into it, Bezos got really pissed off about that, and actually, I believe either sued the government or sued SpaceX. I can't remember who he sued because he didn't believe that contract was valid. But again, I asked the question. So, Brian, you wanted to know what I can verify and all that. I've been telling you that these satellites are going through observatory fields of view. Have you asked the question, how is it that we know that those satellites, those streaks of light are in fact Starlink satellites? Is because we know what the orbits are. We very much like the ISS, we know where those satellites are going to be. We can identify, this image was taken at such and such location at such and such time. Starlink was right overhead during that time.
I got you on that, but that's not impressive ultimately. I mean, they can track things in the sky. They can map them to various models and systems. I mean, that's not out of the ordinary. I mean, yeah, they can have lights and communication devices and things that are making tracks in the sky. But where would you lean towards that indicating anything about, what they're claiming it is? In terms of my
initial question, sorry, go ahead.
No, sorry. I'm just saying how to decipher that between them orbiting a sphere versus them tracking above a planar Earth.
My contention has nothing to do with the shape of the Earth. My contention has to do with the idea that SpaceX is a basically puppet company being run by the federal government. It is not in any way really a shape or form. In terms of all the things that you were talking about with mission control, all of that has to do with basically NASA organized programs such as going to the ISS. When it comes to Starlink, NASA has fuck all to say about Starlink. And the United States, the AAS, the American Astronomical Society, has gone to Starlink and said, "Hey, can you do something about how bright your friggin' satellites are?" And they said, "Yeah, we can try, but there's no regulatory power to make them mitigate that power." And so my ultimate point is, if Starlink were basically a puppet corporation for the U.S. government, then why is it that their product is interfering with billion-dollar installations that are also funded by the government? It seems to be blowing your own foot off.
You still haven't answered my question. How are they dodging my state? I want service. I want Starlink service. And I just posted a video of a 700-mile chain of satellites in a dead straight line. Okay, maybe you wouldn't be able to see it. Maybe the 14 degrees wouldn't be noticeable. But I think 14 degrees over that distance would look like a fucking rainbow. But you see a 700 mile dead straight line. I think it worked perfect on a flat Earth, but I think on a globe, you couldn't have full service internet. On a flat Earth, you could, but on a globe, you'd pretty much have you'd be blocked out every fucking hour. So the satellites would be on the opposite side of your globe, so you couldn't have full service. So just by them claiming full service, to me, is proof of flat Earth.
Okay, hold on, Brian. So is it your contention that that someone in Florida cannot get the Starlink service? That it is physically impossible for them to do that?
I've never heard of it here. I've never been
Well,
offered.
I've never heard of it here
I've never
either.
seen it. I stargaze every night. Damn.
Yeah, Brian, it works and works very well. Upwards of 80 megabyte download, which is quite high considering. I mean, original high-speed internet was like 12, 15. You know, that's considered technically high speed, even though that's, you know, nowadays people have upwards of 1,000. But 80 megabytes up and down, very solid, no delay. So it's absolutely a very real system that pulls the internet. And of course, it's 24 hours a day. So whatever the system, whatever the systems are, yes. Well, no, it's not necessarily everyone on Earth. There are certain areas, but you know what's wild about it though? You can take it out of the sanctioned area and it still works. So yeah.
What city do
Let
you
me
live in,
ask.
Brian?
Okay, that's news. I trust everything Gio says. I trust because I know he's well researched. Okay, now if they have if Starlink is up to a 700-mile chain, and how is the internet like shooting through the Earth or something, or do they have like multiple chains that I don't know about? How come I can never see them, man? Just curious.
So they're basically, when the satellites are launched, they're launched in packets of 48. They are then deployed, which gives you a very long line of 48 dots flying in a row, which is what I think you're talking about. But basically, that's an injection orbit. Those satellites are getting higher up and getting dimmer, and ultimately they're being deployed around the globe, evenly spaced, roughly speaking, so that you never have interruption of service. And
so they're circling the entire globe.
Correct.
So when did they go from 700 miles to 24,000 miles? Just curious.
I'm not sure. Those numbers actually don't track for me. From my understanding, low Earth. Okay. From from my understanding with Starlink was that injection orbit was around 240 kilometers, and then it goes up to 600 when it's fully deployed.
Brian, they don't stay in a tight line. They spread out.
Yeah.
From what I found out, what is the entire LTE network for South America was run with less than a dozen balloons. Okay, the entire LTE network for the entire continent with just 12 balloons. You know, I forgot exactly how high they were. I think like 100,000 feet or 80,000, maybe 120, somewhere in there. I forgot the exact height. I'd have to go look at some old videos. But so doesn't that seem more plausible that you have balloons up there like they've already done, that they already can? I mean, that almost reminds me of like the shit Professor Phil Bell showed, that Brandon showed on his channel, like them dropping all these little satellites and they're going into the clouds and shit, man. And then you see white shit blooming from them. So it's like they're just dropping balloons, man. It's more likely to me, in reality, that they're on balloons, and that they would absolutely spread out, but it wouldn't take that many to network an entire continent to have good service like that.
There's a map that I linked for you, Brian, if you want to check your coverage area.
I'm not certain. I can't speak to South America, but what I can also speak to is one of the reasons why you probably haven't seen Starlink commercials in your area is because Starlink isn't for you. I don't know where you live specifically, but Starlink is specifically designed to get to folks who really have no other alternative. Well, at least in theory, they have no other internet alternative. So we're talking about deeply rural areas or deeply impoverished countries. So
Shouldn't I
anywhere in
still see them though?
Florida,
If there's a globe, if they're how high up are they?
I think when fully deployed, they are around 600 kilometers above the Earth's surface. They have magnitudes from 6 to 8, and no, they should not be seen by the naked. Well, the 6th magnitudes ones, yes, those can be seen by the naked eye if you were in a very, very dark sky or dark
What
sight.
about the complaint about how bright they were? What happened to that?
Yeah, if you're in a very dark sky, you can still see satellites. But when you're using a telescope, they're blinding. I mean, 6th magnitude through a modern telescope is actually almost unobservable because it's actually too bright.
I just think y'all are too quick to accept everything you're told, man. I mean, it's not healthy to accept everything, man. Just
Brian?
fall outside the box and question shit and other possibilities and stuff, man. It's unhealthy just to believe all the shit you're told, man. To me, man, even whether it is right
Brian,
or wrong.
Do you know what I do for a living?
No, I don't.
I'm an astronomy professor. I have a PhD in astronomy. I've done active research.
Park?
This is Professor Parks. Hi, Brian.
Oh, okay. Hey, man. Yeah. Okay.
So it's not like I'm accepting things that I've been told. I know people who work at SpaceX. I've done active research of my own. So, when I tell you about these telescopes that are having a problem with these mega constellations like Starlink, I've seen the data. I've seen the problems that they're facing. So
Let me
this
tell
is
you
not
this,
something
though,
that
man.
I'm just
I'm here
accepting.
in Florida, Professor Parks. All right, I'm here in Florida, and I'm about 100, little over 100 miles north of where they launch these fucking things, right? So I see them, I've recorded them, I've watched them, over and over and over.
Yeah.
They don't go that fucking high, dude. I'll give SpaceX this, like the SpaceX rocket went like way higher, dude. Dude, to me, it looked like it was about like maybe even 20 miles up, bro, 25 miles. Like the NASA ones, bro, to me look like, maybe it's perspective or whatever, but to me, they're way lower than the SpaceX rockets. I haven't seen a SpaceX launched here in a while, but they look cooler. They're higher. The NASA rockets, man, they don't get above the horizon from where I'm at. And I'm not that far, man. And to me, like when we sent these rockets up, like some badass amateur rockets, and they're going straight up and they're spinning. So they're going to cut through the atmosphere a lot better. They're just going as high as they possibly can, and they're trying each year to break their own record. And they're only getting about 70 miles, 72 miles. That's it. They're capping off, and they're like the first one was like 60, and then 62, then a couple of years later 65, and like, bro, they're doing everything they can to these rockets to just get a few more miles, a couple more miles, and they have these anti-yo-yo mechanisms to make them stop spinning, but that's what it takes to get up that high. And why the fuck aren't they just cutting at an angle? I mean, why is there a limit to how high they can get? Why can't they break that 72-mile record? It's stood for like 4 years, bro, and they're trying, but why can't they break that record? And why are these rockets just look like they're just angling off, dude, and basically like a glorified airplane path, and not getting that high? It's just like, I'm just going off what I see, and that's what's making me question shit. It's possible that they're not going like they say they are, man. I'm just throwing that out there.
Rob doesn't like to defend NASA. It's not like worth it for him.
Not really. I mean, mean, because most of my experience is in basically university run research. So with the projects that I've been involved in, I don't think I ever got a NASA grant. All of my money came from NSF. So the National Science Foundation. So I am technically not.
I've heard you in the past, and I know you've got you're free to listen to all the speculation that we throw at you and everything, and even throw some of your opinions out there and stuff. So yeah, I'm gonna treat you. Plus, I like asking you questions and shit. I respect your position and everything, and your education and all that, and just the fact that you're here talking to us, man. So that's why my tone kind of changed and shit when I found out who it was. So
hey, no problem.
Because from already haven't heard you, right?
Yeah, I appreciate that, Brad. And I want to say that, I appreciate that. Yeah, all right. So if you're given a flat Earth, yeah, there would be a prediction that the southern hemisphere would have a larger amount of air than the northern hemisphere, and there would be consequences because of that. So I do applaud you for looking into that. I don't know. I'd have to watch your video, but I don't think you can really go by cruise ships because, as Ruhiv said, no one's going to take that cruise from, say, Sydney to Santiago. I mean, I really can't see a whole huge demand for that. As for the time zones and the international dateline are almost exclusive or are probably more politically motivated than they are geographically motivated.
You're
so
right.
if there are 4 time zones in an area, that could just very well be that the government at that point basically said, "Oh, fuck it, we're going to do 4 time zones for some reason."
You're absolutely right about that. But think about this: when you're navigating, bro, we have to go by the time, like we go by the time zones. Like it's not in any way consistent. Like UTC -5 or Greenwich, like the Greenwich hour -5 or -4, bro. It's so inconsistent. Like anybody could model some shit if I could just skew the fucking. And not saying that that's what they did, but it does appear like that's what they did. Like they just mucked with the time zones to match and to make a big model that works. And kudos to them. They've got a model that works and everything, but it's not as perfect to me as they say it is. Because like to me, on a flat Earth, you'd have perfect time zones, that would have to work because everything's doing a circle, which is what the stars do year after year after year after year. I mean, you would know that they're just doing circles and they offset each year, but they're doing their same ass circles every day, day after day after day, for the most part. And but all this cell nav and shit's based on time, and time is very, very important. And if I could skew the time, and skew the map. I mean, if to skew the map, all I'd have to do is skew the times. What I'm saying to make it all fit, that's what I'm saying. It would still work, but it wouldn't prove nothing, in my opinion.
I don't do celestial navigation at all. I don't even really know how it's done. But what I can tell you is that astronomers, at the very least, and I would assume the Navy also does, we have something called sidereal time, which is basically it's 23 hours, 56 minutes. And there are no time zones. It's just, that is if right now it is, say, I think it's close to maybe 4 hours, 5 hours over my meridian. And then somewhere on the opposite side of the Earth, it's going to be 12 plus that. And so there are no time zones in terms of sidereal time. So that's kind of an absolute timing system.
Right. Good.
So I don't know, like I said, I don't know if sidereal time is used in celestial navigation, but I would imagine it is. Or at least UTC time is probably even. They probably use UTC time. So
yeah, it's UTC.
I don't know how time zone would.
Yeah, that is how that works. UTC time.
I don't know how the time zones would fall into that.
But
because if everyone is using UTC as a reference,
it's definitely a bad one too. Like I should have brought up a few others, but it's literally I could make a fair argument for every prediction. Like if you think of every circumstance, like the world record times, I would, before looking into it, I predicted that the times are going to be faster in the north, and I didn't just look for like some off the wall record. I looked for a 24-hour record and races that have been ran for fucking decades with hundreds of boats, multiple days. So you'd think there'd be conditions. At least one time in the south matching the conditions in the north for one 24-hour span. And what it looks like is these boats in the south are literally going faster, it looks like, in these faster winds. But get recording way weaker times, like 24-hour record in the north is 722 miles for a 24-hour leg. And in the south, it's 536 miles. That's pretty fucking significant, bro, considering the decades and the each time they do this race that I was referring to is like 100 days. So just one day, all of them couldn't come up with any of the conditions to get a good 24-hour time to match dozens of records faster in the south and the north. I mean, and that's another one. And then we predict the sun. Like it's been said, it's in books, it's in history. It's still flat earthers who claim that in the south, like Sergey, the guy who's charted 100,000 nautical miles, says the sun it sets faster in the south. It comes in faster, it sets faster. That's a prediction to be made on a flat Earth if the southern hemisphere was larger. And then there's just several more. I probably shouldn't have brought up the cruise, but I put 10 in that video. But it's just like everything we see, man. It is at least suspicious, if nothing else, right?
Well, it certainly raises questions, but I would think that those questions have answers that are consistent with the globe, but not my expertise. I've certainly watched the video, although at this point I need to watch Alan's video on relativity because I'm really behind in getting him my thoughts on that. But I can definitely watch yours, see what's up.
Yeah, I'll repost it. It's a pretty interesting video. I'll post two of them. The one with the races, and then the one with the 10 predictions. In fact, I might be able to DM them to you, or you can just watch them when you get a minute. I'll see.
Okay. Now, who is it that's lying to Flat Earth? Like, who is it that's... let's make the assumption that the Earth is flat. Who is it that's actually doing the... Who are the people? Who is the wizard behind the curtain? Is my question.
That's a good question, man. Like I said, I didn't really think like that. I mean, I thought absolutely the astronauts, but we're lying. That goes without saying. I think we've showed that they're dishonest. I would have to say the people in charge, man. If I'm gonna go all the way out there, I'm gonna say like the people and making the models, making the maps, and I'm pretty sure it's been passed down over the years to and the torch has probably been passed, man, like where they're just modifying these models, and then a lot of people working there are oblivious, and they're just giving the data. They're giving the data. Go ahead, Dan.
Let's say it's untested and unproven till Byrd, Admiral Byrd. I want you to just consider the years 57, 58, 59, and the world of change that happened at that time. I think it's 60, Eisenhower leaves office, maybe 59, and begs us to beware of the military-industrial complex. Without going too much further, that answers your question as to who had an interest and control at that time, because he was warning us that he felt that it had already been government had already been left out of the loop at that point. And when Kennedy came in thinking he was president, he got killed. And they've had the control of these programs ever since. So,
I've got a few things on that. As I pointed out to you before, astronomy has been around forever, and astronomy is under the conclusion that we are in fact a globe or circling around the sun, which is in fact circling around the center of a spiral galaxy, it has nothing to do with the government. So why haven't, like, who's controlling us is my question. Is it still the government? Because if it's the government, then it has to be way before Eisenhower. And then also, how is it that, we are at each other's throats globally, but on this issue, all of the global powers seem to be all on the same page?
Okay, how does
Unless there's something
astronomy
above that.
how does astronomy tell you that we circle the sun? You see
We can
lights.
do that.
Sorry, go ahead.
Yes. Yeah. We see it. We study. We look at stars and their motions, and from that we can, and also the planets, Venus, for example.
Okay, so you see lights that are up in the sky moving around. You make assumptions. You don't know what your assumptions, you don't know whether they're true or not, because there's no way for you to verify this. You just make assumptions based off of the movements of the lights in the sky. How is that knowing that we circle the sun?
We actually make predictions from an underlying model. So the idea is, if we are in fact orbiting around the sun at a mean distance of 1 AU, then that would indicate that stars at this particular distance would give us a parallactic shift of this much. This stars at that distance would give us a parallactic shift of that much, and we can make the observations. And in that case, we're just actually making the observations. But prior to that, we can do the same thing with asteroids. We can look at asteroids, use trigonometric parallax to determine their distances, and then we can shoot a radar pulse at them and get a distance that way, and they match. So our distance measurements,
Have you seen one
our
of these
distance
radar
indicators.
Because
Have I seen one?
The top guys in that said they tried to do the radar, they tried to do the lasers to the planet and whatnot, and none of them worked. They couldn't get accurate. None of them matched. They didn't say that about the moon, so maybe that's a whole different argument, and maybe the asteroids is a whole different argument. But they couldn't do radar balances off any of the planets and get accurate distances. And that's the guy who had to fix. That's Ron Hatch, the guy who had to fix the GPS because it wasn't, given the relative calculations and shit, which doesn't really prove for just the globe, but the radar didn't work was my point. So have you ever seen one of these radars off an asteroids or planets that he spoke of?
Have I seen any of the? Have I seen that? No, but I will need a citation, because you can talk to any ham radio operator who you can identify, because they'll tell you that they're a ham radio operator. And they commonly do this. They commonly send out a radio signal to the moon and time how long it takes to get back. So we have been radar mapping planets for a very long time.
Yeah, okay. I can't verify the moon, but I'll post where they tried it with the planets. It didn't work, and this is straight from the guy who fixed the GPS problem. It's a short video too, and it's right to the point. And he straight up says that they tried radar bouncing the planets and they got the wrong answers, pretty much. So I'll send that, and once again I'll DM it to you. So you ain't got to watch it right this second, but it's a very short video. I recommend you at least glance at some of these videos I'm sending.
Oh yeah. That's really surprising to me, considering the Magellan mission completely radar mapped the surface of Venus. So I'm not entirely certain how radar mapping doesn't work.
In 1961,
since I've seen that data.
In 1961, astronomers from the Jet Propulsion Laboratory in California bounced radar signals off of Venus and got a measurement of the range between the Earth and Venus.
Yeah. We did that. Sleeping Warrior actually showed me an article where the first part of it was talking about the failures of that mission. And then I had to redirect him to further down the page where it says they were successful in the early 60s, 61, I guess. So yeah, that's completely news to me that we can't do that. But to answer the other question, basically we construct a physical model on what we believe the universe is like, and then that's going to lead to predictions, which we then make observations to verify those predictions. So that's how we have confidence in stating that we are in fact a planet going around the sun, which is in fact going around the center of a barred spiral galaxy. So.
Going back to the people that are covering up the true nature of the Earth, like when would they have? When did they find out that the Earth was flat, and then subsequently cover it up? Like how far back would that have had to have happened? Anybody have any ideas?
Yeah, well, if you look at every document and every experiment ever done, they treat the Earth like it's flat and stationary. All the airplanes, all the DOD, all the Army, Navy, we've showed just once they declassified all the documents. So what the globe is a mathematical model. They literally did these measurements on a flat Earth, and we're not arguing that you'll have like a model working all that, but it's just a mathematical model. Okay, everything is measured and treated as flat and stationary, and then modeled onto a globe that's spinning and hurling and all this other shit.
Yeah.
So it's all treated as it's flat stationary. But the one that I was speaking of, Parks, it says that the GPS engineering documents show that the Sagnac effect is not the Earth, and that's where in there the guy who had to go fix it, the guy who worked straight with the DoD and to fix the GPS. And they still have to correct it like twice a day. So you can never get a cumulative effects on how far it's off to even do any math on it, because it resets twice a day. They literally, but he says in that short video that how they tried the radar bounces off the planets and none of them worked. And this ain't a guy just doing a home video, bro. This is during a conference. This dude knows his shit a lot more than I do.
No, I believe you. Just maybe there's some missing context. I don't know.
No, I don't think he's talking about from like that guy just said they map Venus like with probes and all that. I don't think he's referring to I think he's referring to like from Earth, like they tried to do the radars. And once again, he didn't mention the moon. That's a different argument, but he's just referring to the planets. He doesn't mention probes or no shit like that. To me, that's all fantasy. That's my opinion.
The process of getting the distance between the Earth and a planet using radar is called radar ranging, and it was performed in 1961 by the Jet Propulsion Laboratory. I'll have the link for you in a minute.
Well, they were bouncing signals off the moon. If you even look at the videos where they bounce signals, dude, in the Mythbusters and all that, you'll see spikes before and after the spike they claim is the right one, bro. It's like, bro, they sent they sent 400 quadrillion photons and got one back. I repeat, 400 quadrillion photons and got one back, bro. And that's even saying basically that the light is following the conservation of momentum, which in most arguments you'll have to claim that it doesn't. And no matter what way the planet's going or the solar system, the light is just going to go in a straight path because it's not going to conserve momentum. But in this one scenario where we're bouncing shit off the moon, it has to. But that's arguable. But I heard they were bouncing shit off the moon well before the reflector and all that,
Well, of course, as a ham operator, I did it in the 70s. I mean, it's easy to bounce stuff off the moon. It's much closer. Venus is a little bit of a chore, and that was done way back in 1961.
Yeah. Right, and you're gonna get stuff like what do you? Okay, so you're a ham operator. So tell me what you do. Exactly what do you do? Because I've never got a straight freaking answer about this. These are genuine questions.
You're asking how did I do the bouncing? Okay, you use either a horizontal or vertical antenna. You can get them also with both horizontal and vertical by using a cross antenna. You basically know that the moon is going to be rising at a certain time. The best time to do it is when it's above about 10 degrees above the horizon, and you aim it at a full moon. It's easier that way than to do it off of, because you can see it. You aim it at the full moon in that direction, start transmitting your signal, and you transmit the signal on one frequency using a variable frequency oscillator. You receive another signal on another frequency with a second transmitter transmitting on the other frequency. And what you do is you send both signals out at the same time, and both receivers will pick up each signal different, if they're both at the same, you measure the amount of time each receiver receives the other's.
So you need two transmitters and two receivers.
It's easier to do two. It's easier to do two, and you get much more accurate, as far as the amount of delay. But you can do it with one.
How far away is the distance between the transmitters and the receivers? Or is it the same distance?
You can have them off the same antenna. It doesn't matter.
Oh, okay. So two of the same. So you could use the same transmitter and the same receivers, but just do it twice.
You use what's called a variable frequency oscillator. It's a VFO. It's external to your ham radio.
Like a rectenna.
No, it's another transmitter. It just basically sends a second signal on a different frequency, and it receives on a different frequency. It's kind of like a second radio, but it's attached to the same radio.
Okay, and what happens? Real quick, I'm with you so far.
Well, if I transmit on one frequency, I transmit on one frequency off the main transmitter. The second transmitter also transmits at the same time because they're both keyed up to the same mic, and the receivers will pick up the signals.
Okay.
X number of seconds later, coming back from the moon.
Very good. Can you tell me roughly what signal you're sending?
It's in the 10 and 11 meter bands. So it's you could do it in either one of them. Jesus. I was doing it at 30. I think, God, this is so long ago. I'm pretty sure I was using 10 meter, which is ham radio. 11 meter is CB radio, but you can do it on either one.
That's massive, right? That's massive.
No.
Aren't them the kind that bounce off the ionosphere? Or am I wrong?
Yes, you can do that also, but that's why you aim it at more than 10 degrees off the horizon. Anything close to the horizon is going to bounce off the ionosphere.
So couldn't you be getting a good angle that's bouncing around and coming back? Like
No.
you say, it works best at 10
No,
degrees.
you're not shooting it straight up, and even if you did, to bounce off the ionosphere, you cannot hit it at a direct angle. You have to bounce off from 10 or 12 degrees off the horizon. Anything straight up will go straight through the ionosphere regardless of what frequency it is.
Okay, you say at 10 degrees it works the best. So what happens
Above 10,
when you say works the
above
best?
10 degrees. It could be directly above you and it'll work beautifully.
Okay, so you could send it straight up and it works the best also?
It works it's as good. Most people don't bother doing that with their antenna. Why spend the money for an antenna that's got an axis on it? It's easier to just have your antenna pointing a few degrees higher than what you normally do when you're transmitting for long distance transmissions.
And so you get your own signal back.
Yeah, you get your own signal back.
And can you do that? Can I aim my shit anywhere and occasionally get my own signal back even if it's not pointed at the moon?
Yeah, there's an antenna out there. I don't know if they still sell it, and I call it a moonraker. It's designed specifically for that. It's not only designed for transmitting long distances across the surface of the Earth, but you could also transmit up to the moon and back. And it's got both horizontal and vertical elements on it. And you just aim it at the moon. Set up your system with either, I don't know what they sell for digital ham radios now. All the stuff I had were running on vacuum tubes. I used a Tempo 1 with a variable frequency oscillator, and I had a second radio Yaesu that I was using. So that was, you're talking something that's 45, 50 years ago.
I don't know if y'all just heard that shuffling, dude. This cat just come out. Dude, my own cat, dude, just scared the lights out of me, man. Came out of my utility room, bro, and a bunch of shit fell. And I'm like, what in the world, dude? It felt like a freaking damn giant was coming at me, man. It's my little cat, dude. Sorry about that. But so you say we can get signals though without the moon being there, like if we angle it at certain situations.
Without the moon being there? I never said that. No, the moon has to be, visible. It has to be in the line of sight of the antenna in order to bounce off of it. You can't bounce it off the atmosphere and hope that it hits the moon on the other side of the Earth.
So there's no angles where we can angle stuff and pick up anything.
You do understand what I'm trying to tell you. I'm trying to tell you a directional antenna, one that will point your signal in a particular direction. It's best. I've always had the best luck transmitting it horizontally off the horizontal elements rather than the vertical elements. And you transmit that signal horizontally off the moon, it will bounce back about 2 seconds later, and you'll pick up the signal's echo coming back at you.
Bro, I've never heard of 10-meter waves making it through the ionosphere, and maybe I mean this is a first, and I'm not denying it. I will look into this, but I heard them are like the biggest ones, proving the ionosphere. But so if you're saying that some of them are making it through, but at a better angle to cut through the ionosphere.
The higher the antenna's angle from the horizon, the more likely you're going to go through the ionosphere easily.
The higher, so the less the
angle. By the way, when you bounce signals off the ionosphere, you're not bouncing the whole signal off the ionosphere. Most of your signal actually goes through the ionosphere and continues on out to space. Only a small portion of it bounces back to the Earth, and the guy at the other end receives that signal. That's why when you talk skipland, as they call it, you basically hear the other guy, but certainly not in the volume as if you were in the same vicinity or down the road from him, as he was 20 miles away from him. If he's transmitting to you, it's going to be much weaker because it's bouncing literally 90% of the signal is going on out to space, and only maybe 10% is coming back to Earth to be received by receivers.
Did you say the more direct, the less bounce?
The higher, the less atmosphere you go through. In other words, the higher the antenna is pointed upward, the less atmosphere it has to go through, less signals lost to bouncing. You're going to still get it to the moon, even if you shoot it at moonrise. You'll get it to the moon and probably have a difficult time hearing that signal coming back because it has to go through all that atmosphere to come back.
Wait. Why can't I?
Do you listen to anything anybody says to you? Let me ask you a question. Do you really listen?
I heard everything. I just got one final question.
You're not going to be trolling me with a bunch of questions.
I gave you the answers. Bro.
I gave you the answers. If you can't understand the simple process of sending a signal through as little amount of atmosphere as possible, is the best result, and any amount of atmosphere will still get the signal to the moon and back. The point is that the closer you are to the horizon when you send the signal out, the more that signal has to travel through atmosphere to get back to you, and it's not going to be strong enough for you to pick it up.
I'm sorry, I'm a bad student, bro. I mean, if you teach me something, just be patient with me for 1 second. I just got a couple more key questions because I misunderstood you earlier about the angles and all that. Now I understand exactly what you're saying. But then I would ask this: so the less atmosphere I cut through, the better. So if it's vertical, then that might be the best scenario, but I'd have to move my antenna and all that. I understand that. But if I was in that scenario, wouldn't I wouldn't be able to get my signal on my receiver off the ionosphere?
I'm sorry, I had to pick up my coffee. What did you say? I missed all of that.
I thought you said that we can't retrieve signals bounced off the ionosphere. You said that there has to be a moon there or something.
Okay. No, did you hear anything I said about the ionosphere? I said first.
Yeah, I did. But you said the less atmosphere, the better, right? So I did understand what you said about you don't have to move your antenna. You don't want to have to move your antenna to straight up and down just for a fucking moon bounce and shit.
Listen very carefully.
It's the least amount of atmosphere.
Hang on.
If it's the least amount of atmosphere, and it's going to bounce back. If the 10-meter waves are going to bounce back, would not be able to record that?
You can stop and listen to what I'm going to tell you now. Basically, if you're trying to bounce a signal off the moon, it doesn't matter which frequency, as long as you get through the atmosphere, you could technically bounce almost all radio signals off the moon. The point is that in that frequency range, or that 10 and 11 meter band range, if you're bouncing that off the moon, you don't want to bounce it through as much, too much atmosphere, because it weakens the signal getting to the moon and back. That's the only thing. It has nothing to do with the ionosphere. like I told you, anytime you bounce signals off the ionosphere, only 10% of those signals actually bounce off the ionosphere. The rest of them continue on out to space.
Okay, but couldn't I
Now,
receive them
not
though?
quite
Once
done
it
yet.
bounced off?
Not quite done yet. If you're bouncing stuff to the moon and back, the higher the moon is up in the sky, the better the signal return is going to be because there's less atmosphere for it to pass through to get back to you. That's the only
That's what
thing.
I just said. You're just repeating, and then you took a break right during my
Why
question.
did you ask
And
me
I'm
another
agreeing.
question?
Listen, man, just calm down a little bit, bro, and hear my question because I want to know if I'm wrong or not. But so the less atmosphere, the better. If you had the patience to move your antenna to straight up, and but what I'm asking is this: so if the better, less atmosphere, but 10% is going to bounce back, wouldn't I get a signal bounce back from the ionosphere?
No, it doesn't bounce directly back at you.
But it does off the moon.
Yeah, it comes off the moon because the moon's facing directly at you. You're bouncing it directly to the moon. It's going to come back
So
from
not
the
a
moon.
concave ionosphere that would obviously reflect back at me, but a convex moon.
If you had,
listen to what you're saying, bro.
Just a minute. Listen to me very carefully. Any signal that got bounced off of the ionosphere and for some reason came right back at you would come back at you almost instantly. You wouldn't even hear it.
Yeah.
Or the receiver would hear it. I ain't saying I
You
would
wouldn't
hear it.
You would
And it
not
bounce
hear
back
it.
and forth.
It wouldn't.
would
It
have to
wouldn't
bounce
matter.
back and forth several times, like
You're missing
like
the
the
point.
signal across the Atlantic, right?
I know what
That
you're trying to
signal
do. You're
across
trying to say that all signals that come back to you are coming back off the ionosphere. Not with a 2-second delay, they're not. They literally would have to go all the way out across the entire planet around the Earth 4 times to equal the distance to the moon? 14 times. That's a lot, isn't it?
Or just I'm just throwing out another possibility, but it seems like you're kind of denying the fact that the receiver would even pick up the ones bouncing off the ionosphere.
You wouldn't hear it. The point is you wouldn't hear it because as you're speaking the words, you're going to be hearing your voice in your own ears from your own voice being produced and coming back through the headset if there's anything coming back at all. And that signal would be so weak. The ones coming straight back, we're talking less than 1/10 of 1%, or if it is coming back at all. If you're even able to receive it, if you think your receiver is strong enough to pick that signal up, you've got one hell of a receiver,
bro. If you think your receiver is strong enough to bounce something off the moon, you're saying that it's more likely that you're bouncing something 230,000 miles away that's convex, that's literally going to scatter. Hold on. It's going to scatter everything that hits it in every direction, but it's less likely that an ionosphere that is literally concave or flat and closer at just 100 miles. You're saying it's more likely that we're going to get a signal off of the convex moon 230,000 miles away, bro. That to me is fucking ridiculous.
Oh, you can believe that it's fucking ridiculous, but let me ask you this question. How do you get a signal that's going out 2.5 seconds return trip? Where's it going?
It's fucking caught up in the ether, bro. It's just like y'all say that. Hold on.
Okay.
Y'all say that the transatlantic bounce is bouncing up and down to get across the Atlantic because it has to be line of sight. So y'all say it's bouncing up and down off the fucking off the ground and off the ionosphere. So what's the difference?
Well, let's do this. Let me ask you this. On the day that I shoot it at the moon, and I shoot to the left of the moon and to the right of the moon, I get no echo except when I'm pointing directly at the moon. You tell me why the ionosphere and the ether is not working everywhere else where I point.
Bro,
but it just happens. I'm not done yet. I'm not quite done yet. I point from the right of the moon and the left of the moon, I get no signal back, but I point directly to the moon, I get a signal back. And I know this to be a fact because I've trimmed my antenna and missed the line the antenna, kept transmitting, couldn't hear anything.
That,
the point
that would help your case if you could show me that.
Mike, you want me to go ahead and dig up my 50-year-old radio, set up an antenna just to satisfy your dumb ass? Forget it.
Dude, you ain't got to be a dick, dude. Start calling me names, bro. All I'm asking for is to see this evidence,
You're
bro. Because
insulting my intelligence when you tell me that I gave you a basic plan of what happens when you point to the moon. I told you what happens when you don't point to the moon. You get no signal. You come up with this idea that it's ether bouncing it back. If that's the case, it should happen all the time. It should happen all the time at 2.5 seconds. And what you did was you made up something that isn't true. You can't prove the ether. You can't prove that the 2-second signal you're getting back is bouncing off of anything out there other than the moon because it happens to be pointing at it.
Bro, you're the one getting worked up, calling me names personally, bro, and I'm asking questions.
Because
and
you're
listening to you get
irritating.
mad because I asked other
I'll
questions,
give
bro.
you why. You're
I
not
literally,
asking
why are you
questions.
interrupting me, dude? I just listened to you waffle
because
on
you-
and insult me, bro, and you got to interrupt right when I go to talk.
Fine. I'm
Now,
done
what
with
I'm saying
class.
is I
You can
literally
go-
get
I'll
a
dismiss my
delay.
student.
I literally get a delay watching World Cup, bro, which is only a
How-
couple thousand miles away, bro. I'm just saying.
Yeah, you know what that delay is caused by? The broadcaster puts a delay in there for it.
You believe everything they tell you, bro.
No,
so
the
why wouldn't you?
broadcaster
Why wouldn't
has
you
a
say
reason
that?
for doing that. You want to know what their reason is?
My reason is that I've asked
Ever
for
since
people to show this, and nobody ever has,
1979,
bro. Nobody's ever
I'm
shown
sorry,
me this, and I thought maybe you'd be different, bro. Nobody's ever shown me the shit they're talking.
I
They
think
said I
Ray-
could go somewhere.
hang on.
They directed me. I went to FCCJ. I went to the beach. They said there's a club, a SAT club, like a cell net or a hand SAT club. I went to the beach looking for this place. They said you could go here and they'll show it to you. They'll do it with you. I went all these places, bro, and they didn't know what the fuck I was even talking about. And so everybody
You
keeps
went-
saying
you
this
went to
shit,
a
but
ham
nobody
club?
can show me, bro.
Wait, you went to a ham radio club?
I went looking for ham radio clubs, 2 of them that were supposedly near me, and nobody even knew what the fuck I was talking about these moon bounces.
Who told you to go that way? Why didn't you just go on the internet and ask for, and look for ham clubs that do just
Bro.
that?
Y'all all claim this shit, but nobody ever fucking shows it.
I don't think you went to the right club. I think you literally did not make an effort at finding the right club. I probably could help you. I'll help you out by finding a club for you. How's that sound?
Just do it and or show me somebody actually doing this shit so I could see it.
You're a lot of ham operators. Once they've done it, they don't do it like every day. They go, "Oh, I just want to bounce signals off the moon all day." Who are they going to talk to? Themselves? Most of the time, they're interested in only talking to other people, and you want them to take time out of their
You
day.
gotta understand, I'm a skeptic, bro. It's a
No,
story to me until I
what
see
you're
it.
doing what you're doing is you're telling me first that it doesn't work. Okay, you can't transmit to the moon. Then you give me this reason of what you think is actually happening when I tell you, well, what is happening when I get this two-second delay in the signal? Oh, it's bouncing off the ether. Then why isn't it? You tell me this. Why is it only happen when I'm pointing at the moon? And you go,
don't know.
oh, I need
You
to.
asked
I
me
need
how
to.
else. You
No, wait,
put me
I'm
on the
not quite
spot,
done yet.
and I
I'm
just
putting-
threw up something, bro. I don't know.
What-
You asked me
that's
how,
my
and I just threw
point.
something out there. I don't know that
That's my
happened.
point. I've lived it.
But hold on, you're not willing to contemplate any other. You're not willing to show that you did it. You're not willing to contemplate any other possibilities, bro. And then you're calling me fucking names, dude.
No. Okay, well, I apologize for calling you names, okay? But I'm going to tell you something. You're being really stubborn about this, and you're not thinking about what I just said. What I basically said is, first, you have an opportunity to go find a ham club yourself. You could do that work on your own. Secondly, to ask me, which I'm recalling from memory from 45, 50 years ago, something I did probably only 2 times in my entire life. And both times, it worked. And the only reason why I wanted to do it is to see, because other ham operators are doing it. Let's find out whether it works or not. Sure enough, it does. Now, here's my question to you. If you're so willing to insist that there is no moon out there that you could bounce a signal off of, then you got to tell me what am I bouncing my signal off of?
That's what I don't know. Maybe it is bouncing off the moon, bro. I'm not denying it, but for somebody who's only done it twice, surely knows that 10 degrees is the best angle for where you're at.
No, anything above 10 degrees, I said. Okay, I don't remember what I shot it at. Probably was around 30 or 35 degrees because I think my antenna, but if I remember right, I was living, where was I living? I was in the Midwest, so I definitely had my antenna on the roof, not on a pole, not on a
Maybe you didn't do it, right?
tower.
Maybe you didn't do it.
Oh, no, I did
all right,
it.
Brian,
Okay, now
I wanna
you're calling me a liar.
Yeah, that's where I need to interject.
I have a question real quick. I have a quick question.
Sure.
If this is so easy, why did the astronauts have to put the reflectors on the moon?
Which reflectors? The laser reflectors?
Yeah. If you can,
That's a JPL.
what you're doing is
It's a JPL experiment. It was done specifically for the Jet Propulsion Laboratory. They were doing experiments of bouncing lasers off the moon. They needed to put an instrument package up there to reflect those lasers back. It gave them an opportunity to measure not only the distance to the moon, but also to check out things like, I think they were working on those same reflectors had. If I can't remember if they had the ability to send radio signals back also. But no, they just bounced lasers as far as I know. So I don't know all the gist. I just know it's JPL that did that experiment.
It's it also is much higher precision than you're going to get a much higher precision answer than
the radio waves, of course. Yeah, because I'm using my ear. I'm literally watching, the clock, and I'm sending out the signal, the second hand of my clock, and listening for it to come back. And there's definitely a 2-second delay.
Hey, Brian, the thing I wanted to interject was it kind of sounded to me like you didn't believe him when he said he did
I was
this.
just fucking with him at the end, bro. I hope y'all heard me at the end, bro. I'm just joking. Like maybe you didn't do it. Or I was just poking the bear a little bit, bro. I'm totally joking. If you did, if you did it, you know you did it, and you don't need me to say that you did or didn't. I'm just fucking.
I don't care whether you do or not.
But anyway, I wanted to ask you this: is there telescopes on Earth, or maybe and up above a little bit that can like if they're so precise with the math, like can they see something through that reflector? Like can they see like a planet or a faraway star through that reflector? Are there telescopes with that?
You talking about reflecting telescopes looking at the planets? What are you talking about? What do you mean?
Maybe not planet. That's a long shot, but there's so many stars. Maybe they might be able to catch a star like shining into that if they caught the right angle. If they know exactly where it is, they know exactly the angle that it's at.
What are you talking about?
He's talking about the moon. He's talking about reflectors on the moon.
Are you talking about the reflectors?
Yeah.
No.
Oh wait, okay.
It's designed. Those reflectors are aimed directly at Earth. They're not aimed anywhere else. The only thing they're going to see is Earth.
Mirror, like if we could find a big old thing of water out there, you know how gas and liquids or fluids like clump up in y'all's space to make stars and all that. So we could find like a bunch of liquid. If we find a bunch of liquid like way off in a nebula, like a million, so many light years away, and we could get a reflection back on Earth. We could see the dinosaurs, maybe, man. Maybe we could see back at Earth. We could catch a reflection
back in time. Yeah, how see the dinosaurs on Earth? How powerful of a telescope would you have to have? First, the magnification of a telescope.
Laugh at that, man.
Yeah, I'm not laughing.
Okay, I got a quick question. Is the astronomer still here?
He is. Yes, okay. I am.
I have a question. When you're observing, when you're looking at the stars and stuff, what do you use?
What do I use now? I use a 32-inch Cassegrain reflecting telescope.
Okay, and what do you actually do? You actually see something through the lens, or are you looking at a computer monitor?
Either. So we have 4 devices attached to the telescope, which we can switch between. We can use an eyepiece, which I did actually tonight. We have a digital camera or CCD camera that is primarily in the optical or what we can see range. We have a so far untested infrared camera, and then we have a video, basically a webcam that we've also stuck onto it. So,
okay, is it possible that to show an image of what you actually see when you're doing your observations? Is there? I mean, do you have like photos or something of not just something kind of like what, but is it possible to see what you actually see when you're doing these observations? Sorry.
So I'm maybe a little bit confused as to what you're wanting. So we can take digital images through that telescope. Are those images going to be the same as what you would see through the eyepiece? No, because the human eye and the CCD camera are much different detectors, and so their sensitivities are much different. And so and also the images that we take using the CCD camera are monochrome, as opposed to color images that you obviously see with your eye. So, but they're pretty much the same. I mean, they may not, the CCD images are brighter. Like I said, they're grayscale. The ones with your eye are going to be, in color, but they're going to be way fainter, or are way fainter.
Doesn't Saturn look like a light, Rob? Man, I'm just saying, like, to me, Saturn does look like a fucking light, dude. Like, the rings are the same brightness as the damn planet thing, and the way you're making it sound like you're just getting a big image of what we would see, you know, a bigger version of what we see.
Well, hold on. I
I've
want to
never
get back
said
to
that.
hold on. There's a reason I asked. But I heard a long time ago that what astronomers, what they actually see is they're just looking on a computer screen, and they're basically seeing pixels, like little square lights, like pixels, and then that's all they're basically seeing. I just wanted to know if that's true.
Strictly
Do you
speaking,
actually?
sure. Okay.
That's with Hubble, bro.
Okay, so
hold on. So strictly speaking, true in the sense that the CCD camera that I'm using is a 4K by 4K chip. So I am looking at 4,000 pixels square or 4,000 square pixels of the night sky. Can I see individual pixels? No, I can't distinguish the individual pixels that just by eye, but it's basically it's a photograph. It's a digital image. I mean, if you take a picture with your cell phone, you are technically looking at pixels of light.
right, I get that, but what I meant was, they showed a picture of and it looked like just a square, like a faded square light on
That's Hubble, bro.
a computer screen, and that was supposedly the image of a star, just a square light.
So what you may have seen is particularly with JWST coming out, they really like to demonstrate what we can do now as opposed to what you can do before. And if you look at images from the previous infrared telescope Spitzer, they are much more pixelated than the images that you're getting from JWST because the technology just is inferior for Spitzer.
Okay, are you able?
But you can,
are you able to display what you actually see? I mean, can you post like an image of what you actually see and you study?
Oh yeah, I've done a couple of live streams where I've basically operated the telescope on a stream. So yeah.
Is it
and I can do it
possible that
again.
you could send me one of those? I'd like to.
Sure, yeah.
Because I've never seen it. Okay, cool.
Yeah.
Thank you very
I've
much.
looked at I did a stream for one of the lunar eclipse. It's really not all that impressive. I did a stream for the green comet. That was really not impressive. But the ones that I do like are the ones that I looked at a couple of globular clusters, so of stars.
Well,
Those
if you
are
could, just the
like-
best ones that you think are, the best ones that you have.
I'd
you
like
don't
to
mind.
see
Well, I
one.
mean-
Here's
Yeah.
what I don't understand, Rob. How is Saturn tidally locked to Earth? Like somewhere in its span around the solar system, whether you say it doesn't turn or whatever. But how come it's always the rings pointed down, like facing us, like, and the rings are always the same luminosity as the orb? Like, I'd like to see one picture of Saturn tilted sideways or away from us. How is it tidally fucking locked? Like I'm saying, like that baffles my mind how it could always stay the same angle to Earth, dude. And with all this motion, man, that
Well,
begs the question.
I don't know who told you that the Saturn was tidally locked to the Earth, but they were either lying or incorrect. I can send you a picture where you can clearly see the tilt of Saturn's rings change over time. Galileo saw this. Well, did he get? I'll back off that statement, but I can show you images where the tilt of Saturn's rings changes over the season because basically our orbits are not coplanar. They're not exactly in the same line. So sometimes we're below the Saturn, sometimes we're above Saturn.
Can you show me
I don't
one
know
with
what
it
you mean
pointed
by
away from us? Like pointed away, it's always pointed towards. Like the bottom ring is always lower. The one close to us is always lower, and the other one is always higher. Can you show me one flipped, like where it's pointed away from us or something?
Yeah, there's a great composite image somewhere. You can probably Google it, where it shows basically the extrema of the disk tilt. So sometimes you're looking at the Saturn as if you're below it, And then if you continue to look at it over time, the disk appears to kind of flatten out, so that it's almost not even there anymore. You could barely see it. It's basically just a line. And then over time, the disk looks like you're looking above it, above the disk. So yeah.
Where do I look to find this?
I don't know. Let me see if I can find it. I'm on my phone in a Walmart parking lot, so you'll have to forgive me.
That's
for
a good
yeah,
place
you
for
gotta
an
do it. You ain't gotta
astronomer
do
to
it
be.
right now.
Saturn
No,
is
I'd rather
axial
keep the
tilt.
conversation going, Rob. To be honest, I questions and stuff, but
Yeah,
that's cool. That, if you
I
say
can.
that's happened and you, but when you glance over them videos when you get a minute, like a couple of the short ones that I sent, and maybe then you could like maybe send me when you got a minute, if you just come across it and remember it. I haven't been able to find that.
Yeah. So if you want to Google, let's see. I'm looking at a U.S. Universe Today .com article, Tilt of Saturn, and it's basically it's a composite Hubble image. Basically, it's Hubble images of Saturn over time. So it's like in this case it's 5, but I've seen where it's like 10. But you can definitely see the tilt of the rings changes over time. So you could try to Googling that, universetoday.com space tilt of Saturn.
Hey, do you believe that Saturn is made up of gas like Jupiter and Saturn? You think they're balls of gas?
Oh yeah.
That rain diamonds.
Yeah, they're
Jupiter raining diamonds. You don't think that they just had to say that to make the gas dense, to make the to jive with the orbits and shit, to have something that big, but so that's only gas to give it the gravity it needed. They say, of course, it's raining fucking diamonds, but it's all gas. I mean, you don't think that it's just like gas couldn't form like that in a vacuum?
So I don't know about raining diamonds, but Saturn does rain metallic hydrogen, which I think is pretty damn cool. But or at least that's what we believe it does. So with Jupiter and Saturn and Uranus and Neptune, they're primarily composed of hydrogen helium gas, but we do believe that there is a rocky core at the very centers of them that are roughly the size, maybe a bit bigger than the Earth, and essentially those are the core kernels that formed first, and then the gases basically got gravitationally bound or trapped by those large masses at the core and built up the planet to be bigger and bigger until you see what it is today.
One other question to try and provoke some thought, just to try and provoke a little thought from you, man. Like they say, that, I mean, Mother Nature's got a hell of a way of equaling itself out, like with pressure and temperature and all that. It's like crazy how everything equals out the way it works, perfect for life. And so they say, like buoyancy is based on little g and everything. So if gravity increases, then buoyancy also has to increase. So ain't it fair to say we would basically weigh the same amount on Jupiter if you really think about it? Or can I just ask you this? If gravity increases, buoyancy also has to increase, right? At least mathematically.
The buoyant force would increase if you increase the acceleration due to gravity. Correct. In terms of how much you would weigh, you actually would weigh a hell of a lot more on the quote unquote surface of Jupiter, the upper atmosphere, than you would weigh here. Simply
but I'd be more
because
buoyant, though. Yeah, in a vacuum. In Jupiter's atmosphere, I'd be super buoyant. I would actually float around. If diamonds are, if it takes something like that dense to rain to the ground, then I could probably just jump up 100 miles. Well, maybe not that far, but I should be able to jump up 100, 200 feet due to my buoyancy.
I don't know what the buoyant force.
Sorry, go ahead.
What? Oh no, I was going to say I don't know what the buoyant force is in comparison to gravity. So when people talk about the buoyant force as a what's the word I'm looking for? Alternative to gravity. What I think people fail to realize is that there are two things acting on an object at the same time. So right now, we are all experiencing a buoyant force due to the atmosphere that we're in. But the force of gravity, or the effect of gravity rather, is much, much larger than, and so that's why we don't float up like helium balloons. So if you were on the surface
I
of,
agree. That's why I tried to use like a big planet. But like say like a quasar or something, like supposedly 4 billion tons in a teaspoon. You think, I mean, do you kind of suspect? Does that sound suspect? Is it fair to say like that sounds, coming from a mind of somebody like myself, like you could see where that's a little bit suspect, like a teaspoon of something weighing 4 billion tons. Is it fair to be skeptical about something like that, at least in your mind?
so that actually kind of, I kind of laugh at that because I don't know if Dan is still here, but one of the first conversations I ever had with Dan was towards that end. He was irritated that he was seeing lots of different values for that 4 million tons or 15 million tons in a teaspoon of a neutron star. But skeptical? See, actually, that's a very, very good question that I've been wrangling with. In that, for me, when I hear that some kind of pun intended astronomical number, to me that it invokes wonder rather than skepticism. So it comes down to why is it that you would be skeptical of that? Why do you think that astronomers are lying to you, or somehow trying, or are wrong, or deceiving you?
I don't think that astronomers are lying, bro. As far as that goes, I think y'all are, modeling out the universe the best you can and y'all have been standing on each other's shoulders, bro. But nobody knows what the fucking star is, bro.
Can I answer the buoyancy question? Do you mind if I answer his buoyancy question real quick?
Yeah.
Buoyancy only really is a force that's upward. It's exerted in a fluid. If you're talking about Jupiter, and Jupiter's, the atmosphere of Jupiter is not a fluid; it's a gas, and it gets denser as it gets closer to the surface. The solid part of Jupiter is most likely frozen hydrogen. If you were standing anywhere within that atmosphere, the pressure alone would crush you. Not to mention if you were standing on a platform at any level, it's all gas. It's all gas. It's not a fluid. It's not a liquid. It's too cold actually to liquefy.
Thinking about this two-dimensionally, bro. Think about this. For something to rain down, that means it floats until it condenses, and once it's dense enough, it falls down. So on Jupiter, it takes the density of diamond. Okay. And then
diamond doesn't.
Hold on, and then metal hydrogen, bro, is an absurd fucking pressure density, bro. We can't even replicate that on Earth, and so anything that's not that dense is just going to float up there, bro. So if you think about it, as far as the full equation, then hold on. If something has to be as dense as a diamond to condensate and rain back down, then that means until it condenses into something as solid as fucking diamonds, it's going to float. So somebody like me is going to float. Everything about it is fucking retarded.
No, you're too dense. Literally, your body is the density of your body being liquid water mostly, which would turn to ice instantly as soon as you got to Jupiter. Even if you were in a suit, the minute you were in a suit, that's going to be dense enough to go through hydrogen at that much of a gravitational pull. It's a gas. It's not a liquid. If it were liquid hydrogen, you might briefly float in liquid hydrogen, but I doubt it because liquid hydrogen is it's not near as dense as anything of the materials that you're carrying or wearing, and that gravitational force is so strong it will pull you through that liquid hydrogen down to the solid. And
that's what they got you thinking, bro. But you didn't hear what I said.
I heard what you said.
Hold on, for it to rain diamonds means that it's whatever's up there before it's condensed into something as solid as diamonds, it's floating.
No,
and diamonds are very compressed,
carbon molecules.
Bro. So
The carbon molecules.
For it to rain diamonds, bro, then something up there, it's got to make its way up there, like coal or something like that, and then it compresses enough, or the temperature changes enough to condense it into something as solid as diamonds for it to fall back to the ground, bro. Or liquid metal or metal hydrogen, which we can't even
You're misunderstanding.
we can't even make a metal that fucking dense on Earth yet.
Okay, hydrogen is a metal. Okay, but the problem with hydrogen and the problem with carbon turning into diamonds is the carbon molecules are going to gather together because they are heavier than the hydrogen around it and the helium around it. Those are the two main, the majority of the atmosphere of Jupiter. And so any carbon that shows up there is going to be showing up, going through that atmosphere and collecting up with other carbon molecules as it goes. That pressure is so high, it's most likely turning it into diamonds. That's why it's called raining diamonds, because it's heavier and will fall. The same will happen with water. It'll crystallize and fall to this. It will not float back to the top if there's any water at all. Most of that water is not there. Same with any other nitrogen, any other anything heavier than the hydrogen atmosphere itself will eventually condense and fall to the surface of.
But at some point, bro, can't we just be reasonable and know that gas doesn't gather in a vacuum? I mean, can't we be reasonable and just go off what we know?
Right.
And we fucking know that gas doesn't conglomerate or gather in a vacuum, bro. It literally spreads. And I got one for Xanax specifically, where it's the NASA people talking about what they have to do to tires because they can't launch a regular steel belted radial because they'd burst. I got a little clip I wanted to show Xanax if he's listening or on YouTube or if he could join, where NASA themselves say that a regular steel belted radial would explode under them conditions. So it's not just a 14 psi; it's a differential. And it has to do with the size, the volume, and the pressure. So it's not just the pressure; it's the volume.
If you're gonna, you can deny gravity as the cause of why the Earth has an atmosphere. You can simply deny that. Just say, because if you're inside a container, we need a container basically for the gas to stay inside, stay attached to us. And I'm going to ask you a question then. If you're in a container then, and flat earthers believe there's a container, a dome, why isn't the gas evenly distributed throughout the container?
I showed it, bro. I did this myself. I took 70 feet and did it linear on the ground. I took 70 feet of PVC pipe and I just heated up one end. I set it in 10 foot of gutter, rainwater gutter. And then the other side, I put another 10 feet of water, but I dumped ice in one and just hot water in the other. And I was able to blow up a fucking balloon partially on the hot side. Then what I did is I squeezed the balloon where it blew up on the hot side. And it bounced the balloon 70 feet away. It was bouncing the cold side, which was completely limp. And then instantly it filled back up. And I just kept squeezing it and it bounced to the other side. And then it gradiate right back to the pressure side. So in 70 feet in containment, I was able to show a pressure gradient horizontally, bro. So that's called a demonstration. If you want to say that gravity's holding the gas down, we ask for demonstration, bro. You can't show us shit.
Okay, you didn't answer my question. First, you didn't answer my question. My question was this: you have a domed Earth, and there's atmosphere inside that Earth. Why do we have a gradient of pressure inside that dome?
Because we live in a dynamic system. He just explained this to you.
I literally demonstrated it, bro.
Except for one problem. If the wind blows at the lowest level of the atmosphere, it should blow enough of that atmosphere up to the highest possible level and cause pressure changes at the top of mountains.
Bro, I've literally showed them putting the balloons.
70 foot is not what I'm talking about. I'm talking about
I literally didn't answer it.
I'm talking about tens of thousands of feet of atmosphere. And you tell me why, when you get to the top of a mountain, the barometric pressure at the top of that mountain rarely registers more than plus or minus literally 1/4 of an inch, if anything at all. That's it. Might drop down an inch on when there's a weather system coming through, but as far as a regular windy day and so forth, you do not see that pressure change. And that should be happening all over the place on a so-called dynamic Earth. What should be happening if you have a closed container is you should have equal pressure all the way to the very top. And that, you can't explain me. How do you get your dynamic forces? Where's your dynamic forces and where's that energy coming from?
You got all different kinds of cycles happening.
Yeah, what's driving those cycles?
I can't remember the name of it, but it's a glass jar thing where you create your own environment. It creates its own atmosphere and everything. I wish I could remember what
I think it's a Leiden's jar.
but I mean, you create what Earth is inside this jar because it has its own system where a lot of different cycles happening and everything. How is this so hard for you to understand, or do you just reject it?
Wait, did you not hear what I said, bro? I'll post a video in live text if you want to see it. But I literally showed a balloon blown up, like puffed up, in 70 feet, bro, in containment. Like literally in 70 feet, laying on the ground, just heating up, just putting one side of the pipe in cold water and the other side in hot water. And I literally showed a gradient in 70 feet, bro. And you're asking how it could happen in 6 miles, like, or at the top of a mountain. And bro, what we're asking is to show us the pressure to begin with. Who cares? You can't have a pressure gradient without the pressure. You can't have the pressure without the container. I literally showed a gradient inside containment. It was very easy, bro.
Can I ask you a quick question, Brian?
Yeah. Go, you, bro.
Yeah, what was the size of the pressure difference? What was the pressure at either end?
It was I didn't have scales. I just put a balloon. I
Yeah,
capped off each. Listen, I capped off.
hold on.
Let me answer, please. I capped off each end with a balloon, and I showed the balloon puffed up on the hot side and completely limp on the other side. Then I squeezed the puffed up part and watched it bounce all the way to the cold side. I did that 3 or 4 times, and it just kept puffing up the hot side.
You realize you're using energy to create and change those pressures. I'm talking about a dome where there's no energy in it, just the atmosphere, the earth. Where's the energy coming from to make sure we don't have a pressure gradient? And the problem is we do have a pressure gradient.
What do you mean, where's the energy? The sun. What have you
really a
rejected
local
the
sun
as an energy source?
Well, where's the sun? Is it inside or outside your dome?
You're grasping at straws, bro.
No, I'm not. I'm literally trying to find out. I'm trying to find out what it is you guys think the Earth is. And
are you saying we don't get any energy here?
No, I'm saying how are you getting this wrong?
I understand you're getting energy. You can see it outside. You can see storms. You can see all sorts of wind blowing and so forth. And the sun is driving all this thing. But why, if we're in a closed container, why is there a pressure gradient? It isn't the wind that's causing it.
Dynamic. Oh my gosh, we just explained this. It's a dynamic system with a lot of different cycles, a lot of different things happening all over it.
Something has to cause the lack of molecules up high versus the massive amount of molecules close to the surface, and why there's a pressure gradient that's pretty much the same regardless of the weather. In other words, just a couple of millibars, a couple of inches of barometer period is the difference when a storm system goes through, but the actual gradient never changes. Why?
How do you have the gradient without the pressure?
He wants a story, dude.
How do you get the pressure without containment?
It's the pressure gradient that I'm talking about. Okay,
bro,
if you have a pressure, if you have a container, hold on. If you have a container, those gases are going to distribute themselves equally through the container. Am I not correct?
No, they're not.
No, I'm just posted in live text,
bro.
What is forcing them to not spread out throughout the entire?
I did it with temperature, bro.
I know why it's happening on Earth with gravity. Okay, but
okay. You're asking a flat earther. Sorry.
No.
Sorry.
I want to know why. I want to know why in a domed Earth that has no gravity. How do you get that?
You'd agree that it gets colder, right? You'd agree that the higher up, the colder it gets, right? So that's why I did it with just temperature alone. Just temperature alone, I showed a gradient once again in 70 feet. So
where did you apply your heat?
Excuse me, bro. Excuse me. So instead of seeing a demonstration, you'd rather just listen to a story that you can't demonstrate.
Well, right now I'm listening to a story because first I haven't seen your demonstration. I don't.
Live text one, bro.
The what?
I posted it in Live Text 1. It's a condensed version of a gas pressure gradient inside containment. It's very easy. Anybody can do it.
So hang on, Brian. Inside a small container with no weather or fucking dynamic system, there is a pressure gradient, right?
Yeah, literally in 70 feet, like 60, 70 feet, with just
Yeah.
a little
Who
temperature
was
difference.
saying? Who was saying? I think it was Scrapped a minute ago, saying like it's a whole dynamic system. That's why the pressure gradient exists. It's
Yeah, I
clearly
think we
not
can
what
all
exists.
agree. Yeah. We can all agree it
Yeah.
gets colder the higher we get. I mean, we've
So
showed you
Scrap.
balloons. We've showed you balloons in liquid nitrogen,
Right.
and the whole balloon deflates, right? And so we know the air, even though the whole balloon's flat.
Brad is saying the cause of the pressure gradient is this dynamic system, the weather, blah, 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 the sun, right? If we've got a container that's not exposed to weather, we still have a pressure gradient. Right? So the weather dynamic system bullshit is not the cause of the pressure gradient because we can isolate it.
I'm not saying it's the only. I never said it was the only cause.
I'm
just saying that's a contributor.
No, it doesn't contribute hardly anything at all to the pressure gradient. Literally, all the storms in the world couldn't change the pressure gradient. You couldn't have a even with the highest low pressure system. Let's say we take it down to 26 millibar, 26 inches barometer. That's a huge
Dodging
low
the
pressure
argument,
system.
bro.
No, there's a reason why I'm saying this.
Bro,
You
we're
still go,
only asking you for pressure without
still
containment,
rise.
bro.
Hold
Not
on.
gradient.
The fact that it's possible to have a pressure gradient means that you don't need a physical barrier to have gas pressure.
Correct. That's what it boils down to.
Wait, what did you just say?
I've got a question for the flat earthers.
Wait, what did he just say?
I can say it again if you like.
Yeah, would you please?
Yes,
I don't
please.
think he got it.
So I said the fact that you can have a pressure gradient in gas means that you don't need a physical barrier to have gas pressure.
That's what we're asking y'all to
And
demonstrate.
why do you say that?
The air has a gradient in it.
If you want proof of a pressure containment, just walk outside, bro. That is proof. The fact that there's pressure is proof there's containment of some kind.
Hang on.
I don't know exactly what, but that is
Hold on,
proof
hold on,
of
Brad.
containment.
How does that
The
work?
fact
What's
that
the
there's a
logic of
gradient,
that?
though, is the important bit.
Do you
can have-
realize
you
that
can
you
have
need
gas-
the
you can have
pressure
gas.
first?
You can have gas in two different places at two different pressures, right? Without a barrier between them, right? Is that true?
Well, Brian says no. I want to hear his
Not
logic.
outside of
No.
containment. No, not outside of
Why?
containment, bro.
What's your explanation
where
of
does
that,
the
Brian?
container come from, though?
Oh,
Where-
you want to
like,
have the gas if it's
so if I can
not
have one
contained.
pressure next to another pressure, why can't I have some pressure next to zero pressure?
That's what we're asking you to demonstrate, okay? We're asking
Yeah,
you
the
to
atmosphere.
demonstrate. And don't just point outside, because that's my evidence. My evidence
How
is
why is it
pointing
your
outside.
evidence?
So what I'm going to do is
no, hang on, Brian.
Hold on. What I'm going to do is use a separate container instead of using the atmosphere. Since y'all don't believe that, we certainly don't believe what you're saying. So use a separate container, and then show us pressure without containment. Show us a gradient without containment. Okay.
Yeah, the atmosphere.
Don't just no, bro. That's my evidence, bro. You're doing the same.
What?
thing.
No. What is your logic? What is your logic that says the atmosphere is contained? You're asserting it is, right?
Bro. The fact that there's
But
pressure.
the
Prove
fact
it.
that
what's
there's a
the
pressure
logic of
gradient
that?
means there doesn't need to be a container between high and low pressure.
It's a net.
No,
Yeah,
no.
exactly. Which means it's contained. I
No,
literally just
Brian.
showed
No,
you a
you're
video.
missing what I'm saying. You're missing what I'm saying.
Y'all
The
interrupt.
fact that
Y'all
there's a
y'all
gradient.
interrupt me right when I go to talk, making me get loud, making me look bad. I don't know why y'all doing that.
I want to
I
hear your
literally
logic
showed y'all
for why the
video.
atmosphere has to be
I
contained.
literally showed y'all a video of a gradient inside containment. Now, what we're
Right.
asking you to do is demonstrate y'all's horse shit. Show us pressure without containment. Don't just say look
Right.
outside,
The
bro.
atmosphere.
That's our proof.
How is it your proof? Explain your logic. How it's your
Because I
proof.
demonstrated it.
No, you demonstrated gas pressure inside a container, right? How does
No,
that
he didn't.
mean? that the
He showed you a gradient.
Yeah,
You
so
lying
that's
yeah,
fine.
inside a
sack.
container.
He
He's
demonstrated
not
what
lying,
you
man.
guys are
Just relax.
saying can't
Don't get angry.
happen.
There's no need to get angry.
He didn't
Oh,
measure
no,
the
I
he
want
didn't measure the
to say this.
gradient, did he? He didn't
You
measure
guys
it.
are turning this upside down. You're
No.
claiming we can't.
He filled a balloon.
No,
He didn't
I
measure
want to say
anything.
this. Hold on. You guys are saying that we can't have a gradient inside a container. He
No, we're not.
demonstrated
No, we're
that
not.
you
No, we're
can.
not.
Yes, you did.
He
That
No,
was
I'm
your,
not.
your beginning argument.
No one has said that.
No,
That was
Blew a balloon up from
yes,
a tube.
you did.
no,
Okay,
I
well, I
didn't.
haven't said that.
Please quote me. This is recorded. Please quote me, Scrap.
When we were talking about the container, the Earth needing to be contained, you said, "How do you have the gradient?" He just demonstrated to you how you can have a gradient
didn't,
in
though.
a
I agree.
contained area. Okay,
Yeah,
so
that's
I
now
fine.
the
agree.
That's fine.
question, our
That's fine. That's
question
not an issue.
now, our question now is, how do you have gas pressure without containment?
Right. Look outside. Why does
do
it
we
have
need
to be
containment?
contained?
Oh, that's
You just need a surface to measure gas
Rufus, it's
pressure.
not a good argument.
Why
begging
does
the
it need
question.
containment?
You can't say look outside as an argument against a container.
What about
What
a
does the
flame?
Why
container
does it
do?
need to be contained?
Yeah, you can ask
What
that.
is your logic,
You can't
Brian?
explain.
Brian,
You can't explain.
No, hold on.
Brian
Like
did
it
a balloon
needs to
test.
be.
please
That's why.
explain why it's an antecedent. You keep just saying fucking Oakley bullshit.
Because that's the
Why?
definition of gas pressure.
No,
Definitions
Brian.
definitions
Wait a
don't
second, hold
dictate
on.
reality, Brian.
I
What
get-
would happen
Gas
if
It
there
pressure
was
is
no
caused by the
barrier?
force exerted by gas molecules colliding with the surfaces of objects, not containment.
Brian, what would happen if there was no barrier?
And there was a vacuum. The way you demonstrated, the gas would fucking blast off, bro.
What's a vacuum?
Right. So it would equalize, right?
A low pressure, the way y'all say is out there, then so y'all are basically saying that it gradiates down to infinity. Is what I'm
Right. So
hearing.
you're saying if there's no
What
container.
we're saying is we have literally demonstrated the gradient inside the containment, which
Yes,
shows
completely agree.
You can definitely show gradient.
God, you asked a question, dude, and then you can't give me 20 seconds, dude. Go ahead, dude.
You're completely fine with showing your gradient inside a container. No problem with that. What would happen if there was no container to our atmosphere? You're basically saying it would equalize, right?
No.
If there was a vacuum, the way that your model is described is absurd, dude. You've got an infinite vacuum, 10 to the negative 17 torr of a differential that is so absurd that you can't demonstrate gravity doing jack shit to to a differential that vast.
You assert that a container is required. What would happen if there was no container?
Or you think gravity is making
There wouldn't be any gas.
down here at the bottom
He's asking
of
a question,
a
Brian.
sphere,
He's
bro.
asking a
It's
direct
ridiculous.
question.
Yeah. It's a question,
If
Brian.
there
What
was-
would happen if there was no container?
I
The
already
gas
answered
would
it, bro. If there
expand.
was no container, the way your model describes, with a differential that vast, then the atmosphere wouldn't stand a chance, bro. Gravity wouldn't stand a chance against differentials that vast.
But what would happen to
And
the
y'all know
atmosphere?
this.
What would
Y'all
happen?
Where would
deep
it
down,
go?
y'all know
Where,
this, bro.
What would
where
happen?
would it go? Where would it go? Where would the atmosphere go if you
It
have
would go
such?
off into your
Just
universe,
space.
bro.
Oh my
Okay, so
God.
you're
Hey,
saying it would equalize, right?
No, I didn't say it would
No.
equalize. I said it would blast off into your infinite universe. It would never, ever. It'd be being stretched to fucking oblivion, bro. How
good.
could it
I'm glad.
equalize?
I'm glad
So
you brought that up.
it would equalize it amongst the entire volume of whatever, right?
Right.
How
Or
could
it would reach
equalize,
some
bro, when
equal.
it's getting
Well,
stretched out
you're
to
saying it's going to
infinity?
move. You're saying it's going to move. Is it going to reach some equilibrium point?
It's not going to change your universe of 10 to the negative 17. It's not going to affect that because you're talking about differentials, bro. When we're talking
Yeah.
about gas pressure, we're talking about volume, and pressure and volume and differentials. Okay, I
Okay.
think y'all
I
know this.
understand.
You know
No,
this
you're
deep
not.
down, bro. That the little force, non-force of gravity could never puddle fucking gas down at the surface, bro, with a differential that fucking vast.
But it does it
It's
to
ridiculous.
water.
Jesus.
Does it
Hey,
to
Brian,
water.
let me ask you this. Okay, you're flying in an aircraft that's at 100,000 feet. The air pressure out there, outside your airplane, is down to the point where you have very little atmosphere at all. What's happening to the air outside, right outside your plane as you travel through it? Is it leaving and going even further out into that vacuum that's maybe at 110,000 feet?
No.
Or,
Yes.
or is it just staying put?
It's the
It's
same
stable.
thing as a balloon. Hold on, Riff, please, y'all. Give me a second. And that was an interesting question. Okay. Now, I refer you to my demonstration, but let me go a step further than that. Okay. Here, even at the ground, we could take a full inflated balloon, put it in liquid nitrogen, and it completely deflates.
That's not what I asked.
And then, hold on. I knew y'all were gonna fucking. So when we pull it out of the liquid nitrogen, the same amount of air is in there with zero pressure, but it's the same amount of air, right? So why? So are you telling me that when I cool it down and it completely deflates, and then it warms back up and re-inflates, are you telling me when it's flat and zero pressure that there's no air in there, or is it just fucking? Is it just reacting to the temperatures?
Not what I asked. I asked you, as you're traveling through those air molecules at that altitude, there's a certain number of air molecules per square inch as you're traveling through it. Are those molecules headed upward where there's even less air molecules, like at 110,000 feet? Or are they just staying there at 100,000 feet?
No,
Or are they, because air, hold on, air or gas naturally in a container will try to distribute itself through all parts of the container. So
I just gave you an extreme example on the ground of how it doesn't do that. Due to temperature alone.
While
And you're interrupted right when I go to respond. You're instantly interrupted again, bro.
I'm trying to tell you that
I'm telling you that if you stop interrupting, I'll answer, bro. Yeah, I'm telling you that there's got to be
Hold on,
a
Brian.
cutoff.
Hold on, Brian. Thing is, your mic is popping, it's cracking and popping, and it's super loud again. So I don't know if you could try to fix that. But the louder you get, the more aggressive you're getting, the worse it's getting on our
Yeah,
ears.
but if you stop them from interrupting me, Gio, every time I go to talk, they ask me a question and they're puking on me, bro, making me get loud. I even asked.
That's what you do.
Brian, do me a favor. Listen to me for just a second. It's about your experiment I want to talk about, okay? I understand that you did this experiment on the ground. I haven't finished watching your video, but I have a pretty good understand where you're going with this. And you're applying an external force of energy in order to do this experiment. I'm talking about up at 100,000 feet, where there's no real external force of energy, and this could be nighttime or daytime. I just want you to tell me what's happening with the air molecules up there. Why are they staying at a gradient at that altitude so high? And eventually you go high enough, you run out of air molecules to the point where
you know? Okay.
it's
all right. Well, let's
because
let him respond.
hold on. Enough pilots have literally gone to that altitude. I want you to tell me where those molecules are going and why they're staying put.
Okay, so I'm gonna tell you that there's got to be a container, and before you start jumping all over me, because if there was a vacuum that kept getting stronger and stronger, where that little that 0.5% is a massive vacuum in comparison, and I literally showed you a difference on the ground. So I'm saying that there has to be containment up there, or it would gradiate to infinity, and that's not what we witnessed. But we can only really see what happens at 100,000 feet. But here's my point. My point is if I had you inside of that balloon at ground level, not even 100,000 feet, so I'm going extreme here. If I put you inside of that balloon, I had a giant balloon that I put in a big pool of liquid nitrogen, and it's completely flat, so there's no air, zero pressure, zero, like there is on the cold side of my PVC pipe. Zero pressure, you wouldn't be able to breathe, and you'd measure zero pressure, but there's still air in there, right?
Sorry, you said it doesn't gradiate to infinity. That's exactly what it does.
You think that the atmosphere gradiates into infinity?
Well, to infinitely small, obviously, infinitesimally small.
That's a bad argument, Riff. But so answer my question. I answered yours.
That's literally what happened.
In that balloon, that zero pressure that we're measuring, because it's not blowing the balloon up at all, the differential is zero, so we can't breathe. But there's still air in there, right? Even though it's zero pressure.
I tagged you in an image a couple of minutes ago, Brian. 14 minutes past.
Brian, you talked about the powerful vacuum out in space. What do you think that vacuum is?
Can I ask the flat earthers a question?
It's supposed to be a differential, bro, like a vast universe size differential.
It just means the lack of. A vacuum is nothing more than that. And when things try to fill into a vacuum, in other words, if you have a vacuum chamber and you release a balloon in there, it's all the gases in the balloon are going to leave the balloon and spread out evenly within the chamber, increasing the amount of air pressure in the chamber. It's no longer a true vacuum. But when you're dealing with the surface of the Earth and you have this gradient of atmosphere going up with no container, something is holding it down on the Earth. Our explanation for it is very simple. It's just gravity. It's the gases have a mass. They're attracted to the mass of the Earth, and they stay on the Earth,
Show me
and they don't
gravity in it.
leave.
Yeah, but you
The
can't show me
vacuum
gravity
of
in any
space-
gas law, bro.
Just a minute. The vacuum of space doesn't suck air off of the Earth. Okay. If the Earth suddenly lost its gravitational field, all of the gases would leave. Most of the things that are not tied down would leave and go out into space just because there's nothing holding them down.
Okay, you can't demonstrate this, bro. You can't demonstrate what it's. I can't even
What do you
believe
mean
you're
I-
just saying.
what
Hold
do
on,
you
let me
mean I can't
finish, bro.
demonstrate?
Fuck, dude. Let me respond. You just monologued. Okay, now you're making me forget what I'm even trying to fucking say.
You must
just
have a
start
tough time in school.
repeating
Dude, you
bullshit.
got
bro.
you gotta go one at a time. I mean, it's fair to let him respond, right? Without constant.
Of course, go ahead.
When someone nips at you when you're talking, it is very hard to keep a train of thought. You know, like the minute you respond, they're going rah rah and they're clipping and jumping. It's very difficult to get a thought out, and it can be frustrating. So yeah, just let him respond uninterrupted, please.
Appreciate that. But real quick, I'll make this quick. Is everybody keeps saying it's just 14.7 pounds difference. Well, I've got a NASA video I just clipped out where they are making they've got some real new. It's called Night and All, where they're making their rover tires, and I don't believe all the other shit. But what they do make perfectly clear is that they can't use steel belted radials because they will explode on the moon conditions as well as on Mars. The pressure differentials, they would explode. So you're not going to tell me that a steel belted radial and 14.7 pounds ain't going to do shit to affect one of them. So that right there, I rest my case with a cherry on top.
You can demonstrate 14 pounds per square inch as being very powerful. Just take the air out of a Coke can. Watch what happens to it. It's gonna completely crush it. Period. But that's because it's 14 pounds per square inch, and when you're dealing with external pushing out, on a rubber tire to a vacuum, yeah, the tire's going to explode. So what do they make the tires out of? Steel, just bound steel, like they did on the lunar rovers. And they literally would be able to travel across the surface and no problem at all. You don't have to fill them up with air. They're going to wear out over time. You have to replace them, but that's the way it is with all tires. The only difference is you don't use gas.
Okay, well, at least you agree to that. So, but somebody like Zanuck would say that it's just a 14.7 pound difference, or 14.6999. So he would say that any decent tire could easily hold, three times the amount until it explodes. And so at least you don't agree with that horse shit.
Well,
Because,
first,
like
they
I said,
don't-
I got
they
NASA
don't
himself
inflate-
saying that the differential would explode the tires.
They
or
don't
whatever.
inflate 14.7 pounds. You don't inflate a tire to that.
You do like 38, don't you?
Yeah,
36,
it's going to be some of them are 70 pounds, and
No.
the reason is because you want the tire firm against the atmosphere that's pushing in on it. Otherwise,
No.
if it's 14 pounds on both sides, the weight of the car will cause the tire to go flat.
You missed my point, bro. The differential. Okay, he says that that it's all about just differential, and he don't think the volume of the differential has anything to do with it, and it's in all the gas laws. The volume absolutely has everything to do with the differential. So when you're talking about a volume that's infinite, and I mean I don't know how they can even measure that, but a 14.7 pound differential is not near enough to explode a steel belted radial, although they said that the steel belted radials would not even withstand a Mars, or might not withstand the Mars, but certainly wouldn't withstand a moon atmosphere.
Can you have a look at the image I posted to you, Brian?
Can I put my question in?
Did you
now?
post it in live text?
Yeah, 14 minutes past.
Are you ready to listen to my question, Brian?
Yeah, man.
Oh, Scrat's gone, so it's just to you now, Brian. In your flat Earth with a container, and it's a dynamic system inside, how does that dynamic system make the atmosphere gradient? What's the mechanics? Do you have any idea? If you don't know, it's fine.
Gas law, bro, is temperature. Okay, PV equals nRT. Okay, what that's telling you is that the pressure, according to the volume, is in direct relationship to the differential, and it's basically pressure volume is temperature volume related. It's differential. That's just ideal gas law. There's no gravity in any gas law. Charles law, Boyle's law, ideal gas law, and any of the gas laws. There's no G It's just temperature. It's just
Okay, so
volume,
am I right?
pressure, and temperature, bud.
Am I right in thinking you think the sun is making a pressure gradient inside the dome?
No, I think the temperature is making the
You
pressure
think
gradient.
temperature comes from the sun, right? We agree on that.
No, temperature also comes from the ground. Why don't it get hotter when we get close to the sun? It's colder, right?
Do you think it gets colder as we go up towards the sun for some reason?
I don't know, bro. In your model, when we get closer to the core, it gets colder. Like in the ocean, where we should be getting closer to the hot shit down there, but yet it's getting colder. We get closer to the sun, it should be getting hotter, yet it's getting colder. Everything's backwards in your model, bro.
Am I right that you don't really know the mechanics of how there's a pressure gradient under the dome?
All I know is the gas law and the temperature
All right, yeah.
and the
That
pressure
works
and
on
the
a boat
volume.
too, you know?
No, it
What
don't.
what does the R stand for in your gas law? That's what I thought.
Don't you think, Brian, that if
No,
gravity
what's the
was,
R stand for, Don?
if gravity was real, it
Ideal
would
gas
make
constant.
more sense.
That was
It would
directed
make
at
more
you.
sense than temperature, right? Because it just pulls it right to the ground. There's no, oh, it could be hot over there, it could be cold over here. It's just hot at the ground and then cold up in the sky. Except we don't use hot and cold because gravity. It's just more air near the floor, less air near the sky. It makes more sense than nuanced temperature all over the dome. And that's why we believe gravity over your made up thing, because it makes more sense.
So what's the R,
Yeah,
buddy?
but if
What's
you
the
wanna
R? What's
call
the R?
gravity-
Sorry, I'm waiting on him to answer. What's the R, Don? And PV
It was
equals
it was
NRT.
actually directed to you. That question was directed to you.
To me, I'm the one who
Yeah,
brought it
no,
up, dude.
Right. I'm
It's the-
asking. I asked you what it is.
It's the fucking constant, dude. It's the arbitrary fucking
What is
number.
what is the universal gas constant?
It's the idea. It's the constant, the gas constant in ideal gas law. It's
Yeah, how'd
arbitrary.
they
It's
come up with that?
arbitrary. Okay, I'm trying to explain, and you're puking on me again, bro.
You're
You
using
can't help
an
it.
arbitrary formula, did you just say?
Yeah, it's an arbitrary number. It's a
great.
gas
I
constant.
won't be
Any
using that
constant
then.
is arbitrary.
I
in my
won't be
opinion.
using that then.
But is pi arbitrary?
That's a mathematical constant, bro.
Oh, we sure.
I mean, it's not arbitrary, but it kind of. I mean, depending on what you say, numbers. 3.14. There's other number systems we could use to.
Anyway,
to
can
have
you
pi
check
in.
my image at 14 minutes past?
Yeah, I was
Pretty
trying to
close.
look at it, dude. He started asking me questions, but I'll go back and look at it.
The gas laws are based on gravity, based on relativity, Brian. You can't get away from that.
No, they're not, Don. None of them are based on gravity.
Seems they
That's
are,
ridiculous.
as we've just discussed.
Show me one, please, that has.
You use
G in it.
one. You're the one using it.
Oh my God! Correct it, Riff. Help me with this one, bro. Please, your own.
What? I don't want to turn down, so I don't know what he was saying.
He says that gravity is in all the gas laws. Will you please correct him on that?
Yeah, it's not in all the gas laws. PV equals nRT is 1. There you go. Done. Not in all the gas laws.
Do you know why in that particular gas law that gravity is not in there?
Who's that to?
Because that gas law can apply in any particular situation, whether you're in a container that's in a gravitational field or without one.
Oh, great. It doesn't rely on gravity. Is it relativity? Yeah.
Yeah.
Okay. That's based on some understanding of gravity, right? Just a little bit.
Rui, if you didn't have to go up
How do they measure
100,000 feet to show me that 0.15, I could show you that on the ground once again, just using gas law and using cold temperatures. I could show you that on the
But
ground,
I'm not
but it's
talking
still got to
about
be
that.
in containment, right? I can't
No.
show
Well,
you
no,
it without
that's the
containment, can I?
question.
Your
That's the
your
question.
your
There's
PV
no
equals
barrier.
nRT has nothing to do with the gradient that we observe in the atmosphere, or for that matter, in your experiment.
Well, y'all
Brian,
choose to
that's the
believe a
question.
story, bro, and you at least admit that.
It's not
Listen,
a story.
gas.
It's your experiment I'm talking about. Where's PV equals nRT come into your experiment?
So if we start evacuating Sandusky, Ohio, then in the gas at the bottom, it's going to pull at the bottom, right, because of gravity, and that'll be the last little bit of air we get out. Because so in other words, we could take an alarm bell and put one at the top of the Sandusky chamber and at the bottom, and the one at the top will hear that. It'll go deaf first and we'll still hear the one at the bottom because there's still enough gas for us to hear it because gas is pulling at the bottom due to gravity. Where gravity is the strongest. And bro, you can't demonstrate that. It's a story y'all believe, and I can't believe y'all won't at least come to terms with it's an idea you believe, and you can't demonstrate it because you can't.
Can you answer the question on the actual slide? Like, there is no barrier between 30 inches of mercury and 0.15 inches of mercury.
I did
So
better,
where
Ruif.
is this barrier required? At what,
I did it.
At what pressure?
I did it in 70 feet, Ruif, with temperature.
I understand your experiment.
Would you rather
that you have
my
a gradient inside a container. That's not the question that I'm asking you.
Well,
right?
you sound like you'd rather me tell you a story. I figured
now you're talking
demonstration
over
would be
him
better
and
than that.
complaining.
Where is
Do you
this
want a-
barrier required?
Do you want a story,
pressure?
or do you? I don't know.
At what pressure differential is this barrier required, given that there is not a barrier between 30 inches and 0.15 inches? Are you
Well,
saying
I
there
could
has
say-
to be a barrier between 0.15 and 0?
I could say this, bro. Instead of giving you a story or running my mouth, I'll show you zero pressure on the left side where I've got it in ice water. There's no pressure at all blowing up on that balloon. It's completely
That's
limp.
not an answer to the question.
On the
Robert.
hot side, it's puffing the balloon up, bro. So that is in 70 feet. So instead of just giving you a story, I could just point you to gas law and literally show it to you in containment. There's no barrier between the pipe, is there?
That doesn't address my question at all. I'm asking where this barrier is required, given that there is no barrier between 30 inches and 0.15 inches. Are you saying it has to be between 0.15 and 0?
No barrier required. Once again, I
there
can
you
show
go.
you this inside containment. There's no barrier required. I can show you this on the ground.
So we can
with
have
a
gas pressure
differential
without a container.
inside containment. Now, what we're asking you is show us this pressure without containment.
You just
We've showed
agreed
you
that we
the
don't
atmosphere
require a
has to be
container.
contained.
You just said you don't require a container. Done.
No, I just said I demonstrated it inside containment.
Right.
It doesn't.
I
It doesn't.
agree.
So I can show a gradient inside containment.
Is the
Now, what I'm asking
container
you-
required?
Container required, right? Have pressure. Period.
Is the
Much less a
container
gradient.
required? Why? And where does that container? Well, like I said, there's no barrier between 30 inches and 0.15 inches. Are you saying that there must be a barrier between 0.15 and 0?
Bro,
You
you're
have to
being
be saying that.
okay. Please don't interrupt. Once again, let me just finish and I'll make it quick. Okay, no, I'm not saying there's a barrier, and I've went one step beyond and showed you a gradient like you're describing.
Jesus Christ, Brian.
Here, you can't help it, can you? I've literally demonstrated the gradient here on the ground without a divider, or I've demonstrated all that inside containment with no divider. Okay, I've literally showed you that inside of containment. So
Brian,
I'm saying
did you
there's
hear-
no container necessary inside the containment. What we're asking you is to show us this pressure gradient, or show us pressure period without containment. It's necessary to exceed it.
Yeah, no, that's your claim, Brian. That's your
Trying to
claim that it
now.
needs a container. That is not my claim. You have to back up your claim that it requires one. So I'm asking you, where is that barrier required, given that there is no barrier between 30 inches and 0.15 inches?
I'm not
Are
only
you
denying
claiming?
it, Ruhiv, I'm proving that you don't need one on the ground.
Excellent.
Okay,
We agree. We
once
don't
again,
need a
once again,
container.
Once again, bro, inside of containment, I'm proving we don't need a barrier I can easily demonstrate what you're asking for, and you're trying to turn it around on me, bro, which to me is a bad tactic, bro. So you're asking me do I need containment between the differentials from the ground to whatever height? And I'm telling you that no, I can not only that, I can show you this gradient in 70 fucking feet inside
Look, Brian,
containment.
5 times I've said I'm completely fine with you demonstrating a gradient inside a container. I'm asking you, can we have a gradient without a container?
No.
Okay, so then my question is,
you can't have
right,
any
so
pressure. Much
that's
less
your
a gradient.
claim. That's your claim, right? But my question then is, given that there is no barrier between 30 inches and 0.15 inches, are you claiming that there must be a barrier between 0.15 and 0?
Not only am I not claiming it, I'm demonstrating
Hey.
the necessity that hold on. And it's not me making the claim, it's every gas law known to fucking man making that claim.
So
not me.
you're saying that not required, container not required.
I'm saying not only is it not required, I can demonstrate it inside containment.
I don't fuck, Brian. I understand that you've demonstrated a gradient inside a container. I understand. Please stop bringing it up.
Well, quit asking me if I think that there needs to be containment in between the two fucking pressures.
Okay, so we don't need containment then to have a gradient. You agree?
No, you need containment to have the pressure in the first place.
Why? That's your assertion. Why?
No, that's gas law, bro. Quit putting that
It's
on
not
me.
gas law.
It's not gas law.
It's not gas law. So now it's not gas law. Okay, go back and look
Give a
at gas
citation,
law,
bro.
Charles law, ideal gas law, Boyle's law, any gas law. That's fucking not me. This is law, natural law.
Just the direct
gas law. I want to say
citation.
What about? I don't want to get back to that.
Point is, the gradient excuse is more proof for containment, and I've demonstrated that.
All right. Did we all go quiet? What happened?
But Brian, just because things can have containers here on Earth, how can you then extrapolate that that's what the sky is?
I can't, but if I'm debating and they're telling me that a gradient, when I'm asking for, that's a fair question, but when I'm asking for example of gas pressure without containment, a gradient is just helping my side of the argument. That's my whole point.
Brian,
There's something going on, but to me, there's got to be some type of containment, even if it is temperature alone, but there's still got to be some barrier because I don't believe that the atmosphere gradiates off into infinity. That's what Ruth just said. He said the atmosphere gradiates off into infinity. I think that's ridiculous, in my opinion.
Okay. So you must be asserting that there is a barrier between 0.15 inches of mercury and 0. You have to be. If you're not, then we don't need then we don't need a container. We don't need a container. Done.
For a gradient? No, we don't. But for pressure itself, we do.
Why?
What's the difference?
You've just made an assertion. Why gas pressure requires a container?
Bro, you're not coming at this to me, man. You're coming sideways here because the definition of gas pressure is
definitions don't dictate reality, Brian. Definitions don't dictate reality.
Bro, to me, there's a cutoff and some type of containment, bro. There's not an infinite vacuum. That's just the way my mind thinks. And I can demonstrate my shit. You can't. It's that simple.
We talk about
point outside. That's the gradient.
Brian,
What reason is there to require a container? Reason, not just an assertion or a definition. What reason?
Because you can't have pressure. It'll fucking.
I literally
off.
just said not an. Okay, that's better. It will escape. Right? Does our atmosphere escape, or is it in equilibrium?
Ruhif, if you think it's a gradient to go into infinity, how much pressure would there really be on a little teeny speck Earth if it gradiated from -17 torr down to 14 psi? If it was legitimately a gradient, then it'd be a millispeck of fucking pressure here at Earth. What's gravity going to do to control the gas?
Does our atmosphere escape, or is it in equilibrium?
No, you just said it's a gradient. You just said it's a gradient into infinity.
Yep.
So
No.
why isn't it an even gradient then, Ruhib?
Right.
If you
Does our
can't
atmosphere
demonstrate gravity
escape?
doing nothing to gas.
Does our atmosphere escape, or is it in equilibrium? Was the question.
Dynamic, bro. It's never in equilibrium, ever.
Yet we can set our
yes, it
altimeters
is.
off it, Brian.
No, it's not.
Jesus.
Okay, your argument
Even
about
at night,
dynamics.
even at night, fucking ceiling drops, bro.
I already demonstrated your dynamics is totally a false argument because
Bro,
anytime you
y'all
have
are arguing against nothing,
Let-
bro. I
okay,
mean, y'all have nothing.
if you want, if you don't want people to talk over you, don't be
Sorry, dude.
sitting there
Sorry,
doing
I-
it to us. Thank you.
You're
Like I
quiet.
said, I already demonstrated that if you have a dynamo or any kind of dynamic changes within an atmosphere, okay, that still doesn't affect its gradient pressure. It literally has little or no effect to its gradient pressure. And that I demonstrated because you could do that with a barometer during a hurricane and see that there's very little effect. So now
please
you
answer
explain
this
to me
simple
how
question.
okay, let me finish what I was saying. As you have the pressure going up in the atmosphere, this not being affected by your dynamo, you're going to get to eventually no parts per billion or 1 part per billion atmosphere, molecules of whatever the atmosphere is made out of, which is technically a vacuum.
So
The
here's what
vacuum
Ruhib
of
is saying.
space is not perfect. It's not a perfect vacuum, but it has so many scattered molecules so far apart that it's not measurable. There's no way to measure the pressure, so it's considered zero. What's
So
your
it'll
question?
explode a tire according to NASA, but it won't fucking suck off in the atmosphere. So here's Ruhib's.
It won't explode.
What does that have? Yeah.
Stop, dude. So Ruhib's claim is this. Ruhib says that it's a gradient off to infinity, but now he says that okay, well it's a slow gradient at first, but then it once it hits a certain height, then it starts slowing down off into fucking infinity. That is ridiculous, dude. Now my point is, so answer this one question. Answer this one question. If here on the surface of Earth, where gravity's at its strongest, and all this other, if I put a balloon in liquid nitrogen and it goes completely flat, where there's zero differential, and if I put you inside of that, a giant balloon in that cold of weather, and it completely deflated, where there was zero pressure, could you breathe? Is there air still in there, even though you couldn't breathe, and it's completely flat with zero pressure?
How did you put the balloon in the liquid nitrogen? You just put an inflated balloon inside liquid nitrogen.
And it goes completely flat. And
So
when
it
you pull it
cooled-
out,
it cooled the
when you
air.
pull it out, it takes about 4 or 5 seconds and it reinflates. So the
Right,
air's still
right.
in there, though, right? So even
Yeah.
though it's completely flat, the air is still in there, though. That's my
Okay,
question, right?
You know what pressure is, right? It's what actual pressure is.
I'm asking you a question, man, and I expect
Molecules
somebody
are
to give me an
farther
honest answer.
apart. Molecules are farther apart in the balloon at room temperature. When you lower that temperature down to the temperature of liquid nitrogen, the molecules are much closer together.
Very good. So that follows gas law.
No, that's just decreasing the pressure within the balloon. It has
Don't
nothing
say
to do.
no, bro. That does follow gas law. And
So
so
what?
my question
It
is,
has
so you're
nothing to
agreeing that
do-
there is still air in there, even though there's zero differential. There is still air in there, correct?
What does that have to do with the gradient we observe in the atmosphere?
Trying to teach you gas law. Y'all don't
Yeah.
seem to
I
understand.
know. I already know what the gas law is. That has
No,
nothing
you
to do
don't.
with it. We're gonna try this again. Okay. It has nothing to do with the gradient that we observe in the atmosphere. You can go ahead and use the gas constant and try to figure out how far the molecules are apart, and but you cannot explain why they're getting farther apart the higher you go up in altitude, and closer together the closer you are to the surface of the planet.
Why won't
And
you
they're-
answer my question, bro? I'm only asking you a simple question. Even though the balloon is completely deflated and there's zero differential, there's still air in there, correct?
There are molecules of air that are very close together, yes.
Okay, so there is your explanation for your differential inside containment, and once again, easily demonstrated
No, that
according
is
to
not.
gas law.
That is not, because you applied an external force to cause the molecules to come together. What's the external force that's causing the pressure changes in the atmosphere that you observe right now?
It's not gravity, okay?
I
Show me gravity doing
understand.
anything.
I understand you don't think it's gravity.
So what's your
Okay,
answer then?
But you're not answering my question. That is
bro,
my
you
answer.
are literally arguing against gas law, bro. And,
No,
and
I'm
nobody's
not
backing me
arguing
up
against
here.
the
This is
gas law.
fucking ridiculous, dude. You are literally
Okay,
arguing
you are
against
not answering my
gas law.
question. You again have you have sidestepped my question by
Bro,
jumping
you're
back to
living
your
in a
answer.
fucking fantasy and you're arguing against gas law, making it
Should
out
we
like you're
try
arguing
this?
against me, bro.
Shall we
You
try
haven't
this
answered my
again?
question, bro.
Okay. Wait a minute. I thought I was the one asking the question. Do you understand?
Bro, just go look
I
up
answered your
gas law.
question. I answered your question. I said I agree with you that there is that the
You're not
balloon
agreeing with
has
me.
gas.
You're agreeing with gas law.
Big deal. What does that have to do with the atmosphere? Which is
All
now
of
my
a sudden,
question
you
to
want to
you.
just drop gas law
Just a
and
minute.
act like you live in a fantasy world where there's a gradient off to infinity.
Okay, Brian, you're interrupting me again. I'm going to ask you one last time not to interrupt me while I ask
You
my
just
question.
asked a fucking question, dipshit.
No, you need to listen to me very carefully. I've asked this question about 6 times now, and you've not even come close to answering it because I think you want to avoid answering it. Now, here's the question very simply. What does your gas law have to do with demonstrating what's happening in our atmosphere? Don't go to your experiment. You explain to me what's causing the pressure gradient from ground all the way out to near vacuum in the atmosphere. You can do that as you go up a mountain and so forth. You can see it decreasing in pressure. What's causing that pressure gradient, and how does your
gas law? You ask a
temperature?
question and you start
Hold on.
You ask a question and you start blunt.
How does your gas law do that? Where is
It's
it?
not my gas law, bro. It's
Temperature.
temperature. It's a dynamic system. It's in gas law. You can figure it out by using ideal gas law, bro. You're saying how is my gas law? It's not my gas law, bro. You're not
What
arguing
does
with me.
temperature do?
You're literally arguing against gas law.
What does temperature do to your gas gradient? What
It
does it
lowers
do to your
the
pressure
fucking pressure. PV equals NRT, bud.
Yeah.
Get
Okay.
it?
Go ahead. It's lowering the pressure. How?
Does it matter? I'm
pressure
not
and
teaching you all of gas law, bro. You need to go learn this shit.
If that's the case, why is it when you go up in altitude and it gets colder, why aren't we finding more molecules of gas compressed
Oh,
together?
really?
Closer
Oh,
together?
so now you're starting to get it.
No,
right?
Your
So
temperature.
no. So now you're getting it. So you're saying that in containment, if the temperature's colder, then there's going to be less pressure, right?
No,
according
that's
to
wrong.
gas law.
According to gas law, if the temperature's colder, you can actually have higher pressure. And the way you have higher pressure, go down to the surface, cool all the gases down. They're all going to come down to the surface, closer, and pressure will increase.
Right. Now show me a gas law without volume.
Your balloon had just the opposite happening, didn't it?
It's exactly calculable according to gas law. That's my whole point in bringing it up. Now, hold on, man. Every gas law has volume in it. You can't invoke infinity. Y'all don't know what you're talking about, bro. You are arguing against fucking your own model.
You're actually demonstrating less pressure when you deflate that balloon, and I'll tell you, or more pressure when you deflate that balloon with liquid nitrogen than you are less pressure, because you're saying as the balloon reinflates, there's more pressure. Okay, on the surface of the balloon itself, yeah, there's more pressure because the molecules are pushing outward because they're spreading apart. But as you cool those gases down, the surface inside that balloon where those gas molecules are crammed together, that's much higher pressure.
So no G, right? No G, right?
Excuse me, G, what do you think? Why is it laying on the ground?
Y'all keep talking about gravity, so no G.
Where are all those molecules?
You just described it
Are
perfectly,
they evenly
bro,
distributed
with the
in
pressure
that
and the
balloon?
volume and the temperature. So no G, right?
This is
Can you
getting
answer
so
my one
boring,
question?
guys.
Okay, you're not listening to what I'm saying at all. So
it's a simple question, bro.
Brian,
you just explained,
you're
no
simple.
G, right?
Brian, you're hanging on to an experiment that doesn't prove anything as far as the gradient.
So
within
now
the
who
atmosphere.
can't answer a simple question, bro?
I already
no G,
answered
right?
it. Yes, it's G. Is your balloon floating in the air?
Show me the G, please.
When you dipped it into the liquid nitrogen, did it float up? No. Did it stay inflated? No. It all went where? As the molecules came close together, they became more dense. The density, basically, the weight of those molecules rested on the bottom of the balloon. the pressure of those molecules together, if you were within amongst those molecules, would be very high for the location there.
You're not honest, bro. You're not
I'm being
honest. You're
very honest.
monologuing, bro. And you just said that G is in
You
gas
don't
law.
need to
So
answer.
now
That's
I
not
ask
my
you
problem.
to
That's you problem, not me.
You're interrupting me when I go to respond. Every time I go to fucking respond, you start puking on me, bro.
And you didn't puke on me at all tonight, did you?
Oh, I apologize when I did, dude. Now, what I'm
No.
asking you,
How many
you just
times did you
said
do that?
You just said that there is G in gas law, which means you don't
No.
understand gas law.
In the
So
gas
now,
law formula,
can you please
no.
show?
G
Shut
is not.
up, dude. Can you
Jesus
please show me
fucking Christ.
G
What
in
does
gas
G?
law?
What does G have to do with the gas law? Period. Number one, and that balloon.
You
Nothing.
just said it's
What
staying
does
down
it-
at the
hold
ground.
on.
Okay, so I'm asking you. So I'll ask the first question: is G in any gas law?
Actually, it is in that balloon. Now that I think about it, where are all those molecules once you've cooled them down? Where are they? Are they evenly distributed within the balloon, or has it gotten so cold that they're all forming at the bottom of the balloon?
So is that your answer? Yes, G
My
is in gas
question
law.
to you is to answer that. Are they at the bottom of that balloon? Yes or no?
No.
Oh, really? So you're going to find some of those cold molecules at the top of the balloon, equally distributed within that balloon that's completely collapsed. It's completely collapsed now because all those molecules are pushed together because of the temperature being so cold.
This dude's a troll, dude. Gio, this dude's a fucking troll, dude. He's asking
You
me,
don't
pinning
like
me
my
down.
answer.
I'm
You're
answering
both trolls.
it specifically.
You're both
He's
trolls ruining
monologuing, dude. He's
everything.
interrupting me every time I respond, and then he's not answering a simple question. And then he
didn't
won't
answer your
demonstrate.
question.
I'm asking you to show us, teach us something, bro. Teach us show us the
Ryan.
gas law with G in it, please.
Brian, I didn't demonstrate the gas law with G, and I just demonstrate how gravity is affecting the gas molecules within your balloon. They're causing all those cold molecules of gas, to be down at the bottom of the balloon. They're not evenly distributed in the balloon anymore because you made it too cold for them to be able to do that.
How do you know that when you can't even measure it? There's zero differential. It's flat.
You're the one who did the experiment and showed me that the balloon is flat. And
I
on the
didn't do
ground,
that
it's
experiment.
not in
Anybody
the
could do this
air.
experiment. It's to demonstrate PV equals nRT, bro. Not no PV plus G.
Nobody's
equals
arguing
nRT.
that PV equals nRT is wrong or anything like that. I'm not even saying it's wrong. I'm just telling you the reason why we have a gas gradient in the atmosphere is because of gravity, and it's literally
Very good.
sidestepping it's literally sidestepping that equation and ignoring it completely because it's pulling down on every one of those molecules, increasing the
bro.
pressure that it's. No, I know you don't believe that.
No,
That's my explanation.
watch this guy
And you
squirm,
need to
y'all.
prove-
Watch this
you
guy
need to-
squirm.
Wait a minute.
Okay,
You
so
need to-
if I evacuate a vacuum
You're talking
chamber,
over me again. I'm
no,
not gonna
you
do
were
this
done,
again.
bro. You just
No,
monologue. Let me
no,
respond.
I wasn't done. I was
So-
nowhere finished.
Bro, you made a point. You want to
No,
make
I
another
did
one?
not. I was going to talk. You got offended because I suddenly went from describing to you how the atmosphere worked and then asking you the very simple question: how does your so-called gas law be the only explanation, why the atmosphere behaves the way it does?
For the last time, bro, it's not my gas law. Now, just to watch this dude, to
Or
prove
just
he's
gas
trolling, to
law.
prove this guy's trolling, okay, if he even lets me get this out without fucking interrupting. Okay, so if I start evacuating gas out of a vacuum chamber, are you telling me that what's left in there is sitting at the bottom, puddling at the bottom, pal?
No.
Answer that question.
No, because you didn't have. What temperature is it? What's the temperature in there?
Oh, no, I'm asking you, you're saying gravity and all this. I'm asking
What
you.
is
and
the temperature in there? If the molecules are excited enough because of heat, they overcome the force of gravity and distribute themselves equally within the chamber.
So the last remaining few molecules must be puddling at the bottom because of
No.
gravity, right?
No, you didn't hear that, did you?
So no G then, right? So no G, just temperature.
What part didn't you listen to?
You're backing me up, pal, because now you're translating.
No.
Yeah, you're
Temperature-
reciting
you lower
gas
the-
law, bro,
lower
which
the
is all I've been
temperature.
doing the whole time.
Lower the
Listen, you're
temperature.
interrupting again, bro. All
Low-
I've been saying the whole time is that
Jesus
gas law. And you're
fucking
calling it my gas law, and that's why I keep saying you're trolling, bro. And then you said G is a part of it, and then you give me an example of, oh, well, this is how G might be a part of it. But then you go right back to reciting gas law, asking me what the fucking temperature is. The temperature is part of the gas law. G, once again, is not. Go ahead. Sorry.
So again, wrong. And here's why. the temperature, you lower it enough, those molecules don't get excited enough, gravity takes over and pulls them to the bottom of the container. The air molecules that are on Earth are massive enough. There's enough of them. The only ones that escape the actual gravity of Earth are the lightest ones, helium and hydrogen. Lithium, if it was in gas form, would literally escape also. It's so light. But you basically have these molecules staying on the Earth because of their mass.
Escaping to what, dude? It's a fucking it's a gradient up into infinity. What are you talking about escaping?
It's a gradient.
You agree with Ruif that it's a gradient into infinity, bro.
Okay, now, since you interrupt me again, let me explain something about what Ruth said.
Bro, I waited for you to fucking stop, and then I responded, and then you interrupted me. You're lying.
Can I finish now? So, if you're talking about a gradient that goes off into where, I don't care what you believe in. If you want to talk about a dome and all that, let's talk about what I believe in, since you wanted my answers. And then I'm asking you for your answers. You just refuse to give me any. Here's the question, okay? The gradient that goes off into infinity is actually a gradient that goes off into what's called near infinity, because the vacuum of space has something in it. It's just called a vacuum because there's so little of something in it that it's technically a vacuum. It's an accepted, known fact of science. We just accept it as a vacuum, even though there's plenty of stuff out in space, but it's so far apart, it has absolutely no pressure. Now, the second thing I want to ask you is, how does the gas law apply to the radiation that's happening from the surface of the Earth to the highest altitudes that you know of, where you've sent balloons to, people like you who don't believe in space travel or whatever? You get up to that high altitude, the molecules are so far apart, they're almost in a vacuum. How does that happen with a
Okay, please don't interrupt my answer this time.
Right.
And thanks for lying through your teeth. You were done. Anybody who doesn't believe me, go back and listen. I responded. He interrupted me and accused me. Dude, you can't help it, can you? I don't appreciate you being dishonest.
Stop giving,
Quit fucking interrupting me, bro. You literally accused me of interrupted, and when you're lying
answer
through your
the
fucking
question.
teeth. Okay, a container. That's how. Now, don't interrupt. Okay, you just said you're puking on your own self because you said it's a gradient. Then you said that shit's escaping. So how is it escaping if it's a gradient into infinity? Okay, to answer your question, a container. That's the fucking answer. Now, my question to you is that how is something escaping a fucking infinite gradient?
It's
genius.
It's escaping the gravitational pull of the Earth. It's going out into outer space, or basically out into the vacuum, to join all the other molecules that are spread out in the vacuum. And that's basically what these lighter elements do. Because they are so light, the force of gravity is not keeping them in.
So not an infinite gradient.
Nobody said it was a real. Okay, you misunderstood what he was trying to imply when he was describing it as an infinite gradient. It's just a vacuum, something that you don't. It's not a big machine out there with a hose sucking all the air off of the Earth. Okay, it's just.
You're not honest. I'm done, man. I'm done. You're not honest. Somebody pick up for me, please. I'm done. This guy's not honest.
In that? Well, fine. You can run if you want.
I'm not running. You said it was an infinite gradient.
Where's the container, by the way? Where's the container? Now, you talked about this container. I would love to hear where this container is.
Bro, you accused me of interrupting when I waited for you to finish, and I was just watching the clock. I'm listening.
About the gradient. Wait, Brian, I answered your question about the gradient. Now I'm asking you, where's the container?
Bro, you just started right when I went to talk, and you fucking just piped up over me again. Every time I went to speak, you keep doing it, bro, and it's getting me aggravated, loud, making me look stupid. I'm asking you to calm down so I can calm down.
That's fine.
Now, I just said there's a container up there. That's how all this is working. It's all
he's asking where it is. Where is it, Brian? What's the evidence for it?
Somebody else, man. I'm not dealing with it.
Yeah, just stop, Brian, because you.
Brian, don't run from the container question, because now you're the one doing.
Bro, you're
being dishonest. You're being dishonest if you say there's a container and you cannot tell me where it is.
Earlier, you're calling me fucking a piece of shit, and now you fucking
I never called you a piece of shit.
I'm
Pretty sure I didn't use that.
And you're just lying, bro. I'm not
Back to the conversation,
please.
Can you tell me where the container is?
No, that's a no. We don't know where it is on the flat Earth. There's no evidence of the container.
Nothing wrong with not knowing, Don. Nothing wrong.
It's fine, Brian.
That's good.
That's why he's been asking you for 20 minutes, but you couldn't explain.
No, he hadn't been asking me that for 20 minutes. Go back and listen, bro.
been
That
asking
too
you-
is a lie.
It was
been
about
asking
40.
you
It
for
was about
final
40 minutes
answers.
ago when I asked you where the container was.
You haven't given any final answers because you don't know. That's where we've got to. It's an antecedent thing. You believe it has to be there. You don't need to find it for anyone. Same for God. Same for the Earth being a globe. I know it's a globe, Brian, so I don't have to provide anything to you.
Yeah, there's a very big difference between knowing something as opposed to proving something. But on the other hand, science never proves anything. Proofs are for mathematicians and logistics, logic. Proof is just not something that that scientists go for. What they go for is consensus and an understanding and knowing. And we basically know what's causing the atmosphere to have this gradient. It has nothing to do with the dome.
Of course, on the globe model, it's just gravity, and it makes sense. You don't need to find a dome. We can find gravity, and we can prove that to you.
What's gravity made of?
It's not made of anything. It's an invisible force that we're trying to measure, trying to understand.
Right, so it's something that's like make-believe, yeah?
No,
it's an invisible force that we're trying to understand. It's not.
If it were
you keep invoking gravity, you need to explain exactly what gravity is.
I just told you, Carlos. It's an invisible force we're trying to understand. That's the explanation.
That's a non-answer.
No,
Carlos,
it
it's been
isn't. That's the answer.
experimentally shown that it exists. And not only that, now they're discovering that there's also gravitational waves. The effect of gravity actually it comes in forms of waves. All of this stuff is literally being discussed, debated, and trying to be understood by science. But all the indications point to that far
You don't
more
want to
than any
start getting
indication.
into gravity
Just a
because
minute.
I think
Almost
which is in
done.
the room.
It was literally almost done. I know I'm a windy guy. I talk a lot. Many years of teaching, many years of life cause me to ramble on sometimes. But I'm going to get to a point here. Very simple point. All of this evidence and discovery towards gravity far outweighs anything that points towards the dome. You cannot just say, I know there's a dome up there because scripture says it or whatever reason you came up with for it. But
Nathan Oakley said.
reams and reams and reams of journals and everything else describing gravity and experiments dealing with gravity all point towards gravity.
Gravity exists on both models as well. It's not like you can just get rid of it. Carlos.
So is gravity sort of a description of the way that everything finds its equilibrium?
Sort of. Some of it describes that, yeah.
And what's the mechanism behind that? Everything finding its equilibrium.
We don't know the full mechanism, but we know mass appears to attract mass.
Is there any evidence of that?
Of course there is, or else no one would
Cavendish.
believe it, would they? Of course there is. Things falling to Earth, moons going around planets, things falling the same rate in a vacuum chamber, and the Cavendish.
Well, all I can say from this long-winded debate is that Brian has a whole lot of evidence, and you don't have really any evidence for gravity, which is your main crux.
I just gave you 4 evidences for gravity, but Brian hasn't given us any for his dome, except it has to be there.
What
Which isn't very
evidence?
good evidence, is it, Carlos?
He talks about something that's real and measurable, gravity. You could use all sorts of explanations for gravity. There's no solid evidence.
Okay.
I
Have
gave
you
you
ever
4 evidences. Why
have
are
you
you
ever
ignoring them?
have you ever done any of those experiments that we've talked about when we talk about experimental demonstrations of gravity? Like, have you tried Cavendish? Have you? I remember back in college doing it.
He's seen it all, but he's pretending he hasn't for some reason. I don't know why Carlos would do that. Why would you pretend you haven't seen any evidence, Carlos?
Yeah, I've seen evidence for a downward vector for sure, but there's many other ways to explain gravity.
What about Cavendish, the sideways vector?
It doesn't need to be mass attracting mass. It could be to do with a negative and a positive charge.
Okay, but in Cavendish's experiment, these two masses they weren't negative or positive. They were just two heavy iron balls, basically, and they didn't go downward. They went towards each other, sideways.
So not up and down.
No.
So is that sideways gravity?
If it was up and down, it would be disingenuous. It wouldn't demonstrate mass attracting mass. It would be demonstrating things falling to the earth, which they already established.
Yeah, it's amazing that you have to actually put the experiment into an environment that doesn't naturally exist. For example, a vacuum chamber.
No,
That's
Cavendish is not done.
It's to show no air resistance, to show the law working of gravitation.
You use big enough heavy balls, you can also demonstrate that there's no air. You can do it in what you call it, without a vacuum.
What about Cavendish, Carlos, the sideways vector? Have you debunked that? Yeah.
No, but I'm sure it's explainable. I just see that you really need to look into a little bit deeper because everything that's provable Brian was saying is 100% true, and it's all backed up with experiment.
Wow.
It's all done in a container.
Yeah, but doesn't that debunk Brian's pressure gradient test through a tube as well? Because it's in a container.
While it's a bit quiet here, does anyone got any objection to Blartek being unmuted?
Oh, I love the guy.
Okay. I'm not an atheist globe. What Earther mod? That's for sure. I'll unmute him if no one's got any objections.
Fair dinkum.
I don't know him.
I just don't want to regret it.
Oh, you probably will regret it, but that's your responsibility.
No, yeah, thanks for that, Terry. Much appreciated.
An atheist globe Earther as a mod.
Well, we were having a discussion and I got muted, and there wasn't any reasons why I was muted. And
What, today?
They logged off.
Was this today?
About 5 hours ago.
That's probably Geo or one of the other silent mods who never tells you. Maybe Jeremy. Or Lightwater. Or Left Lane. They all do it.
Well, I'm not an atheist globe Earther, that's for sure.
Yeah, but there are some. Look, okay.
Are you a communist, Terry?
No, I was trying to make a joke out of it. That's the whole thing. But anyway.
Sorry to ruin the conversation.
Nah, it's okay. It was winding down. We haven't gotten our proof yet, so.
You mean winding up?
Yeah.
But yeah, this is you're making good points here. I'll jump in. Let's get back into research and start working out what the hell's going on. Because the science we're giving is not working out, nor does it make much sense.
Whose science?
What is
Our
gravity?
science or mainstream science?
Their science, the popular science for the magazines. None of it really adds up. It's all speculative, hypothetical, unproven. And it's 500 years old, even older.
Huh? What's 500 years old?
All this gravity, and a lot of this science is ancient science that was never proven.
God.
What about the law of gravitation, Bartek? Do you think that's been proven? Things fall at 9.8
Well,
meters a
it
second.
doesn't mean anything. It's an assumption. The law of gravity is an assumption that
No. I'm talking
that's what
about
it
the
is.
science of measuring things dropping at 9.8 meters a second. That's not assuming, is it? They've actually done it.
No. But the gravity side of the equation is an assumption. We know objects fall.
No, the law of
fall
gravitation.
to something.
The law of gravitation says things fall at 9.8 meters per second. That's been proved.
Yeah, but it doesn't take into reference that it's actually gravity doing it.
Oh, right. Well, no, that's what we called the effect, gravitation.
So it's a label.
It's a word for a thing we found out, yeah. Like all words.
Yeah, we could call it strawberry. We could call it anything.
Okay, so it's an explanation then. It's not actual law or something. It doesn't
It's
really
a law
say
because
anything.
they've proved it always happens. That's what
Okay, do you know what a law is? Let's get into tin tax.
Something that always happens universally.
No. A law is a legal term for a law. Sorry, it's a legal term used for a rule created by man.
No, that's a fake version of law. Law means a constant, universal nature.
I'll look it up, but
The law are things that we know happen all the time, always. And
Yeah, laws can have different meanings and different usages, so that's where the difference is.
religious people tried to explain that there were certain rules that happened all the time, always, and they made them up.
so you're saying there's different laws in science as opposed to the legal or political
I'm
system.
just saying what I meant by the law of gravitation wasn't to do with a legal
Mm-hmm.
term. It was to do with people deciding that always happens.
Bro, gravity ain't a law, bro. It never happens. Ever.
Gravitation is.
Hold on. If you want to give the right conditions of vacuum, so I say with the air pressure, okay, let's start with a vacuum. If we're going to do this fairly, let's be honest. We got to start with a big ass vacuum chamber, okay? And then what we want you to show us is gas pressure inside of that vacuum chamber, okay, without containment. We could show you gradients and containment in that vacuum chamber. We could show you different things, dynamic systems, all that. And show me a helium balloon falling at 9.8 meters per second squared. You can't show me helium falling ever because it never, ever fucking falls. If you put it in a vacuum chamber, it's going to expand equally. This law you're speaking of, bro, is outdated science. This argument is the first step to updating it, bro.
Brian, you didn't listen to anything I said about the lighter gases, did you? Not a single word I said about it.
Bro, I ain't even talking to you. The only reason I'm talking is they're talking. I don't feel like you're honest, bro.
Yeah, except for I didn't lie about you. You didn't listen to anything I said about the lighter gases. What are the lighter gases doing? Why are they the ones that are not being pulled down by gravity?
Bro, I literally waited for you to finish, and I started talking, and you literally said that you were still talking, interrupted me to say that, bro. That was dishonest. Anybody who doesn't believe me, go
Wait a
back and listen.
second. I'm not even talking about what happened before. I just asked you if you were listening to anything I said about the lighter gases because you just made a statement about helium that confirms what I said about the lighter gases and then claims that that's the reason why there's no gravity.
He claimed that it's a law. If it's a law, that means it always happens, okay? It doesn't always happen. Helium will never fall in a vacuum. Ever.
A law is a consensus amongst scientists for observing, excuse me, observing a phenomenon that happens over and over again and is consistent. And when they were observing those phenomena, they were describing massive objects, objects that are of enough mass to be affected by gravity. Something that is not of enough mass, and for instance, a blimp basically has not enough mass or density, basically because of the helium inside the blimp, causes it to rise and defy gravity. An airfoil causes it to rise and causes a plane to rise and defy gravity. Those are observations that take away from the observation of the law of gravity. But actual molecules that are heavy enough to be affected by gravity will always behave the same way, fall at the same rate, and that's where the law of gravity comes from. It has nothing to do with the gravitation idea itself and how you can avoid it or how you can how you're affected by it.
Fine. Quit calling it a law. Like the guy just said, it's something that men agree on. You disagree with him.
It's a term that scientists use. If you don't like the term, why don't you write a paper about it and say, hey, I'd like to have this idea of laws
you're right.
changed.
We need to challenge the whole meaning definitions and the explanations for this. It's not adding up.
Yeah, somebody might get a Nobel Prize.
Well, it's probably already been written. People have been challenging gravity for 500 years. It seems to get buried a lot.
Yeah, that's true.
So, what else do you guys want to talk about?
I wasn't trying to prove a globe Earth just by saying I believe in the law of gravitation. I was just saying people have claimed it's a law already.
I know, but I mean, I pop in here every once in a while, and it's not obviously like, this room is always moving and everyone's changing, but it seems to be always the same conversation.
The biggest issue I have with the spinning ball, if you want to get on a new topic, is that the penguins in Antarctica, they have to be spinning a lot faster than the monkeys in the equator, yeah?
That's not a good topic, my friend.
Okay.
It's actually true, because
Are we now on the spinning ball thing?
Yeah, I hate that word.
Yeah. Who was the one talking about the penguins in Antarctica?
Blah something, whatever his name was.
He got kicked then, Terry. Is that right?
Who? I didn't do it.
No, Bartek might have been kicked again.
Yeah, I don't know who'd do that. He wasn't doing any harm.
I don't know who did it either, but somebody must have gotten fed up with the analogy and the argument, because where does it actually lead?
It goes around in circles.
Yeah.
Merry-go-rounds.
Yeah.
It's
So is there a
around in
difference,
circles.
like, is there a difference on Earth? Like, I thought that gravity only was to do with inside our Earth's atmosphere. So it's like a mix of weight and pressure, and then gravitation is to do with the influence between our planet, so-called planet, and all the others. So they're two different things, aren't they? Gravity is local, yeah?
No.
And then gravitation is what you would experience, like between the Earth and the Moon and Earth and the Sun.
No, gravitational field it covers everything, and basically,
No, not field.
it keeps the atmosphere on the Earth, as well as it also keeps the Moon from falling onto the Earth and actually falling around it. It keeps the Earth falling around the Sun. It's all all encompassing. Every body of mass has its own gravitational field or warping of space time.
So it's a field. Is it kind of like a magnetic field?
No, it's not electromagnetic. No.
No, but would it?
It's described as the warping of space time, basically, where you have.
Right. How would you draw it? Like, if you had like a paint program, how would you draw it to illustrate it? Would it be like a mesh web, or would it be like just like how
You
would
could take
you
it, put a
do?
bowling ball in the middle of a trampoline. That's the best way you could show how it works.
Can you draw it?
I don't have time to draw it, but yeah, you could draw the same thing.
Has anyone done that? Has anyone demonstrated like with like arrows and like the way and
Oh
like
yeah,
in a
There's
diagram?
plenty of diagrams out there on the internet. Just Google, gravitational or the theory of gravity or whatever, and you'll get all sorts of
it
images.
comes from like a lot of mathematics, man. That some of the assumptions right along the way you may disagree with, but these arguments, they've been put forth, and we've talked about them ad nauseum. I don't know. At the end of the day, like, it is a model of the universe, right? And it has been tested, and it's whether or not you believe the people that are testing them based on those assumptions that they say are correct. That's all. Some people believe in them, right? Some people believe in these tests, these experiments that have gone on within the past 100 years, essentially. Some people say that there are other experiments that provide another model that disprove this model, and the people that are saying that this exists, right? Time dilation, length contraction exists. They're lying. So that's it. That's it. Right.
So does gravity have an equation?
Yeah. Well,
yeah,
it
there's
doesn't
lots
have
of
an equation. It's described by equations.
Okay, so what would
attempted to be
there must be an
described by
equation like for the Earth and the Moon, and then another equation for the Earth and the Sun. Yeah.
No, it's the same thing, but when you use an equation, right, you bring in, one point reacting to another point, and that would either be the
variables.
moon or the sun. Right. And if you have a three-body problem, right, which is if you bring both the moon, the sun, and the earth together, then the equation on paper becomes too complex, but you can use mathematical methods to that are very complex and true approximations in math that describe it well. And if you apply that to a computer, it can describe it nearly perfectly, but not actually perfectly. And that's called the three-body problem. So, just putting it all out there, this is what, mathematicians, this is what people dealing with science are doing, and how they're trying to explain away, right, the mysteries of the universe, like the moon and the sun. And you're right for questioning it. But it's just that a lot of the questions that go on and a lot of the discourse and the conversation is just not really worthwhile. It's basically just like two people kind of arguing with each other just because they want to.
I agree.
Yeah, you're spot on there, man. I totally agree with everything that you said. Yeah. Fucking hell.
I mean, I've been hanging out and listening to this. Like, I studied physics myself. I'm not like I'm not a flat earther, but I'm not even, I see the problems in the world, right, and the corruption that is in the world and in NASA, whatever, also. But it's just that I don't think the answers are in, I don't think the flat Earth is true. I don't think the answers are that like we live literally on a flat Earth. I think more, in a more nuanced way, that like the answers are in the sense that like measurement is, limited, and like any model that you take, even if it's flat or round, or like whatever you claim to know about the stars or quasars or whatever astronomy, just those objects that are out there, we have very little data on what they are, and we're trying to ascertain through our own models of what they are, and that will always be wrong. Even on like our Earth itself, like with our theory of gravity, trying to figure out what it actually is. Like, it's changed. It's been wrong every step of the way. And, you know, I think that's the nature of measurement. The nature of like trying to encapsulate something mechanically, right? You can only capture something mechanically if you have a use for it, and that use is limited. And that's the nature of what we're doing. But so, you know, I applaud Flat Earth for like questioning these things, because I think a lot of people who study science and physics, they don't question them, and they don't question the nature of like the limitation of their measurements. They just like them.
I think you're completely misrepresenting science. And being a scientist, the first thing I do almost every morning is I'm reviewing people's papers all the time and questioning their data, questioning their assumptions, questioning their conclusions.
Right.
It's when we come to a consensus and an agreement, then the paper gets passed on.
That's not what I'm talking about.
I think you're
No. I'm saying that's all well and good, but I'm saying that the conclusion that you come upon, right, after conferring with your, you know, fellows, it is limited, and it has been limited, and there's no, you know, sign out in the future, right, that it won't be limited. But you're treating it as if, like, you know, it's the truth. And
no, I said earlier in my conversation with Brian, I said scientists don't go for proofs. Mathematicians and people who believe in logic do. Scientists are always questioning, and we're constantly, anytime new evidence comes along or new data comes along, we reevaluate almost all of our assumptions and all the laws and everything.
Right. So I'm just all that I'm looking at. I'm looking at the whole field of things of science, right? And I'm just saying this is all measurement, right? And I'm looking at the nature of measurement, not how you interact with your colleagues and how you ask questions and how you all, you know, try to come to the best solution for a mechanical thing, which is a measurable thing. Right?
Which measurements are you talking about? I mean,
all measurement.
Speed of light's been changing over the last 100 years.
No. That's not what I'm talking about. I think you're extrapolating, but I'm saying that when you measure, right, when you make a measurement on something, right, that is has a limited use.
I'm listening. I'm waiting for, you know, an example, because right now I don't understand where you're going with this. Seems like every measurement. I mean, I'd take a lot of measurements. You know,
look at the sky, right, at night. Look at what you're seeing out there, right? Look at a tree, right? It'll just take a tree, for example, right? A measurement on a tree. You say, you know, it's biology, it's a science, right? You say it's got waxy leaves. It's a qualitative measurement. You know, it's
systematic properties, yes.
Yeah, it's properties, right? Exactly. And anything that you can measure about it, even go to quantum physics, right, which is what I studied, right? Any measurement that you're capable of making, right, is, you know, you're lucky to even get a measurement in quantum physics, but you're also barred from measuring certain things. Meaning, essentially, like there are aspects of the universe, right, that you can't just keep measuring and measuring and measuring. It becomes meaningless at a certain point. So no, like the measurements that you make about a particle are not actually the particle. Do you get that?
Yeah, I understand that. I mean, but the quantum realm isn't going to going to deny or defeat established, you know, observations of a globe, for instance, from orbit, or established observations of the motions of the planets and stars.
Right. But okay, observations of a globe from orbit is a end all, you know, thing for the flat Earth, right? But they don't believe that that's actually those representations of the globe from orbit are actually real, right? So
yeah, but that's not a science problem. That's a they problem.
That's okay, but that's it's a questionable realm, right? Where that area, you know, if it wanted to be proven, it could be proven very easily. But there's always a way to kind of poke holes in what they're showing us, right? Regardless, like that's a mystery for a different conversation. Now, what's going on in the sky, in the heavens, in the night sky, that is all, even astronomers, right? They will look at a star and they'll be trying to look for an exoplanet, and they will spend 10 years looking for an exoplanet, and they'll finally find evidence of one in their signal data, and it'll take them another 5 years after writing the paper and finding evidence of it to actually believe that it's an exoplanet. Do you know why?
Enough observations of the transitions in front of the star. Yeah, I know the science behind discovering exoplanets.
Because the reason, the way that they're determining that something like an exoplanet exists is so just separate, right? It's just signal data, right? They're just looking at signals, and it's even the data itself doesn't actually convince them that this exoplanet that in their heart they've been looking for actually exists. And then 5 years later, after it's kind of agreed upon, and people have kind of molded over and come to a conclusion that yes, you discovered this exoplanet. They agree, but man, that it leaves a bad taste in their mouth. And I'm not talking. I'm saying, like, this is the nature of astronomy.
I know a lot of astronomers. I rarely hear any of them sitting there saying, when they're describing a particular planet they may have discovered, an exoplanet or whatever, they don't sit there and just, feel bad about it or anything like that.
The first one who did.
Okay, but there's been thousands since then, and the data collecting has been so much better now, because not only do you have
since then, right? They can just kind of put their hat on, on the stand and be like, hey, I found another exoplanet. Great. But the first guy to do it took him 5 to 8 years to actually like agree, that
because he had to be sure. His data collection abilities back then, a lot of things could have been interfering with the observation of that star. Between us and that star, that could have given the illusion that there was an exoplanet there, causing the dimming and so forth. The problem is that better instrumentation allowed them to be more accurate and discover these. And the fact that he was having, being extra careful, not even sure, nervous about making the announcement, and anybody who makes an announcement in science that's a breakthrough gets nervous. I discover a new species, and I'm sitting there nervously waiting for my colleagues to confirm that I've actually discovered a new species, that there isn't somebody else who's already written a paper on this particular animal that I'm looking at.
Yeah.
And that's just because that's natural. That doesn't make it wrong or in any way, shape, or form, bad science. He's doing the right thing by being, ultra careful.
Yeah, being ultra careful
Doesn't make the science wrong either, though.
Well, it might, and that's
in
where
what way
comes in, because actually you don't actually know, right? Like what you're looking at is just signal data.
In every situation in science, you could technically say you don't actually know. You don't actually know. I don't actually know for sure if the genetic makeup of this particular species of ant is close to the other. I have to rely on the instrumentation and the analysis done in labs and so forth. And I, in the back of my mind, think, could there be a lab mistake? Maybe we have a lab technician who's a little bit lazy,
could be wrong,
and he just fills out the report, and saying this is correct.
And it might take a decade for somebody to actually,
discover this right and correct the error. That doesn't make the science wrong. It never makes the science wrong in that sense. The science is constantly questioning, which is the reason why the data later on gets discovered as wrong and corrected in most cases. I think of a couple examples, and again, being an entomologist, I'm just going to tell you that there's a lot of people's names attached to different specimens in a collection that I know who discovered these particular species. But the one guy comes to mind in particular, his name was Smithy, and he late 1800s had described about 300 or 400 different species of Columbian ants. And he literally worked that part of South America and was known for the we went over his collection, and a lot of these specimens that he had in his collection weren't even collected couldn't have been collected in South America. He literally were mismarked, and whether it was his assistant or himself on a drunken night, whatever. We had to go through the entire collection, redefine and redescribe all of his insects, and recap, find out what species they really were and where they actually came from. So, but that didn't make the science process bad. It just said, "Hey, look, this is a mistake. It's been corrected," and everything that he wrote, yeah.
Would you agree that science is only correct until it's false? That it's proven false. Like that's what the state of science is.
You could say that, yeah. In some ways, sure.
You can understand why people might think that can't be true. We need to do more. If the state of it is, it might never be true. You always have to do more.
Yeah, well, science is always working to do more.
I think that was Santiago's point about people think because they're in the field of science, they're working with 100% facts. So they've ignored the fact that their assumptions could be wrong and it might be improved next year.
That's a bias. That's a scientific bias by the scientists to be
that's
that
what
way.
he mentioned.
If I can clarify my point was that when you are making a measurement, that is all that it is, okay? And in certain realms of science, it shows you that, right? It shows you, it brings you to confront the fact of that it is only a measurement. So in the same thing that when you are measuring, ants and calling them whatever you want to call them, right? You're dividing them based on your own, presuppositions, your own,
we use keys basically. There's a key we follow, and systematic keys that will guide us to one family or another, or one species.
Your own key, right? And your own divisions, and you divvy them up in this certain way, and you say these are these, these are these, these are these. This is the act of measurement, right?
Yeah.
You can, and okay, it's not like inherently true, right? That how you are dividing them up is the truth, right? It's only
no,
true.
It gets changed all the time. The
Exactly.
keys get changed about every 10 or 15 years as new genetics and new ancestry is discovered. We realize that one group of insects don't belong into that family. They actually belong in another family because they're closer related to that.
Okay,
but that's natural.
So you would understand what I'm saying, because I'm not talking about any particular field. I'm talking about the field of measurement itself, right? Just the action of measurement, which is that it is inherently its own thing, right? It's off on its own. It's not ever the truth. No model of the universe, right, is going to be encapsulating truth. It's only going to show you, right, what you can do by parsecing this off and this off and this off.
Well, yeah. So like a model of the solar system is very, very precise because it's only covering the solar system out to a certain range. Doesn't cover the Oort cloud. People, when they get their little models that they give to their kids and so forth, are based on science that we know of, and that's why we give them those models. A globe itself is a model. This is the thing. The one thing that really irritates me about flat Earth scientists, as they call themselves, is they have no models. No matter how hard you try to press them on it, even the dome and the flat disk is not, is a very poor model because it doesn't hold up to scrutiny, whereas a globe model at least can hold up to most of its scrutiny. There's some examples where you could say the globe is not a good model to use for describing the Earth. If you were trying to describe,
No, I'm not trying to get into all that. No, I agree with you. Which is that the flat Earth, is not a good model. Absolutely not. And that's my beef with the flat Earth too. Is that they're trying to do the same thing that what they're against, right? Which is to create a model. But at the same time, what I like about the flat Earth is that they, even though they don't really mean it, they're questioning the model, right? And even though it's in such an egregious way where they're questioning like our fundamental, reality, right? I think that it's okay and that it's good, because people do not question their measurement. I mean, they do it for a job, and that's fine, right? That's what the company is doing, right? That's what the organization is doing. That's what science is doing. We are organizing things in this way and not in this way, and we're doing this for a reason, right? And we're garnering some sort of intelligence from it, or some sort of information from it, by doing that, right? That's the reason why they're doing it. But to take that as like a fundamental truth every step of the way, you're going to be fumbling over your steps if you lived long enough. Like, it's just not, it's never the truth. What you say about a species, right, is only helpful for a particular reason. It does not have anything to do, has no relationship with the truth whatsoever. It's just a measurement. And that's the case with all of science. And you're saying that I'm doing science wrong. I don't think that I am.
Well, one of the things that I've always been well aware of as a scientist is the surest way to kill your career is to not have your data checked and double checked by someone else.
I'm not talking about your career, man. Your
and
career
no, data itself. You're talking about measurements, and
yeah.
One argument I had with a flat earther is
talking about
a while
the nature
back.
of measurements, not about what you have to do for your
Right. I had this argument with a flat earther who said that observational science is not a science, and my career is observational science. I literally go out into the field and observe insects.
That's amazing.
And I make literal. I'm retired now. I haven't worked in a while, but the point is that I literally rely on the data I collect, not only actual measurements where I get down on my hands and knees and down to the millimeter, making measurements and so forth, temperature, moisture, composition of soil, all that stuff is measured in the lab. But I make measurements based on observation alone. The thought, mental measurements in every sense, as I'm watching behavior of an animal over time, a behavior based on different situations within interactions with other animals, social behaviors, and so forth. All of that comes into consideration while writing a paper. And what I meant by your career can be killed by not having your data checked is somebody has to go out there and make the same observations you have if you're doing observational science in order for a conclusion to be made. And this conclusion is always in doubt. And there, I think, is where you and I agree on a point, is this constant doubting of conclusions is something that's natural for scientists to have.
Right.
But once enough scientists have made the measurements, have made came to the same conclusions, and this is where something like Newton's law on gravity, even though Newton's laws versus quantum laws are entirely different when you're dealing with gravity. Newton's laws pretty much hold their weight and hold their validity through the observations of what we see around us in classical physics. So there's no reason to sit there and throw Newton completely under the bus and say, yeah, but we have all these new descriptions of, the warping of space-time and so forth to describe gravity. Why should we even bother with the basic classical physics? Because you teach classical physics to get people started on the path to moving towards quantum physics. So you can't literally just say all the science is wrong when time and time again people have demonstrated acceleration. People have demonstrated that, without air resistance, all objects fall at the same rate. All of that stuff is literally science that you cannot that you can't just say is flawed because it doesn't agree with your idea of what you think the Earth is all about.
Well, no, I don't think that.
We're talking about observations. Can I bring in like the stars? The we observe the stars in the south. Okay.
In a second, Trouble. We're wrapping this up.
Sorry.
What they're saying basically is that the acceleration due to gravity is due to some other thing than m times m, right? The mass attracting mass, and that's sort of where the fundamental theory is based on. And from what I garner, a lot of flat earthers say that it's more to do with electricity, right? And they, again, like when you go down this route, they do not have a model, but it's still an okay question, right? And it's an okay question because the gravitational force and the electric force, Coulomb's law, are the exact same equation, except just the charge is replaced with mass. So it's a fair enough first step into that direction.
How far out can the electrical force go, though? Can it go out a distance of, say, from the Earth to the Moon?
Well, see, for them, it doesn't need to, right? But again, like I disagree with this I forget how they phrase it, but something static
electrostatic universe.
Yeah, the electric universe is an okay idea for me, honestly, but it comes down to measurement, right? And what is actually measurable, and if there is a block in measurement, then, or if there are things that are immeasurable, then we're really not going to have any type of physical model in our current state of things to be able to understand. And I do think that there are things that are immeasurable and there are things that break the laws of physics. But it's not, and that's a big thing to say, literally, because if you don't believe that, right? If you think that everything follows the laws of physics as we currently know them, I would say that you are just, well, I don't know what I would say, but look outside the box a little bit, right?
Yeah, so what's your opinion about the people on the ISS? Either they're faking it because they actually can't go there, or they can go there, but it's not anti-gravity, and they're not actually floating around, and that's why they have to use wires. So which one is it? It's either the fake option or the other fake option.
I don't know what you said, Carlos. You said a lot.
Okay, so on the ISS, they're using wires and green screens and blue screens and all sorts of technology to make it look like they're floating around in space.
Yeah.
So is it that they can't go there and that's why they're faking it, or they can go there?
I know,
and they're faking gravity.
I'm not answering. I'll tell you how I understand what you're saying, right? Which is when I looked into this stuff, okay, I was doing magic tricks, all right, and this is how I live my life, like in a large way. Like there is a trend of things, but I find like certain things come along which seem to be important for no reason whatsoever. But I was doing magic tricks a lot and learning how like sleight of hand, learning how to like double undercut, whatever, with cards. And I was watching magic videos, and some of these magic videos, they take you to like a fair where they're showing all these different magic tricks that, like, if you didn't know you were at a magic fair and they were showing you these tricks, you would think that they were completely real. Okay. And I was watching all these things. Okay. And then I tuned in to Jeranism, who I'd been following since he did that piece on the Christchurch child abuse case back in like 2016. That's why I followed his channel, not because of the flat Earth. But I came back in to like see what he was on about, and some of these NASA videos that he was showing just gave me this really eerie feeling that like this is like a magic show, right? It's like a magic trick going on. It's an illusion, right? So I'm not, you don't need to ask me those questions, Carlos, because I have a relatively open mind and I've explored a lot about, what's going on in the world without like holding down to my prejudice and without accepting, exactly, that I know what's happening. But
That's the kind of answer I was expecting to get from you, but I wasn't actually directing that question at you.
all right.
You're directing it to me?
Yeah, so you know how on the ISS we claim that they're using like wires and all sorts of technology to fake anti-gravity. So if that's the case, are they faking it because they actually can't go there, or they are actually there, but they're faking it because there's no anti-gravity? Which one is it?
Well, who says
Because
they're faking it?
100% sure that they're definitely faking it, and we don't know which one is the real thing.
You got a problem here. You already said 100% sure, and there's no way you're going to be 100% sure about anything. After all, you're a flat earther. Why would you be 100% sure about anything? But the question I'm going to ask you, hold on.
Hundreds of videos of evidence.
And almost every piece of video of evidence that you guys have put forward as proof that the ISS is fake, and I have some videos of my own from the ISS that no one has, that I got from NASA, from a friend of mine who is an astronaut who went there. He's a chess player, and that's how I know him. But there's no way it was faked. That number one. Number two is almost every video that you guys have put forward has been completely debunked, and not by NASA, but by the anti-flat Earth community, who can prove to you how you describe it's fake is not. But just on a sidebar here, let's just take away the evidence for a minute. Let's just throw that out. Let's say you are 100% correct that it's fake. Let's talk about what's going on with the how they fake it and in Earth's orbit. They can get there. Why are they faking it is beyond me, because when you're free falling, which is what you are when you're in orbit, you're actually falling towards the Earth, but at a rate so fast that you miss the Earth constantly. And when you're free falling, you're weightless, just like you are in the Vomit Comet, and you're going to float around. And that's the reason why you float around inside the ISS. As soon as you give the ISS a little bump or a kick, a little acceleration, and start accelerating it, all the astronauts in there are going to move towards the whatever the source of acceleration is, the back of the space station, because the space station is going to be moving faster than they are. So they eventually rest against that wall.
I agree.
That's
Everything you said in theory is absolutely correct and true. But why are they using wires to do their magic tricks?
You're asking me something that at first I don't believe is true, so I don't know how I can answer that. And if assuming that it was true, it'd be a mystery to me why they would be doing that.
Great, Angelo. Like, I looked into it and I feel the exact same way as you, because it still is a mystery to me. Like, I'm telling you, I do not know why they're doing these types of quote unquote tricks. I don't think that the Earth is flat. I don't think that they would have a reason to do this, but I've looked into it, right? And I've seen things that are just very odd. And it's not just like from a flat earther's video of like, go, here, circle this and check that out. Like, I've looked into it myself, like, and looked at fresh, NASA videos that nobody's talked about, and tried to look for things that are, uncanny. And I'm telling you, man, like, there has not been, maybe 1 out of 10 of them has been something that I can't argue about. 9 out of 10 of them have been very much like, there are things wrong with this. Like, this is just, like, I'll tell you, like, a girl's floating, she's got this dangling necklace around her neck, right? And it's a big chain. It's floating in free gravity, and her fingers are kind of brushing up against it and moving it. And it seems like a show, right? Just the necklace on her neck, right, seems like a key point for people to pull into, to be like, oh, look, she's in, free gravity, right? And you watch like this necklace and her play with it, and at certain points, her finger will just move right through the necklace 2 or 3 times. And I'm not, nobody's made a video about this. Like, this is just me on my own looking into this stuff, but it is weird. Okay. So it is a mystery to me also why they would do this. Maybe it's cheaper. I don't understand. Maybe it's safer. Maybe foreign powers. What I don't know. But all that I'm saying is that, like, there is more to this story. There is a reason why people are talking about this, and it's not just, you know, oh, NASA's fine, right? Everything is okay. You know, blah 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 blah, right? That there is more.
It doesn't there though. It doesn't just stop there at NASA, does it? Because there are all the other space agencies all pulling off the same type of trick. And then that's when the lies start, that's when your discernment starts to kick in and go, hang on, why are they faking space? And then you go down a big rabbit hole, and
You
and
go
you
down a
find
big rabbit hole, exactly, Carlos.
you
I
know,
don't think
that's a huge rabbit
think,
hole.
Yeah, it's a huge rabbit hole. I don't think people need to go down that rabbit hole.
I